Hello guys. So welcome to this amazing course on complete generative AI with LangChain ecosystem. And here our main aim is to specifically focus on building amazing generative AI applications with the help of LangChain. Here we are just not going to create simple Gen AI applications. Here we are going to probably create RAG applications. We are going to create search engines. We are going to create text summarization applications. We are going to create agent type applications and all. And there are a lot many examples that we are going to see as we go ahead. In this entire curriculum, I have probably uploaded more than 13 plus projects, end-to-end projects that will be available over here. So end-to-end projects, right? Now, in this video, I really want to give you the flow, like how we are going to learn this entire course. Okay, so first of all, we will be starting with one programming language, which is called as Python programming language. Okay, now in this Python programming language, everything that is specifically required in order for you to get started with this particular course, everything I've actually covered in this Python programming language, right? And obviously, when I say Python programming language, this is just not like basic type of level; it is completely from basic to advanced, right? So here I've actually covered amazing libraries like NumPy, Pandas. I've covered inheritance. I've covered multiple things with respect to this, so that you'll be able to. Even file operation is also covered in this, right? So you'll be able to probably implement this all this kind of projects as we go ahead, right? Then coming to the second and important thing that we are going to learn over here is nothing but NLP and deep learning, right? So here we are going to probably also cover this entire NLP with deep learning because this is something we really need to know before we go ahead and start working with LLM models and multi-models, right? So in NLP and deep learning, we are going to learn about RNN, we are going to learn about LSTM RNN. Then after covering LSTM RNN, you'll also be seeing, we'll be covering GRU RNN. So in every RNN that we will be seeing, we'll understand what is the theoretical intuition, what is the practical intuition, what are the problems with the previous one, and why the next version of the RNN are specifically coming up. And if I probably consider this entire RNNs, this is important because this will be useful for solving any kind of NLP use cases. Okay. So once we cover GRU RNN, then we will be working with bidirectional RNN. This is also another variant. Okay. Then after getting through all these things, then we will be also understanding about encoder, decoder, right? And this will have the entire mathematical intuition. And this will be super important in the interviews because in interviews also they specifically ask this kind of questions. And right now also in interviews they focus on basic things, right? So we will be covering with respect to encoder, decoder. Then along with this, we'll also be seeing something called as attention mechanism. Now after seeing this attention mechanism, we will be seeing some more architecture like transformer and BERT, right? So we will also be seeing this. Now with respect to all these topics, once we probably complete it, right? This will actually give us a basic building block to probably understand about basic building block to understand about what? It will help us to understand about LLM models, right? LLM models, or in short, generative AI, right? So then we will probably go ahead and cover what exactly is generative AI, what exactly we'll be able to do with this, right? After understanding about generative AI, then we're also going to go ahead and see about LangChain ecosystem, right? Now, LangChain is one of the most popular web framework, most popular generative AI framework, because this will actually help you to develop amazing generative AI functionalities, okay? API, generative AI applications. Now, the best thing about LangChain ecosystem, it has almost each and everything, right? From this, you can actually go ahead and use your both paid LLM models, multi-model. Not only that, in our course, we are also going to cover open source LLM models, open source LLM models. And this LangChain ecosystem provides each and every functionality. If you definitely want to work with agents, you want to probably go ahead and create applications with respect to, let's say one example that I'm going to probably take in this, we'll be going and chatting with SQL database, right? So this, you'll be seeing here, the chat will basically happen with text. So this kind of applications will be able to generate. Our main aim of considering the entire LangChain ecosystem is that because it has many, many features. We have vector database, right? We have vector database, we have retrievers. What exactly is retrievers? We'll try to understand how to probably go ahead and create chains, how to do the text summarization, right? How to work with creating with chatbots. We'll work with chatbots, and the chatbots will be working with chat message history. Chat message history. So there will be a lot of functionalities that we are going to break down the entire LangChain ecosystem. And in this LangChain ecosystem, there's some of the very important modules that we are going to specifically use. If I talk about LangChain, there are these three important libraries that we are going to use. One is LangChain, LangChain core. We're going to go. We'll be getting to know more about it. What exactly is LangChain core and why this community is specifically used. Then we will be seeing about LangChain community, right? We will also get to know about this, what kind of functionality is specifically in LangChain community. Then we will be seeing something called as LangChain tools, right? And there are many more important modules that we are going to use in this entire ecosystem. But at the end of the day, you will be understanding some amazing ways of creating generative AI applications. And this will be not just simple projects, it will be very, very extreme and important projects, which will actually help you to handle real world AI scenario, real world use case scenarios, okay? Then after probably developing multiple applications with the help of LangChain, then we will be going ahead and understanding about some of the deployment techniques. Now, this deployment techniques that I'm going to specifically use, I'm going to make sure that whatever free resources are available, right? Resources are available with respect to deployment. I will be doing that. Okay, I will not take any paid kind of things with respect to this particular deployment techniques. Okay, so all these applications also I will talk about it, guys. We will be using Streamlit to probably develop this entire application. Streamlit is another framework that we specifically use, right? So here also we are going to specifically use this Streamlit library. Okay, now after covering deployment techniques, obviously we also need to know about fine tuning techniques. So in this fine tuning techniques, we are going to see some of the tuning things. Fine tuning techniques here. We will be specifically using Google Colab. Again, we will try to just use free resources and try to do this. Okay. One of the paid LLM model will be OpenAI. Okay. And here I will also talk about what all LLM models we are specifically going to work. Okay. So over here we are just going to use Google Colab and we are going to learn about some of the important concepts and techniques like quantization. We're going to learn about LoRa, Clora, and with the help of this, we are going to fine tune with some open source LLM models. Open source LLM models. Okay. Open source LLM models. Okay, so we are also going to cover this so that you also get some experience with respect to the fine tuning things. Okay, now coming to the sixth topic, sixth important module, which we are basically going to go ahead and create. It is working with Gen AI in AWS, right? So let's say if you clearly want to completely work or develop your generative AI applications in AWS by using AWS Bedrock. So there is a service in AWS Bedrock which will have many open source models that will be available over there in the hosted mode, right? So with the help of this AWS Bedrock and using other important services that are present in AWS like Lambda function. Okay, so Lambda function, then you have API gateway. So here we will be developing some amazing end-to-end projects, and we'll also see how we can deploy this entirely in our AWS SageMaker. right? AWS SageMaker. So this will be another amazing module that we're going to work with. Okay. In the recent days, one more module is becoming very much popular. That is called as NVIDIA NIM. Okay, NVIDIA NIM. Now, NVIDIA NIM is just like you have this NVIDIA NIM actually helps you to deploy the generative AI models in the cloud. And here, with the help of NVIDIA NIM, we'll be seeing what all kind of open source models are already available in this hosted platform itself. And with the help of this, also, we will be trying to create some end-to-end projects. And here also, we are going to use LangChain. Okay, we are specifically going to use LangChain. So as you know, as this is 2024, we definitely need to know all the new techniques that are available in the market, which will be definitely helpful for you. Okay, and finally, I'm also going to cover one more amazing library, which is called as Creo AI. Creo AI actually helps you to create multi-AI agents, which helps you to solve different kind of, or which helps you to develop different kind of generative AI applications. And this also we will try to use LangChain and we'll develop this. Okay, along with this particular Creo AI framework. Okay, I think over here LangChain will not be used, but it has its own framework. So with the help of this also, we will be generating some kind of amazing applications. So overall, this is the entire course curriculum which I've actually written step by step how we are going to cover. But I feel after doing this many things, you should definitely be able to crack any kind of jobs and even open your own startup, specifically working with any kind of models that you really want to work with. Right here, if I just consider the LLM models that I'm actually going to use, as I said, LLM and multimodal. Okay, as I said, I'm going to use both paid and open source so that you get an idea with respect to both paid and open source. The first one I'm going to specifically use OpenAI. In OpenAI, I'll be showing you examples with like GPT-4o, right? We will be seeing with respect to GPT-4 Turbo. We'll be seeing some OpenAI embedding techniques. Right? When I go to open source model, I will be specifically using this Google Gamma model. So I will be using this Google Gamma model, Gamma 2 model, right? Along with this, you'll be seeing the third important open source model that I'll be using will be from Meta. So obviously models like Llama 3, I'll be using it from here. Along with that, and Mistral. So if you know about the company called as Anthropic, right? We're also going to use this particular model that is nothing but Mistral from Anthropic, which is again an open source model that is available. One of the version of this Mistral we will be using to solve some of the problems, right? And along with this, in Meta, Llama 3, and we're also going to use something called as Code Llama. Okay, Code Llama is specifically used for creating code assistant and all, right? So GPT-4o, GPT-4 Turbo, Gamma model, this model, and then finally, obviously, we're also going to use Hugging Face. How can I miss this, right? So there are a lot of models, LLM models that are specifically available, both open source and paid in the Hugging Face. So we are going to specifically use this. And at the end of the day, by using all this kind of models, we are going to probably create a lot of generative AI application. I will also introduce you how you can actually use this entire open source model with the help of Grok AI infrastructure, which is important for everyone. Grok infrastructure, right? Grok is an LPU engine. Okay, we will talk about it. What exactly is this LPU engine and how it is better than the GPUs? Okay, so overall, this is the entire idea of the entire curriculum itself. There are many things that needs to be discussed, and you'll be seeing that as you go ahead. And all these sessions are like completely in depth explained. Every project is developed in such a way that you should be able to implement it. I've written each and every line of code as we go ahead, right? So I hope you like this particular video. I will see you all in the next video. Thank you. Take care. Bye bye. Hello guys, so welcome to the Python series. Now we are going to start our first session with respect to Python. Now what we're going to do in this video is that, and the entire code that I'm actually going to specifically write, I'm going to use the VS Code ID. VS Code ID, I find it really amazing because here you'll be able to execute your Jupyter Notebook files, your .py files. Along with that, you'll also be able to create all the environments very much easily. So it is feasible that I specifically use VS Code. Along with that, you have a lot of features like extensions, code assistance, and many more things. So the first step, as we are starting, what I'm actually going to do is that over here we're going to create our new environment. As I said, in this Python series, I'm going to use the newest Python version, that is Python 3.12, and I am going to teach in such a way that we see all the new features that have actually come from 3.10 to 3.12. So all the new features that are specifically there, we will be also discussing about them in this Python series. The first step, as you know, that I'm going to create an environment. And again, why you specifically require an environment? Because an environment is necessary whenever you start a new project. Because in our Python project or in our data science project, we make sure that we use multiple packages, multiple libraries and all, right? And every couple of months, these packages or these libraries have new features, and most of them are open source packages or libraries, right? So they definitely have a lot of features that gets included every couple of months. So it is always necessary that you always maintain or try to create your entire project in a separate with a separate environment, so that there should be not any conflict as you probably go ahead whenever a new feature is probably coming up, with respect to the packages. You can actually create a new project and create a new environment out there. But here, the first step, what I'm actually going to do is that let's go ahead and create our environment. And for this also, I will be using conda command. So first of all, I'll not go ahead and write in PowerShell. Instead, I'll go and click on command prompt. So quickly, let's go ahead and write it down. So here I'm going to write conda create -p -v Python double equal to, let's say, I'm going to go ahead with Python 3.12. Okay, and understand one thing is that over here we are using this conda create command. venv is specifically your environment name, and which Python version we are specifically using, it is 3.12. Again, based on different projects, it is not necessary that you always need to use 3.12. It depends on the kind of packages that are available. Let's say open source packages when you're creating deep learning projects or any machine learning projects as such, right? So, but here, since we are learning this Python series completely from basics, I'm going to go ahead and use this environment. So once I probably click this, so here you'll be able to see the installation will start taking place. And when we're creating a virtual environment, some basic libraries or packages will be automatically downloaded by this conda command. So now here you can see over here what are the basic commands, basic new packages that are basically getting installed. So here are all the packages. So I'm just going to go ahead and click on press Y, and once I probably do this, all the installation of the libraries will happen, right? So it is going to take some amount of time. Again, it depends on your internet speed. But let me just go ahead and show you. So here you can see a venv environment is basically created, and these are all the default packages that you'll be able to find out inside this, right? There will be a DLL folder, there will be an include folder, right? So what is the basic environment that is required for any Python project? So that will be covered up inside this particular folder. Okay. Now once you go ahead and click this, now the next thing is that, let's say you want to activate this environment, right? So in order to activate this environment, I will go ahead and write conda activate, and we go ahead and use this venv folder itself, right? The same venv folder, and here we are just going to give the location of this, right? So once we press this, you'll be able to see that I have activated the venv environment. Okay, and now you can probably run any kind of .py files directly from here by using Python specifically. Let's say I probably go ahead and create my app.py, and let's say that I am just going to write over here print 1 + 1, right? So this is the basic command, and I'm printing this particular numerical operation 1 + 1. Now if I really want to run this app.py, I have to make sure that I'm in the same folder location. I've activated my venv environment, and now within this particular environment, we will go ahead and just execute this file. In order to execute it, you just need to write python app.py. So once you do this, here you'll be able to see that I'm able to get the response. Okay. Now let me show you one more thing, because see, as we go ahead with more lectures, right, I'm actually going to create a folder. Let's say this is first folder is Python basics. Okay, Python basics. So inside this folder itself, I will go ahead and create my Jupyter Notebook file or .py file, anything that I require. Let's say I go ahead and create my Jupyter Notebook file. By default, let's say this is my test.ipynb. Okay. Now this Jupyter Notebook file will be a similar Jupyter Notebook file that we actually use in Anaconda, right? The Jupyter Notebook. But in Python also, sorry, in VS Code, you will be able to see that yes, internally you'll be able to execute this text, this Jupyter Notebook file also. Now, initially, if I go ahead and let's say over here an option is probably coming up saying that, hey, detecting kernels. So if I want to select the same environment, right, venv, I can go ahead and click on detect kernels. So here you'll get an option of selecting the Python environment. Let's say this is the environment that I've created, right? venv Python 3.12.0, and these are all the other environments that I've actually created in my local system, right? So I'm just going to go ahead and select 3.12 code. Okay. Now let's go ahead and execute any code, right? So this is my code cell. Okay, I can create any number of code cell that I really want, right? Now code cell is nothing but here I will be writing all my Python code in order to execute it. Along with that, you also have something like markdown. So let's say that I have this markdown cell. I can basically write comments saying like this, like let's say Python example, and if I execute it, in order to execute this cell, I have to press shift enter. Okay. So if I probably press shift enter, automatically this will get executed. Now the reason we have used some markdown because I needed to write some information over here, so like title and all, so I'm writing it over here, right? So if you press shift enter, then automatically the cell will get executed. Along with this, you also have an option of run all. If you want to run all the cells over here, if you go ahead and see, if you just go ahead and press right click, you'll be having so many different options. Okay, but we're just going to use shift enter, so that we'll be able to execute it. Okay, now this is fine. Let's run our first code in Jupyter Notebook. So if I'm going to write 1 + 1, so here you can see I'm getting an error. Running cell with venv Python 3.12 requires the ipykernel package. Okay, so this is one of the requirements that we really need to do. We need to install ipykernel. Okay, so here what I'm going to write is that pip install. If I want to install any packages, I have to just go ahead and write pip install ipykernel. Okay, so once I probably do this, you'll be able to see that if I press enter, you'll be seeing that hey, my ipykernel is basically getting installed. Now what is this ipykernel package? Ipykernel package is nothing but it provides a kernel to this specific Jupyter Notebook, which will be responsible in executing the Python code. Right? It is pretty much necessary and compulsory. In Anaconda, the default Jupyter Notebook has ipykernel already integrated to it. Okay, so this is the first thing that you really need to do whenever you want to run the Jupyter Notebook. You just go ahead and write pip install ipykernel. One more thing that you can actually do is that here, what I will do, I'll go ahead and create one requirement.txt, because this requirement.txt, later on whatever packages I want. Let's say the first package I want is ipykernel. I'll keep a note of this over here, and any number of packages I will be requiring. Let's say in the future classes you'll be seeing pandas, numpy, different packages. So we will try to install it from here itself. We'll write over here and we'll run this requirement.txt, which will be responsible in installing all the packages. Now you can see that the ipykernel has got successfully executed. Now let me just go ahead and run the same code. So here you'll be able to see if I run the same code, now it is just going to execute. It is saying that connecting to kernel, and here I'm having my output, right? So now I can probably go ahead and write any type of code that I want. Let's say I want to go ahead and write print hello hello world, okay, something like this. So here you'll be able to see that it is executing, right? For .py file, I don't want any type of kernel because in the terminal, automatically that particular terminal has this environment set up, right? So in order to execute it, I have to go ahead and write python app.py, right? Or whatever is the file name. In this case, if I want to execute any cell, I have to just press that particular cell and press shift enter, okay? So in this video, we have discussed about how you can go ahead and create an environment, because going forward, any session that is probably going to come up in this course, I'm going to probably create a folder wise like this. For first class, I will probably create Python basics, create my Jupyter notebook file or .py file, execute all the code in front of you, write all the code in front of you, and continue, right? So for right now, I will just go ahead and delete this folder because I don't require it. Because at the end of the day, I will do one thing. Okay, just a second, I'll just close this. Okay, yeah. Now let me just go ahead and delete it, because in the next session, I will go ahead and create everything from scratch. Requirement.txt, I will keep it so that I keep on updating my packages. So yes, this was it from my side. I hope you like this video, and in the next video, we will start our Python basics. So yes, this was it. Thank you. Take care. Bye bye. So guys, one of the most important questions that has been asked by many people who implement end-to-end project, that is with respect to creating an environment. Now there are multiple ways in creating an environment for a project, and it is always a good idea that you probably create a separate environment for every project, because you have a different set of dependencies and libraries that you need to install over there. Now considering this, right, I usually in my YouTube channel, I use conda command to create an environment itself, right? And many people do not have Anaconda installed, they just have Python installed. So due to that, they get some kind of errors, right? You can also create an environment through this Python command, which I'm going to show you. So again, in this video, what all things I'm actually going to cover, all the different ways how you can probably create an environment and start your end-to-end project itself. So let me quickly go ahead and show you. I'm going to show you 3 different ways. I'll open my terminal. Okay, and the best thing is that you can use along with, you can use as a Linux command also, you can use as in Windows command prompt also. So let me just show you the first way. The first way will be using Python command, right? Conda create command I usually show you, but today I'll show you all the 3 ways how you can actually do it. So let me go ahead and write by using the Python command. So I will write python Python, okay, and then here I will go ahead and write -n, okay, and my command name, that is venv, inside what folder. Okay, so here let's say my folder is my-env. So once I do this, this folder will automatically get created, okay, and by default an environment will be set up. Now inside this particular environment, what kind of Python version you specifically have? For that, first of all, let's go ahead and activate it. Okay, now to activate this, what I will do inside my-env, there'll be include libraries, folders, and all. Inside script, there is one activate file. So I just need to go ahead and activate this to activate this particular environment. So for that, what I will do, I will write my-env/scripts/activate. Okay, so once I write this, and now here you can see that my environment is activated. Now I can probably go ahead and install any kind of libraries that I specifically want. Let's say pip install pandas if I do, or pip install numpy, then automatically the numpy will get installed in this specific library. Okay, and later on, if you have many number of libraries, you can basically create a requirement.txt. For this, the prerequisite is that you only need to have Python installed. Now, which version of Python is probably getting installed over here? That also you really need to check. By default, let's say in my Python environment right now, I just saw, right? Let's go and see my Python version. So let me go ahead and write Python version. So inside my Python version, oops, you can see Python 3.8.5 is there, right? So by default, whenever I create an environment, so this Python 3.85 only will get created because in my system I have this specific thing installed. Let's say I want to create with another Python version, then I need to upgrade my Python package itself, right? I need to probably make it to 3.1.0 or 3.1.2. What I need to do is that just go to Google, okay, and probably let's say I go to python.org and here I download the recent version. Then automatically what will happen is that whenever I create an environment that through that way, then I will get this specific version. So this is one way, okay. The another way, so let me quickly, I've activated it. Now I will go ahead and deactivate it. I'll clear the screen. So this is one environment that has got created. Now there is also another way which we specifically use for Linux commands itself. So first of all, I will go ahead and install virtual env. So this virtual env, sorry, I think it'll get as an error. So virtual env, this I will try to install. So once I probably install virtual env, I'll show you how you can create a command, an environment through using virtual env itself. And that also you can also use it in PowerShell or Good Bash. So in virtual env, I will go ahead and write virtual env, okay. And after writing virtual env, let me go ahead and write it -pyp, and then I will go ahead and write Python. Okay, Python, the version I know that it is somewhere around 3, and this will basically be my virtual environment name, virtual_env. So once I go ahead and execute it, you'll be able to see that now inside this virtual env is also getting created, and inside this also you have a script folder. So if you want to activate somewhere, activate, this will also be there, right? Activate file will be there to activate those commands. So in order to activate it, what I will do, I will quickly go ahead and clear the screen and go ahead and write virtual env. I think the folder name is virtual env, I guess. Let's see, virtual_env, so /scripts/activate. So once I activate, now here you can see I'm getting some error. Let's see what is the file name. Scripts slash, I think the spelling is somewhere here itself. Let's see. I'll go ahead and copy this path. Okay. Oops, let me just see. Okay, activate. I will copy the relative path. I'll paste it over there. I think it should be. Now you can see that it has got, it moves into this particular virtual environment. Now in order to deactivate, I will go ahead and deactivate. Okay. Now this is the thing, right? Through this, what you really need to do is that whenever you upgrade your Python, you'll be able to create that particular Python environment with that particular Python version in this. The third way, which is the most common one, which I also use, is by using conda create. For this, you really need to have Anaconda installed. And Anaconda is a better way, I feel, because here you will be able to, make sure that all the packages, all the environments are properly managed. Through the Anaconda environment, you can actually see each and every package that has got installed. So you can also use this specifically. And for this way, you only have to write conda create -p venv, let's say venv1, and here I will give my Python version with respect to anything that I want, 3.10 and all, and why, right? So this command actually helps you to create an environment, even though in the base you have different Python version. See, right now you have Python version, Python v, okay, I will write Python --v. So here, okay, version, okay. Python 3.8.5, right? Now, what I will do is that I will make sure that I create it through the conda. So I will write conda create -p venv1 Python. Let's say I want to go with higher version. Python = 3.10, right? And if I write w-y, then you can see that automatically my entire environments will get created, right? So I still find this as an efficient way. But again, if you don't have Anaconda, and because many people are getting this kind of errors when they are doing my project, because I only use conda because that is much more efficient when I compare it to Python. But it is not possible. I'm not saying that it is impossible to create in other ways. You can go with that. So that is the reason I've shown you all the specific ways to go ahead and you can create a virtual environment based on your needs. So I hope you like this particular video. This was it for my side, and this was a video about creating different ways of environment in your Python project itself. Yes, go ahead and write down if you have any queries. Please let me know in the comment section of this particular video. Hello guys, so we are going to continue the discussion with respect to Python. We are going to understand about single line comments and multi-line comments. Along with this, we are going to understand what is the definition of syntax and semantics. And then we'll see basic syntax rules in Python. Then we'll also be understanding about semantics in Python and what are the common syntax errors and how to avoid them. And we'll also be seeing a lot of practical code examples. Okay. Now, first of all, let's go ahead with the definition over here. So here you can clearly see that syntax refers to the set of rules that defines the combination of symbols that are considered to be correctly structured program in a language. In a simpler terms, syntax is about the correct arrangement of words and symbol in a code. Now, understand when we are doing coding, right? We usually face some kind of syntax error. Why it usually happens? It may be because, let's say, I'm not assigned a variable and I've directly used it, so I may get a syntax error. So that is the reason it is written over here, that it is the correct arrangement of words and symbols in a code, right? Now, this is a basic definition of syntax. I would also like to give you some more definition for semantics, okay? So let's go ahead and write it over here. So here you can see semantics refers to the meaning or interpretation of the symbol, character and commands in a language. It is about what the code is supposed to do when it runs. Syntax is how we are able to arrange the words so that we write a code, and semantics refers to the interpretation. So whatever code we are specifically writing, what it is supposed to do, right? When it runs, like when we are trying to run it, what it's supposed to do? It is more about the task that we are trying to do, right? And that is what semantics basically refer to. Now, this is some kind of basic definition. I know you usually don't go through this, but I really wanted to explain you in a way that anyone can actually be able to understand this who is also starting Python programming language. Okay. Now, let's go ahead and see some of the basic syntax rules in Python. Okay. Now, first and foremost important thing is about case sensitivity. Okay, so I'm going to write a comment over here, case sensitivity. Now, before I go ahead, you'll be able to see that whenever I use double hash in a code, whenever we create a coding cell, right? And if I want to write some kind of comments, a single line comment, I can basically use this double hash. So this double hash basically means that whenever I want to use a single line comment, I can just use this and I can write any kind of comments that I want. Like I've written over here. Let's say that in this code cell, I'm going to discuss about basic syntax rules in Python. So I've just written double hash over here. Okay. Let's say, and there's also an option to use multi-line comments. Okay. Now multi-line comments, let's say that I've created one test.py file over here. Now for multi-line comment, let's say I'll write, this is a multi-line comment. This double hash is a single line comment. And in case of multi-line comment, I have to use triple quotes, right? Something like this, triple quotes. So I'll say welcome to the Python course. So that basically means I'm using 2 to 3 lines and I'm writing this particular lines, right? I'm giving some kind of comments over here. Now, whenever I have comments which expands to multiple lines, I can definitely use this triple quotes. So these are the 2 ways of writing comments in Python programming language. Okay. The reason why I have used this test.py, and see again in Python you can actually use IPynb file, which is the Jupyter Notebook file, or .py file, which is the Python file. Now this triple quotes usually does not work in Jupyter Notebook. It only works in test.py file, right? Other than that, single line comments definitely work for both Jupyter Notebook and the py file, basically the Python file. So I hope you got an idea of understanding about single line comments and multi-line comments. Now let's go ahead and see some of the basic syntax in Python. So first point that I really want to talk about is case sensitivity. And to give you a good comment over here, Python is case sensitive. So guys, now let me go ahead and define a variable. Let's say this is a variable. And what exactly is a variable? Again, I'll give a definition, but let's consider that a variable is something that stores some information. Okay. Let's say in this particular variable, I define my name, that is Krish. Okay. And let's say I again define a variable with capital N, and I write the same variable name, that is name. And here, let's say that I am just going to use another name. Let's say Nayak. Okay. Now, one thing that you really need to know, if I print this particular name and if I print the next name, right? Over here, both this name are different variables, right? It is not the same variable, even though the variable meaning is same, right? Name, right? But I've told over here that Python is case sensitive, right? That basically means both this variable are different identifiers, okay? So if I'm going to execute this, here you can see the first name is displaying Krish and the second name is displaying Nayak, right? So that is the reason we say that, hey, Python is case sensitive, right? Both this variable, right? If you are writing, we always need to make sure that, let's say that I've defined this name over here and again I've defined name. Unless and until both this variable are having that case sensitive things, right? That basically means even though I'm writing with the small n letter over here, then I will be considering both this variable as same. Otherwise, this will be treated as a different identifier, right? So this is one of the very much important information. Now coming to the second thing, right? Second point. Let's talk about something called as indentation, right? Now what exactly is indentation? Again, this is also very much important to understand. I'll just write a comment over here. Python uses indentation to define blocks of code. Consistent use of space, commonly 4 spaces, or a tab is required. Okay. Now, what exactly is indentation? Okay, and if you really want to have a definition for indentation, okay, so we can also define indentation over here. So let me just go ahead and give you some kind of definition. Okay, I'll be using a markdown cell, and let me just go ahead and write over here, right? And let's go through this particular indentation definition. So let me just go ahead and execute it. Indentation in Python is used to define the structure and hierarchy of the code. Unlike many other programming languages that uses braces to delimit block of codes, right? Python uses indentation to determine the grouping of statement. Okay. Now indentation is something that is very much necessary whenever you are writing some clauses, let's say if block or for loop or something else, right? So let's say I'll give you an example over here. I will define a variable. Let's say age is equal to 32, and let me just go ahead and write one if condition. Don't worry if you don't know about if condition. How do we write it? What is the syntax and all? I will explain this as we go ahead. But I just want to give you an idea about indentation. So let's say if I write if age is equal to greater than 30. Now, when I write if age is greater than 30, and if I just use this colon, now see what will happen if I press enter. It is going to start inside this particular block, and automatically it did not start from here. Instead, it started from here, right? So it is what it is basically doing. It is using indentation, right? It is using consistent use of space, commonly for a tab, right? And here it is for a block of statement, right? Block of code, right? So here, if I'm going to write, let's say that I'm going to print 30 over here, and I'm just going to print the age, right? Now, what is basically happening over here? I've just used this if block, right? And because of indentation, we know that this code is only going to get executed when this is true. Okay. If I go ahead outside and if I print it, print age, that basically means this is not inside the if clause, right? Usually in other programming languages, we usually write this kind of basis, right? We try to define this kind of basis if you know other programming languages like C++ or C#, right? But in Python, instead of using this basis, automatically it will be aligned with indentation. Now let me just go ahead and execute it. This time 2 times is basically getting displayed, 32. So one is this and the other one is over here. Understand this age is basically getting displayed, but this is outside the if block. Okay. So this is giving you an idea about indentation. Okay. I've already explained you about comments, but let me just go ahead and write about single comments. So first single comment, let's say this is a single line comment. I'll go ahead and write single line comment. Let's say that I'm going to print hello world. Okay. Now if I go ahead and execute this, you can see only hello world is getting displayed. This comment section is not getting printed, right? Again, why do we write comments? Let's say that I want to define a function. I want to give some information about this particular function. I can write all those info in this comment section. Okay. Now this is important. Okay. Now let me just go ahead and talk more about different syntaxes. One more syntax is something called as line continuation. So here I'm going to basically write line continuation. Now what exactly is line continuation? Okay. Let's say I am going to create a variable total, okay, and I'm doing some mathematical operation like 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Let's say this line is becoming bigger and bigger, right? So this line is really becoming bigger and bigger. Let's say I want to go to the next line. So what I can actually do, let's say I'll write plus, and now I will use a backslash. If I use a backslash, if I press enter, then what is going to happen? It's just going to continue in the new line. Okay. So here I'll just use this, and then let me go ahead and press backslash, and let's say I go ahead and add more elements like 4 plus 5 plus 6. Now if I go ahead and print total, you'll be able to see this will also do all the operations. So if I do the calculation 13, 18, 22, 25, 27, 28, 28 and 28 plus 6, 34, 39, 43, right? And I'm able to get the answer. So you can use, right, in case of basically line continuation, you can basically use a backslash, right, and you can continue the statement to the next line. Okay, so this is very much important. Again, one of the most amazing feature. And again, let me just show you one more thing, one more amazing thing with respect to syntax and semantics. That is nothing but multiple statements on a single line. On a single line. Now, what does this basically mean? Let's say I want to assign one value. Let's say x is equal to 5. I've defined. I want to define another variable. Let's say y is equal to 10. Again, if I want to define another variable, I use a colon, and I'll go ahead and write x is equal to x plus y. Now, what is basically happening in a single line? I've used multiple statements. I've assigned x is equal to 5, y is equal to 10, z is equal to x plus y. Now, if I go ahead and print z, you see, I will be able to get the answer. See, 10 plus 5 is equal to nothing but 50, right? So guys, now you can see that this kind of operation can also be performed, right? Now let's go ahead and understand semantics, okay? Here also I'm going to put some points. So understanding semantics in Python, okay? Now the first thing that we are going to understand is about variable assignment. So what exactly is variable assignment? Let's say that I define a variable like age is equal to 32, okay? So here, when we run this particular command, right, when we run this line of code, then in other programming languages, you usually define the data type beforehand, like int age, float age. But here in Python, the kernel automatically understands during the runtime. So here, the kernel will understand that age is an integer because here we are assigning some integer value. Similarly, let's say I go ahead and write name is equal to Krish. So here you'll be able to see that name will be a string, right? So name is a string. So I will just go ahead and execute this. If you want to understand whether I am how to probably check the type of this, so I will go ahead and write type of age. And let me just go ahead and execute it. So here you'll be able to see that, hey, I'm getting an integer value. So this basically indicates that age is an integer. And then if I go ahead and execute type of name, so here you'll be able to see that, hey, it is an str type, that is nothing but string type. Now, let me do one thing, okay? The type that we have actually run, right? It is also called as something called as type inferencing. So here I'm going to basically write type inference. Now, Python infers the type of a variable at the runtime, and this is basically allowing dynamic typing. Okay, so what does it basically mean over here is that okay, I will just use this in the other code. Let's see. So if I go ahead and write over here, I'll create a variable is equal to 10. Okay, and let's say I go ahead and write print type of var, right? This will be variable. Okay. Now what is basically going to happen over here? Once you probably execute this, you are able to get an answer saying that it is of int type, and class will be int. Okay, but if I go ahead and use the same variable and assign some other name or some other value, let's say Krish. Now if I go ahead and print the type of variable, now what I'm actually going to get, right? So here you'll be able to see that I will be able to get str for the same variable itself, right? So here you'll be able to see that whenever we refer to the type of this specific variable, we will be also able to see something very amazing. As we keep on changing this particular variable, we'll be also able to see the inferencing type, right? So basically when we're searching for type of this, it is basically showing different things. So that basically means what? During the runtime, you can change the type of the variable with different values. Okay. Now, this was one of the most amazing things with respect to semantics. Okay, as you know, something over here is that we also need to understand like what happens in the case of indentation error. Let's say if I go ahead and write age is equal to 32, and if I write if age is greater than 30, okay, and if I go ahead and execute it, and let's say I don't use this indentation, instead I start from here and I go ahead and write print age. So here clearly you'll be getting an error saying that hey, indentation error expected an indented block after if statement on line 2. So this is how you will be able to understand it. All I have to do is that start from this, and automatically you'll be able to see the answer. Okay. This is important. Otherwise, understand without indentation, things will not work out. Even though you create classes, even though you create functions, whenever you write a block of codes within some kind of blocks, etc., like an if statement, for loop, or while loop. So indentation is specifically required. There you do not explicitly need to use brackets. Now, one more syntax error which usually people do. Let's say I have defined a is equal to b, and you know that b is not defined. So if I go ahead and execute this, this is also kind of syntax error because name b is not defined over here, right? So this basically becomes unknown variable, right? So this is nothing but this is basically called as a name error. Okay, I'll be showing you as we go ahead with respect to exception handling and how do we handle all these things. We'll be talking more about it. Okay. Now let me do one thing. Let me just show you one amazing example of indentation, some code example of indentations. Okay. And again, after this session also, I will be giving you a lot of quizzes, assignments, practice sessions and all. You just need to go ahead and do it. Okay. Practice it. So here if I write if true, say true is a kind of a Boolean variable. I will be talking more about variables in our next session. Let's say I go ahead and print. This is my correct indentation, right? Indentation. So here this basically becomes my statement, and print is just to print anything in your output console. Okay. Now inside this true, let's say I have another condition if false. Now if I want to write any print statement inside this block, then I have to again do an indentation. So here we go ahead and write print this one print, right? This one print. Why do not print? Because by default it is true. This is going to print it is going to check this condition and it's going to come out of this particular condition, right? And finally, you'll be able to see that I'm printing one more thing over here saying that whether this will print or not. You just think, okay, this will obviously print, right? Because this is not getting executed, we are not going inside this, and finally this print statement will execute. Now, if I want to go outside the if clause, then this will be another print statement, right? And I can basically say outside the if block. So how many times print is going to just pause the video and understand how many times the print statement is going to execute it, right? 3 times. So if I go ahead and execute it, you'll be able to see correct indentation. This will print outside the if block. Okay. So this is basically going to get printed, right? So these are some of the amazing examples of indentation. Okay. Now let me do one thing. Let me show you one more thing, right? One is with respect to correct variable assignment and type inference. But before I go ahead and explain you more about this, these are some basics about syntax and semantics. Now, as we go ahead, what are things we basically covered? Single line comments, multi line comments, definition of syntax and semantics, basic syntax rules, how do you define a variable, what is case sensitive and all. Everything I've actually covered over here. Right? This actually gives you an idea about basic differences between syntax and semantics also. So I hope you like this particular video. In the next video, I am going to talk about variables, then data types, then operators. Right? So yes, this was it from my side. I will see you in the next video. Hello guys, so we are going to continue discussion with respect to Python, and in this video we are going to discuss about variables. Okay, now what exactly is variables? And here I've also given the entire video outline. So we will first of all introduce the topic is introduction to variables. Then we'll be seeing how we can declare and assign variables. Then we'll talk about the naming convention. Then we'll understand variable type. We'll see type checking and conversion, dynamic typing, and finally we'll be seeing a lot of practical examples and common errors. Okay, so all these things will be specifically covered in this video. Okay, now first of all, as usual, let's go with the definition. So variables are fundamental elements in programming used to store data that can be referenced and manipulated in the program. In Python, variables are created when you assign a value to them, and they do not need explicit declaration to reserve memory space. The declaration happens automatically when you assign a value to a variable. Okay, so the best way to give you an example is that let's say if I define a is equal to 100, so this basically becomes the variable. And always remember, guys, whenever you start a new notebook file, always make sure to select the kernel. Okay, now if I'm going to write a is equal to 100, this basically means that I've created a variable a and I've assigned a value to 100. Okay, now obviously in my previous video I've also defined some basic variables and all, and I've assigned some values, let's say string, numerical, integers, floating point, anything, any values you can basically assign. We'll be learning more about it. So first of all, let's go ahead and understanding about declaring and assigning variables. Okay. So here you'll be able to see that let's say I'm going to define age is equal to 22. I'm going to probably define height is equal to 6 feet or 6.1. That is specifically my height, so I'm writing it down. Height is equal to 6.1. Then let's say name is equal to my name. I will go ahead and define Krish. And then here you can also see that I can also define a Boolean variable. Let's say I will go ahead and define is underscore student. Okay. I'll also talk about naming convention. What is the best naming convention of defining a variable? What are the good practices? Everything I'll be discussing about. So let's say I'm going to define a Boolean variable as true. Right. We'll learn more about the specific data types in my next video, but here I'm just giving you an example. Okay. So age is equal to 32. This is there, and I've actually written it. Right. Now let me quickly go ahead and print it. And this is how we assign a variable. Right. We're declaring a variable and we're assigning some values. Right. So now let me just go ahead and printing the variables, right? So here you can see. So now first of all, I'm going to print age, right? And this is where I will also show you how you can use different print, how you can display in your console in a different way. So first of all, let's say I want to print age. So age colon, let's say I want to assign this age colon with some value over here. So I will go ahead and find a variable age, right? Similarly, if I go ahead and show you the next print statement here, I'm going to basically write height, okay? And with respect to this particular height, I'm going to define another variable. Let's say this will basically be my height. Another next thing that I'm going to print over here is my name. And here you can probably see that I'm going to basically define my name. And let me just go ahead and write comma, and this will basically be my name, right? So if I want to define all these things, here you can see I'm displaying age is equal to 32, height is equal to 6.1, name is equal to Krish. That basically means, see, when I'm printing, I can also call this particular variable that I've actually defined, okay? So these are some of the ways. Again, we will be discussing about more different Boolean type, more different data types as we go ahead, and that is how we declare different variables. But just a basic idea for you with respect to the variable declaration. Okay. Now coming to the next one, which is basically called as naming convention, and this is the most important one. Like how should we name a variable, right? And for this, you really need to know about the naming convention. Some of the important points that I would like to mention over here. Let's say variable's name, right? The variable name that we define, right, should be descriptive. Okay. Then the second point that I would like to mention, they must always start with a letter. Okay, so this is the second condition, or it can also start with an underscore. Okay, underscore, like underscore, this kind of underscore mark, right? And it can contain letters, numbers, and underscore in between, right? In between, but always understand they must always start with a letter or underscore, and it can contain letters, numbers, and underscores. Okay, within inside that. Okay, and one more thing, very important point which I've already mentioned: variables names are case sensitive. Okay, this also I've defined it. So these are some of the important naming convention with respect to the variables. Okay, now let's see some kind of example over here. So first of all, I will just go ahead and write some valid variable name. Okay, so valid variable names. So first valid variable name, I'm going to define it as first underscore name is equal to Krish. Okay, last underscore name is equal to Nayak. Right. So is this a good way of writing a variable? Yes. Does it start with a letter? Yes, it starts with a letter. Can it contain letter, numbers or underscores? Yes, it can contain. So here you can see I'm having letters or underscore. I can also put numbers in between, but not in the starting. Right. So this is a good way of defining a variable. Okay. So here this absolutely works fine. Let me show you some invalid variable name. Invalid variable names. Okay, so let's say that I define with a number, right? And if I go ahead and define over here, age is equal to 30. See, I'm getting an error saying that invalid decimal letter, right? So I cannot start with a letter. So this is one way. Okay. The another way is that can I define something like this? First dash name, right? Can I define like this? First dash name is equal to, let's say, Krish. Can I define like this? Will I get an error? So here you can see cannot assign to expression here. Maybe you mean double equal to or instead of equal to. So this is not being considered. This symbol is also not being used, right? So obviously this is also an invalid variable name, right? The third invalid variable name, can I use @ and define a name variable, right? So let me just go ahead and check it out. So here I'll just go ahead and write Krish. Will I get an error? It says invalid syntax. Maybe you meant so and so, right? So this is also not a valid variable name. It is an invalid variable name. Okay. And already I've spoken about case sensitive, right? Case sensitivity, right? If I define name is equal to Krish, and let's say I've defined capital name is equal to Nayak, right? Both this are different, right? It is not same, right? If I really want to compare, can I compare like this? Name double equal to capital name. It'll be giving false, right? Yes, the values, if it is same, it will give me true. But in short, you can see that these are different identifiers, right? Later on, I can do the comparison operation and I can do it, right? So obviously, case sensitivity is also there, right? So this was related to something related to the naming conventions. Okay. Now let me just go ahead and make you understand about some of the variable types. Okay. So we will continue writing the code here itself. So let me just go ahead and write understanding variable types. Okay. Now one thing you need to understand: Python is dynamically typed. Okay, dynamically typed. What does this mean? This means the type of a variable is determined at runtime. Right? So this is very much important. Okay, and some of the important data types are like int, float, string, and boolean. Right? So let's say if I had age is equal to 25, right? So when I execute it during the runtime, it will understand, hey, fine, integer is basically getting assigned, so age is an integer variable, right? And let's say that I will go ahead and define some more variables, right? Let's say height, right? I'm going to basically go ahead and define height. Let's say I'm going to write 6.1. So this is nothing but it is integer. This is nothing but this is float. See how I'm also using the single line comments, right? Let's say if I'm going to define my name, so this will basically be Krish. So this is what? This is nothing but str, the string. And finally, if I go ahead and define is underscore student, this is basically my boolean variable, right? So boolean, sorry, I will assign it as true. So this basically becomes my boolean variable. Now, if I go ahead and print the type of any of this, right? Like age. So I'm going to basically get integer. The class will be integer. During the runtime, it is able to understand it. If I go ahead and print what is the type of name, I'm actually going to get string, right? So similarly, you'll be able to find out different types, like what classes it basically belongs to. Okay. Now, one more thing, right? Here, I will discuss about one very important point. And understand one thing, guys. Here, I'll be showing some example. But when I go ahead with more different lessons as we go ahead, right? I'll be reusing all these things. Don't think that I'm just going to write for a single time over here, because these all things will again get repeated. Okay, with all the different examples. Now, let me just go ahead and make you understand about type checking and conversion. Okay. Now, type checking and conversion. What does this basically mean? Obviously, type checking you have known, right? So if I go ahead and write type of height, so that basically means I'm going to get the data type of this height variable, right? So in short, I'm actually getting float over here, right? Now, my question rises: can we convert one data type to the other data type? Is it possible? So let me just go and show you. Let's say if I go ahead and write age is equal to 25, right? Now you know that if I go ahead and write print type of age, so what I'm actually going to get, it is an integer, right? But now I am going to perform some type conversion. Type conversion basically means I am going to convert this integer value into a string value, let's say. So if I go ahead and write age underscore str, and if I go ahead and use this str function, right? Str function is what? String, right? This is what is the class that I'm actually getting. Now if I want to convert this age into string, I can use this str and I can use this age variable over here, right? Now if I go ahead and write print age underscore str, okay? And after that, I will just go ahead and write print type of age underscore str, right? So if I go ahead and execute it, see, initially it was int. Later on, when I printed this age underscore str, here you can probably see that I'm getting 25, okay? But the type of this particular value is string, right? Here you can see string. So this value from integer has got converted into strings, okay? Now the question rises, Krish, what are different types of type conversion can I do? Okay, can I do something like this? Can I write age is equal to int string like 25? And can I convert this into int? Let's see, right? Let's see this. So the answer is yes, you are able to convert it, right? So if I go ahead and print the type of int of age, yes, definitely you are able to convert it, right? And here I'm just going to close it. Yes, the class is int. This is fine. But still, I will just go ahead and use some more examples. Let's say if I go ahead and write my name is Krish, right? Now can I convert this into an integer? The answer is no, right? Because obviously Krish is a complete sentence, right? If I talk about 25 in string manner, this is basically a numerical value itself, right? So even though it is in a string, I can convert this into an int type. But over here, this is my string, complete string. I cannot just convert this into an integer type or float type. So here you basically get an error saying that invalid literal for int with base 10, Krish, right? So this is the value that you are able to get over here, right? Another example, some more example. Let's define some float value, right? So let's say my height is nothing but 6.1, okay? Or let's say 6.0 or 6. Or 5.11, okay? Something, okay? Now, if I go ahead and see the type of height, what exactly it is nothing but float, right? Can I convert this float into an integer? The answer is yes. So if I go ahead and write int and I do typecasting for this particular height variable, you'll be able to see that I'm able to get 5, right? That basically means it is just going to remove the decimal, right? Can I do the opposite again? Can I again typecast this from int to float again? Yes, I can. And it is going to give my 5.0, right? So 5.11, initially I converted this into an integer, I got 5.0. Then again, sorry, I got 5. And then again I converted that into float, so I got 5.0. So this is some example with respect to the conversion, right? Type checking conversion. So this is what I really want to show you over here, okay? Now, let me do one thing. Let me talk about one very important concept which is called as dynamic typing, okay? And this is probably the most amazing feature in Python, okay? Let's say I'm going to define a variable 10, okay? I'm going to define a variable 10, okay? Now let me just go ahead and write print var. I'm going to print this var, and I'm going to also print type of var, okay? Type of var. Perfect. So this initially is an integer, then obviously it should give 10, it should display 10, and it should say that, hey, it is an integer. Now, Python allows the type of a variable to change as the program executes, right? So let me write down this particular comment. Python allows the type of a variable to change as the program executes, right? Amazing, right? Now what does this basically mean? Now I can go ahead and change the value of var, and I can write hello, okay? And let's say I'm going to print var, comma, type of var, okay? This time obviously you know what it will output, it will be string. If you're not satisfied with this, again you can change. So as you keep on executing the code, you can keep on changing it. Like say now this time I define it as a float variable. Now if I go ahead and write print var, okay, var, comma, type of var. So if I go ahead and execute this, here you'll be able to see that I'm able to get this, right? So see, initially it was 10, class int, hello, class str, and finally 3.14, class is float. So what is basically happening? Python is allowing this type of variable to change as the program gets executed, right? So we can basically do this, okay? Now, let's do one amazing thing. Let's just create a simple application with whatever things we are specifically on, okay? And before that, let me just talk about input, okay? Now, what exactly is input? Let's say that a user wants to give some values, right? Let's say age, and I've told that, hey, user, you give the value. What is the age, okay? What is the age? So I'm a user. I want to probably give the value over here. So if I use this, right, input function, and if I print age over here, see what will happen. So once I execute this statement, now see what will happen. So here you can see input box has got opened. So here I'm just going to give my age. Let's say the age is 23. Okay, and I'm going to press enter. So here you can see I'm printing the age. Now one very important thing to show you, right? What will be the type of this age? Okay, so that basically means whenever I'm giving any input from this particular input box by using this input function, what will be the type of it by default type? So here I'm going to go ahead and write 23, and here you can see it is a string type. So let's say I want to probably get this particular input and then also convert this into an integer or float. So I can again typecast this entire thing, right? So now if I go ahead and execute this, now let me just go ahead and write 23 and press enter. So here you can see I'm getting plus int, right? So this is one very important functionality for the entire input function. function over here, and this can be very handy and can be used in various places. Okay, so I hope you're able to execute this and you're able to understand this. So I'm just going to show you one example again. Now let us do one thing. Let us simply create one simple calculator. Okay, now this simple calculator will be amazing. So here you can just see that what this calculator is doing. I'm giving two numbers. Again, I'm using this input, number one, again number two, then sum. I'm doing num one plus num two, difference num one minus num two, and product is num one multiplied by num two, num one divided by num two. We'll discuss more about these operators as we go ahead. And we're just going to display all the sum, difference, and all. So let's go ahead and execute it. Let's say the first number is 56. I'll go ahead and press enter. Again, I've got my another cell. Let's say I'm going to write 43 or 10 something and press enter. So here you can see I'm able to see all the ounces like sum, difference, product, and quotient. Right. So yes, this was amazing. This was, I guess, you're able to understand anything about variables. This was it from my side. In the next video, I am going to probably discuss more about data types, and then finally we'll also be discussing about operators. What are the different data types also we need to discuss about? So yes, this was it from my side. I'll see you in the next video. Thank you. So guys, we have seen different data types again. Hello guys, so we are going to continue the discussion with respect to Python. Already in our previous video, we have discussed about variables. Now in this video, we are going to discuss about data types. Now here is the detailed video outline. First of all, we are going to understand the introduction to data types, importance of data types in programming. Then we are going to explore some of the basic data types like integer, floating point number, strings, and booleans. And after that, after some number of videos, we are going to see advanced data types like lists, tuples, sets, and dictionaries. Here, there is a lot of operations that we really need to understand. So I will be discussing about this topic further going ahead. And then you also have some examples with respect to type conversion and practical example. Now, first of all, we need to understand the definition of data types. What exactly data types are? So here, data types are a classification of data which tells the compiler or interpreter how the programmer intends to use the data. Right? They determine the type of operation that can be performed in the data, the values that the data can take, and the amount of memory needed to store the data. Right? And as you all know, there are different data types. If I probably say integer, floating, they definitely require different amount of memory. Right? Whenever they are storing some kind of information, like you may have int 8-bit, you may have float 16 bits. Right? So different bits information will be there for a specific data type. Right? Now let's understand what are the importance of data type in programming. So data types ensure that the data is stored in a very efficient way. They help in performing correct operations on data, and proper use of data types can prevent errors and bugs in the program. And obviously, memory management is also one of the very key terms. Okay. Now let me just go ahead and show you with respect to the code and how we can basically start with. Okay. Now the first example that we are going to go ahead, right, with respect to the data types is nothing but integers. So here I'm going to basically go ahead and write integers. So this looks like a plain text. Let me delete this because I don't want this. I'll go ahead and create. So here we will be able to see integers example. Okay. And first of all, let me just go ahead and select the kernel. Okay. So the kernel is over here. Now let me go ahead and create a variable of an integer type. Right. Now if I really want to create a variable, I hope I've already told it. Let's say age is equal to 35, and if I go ahead and write type of age, this will specifically give me an integer value. As I always said, whatever topics we are seeing again, it will be getting repeated. We will just be seeing that how more things we can actually learn about this. Right. Now see, I've already spoken about variables. I've already spoken about integer, but since we are learning now about data types, here also you'll be able to see that so many different things are there. Right. Then once I probably create an integer variable, you can also go ahead and create a floating point number. So let's say my floating point number over here, floating point data type. Okay, floating point data type. Here I'm going to specifically use it, and let's say over here I define like or let's say I'll probably define the width, right, or width or height or anything. So let's go ahead and define height. So let's say that if I'm writing 5.11, so this will be nothing but if I go ahead and print the height, right, and if I go ahead and print the type of the height, right. So here you'll be able to see that I'll be able to get my floating point number, right. So here you can see I'm able to get 5.11, and this is nothing but class float. This class was nothing but int. I've already spoken about typecasting also, right. So this is one of the other data type like floating data type, floating data type example. And the next example that I can probably take is for string. So string data type example. Okay, I will be showing you more examples as we go ahead. So let me say this is name is Krish. Okay. And here you can probably see, I'll go ahead and print the name. And let me just go ahead and see print type of name. Okay. So here you can actually see that, okay, fine, I'm able to see all these things, I'm able to get this information and all, right? And similarly, one more common data type that we will be specifically using is something called as Boolean data type, right? And again, guys, I'm not showing you much operations because operations will be coming as we go ahead, right? When we'll be learning about our next tutorial, right? Where we'll be learning about operators. At that time, we'll be discussing more about operations, how we can use this and probably do different types of operation and all, right? So for Boolean, what you can do is that I can directly define true or false. So if I probably use true, right? So this is basically a Boolean value, right? If I go ahead and see the type, right? So type. So here you can see it's a bool value, right? So this is one way how you can define it. Let's say I define saying that is true, right? And I may assign it to true, right? And if I go ahead and see the type of is true, type of is underscore true, you'll be able to see, hey, fine, I'm actually able to get the Boolean value, right? This is one way. The other way is that I may go ahead and directly assign a bool variable, right? And let me just go ahead and execute this. Okay. So here you can see when we use a Boolean variable, right? Or let me do like this, right? So let's say I want to go ahead and define a Boolean variable. So I will go ahead and write bool. Okay. And if I go ahead and execute it, right? By default, it is probably coming as false, right? Now I can also give some other conditions, like let's say I have two variables, right? Let's say I have two variables. Let me define it out. A is equal to 10. Okay. And B is equal to 10. Okay. Now if this is getting added. I don't know why. So B is equal to 10. Okay, so there is some built-in functions and all. I think that is why it is getting applied. If I write A double equal to B, right? So over here I'm able to get true, right? And even though I see when I'm doing the specific operation, if I go ahead and see the type, it is again Boolean, right? So Boolean is another one data type which we can specifically use, and this is just for true and false, right? That is why Boolean is specifically used, right? So we will be seeing more of this kind of examples as we go ahead, right? And I know you are excited to see a lot of operations, but let's go from basics and then we will try to build up more and more concepts, right? At the end of the day, you really need to try and work hard, right? And more you work hard, it is more like you become more perfect in it, right? So let's see some of the common errors that we may probably face, some of the common errors that we may get whenever we are working with different data types. Let's say my result is something called as hello, right? Now for this particular result, right? And let's say I want to go ahead and add 5. Okay, now what will happen? Let's check. Okay, and if I go ahead and execute this, here you'll be able to see that I am getting an error, right? It is saying can only concatenate string, right? Not integer. And here you can see on the left hand side, it is basically a string. And on the right hand side, when I'm performing this specific operation, I'm actually giving an integer. So if I really need to fix this error, all I have to do is that go ahead and write this. Okay, and over here, I need to do the typecasting, right? So let's say if I go ahead and write str of 5, then this issue will definitely get fixed, right? And if I go ahead and print it, print the result. Okay, so here you'll be able to see I'm able to get hello 5. Now that is the power of 5 casting. See, in this particular case, when I was trying to concatenate or add 5 over here, right, and obviously it is not possible because this is a string and this is a numerical value. We cannot perform any mathematical operation, right? And here you can actually see that I'm able to get this. So these are some of the common errors, like minimal common errors that you may be facing. But we will deep dive more into different operations. And one more thing that I really want to talk about, let's say if I want to define a string, right? Let's say like hello. Okay, now you'll be able to see string dot. There's so many different methods, right? If I probably go ahead and see, there's so many different methods. If I go ahead and see over here, see so many different methods, like is digit, is alphanumeric, is case fold, center, clear, copy, count, difference update. So we will also be seeing this kind of operations once we go ahead towards the advanced data type. Because see, we need to understand all these methods, because all these methods, once you understand, you will be able to understand how you will be using in different operations. But right now, since we're just discussing with the basics and we're just in the fourth tutorial, I want to go a little bit slowly with definition, with examples, show you multiple things, and make sure that you learn things in a way that it matters a lot to you, right? And again, as I said, be patient with respect to this. I know many people will be excited, saying that hey, Krish, quickly complete fast, right? But let me go a little bit slowly so that you'll be able to understand things. Okay, so yes, this was it from my side. I hope you like this particular video. Yes, I will see you all in the next video. Thank you. So guys, we are going to continue the discussion with respect to our Python series, and this video we are going to deep dive into the operators, and we'll see that how with the help of Python we will be able to perform different operations. Now here's the entire video outline. So first of all, we will go ahead and see introduction to operators, then we'll see multiple arithmetic operators like addition, subtraction, multiplication, division, floor division, modulus, and exponential. Along with this, we'll see comparison operators like equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to, and we'll perform various operations. Along with this, we'll also be seeing logical operators like and or not, and then we will be like all these things will be shown along with the practical examples, right? So let me just go ahead. First of all, if you don't know about operators, guys, any kind of arithmetic operation or logical operation can be probably performed with this kind of operators. Okay, and obviously when we write any Python code, we definitely require a lot of operations probably to develop our projects and all, right? So quickly, let me just go ahead and create my code cell, and here I'll show you one shortcut. You just press escape and press A, automatically cells will get appended, right? So first of all, we are going to go ahead with arithmetic operations, right? And here with respect to the arithmetic operations, let me just go ahead and create some variables like A is equal to 10. Oops. So I will go ahead and write. Okay, this is getting added. We'll discuss about all these things. No worries. So A is equal to 10. Okay, and let's say I'm going to write B is equal to 15. If I want to perform any kind of operations over here, right? Let's say I want to perform a basic arithmetic operation. I will go ahead and write result is equal to A plus B. So this is the addition operation that we specifically do. And here I can go ahead and print my result, right? A simple addition operation. So here my answer is 15, right? Similarly, what I can actually do is that again. So this will basically be my add result. Okay, similarly, we can go ahead and create our subtraction result, which will be nothing but A minus B. Then along with this, we can go ahead and do our multiplication result, right, which will be nothing but A multiplied by B. This is what we specifically get with respect to the multiplication operation. Along with multiple operation, we also have a division operation. So let me just go ahead and write my division underscore result is equal to A divided by B. Okay, and then we will also be having floor division. We'll discuss what is the difference between floor division also. So here you can see floor underscore div underscore results. Okay, and here you can see I have to just use A double slash, like it's not divided, it's double divided by B. Okay, so we'll discuss about this, why exactly we use this floor division. Okay, so this is my addition operation. This is my subtraction operation, subtraction operation, and the next one is my multiplication operation, and this is my division operation, and this is my floor division. We'll understand everything over here, don't worry. Normal operation, I think you know it, right? It's basic maths. Then you also have which is called as modulus operation. Okay, so here I'm going to basically go ahead and write modulus underscore result is equal to A modulus B. So we'll discuss about this. So this is exactly my modulus results, or here I can write a modulus operation. Okay, and then finally you'll also be able to see that I will also use an exponential operation, and here I can go ahead and write exponential underscore result, which will be nothing but A to the power. To the power, we basically say like we use this 2 star to the power of B. Okay, so this is basically my exponential operation. Okay, perfect. Now let's go ahead and print this result. So here we have this. Then again I will go ahead and write print. Then again I will go ahead and write print. We'll copy this print multiple times because I need to display this results together. Okay, so now let me just go ahead and write the subtract result. Let me go ahead and oops, just a second, multiple results. So I will go ahead and paste it over here. And then we have our div result. We'll paste it over here. Then we have our modulus result. We'll paste it over here. Then we have our exponential results. We'll paste it over here. Okay. One floor division result is pending. So let me just go ahead and write it over here. Print, and I'll paste it over here. So here you can see addition is 15, subtraction is 5, multiplication is 50, division is 2.0, and floor division result is nothing but 2. Right. We will discuss about both of them by 2.0 and 2. Then you have modulus operation. Modulus basically means that it will try to just give you the remainder. Right. So here you can see 10 divided by 5 is like the remainder is 0. So that is the reason you will be able to see zeros over here. And when we do A to the power of B, right, 10 to the power of 5, we are actually going to get this value. Right. Now let's discuss more about this 2. Okay. This 2 operation. Let's say that I want to divide a number like 10 divided by 5. So I will be able to get 2. If I go ahead and write, let's say I will go ahead and write 21 divided by 5, and obviously you know the result, it is 4.2, right? But if I use floor division, then what will happen is that I will get the answer as 4. So whatever will be the floor value, right, lowest value, it will just remove the decimal and it will give you the output. Okay, so this is a basic example. Now you can perform various operations, and we will see. I'll try to create a calculator for you, and over here only I'll show you that particular project also, right, as we go ahead. Perfect. Now the next step we are going to probably discuss about is comparison operators. Okay, so let me just go ahead and write it down, and basically write it down as comparison operators. So guys, now let's go ahead and see some of the comparison operators. Now first of all, we will go ahead with double equal to. Okay, so we will be using double equal to. Now let's say that I'll go ahead and create a result, or let me just go ahead and define a variable called as A is equal to 10. Okay, and B is equal to 10. Now, if I want to probably compare these operators, right, what I can actually do, I can go ahead and write my result, and let me just go ahead and simply use a tuple. I'll talk about these brackets, and just let me write it like A double equal to B. If I don't even want to write like this, just go ahead and write A double equal to B. Right? If I execute it, I'll be able to get true over here. So this is nothing but it is a more of a equal to comparison where it will be comparing between two identifiers and what value it has. Right? It basically compares the value that is present within this particular data type. Okay. Then this is equal to operator. So here let me go ahead and write equal to operator, and you can apply it on various different data types. Let's say I have str1, my string 1. I have like Krish. okay, and str2 I have Krish, right? Same string, right? So capital Krish and Krish. Now if I go ahead and write str1 double equal to str2, then here you'll be able to see I'm getting true, right? Let's say if I use a small a, okay, then you can see that I'm getting a false. So this comparison is also with respect to case sensitive, right? So whatever data is present with respect to this, it is just going to compare it, okay? So this is some type of operations. The next comparison operation that we are going to discuss is nothing but not equal to, okay? So not equal to, which is denoted by this exclamation not equal to. Now if I go ahead and just write str1 is not equal to str2, so obviously based on this comparison you can see that this is exactly false because both of the strings are true, right? So that is the reason it is coming as false. Let's say if I go ahead and define again my string 1 and string 2, let's say I go ahead and define it as string 3, and then this will basically be my string 4. And now let me make this as a small character, okay? And let me go ahead and write str3 is not equal to str4. Now it should probably give me a true value. Why? Because both of them are not equal, right? So this was another operation that is not equal to, okay? Now coming to the next one, which is basically called as greater than. So this will basically be greater than. So this is again a comparison operation which we can actually use. Let's say, and this greater than operation, let's say I have a value like 45 is equal to 45, or let me just go ahead and run number 1, 45, number 2 is 55. Now if I go ahead and write number 1 is greater than number 2, right? So the answer may be false because number 1 is obviously small over here. So here you can probably see that I'm actually getting false, right? So this is one example of greater than operation. And similarly, if greater than is there, then obviously less than should also be there. So less than operation, which is denoted by this. Greater than operation is basically denoted by this, okay? Now in this case, if I want to execute less than, so again, if I go ahead and execute num1 is less than num2, so here you'll be able to see that I'm able to get true, right? You can also print this result. At the end of the day, I'm actually going to get a Boolean value itself because this is a comparison operation. And with respect to all the comparison operation, we are either going to get true or false, okay? Now this is fine. Like less than is there, greater than is there. Now obviously you also have something called as greater than or equal to, right? So let me just go ahead and write greater than or equal to, right? So here, let me just go ahead and show you one more example. Let's say that I have a number 1. Number 1 is equal to 45 and number 2 is equal to 45, okay? Now if I go ahead and put this condition, number 1 is greater than or equal to number 2. So I'm basically going to get the answer right over here as true because obviously this is equal. At least one of the condition is basically getting true, right? So if I go ahead and print it, you'll be able to see this, right? Now here you can actually see that yes, everything is working fine and I'm able to get true. Now, similarly, there is one more comparison operation which is nothing but less than or equal to. Now in this particular case, if I apply the condition less than or equal to 2, again I'm going to get true because 45 is equal to 45. So one of the conditions is getting matched less than or equal to, right? If I go ahead and probably let's say in number 1 I go ahead and write 44, then also it is going to be true because this condition is getting matched because number 1 is less than number 2, right? So over here this is another one operation, right? So just you got an idea about various comparison operation that we have actually done. Now let me do one more thing. Let me just go ahead and talk about logical operators, okay? So here I'm going to basically create a field and let's say I'm going to write logical operators, right? So one is that we have discussed about comparison operators. So let me make a cell over here so that for your reference purpose also it becomes easy, right? So for cell comparison operators, okay? Done. Perfect. So comparison operators, and here you have all the things, right? And now we are going to discuss about logical operators. Now logical operators basically means the three one is and, one is not, okay? And one is or. Right? So most common operation in logical operator is something like this. Now let me talk about this, right? In the case of AND, and if you know about digital logic gates, I hope in college at least some idea you have about it. In case of AND, when both A and B, right, are true, then only you'll be able to get the output as true. Otherwise, it will be completely false. What do I mean by that? Let's say I have two Boolean variables. One is X. Let's say it is true, right? Now in this particular case, if my Y is also true, right? Now if I go ahead and write, okay, let's say that I go ahead and create my result, and let me go ahead and write it as X and see AND operation we have to use Y, right? Now if I go ahead and print my result, you'll be able to see that I'm able to get true, right? Because both of them are true, right? But in this particular case, if I just copy this and paste it over here, and this case, now let me say that if Y is false, then if I go ahead and execute it, it's going to come false, right? Even though this may be true and this may be false, then also I'm able to get false. So in case of AND operation, right, always you need to make sure that whenever both the variable will be Boolean true, then only your output will be true, right? In the case of AND operation. Now let's go ahead and understand about OR operation. Now in the case of OR operation, only in the case when X and Y are false, then only we are going to get the output as false. Remaining all the time, if I keep it as true or false or true, sorry, this is AND, right? Okay, or. Now, anytime you'll be able to see whenever I keep X, either one of them is true or both of them is true, I'm always going to get the output as true. Otherwise, if both of them are false, I'm always going to get the output as false. So this is the most important thing with respect to the OR operation, right? And finally, you'll be able to see that I also have another operation which is called as NOT. And NOT operation is nothing but it is the reverse. It is just a reverse of a Boolean variable, right? What do I mean by that? Let's say I have X is equal to true, right? And if I go ahead and write not of X, then what I'm able to get, see, inverse of this X, right? So here I'm able to get false, right? So not is nothing but it is an inverse of any Boolean variable. So if this Boolean variable is false, then if I go ahead and write not of X, then I'm actually able to see that I'll be getting true, right? So here we have discussed various comparison logical operators. Again, it will be important for various arithmetic operations as such. One good code example, arithmetic or simple calculator we'll be designing, and you can probably check out this code, okay? So here you can see I'm giving float, enter first number, second number, and you're performing addition, subtraction, multiplication, float division, modulus, exponential, and here you're displaying it. So let's go ahead and execute this. So if I go ahead and write 12 and execute it, 4 executed. So here is what is my output, right? So I hope you were able to understand regarding operators. This was it from my side. I will see you all in the next video. Thank you. Hello guys, so we are going to continue discussion with respect to Python, and in our previous video we have already completed operators, and if you remember we have completed one complete section with respect to Python basics. We understood about variables, data types, and operators, right? Now we are going to go towards an amazing new topic in Python which is called as control flow. And in control flow we are going to discuss about conditional statement and loops. In this video we are going to focus more on conditional statement. So here is the entire video outline, what all things we are going to discuss. So first of all we are going to see introduction to conditional statements, then we'll go and understand what is if statement, how to write a statement with the help of Python, then you have else statement, then you have else if statement, then you have nested conditional statements. Along with this we will be implementing a lot of practical examples. I will be showing you multiple examples of real world use case examples, and then we'll try to solve that. Apart apart from that, the final thing is that we'll also see what are the common errors and what is the best practices that we should follow whenever we are using conditional statement with respect to if, elif, and else. Now let's go ahead and let's start our coding. First of all, let's understand what is if statement, right? And this is really important for you all to understand. And as I've always said, before you start any Jupyter notebook, make sure you select the kernel with respect to the virtual environment that you have created. Now, if statement evaluates a condition and executes the block of code within it if the condition is true. Okay, what does this basically mean? Let's say that I am writing age is equal to 20, right? And now if I am writing an if statement, after this if, we will be putting any conditions over here. Let's say if I write if age is greater than or equal to 20. So this is one of the condition, right? So this if statement is going to evaluate this particular condition. And if it is true, right, it is going to go inside this particular block, right? And obviously you know about indentation. Directly you'll be seeing that we'll be able to write the code inside the block. So here I will go ahead and write print. Let's say that I will go ahead and write age 18. And if the age is greater than or equal to 18, okay, and here I will go ahead and write 20. Okay, then I will say that, hey, you are allowed to vote in the elections, right? Something like this, vote in the elections. So here you can probably see the output, you are allowed to vote in the elections. What does this basically mean? When I started my if statement, first of all, the condition that I have written, this will get evaluated. And obviously here you can see the age is greater than or equal to 18 because I have assigned the age variable is equal to 20, right? Now since this is greater than or equal to 18, you'll be able to see that this entire condition will become true. This entire condition will become true. So it will go ahead and execute this particular statement, right? And this is a very simple way of understanding if statement. Let me repeat again. If statement evaluates a condition. So this is my condition and it executes the block of code within it if the condition is true. So right now this condition is true. So that is why it is basically getting executed. How do I say this condition is true or not? If I just go and execute in my new cell and if I see age is greater than or equal to 18, this is true. So if true, I am going to go inside this particular block. So this was about if statement. Don't worry, we'll be seeing a lot of examples. Now let me go ahead and show you the another conditional statement, which we basically say is else, right? Now what exactly is else? Okay. To define else, I would like to probably talk about this. Okay. And let me just go ahead and write a comment over here again. The else statement executes a block of code if the condition in the if statement is false. What does this mean? That if this statement is false, it is not going to go inside this block, right? So is there a way that I can probably move it into another block, right? So for that, we will be specifically using else statement. So let us go ahead and see one more example. So guys, now let's go ahead and see this else statement and how does it work, okay? Let me just go ahead and write age is equal to 16, okay? And now you know the condition if you really want to vote, right? So what is the condition that I have to write? If age is greater than or equal to 18, right? Then I can go ahead and print something like you are eligible for voting, okay? So this is my statement that I've written, right? Now let's go ahead and execute this. Right now, when I'm executing this, you can see that nothing is getting printed. The reason is very simple, because this statement has become false, right? And so you're actually coming outside the block, nothing is getting printed. But let's say I want to handle for this age in a separate way within this if clause, right? So what I can do, I can again go ahead and write else clause, right? Now inside this else clause, I will probably say print you are a minor. Okay, so this will be my else block. Now what will happen if I execute this? You'll be seeing that if this is false, what it is going to do by default, it is going to jump into this particular block, right? Because this is what my else condition is, right? The default condition at the end, right? If nothing is getting satisfied, just go and jump to the last else block and display this. So once I'm executing this, you'll be able to see that here you're getting an answer, you are a minor. So this became false. After this basically became false, it is going to the else block. Again, let me repeat. The else statement executes a block of code if the condition in the if statement is false. Okay, so here you get probably see this. Okay, now let me just go ahead with the next conditional statement, which is called as elif statement. Okay, now with respect to the elif statement, if I really want to give a smaller definition for this, what exactly is an elif statement? Now this elif statement allows you to check multiple condition. It stands for else if. Okay, that is the reason we say elif. Elif statement is there, but if you go ahead and see the full form, it is nothing but else if. Okay, and it allows you to check for multiple condition. Okay, now let me just go ahead and probably put some points over here. Let's say I'll show you some example. If I go ahead and write age is equal to 20. Okay, now let me go ahead and write if age is less than 13. Okay. I'm putting some kind of condition over here. Any condition you can put. You can go ahead and put an and condition or condition, whatever condition you want. So any conditional statements you can write it over here. And obviously you've seen this kind of statements, right? Where I'm actually putting some kind of conditions over here, right? Anything you can actually put over there. Now, if I go ahead and write print, if age is less than 13, I'll say, hey, you are a child. Okay, you are a child. Now, I want to check for other condition also. Let me go ahead and write elif. Now, elif age is less than 18. Okay, if the age is less than 18, then I will go ahead and say print, you are a teenager. Okay, you are a teenager, right? And then I will go ahead and write else. Finally, the else statement by default, this will get, if none of this condition is basically becoming true, this will get executed. Then if I go ahead and write over here, print, I'll say, hey, you are an adult. Okay. And now if I go ahead and execute it, what will happen? Which part will get basically executed? Whether this or this or this, right? So here you can probably see, if I go ahead and execute, you'll be able to see, hey, you are an adult, right? Now if I go ahead and write 17 as my age, right? So first condition over here you can see age is less than 13, which is obviously false. It will go to the next one. Else if it is not going to check multiple condition. Else if age is equal to 18, now here it is going to be true, and this is what it is going to get displayed, right? So here you can see you are a teenager, right? So this actually gives you an idea how this elif basically works, right? And elif allows you to check multiple conditions, right? Now, there may be a scenario where I really want to use nested conditional statement, and this is what we are going to discuss about, okay? Nested conditional statements, right? Now, in nested conditional statement, what all things you can basically do, okay? We can use a combination of if, else if, or else inside the block. Like, let's say inside this if clause, I can write another if clause, right? So here, let me just go ahead and write this particular comment for you. You can place one or more if, elif, or else statement inside another if, elif, or else statement to create a nested conditional statement, okay? Now, let's say, I will just give you some of the examples over here to make you understand like let's say I will give you a number. You need to tell me whether it is even, odd, or negative. Okay, something like this. These are my three conditions. Okay, let's say I have given my number. So let me go ahead and write input. Okay, so first of all, I will define my number. I will use int, and then here I'm going to use input, and here I'm going to probably say enter the number. Okay, I will go ahead and enter the number. Now, my first condition will be that I'll go ahead and check for positive and negative number. So if I go ahead and write if number is greater than or equal to 0, sorry, if it is greater than 0, then I can probably, okay, let me just go ahead and write. Then I can probably go ahead and print the number is positive, right? So here you'll be able to see that I am printing this. Okay. Now the next condition is that I need to check whether this number is even or odd, right? Now in order to probably check, I may write any numerical conditions over here. If number, I mean, I'll try to use any operators, right? If number modulus of 2 basically means if the remainder is equal to 0, that basically indicates that obviously this is an even number. So here I'm going to print the number is even, right? So here you can see the number is even. Else I'm going to probably print the number is odd. Okay. So here you can see what I have actually done. If this gets solved, that basically means we are going to say that hey, the number is even. But if this is not true, then it will go to the else block saying that the number is odd. So what is basically happening? Inside an if condition, I've written another if condition along with the else block. So this is what nested conditional statement means, right? Now there is also one more thing for this if block also, for the outer if block also, I can again write an else condition saying that else, and this time I will go ahead and print the number is negative. Okay. Or a better way will be that if I'm entering the number, I will just go ahead and write greater than 0. Okay. And here in the else condition, I will go ahead and write is 0 or negative. Okay. Now see, this is what nested conditional statement means. You can place one of if else or else if, elif, this kind of statements within another if clause or elif clause. Okay. Similarly, you can write another elif clause over here wherever you specifically want. But the order will be the same thing, right? You need to probably make sure that you manage all the indentation part. If you're not managing the indentation part, then you may get an error. Okay. So here you go over here, and now if I go ahead and execute this, you'll be able to see it is asking for me for a number. If I go ahead and write 12, I'll go ahead and press enter. So here you can see the number is positive and number is also even. Okay. Now again, let me just go ahead and execute. This time if I give 11, you'll be able to see number is positive, but the number is odd. The else part has got executed over here. Now again, if I go ahead and execute it, and if I go ahead and write -1, so here you can see the number is 0 or negative, which is basically going to the else block, right? Why this is going to the else block? Because I've given the number as -1. Now this is going to be false, and it is just going to jump to the else block, right? So I hope you are able to understand this in an amazing way. You got an idea with respect to if, else, and also you got an idea with respect to the nested conditional statement. Now let us see some very important use cases, and I'll just say that some practical examples that we are going to probably discuss. Okay. See, the errors can only happen when you are not doing the proper indentation over here, right? If the indentation is basically done in a proper way, then you should be able to write this if else block in a very efficient way. Okay. Now first practical example that I'm actually going to give you. Okay. You need to determine if a year is a leap year. What does leap year basically mean? Any year that is divided by 4. If the remainder is 0, that basically means it is a leap year. Using nested conditional statement. Now you can pause the video and you can start writing this, right? And you can see what it will probably give you and what it will not give you. Okay. Now let me just go ahead and write this. So first of all, I will go ahead and write year, and I will give this as an input. Okay. And let me just go ahead and say enter the year. Okay. Enter the year. Okay. Now next thing, if I will start my condition, if year modulus 4, right, is double equal to 0. Right. So here, see, understand this particular condition also. If year modulus 4 is equal to 0, right, then what I will do, see here also, I can also write like this. If number percentile modulus 2 is double equal to 0, I've used one additional bracket, so let me just remove this if you are getting confused with this. Okay. If it's double equal to 0, then I will also go ahead and put one more condition. If year modulo 100 is double equal to 0, right? So here I've used two nested if else clause, right? And if year modulus 400 double equal to 0, okay? So see how many nested if else we have actually done, okay? Now if this condition is basically, if this all three conditions is basically true, which is specifically for the leap year, what I'm actually going to do, I'm going to go ahead and write print this year, whatever I've actually given, right? Whatever year I've actually given is a leap year, okay? Is a leap year. So here is how I'm actually using the print statement, okay? I will take one more session with respect to the print formatting, okay? There are different ways of print formatting. So print year is a leap year, okay? Then I will go ahead and write in the else block. What if this is not true? What if these two statements are true but this is not true, right? Then I will go ahead and print this year is not a leap year, right? The same year is not a leap year, okay? So here you can probably see this, okay? Then let's say, fine, for this if it is false, I'm handling it over here. But what about this if? So for this, we will write another else statement, okay? And here I will also give one more condition saying that, hey, print year. And if this is also true, if year 100 modulus 100 is equal to 0, I will be saying that, hey, year is a leap year, okay? Is a leap year. I'm just trying to write it in a complex if else condition. And finally, if this condition is also true in the else block, I will go ahead and basically go ahead and write print year is not a leap year, okay? Done. So here you can basically see that if this condition is true, then also we know that it is a leap year. So for that further conditions we are applying this one, then again further we are applying this one. But if this is also not true, then we also need to handle in the else block, right? Now let me just go ahead and try it out. So here I'm just going to execute it, and let's say I go ahead and write 2022. Now obviously this will be not a leap year, but let's execute this. And here you can see 2022 is not a leap year, right? If I go ahead and execute it again, so let's go ahead and see 2024. If I go ahead and execute it over here, 2024 is a leap year, right? So this is one of the good amazing practical example. Now what I'm going to do is that I'm going to give you more assignments as we go ahead, right? We need to also understand what are the common errors and mistakes that we usually do if you have not written colon, if the indentation part is not done properly, then obviously this will be a problem, right? Now, let me give you some of the assignments which you should definitely do, okay? One is, please try to create a simple calculator, and inside the simple calculator program, you need to take an input from the user, perform different operations, what kind of operations you need to do. If it is plus, then by using if else condition, you will need to do it. So here I will just be, please make sure that first of all, before I show you the solution, you try to write the code from your side, okay? So here you can see, I will just go ahead and update this, just a second. Okay. So here you can probably see I have used float input into the first number, second number operation is either you can upload plus, minus, star, or division. You can also use modulus if you want, and then I've written all this condition. If the operation is equal to plus, then result number plus 1, this. Else, you'll be also able to see nested else if is also there. Else if number is not equal to 0, right? Just go ahead and see this. Whatever things we have discussed till now, I think you should be able to understand it, okay? So let me just go ahead and execute it. Let's say 12, I'll go ahead and press 24, I'll go ahead and press enter, and let's say I want to do plus operation. So here you can see 36.0, okay? So try to do this. One more example that I really want to give it to you, okay? Determine the ticket price based on the age. Okay, so this will be another one example. So I have multiple examples, but definitely do try it from your side. So I'm just putting so that you'll be able to practice it. Okay, So here you can see, enter your age, are you a student, yes or no? So if you are probably saying yes, then you'll be saying yes over here. So here are some of the conditions. If age is less than 5, price is free. Else if his age is less than 12, price is $10. If age is less than 17, and if it is a student, then price is $12. Else if $15, then just try to go through this, okay? And then you'll be able to understand it. So I hope you were able to understand this video. This was it from my side. I will see you all in the next video. Thank you. Hello guys, we are going to continue discussion with respect to Python, and in this video we are going to talk about loops. Already in our previous video we have seen a lot of examples with respect to conditional statements like if, elif, else, and we have seen multiple examples out there, right? Now in loops we will be discussing about what are the different types of loop we usually use in Python programming language, like for loop, while loop, loop control statements like they, continue, and pass. Then we'll be discussing about nested loops, and then we'll be seeing like all these things we will be seeing much more in with the help of practical examples and what are the common errors we usually face and how to avoid those errors. So all these things we'll be discussing in this particular video. So first of all, let's go ahead and work with for loop with a simple syntax. So in order to write a for loop, right, you need to understand what a for loop is. A for loop is a loop, right? It is used to iterate over a sequence of numbers. Okay, so let's say I will give one example like for I. Okay, I is just a temporary variable right now. In, let's say I want to create a sequence of numbers. Now in order to create a sequence of numbers, I will show you with the help of range. Okay, so what exactly is range? Okay, so let's say in this particular range I give 5 elements. I basically want 5 elements over here. So this is turn actually help us to generate numbers between 0 to 5, right? So here you can see that hey, I'm getting a range between 0 to 5 over here. And let's say I want to just display all these numbers inside this, right? Range is just giving us a sequence of numbers between 0 to 5. But if I want to iterate through this all the numbers, I can basically use for loop. So if I write for I in range 5, right? And here if I go ahead and print I, right? Now you'll be seeing that after every iteration, first of all, when we are looping inside this sequence of numbers between 0 to 5, first it will go ahead and display 0, then it will go ahead and display 1. That basically means after every iteration, this number is basically getting incremented and it is traversing through all this range of numbers. One important thing that you should understand that since I've used range between 0 to 5, the last number is not going to get included. So that is the reason you can see 0 is here, 1 is here, 2 is here, 3 is here, and 4 is here, right? But the total number of elements is 5 over here. And here, in short, I've spoken about for loop and range as a function. Okay, so range as a function is also given. Let's say I want to probably use for loop with different range of numbers, right? Let's say if I go ahead and write 1, 6, that basically means I want the number between 1 to 6. 6 is the last number, so we are not going to include it because at the end of the day, with respect to Python, whenever we are seeing indexing, right, it always starts with 0, right? So I'll talk more about it as I go ahead. Now, if I go ahead and execute this, here you'll be able to see 1 is getting displayed, 2 is getting displayed, 3 is getting displayed, 4 is getting displayed, 5 is getting displayed. So I can also call all my range of numbers with respect to by giving the numbers between one number to the other number itself, right? Now let me just give you more examples over here by using range. So if I go ahead and write range of 1, 10, and let me just go ahead and give some third parameter, right? So third parameter over here, you'll be able to see that it is something called a step. Now see the syntax. It shows start as the first parameter inside range function, then you have the stop parameter, then you have the step parameter. Okay. By default, step parameter is usually given as 1. Now start, I'm saying hey, start from 1 end till 10, right? End before 10. I'll not say till 10, but before 10, and use the step size as 1. That basically means only increment one number at a time. So if I go ahead and execute it, this will basically give me a range of value between 1 to 10, and the step size will be 1, right? Now let me just go ahead and make it 2. Okay, so here you can see that I'm starting from 1, before 10 it will stop, and here the range is 2. That basically means the 2 numbers will get incremented. Now let me do one thing. Okay, let me just write 1 over here, and let me use a for loop again for I in range of this, and let me go ahead and print I. Okay, now when I'm printing I, you'll be able to see that what I'm actually getting 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let me make this change from step size 1 to 2. Now what will happen? See, after 1, directly 3 will get displayed because we are going to skip one number. So it is just going to jump 2 steps ahead, right? Now see this. So now I can see 1, 3, 5, 7, 9, right? So I am not probably traversing to each and every number, but instead I've given a step size of 2, so it is jumping 2 numbers ahead. And that is how it is basically getting printed. Let me just show you one more example. Let's say that I want all the numbers between 10 to 1, but now this time I will use a step size of -1. Now what it is going to do? It is going to display a number between 10 to 1, and step size will be -1. That basically means after 10 it will become 9, then 8, then 7. See this? So here you can see 9, 10, 9, 8, 7, 6, 5, 4, 3, 2. 1 is not getting displayed as we know that last number will be skipped. Before this, all the numbers will be displayed. One more example that if I really want to show it to you. So here you can see -2. If I'm using -2, so 10, 8, 6, 5, 4, 2, 6, 4, 2, right? So I hope you have got an idea with respect to for loops and with the help of range how we can actually move. Okay. Now let me show you with respect to strings. I hope everybody has learned strings, right? So strings, how to probably create string. Let's say that this is my string. Okay, this is my string, and here I'm going to write Krish Nayak. Okay. Now if I want to traverse through this particular string, now see one amazing thing about this data structure called a string is that we can traverse to each and every character over here. So if I go ahead and write for I in str, okay, and for I in str, and if I just go ahead and print I. Okay, so string is basically a data structure. It is just nothing but it is a collection of characters, right? Now if I'm going to print over here, you can see krish, then again space neik, right? Let's say that I'm traversing through this particular string, and I also want to do something like I may have a sentence, I may have a paragraph. So based on that, also I can print it over here, right? Just to give you an idea what exactly this is. Because string is a collection of characters, right? It is a collection of characters, and we can also traverse it. So the for loop main functionality is that whenever you have any collection items, like any collection data structure, you can traverse through it very much easily by just using a for loop, right? So I've just given you an idea about it, but as we go ahead, we'll be seeing more complicated example as we go ahead, right? But just to understand the basic example, this is what a for loop is all about. Now let's go ahead and discuss about something called as while loop. Okay, so while loop. So now let's see something about while. So now I have while loop. Okay, now with respect to while loop, right? If I really want to give a small definition, this while loop is nothing but it continues to execute as long as the condition is true. Okay, that basically means unless and until this while loop, whatever condition I'm writing in while loop, it is true, it is just going to execute it. Okay, now let me do one thing. Let me create a temporary variable called as count. Okay, count. Okay, now with respect to this particular count, let me just go ahead and write while count is less than 5. Okay, and now I've gone inside my while loop, while loop over here. So I'm putting this particular condition unless until this count is less than 5. Just go ahead and print it. Okay, let's say I'm going to print the count. Okay, and after this, if I'm executing, see, I also need to increment the count over here. So I will go ahead and write count plus 1. Okay. So what I'm doing, unless and until this count is less than 5, I'm going to print the count, and for every iteration, because we have initially initialized count is equal to 0. For every iteration, I'm writing count is equal to count plus 1. Okay. Now see what will happen. If I execute this, you'll be seeing that 0 is getting displayed. Initially, I will be having 0. So when I write while count is less than 5, this is true. It is just going to print the count. So I'm going to get 0 over here, and then it is going to increment the count. Now my temporary variable count will have one value, right? I'll not say temporary, but my count value from this 0 has got incremented to 1. Then again, this while loop will run. Why it will run? Because this condition is still true, right? So now here you can see when 1 is less than 5. So 1 is obviously less than 5 in the second loop. So again, this will get executed. Then again, this will get incremented. Then again, it will go to the next loop. Then this will become 2, 3, 4. Then but once once it becomes 5, right? While 5 is less than 5, now this becomes false. It is just going to come outside the loop, right? So that is how you are getting displayed with 0, 1, 2, 3, 4, right? So this is a simple way of probably displaying or understanding about the while loop. Okay. I may also write something like this. While, okay, let's go ahead and write count is equal to 0. Okay. Count is equal to 0. While count percentile 2 is double equal to 0. Okay. So now see this condition. What I'm saying, while count percentile 2 is double equal to 0. If this is true, right, I will probably go ahead and print the count over here, right? Right. And let's say that I will go ahead and, or let me do one thing, okay? If I'm starting from count is equal to 0, and this condition is basically to check whether a number is an even number or not, right? So if I just go ahead and execute it, how many times this will get displayed? See, 0 is getting displayed over here, right? And it's continually getting displayed. I'll stop this, see, because I've not written any condition over here. So let me just go ahead and write count is equal to count plus 1, okay? Now, how many times it will get displayed? You just see this, okay? Only one time, because the next time it became 1, this count became 1, the 1 percentile 2 is not equal to 0, so it is just going to come outside of the loop, right, of this particular loop. This is just to show you an example over here, but we will be seeing with more amazing examples. First of all, let's go ahead and just see the basic syntax of for, while, and now we're going to go ahead with respect to loop control statements, okay? Loop control statements. You'll be seeing that, Krish. Please give more examples. Don't worry. After I probably make you understand all these things, then we will be seeing more examples as we go ahead. Okay. Now, with respect to the loop control statement, first of all, we'll discuss about something called as break. Okay. Now, if you really want to understand break, I'll just go ahead and write this definition. The break statement exits the loop exits the loop prematurely. Okay. What does this basically mean? I will just make you understand. Okay. Let's say I want to write a break statement. Now, how do I write a break statement? So first of all, let's say I'm going to run for I in range. Okay. Please make sure that you understand the syntax for I in range of the collection. This is nothing but this is collection. It can be a list, it can be a dictionary, it can be range, it can be string, anything it can be. And let's say I'm writing 10. So 10 basically means it is just going to iterate from 0 to 1. Okay. For one of the condition, I'll say if I is double equal to 5. Okay. If this I is equal to 5, I don't want to probably, or I want to come outside this particular loop. Okay. I want to come outside this entire for loop. So I will go ahead and just write break. Okay. And once we probably write break, okay, it is probably going to come outside of this particular for loop itself, right? Now one more thing. If I is not equal to 5, at that time we just need to print I. Okay. So now see, what is this entire code that I've actually written? For I in range of 10, if I is double equal to 5, I'm saying only when I is equal to 5, do the break statement comes outside of this particular for loop. When I is not equal to 5, you just need to keep on printing the numbers. Okay. So now if I go ahead and execute it here, you'll be able to see 0, 1, 2, 3, 4. Then when 5 came, automatically we came outside of this particular for loop. Okay. And then after that, nothing is getting printed. So we are exiting this particular loop permanently. Okay. Permanently with the help of break over here. But this break will only get applied on any statement, on any condition as such, right? So that is why we are specifically using this break statement. Okay. This is one of the good examples. Again, now with respect to the another loop control statement, we also have something called as continue. Okay. So now we will go ahead and write continue. Now what exactly continue is? Okay. And you also need to know this. If I really want to define continue, okay, continue statement skips the current iteration and continues with the next. Okay. So that basically means, let's say I'm going to write for I in range. Okay. For I in range. And let's say I write some elements over here 10. Okay. And now if I go ahead and write if I modulus 2, right, is double equal to 0. Okay. And this condition is basically just to check whether the number is even or not. If the number is even, let's say that I will go ahead and write continue. Okay. I will just go ahead and write continue. And then I will just go over here and print I. Okay. Now, in short, if I really want to make you understand, this is just like displaying all the odd numbers between 0 to 10, right? Do you agree with me or not? See what I'm doing over here. For I in range of 10, if I modulus 2 is equal to 0, that basically means this is an even number, we're just going to continue. Otherwise, if it is not, which is an odd number, we're just going to print it. So if I go ahead and execute this, you'll be able to see that I will only get an odd number, 1, 3, 5, 7, 9 between 0 to 10, right? And that is what is a continue example. With respect to continue, we are just skipping the current iteration. So just skip. It'll even not go to the print statement. It'll just go ahead and continue the loop, right? So this is what is the power with respect to the continue statement. There is also one more amazing flow control that we use that is basically called as pass. Okay, and you should know all these things because some of the other way we will be using all these things, right? Further when we'll be seeing multiple examples. The pass statement is a null operation and it does nothing. Okay, it does nothing. Nothing means nothing, right? It'll just say, hey, I don't want to do anything on a specific condition. Okay, so now if we go ahead and write for I in range of 5, let's say, okay, for I in range of 5, let's say I'm giving this particular condition. Okay, I'm saying, hey, if I is equal to 3, if I is double equal to 3, okay, then I'm saying, hey, just pass. Okay, do nothing. Okay, I don't want you to do anything over here. Okay, and then we are going to print I. Okay, now see what will happen. In this particular case, whenever I say, hey, whenever the number is even, just skip this for loop. But here it is saying, do nothing. Just go ahead, right? Just go ahead and skip it, right? Now if I go ahead and execute it, now see what is happening. 0 is getting displayed, 1 is getting displayed, 2 is getting displayed. When I is 3, again, I'm just saying, hey, skip it. So it just skip this if loop, right? Or the best way will be to print something like this. Okay, the number is, okay, I will write number is over here as I. Okay, now you'll be able to understand this. Now this pass, as soon as we do the pass, right? At that time, what will happen? First of all, see, when I is equal to 3, only this will get printed, and we're just going to skip this, okay, or do nothing as such. So here you can see 0, 1, 2, 3. The number is 3, 3, 4, right? Pass in, it's just like a null statement. Suppose I don't have anything to give over here, I'll just remove this, and I will just write pass. Do nothing as such. Okay. So this can also be useful, and again, we'll talk about it. What exactly will be the use case over here, right? But most of them, if I probably consider pass, continue, or let's say if I'm probably defining an empty function, and if I define an empty function, and if I internally write just pass, that basically means that the function does nothing. Okay. So this is some of the amazing things that have been brought by Python. If I talk about break, this will be very handy because on a certain condition, we're just going to break this or come out of this particular loop. We can use break. Then we have continue. Then we have pass. Right. Now let's talk about nested loops. Okay. So let's talk about nested loops. Nested loop is nothing but a loop inside a loop. Right. Let's say I will run a loop for I in range 3. Okay. And let's say for j in range 2. Okay. Now what I'm doing, and let's say I go ahead and print. And here with respect to the print statement, let me show you how you can use f string also. So f string is nothing but here I'm basically writing it out, and here I'll write I is equal to will be equal to I and j equal to it will be equal to j. Okay. So whenever we use this f string formatted statement to display the variables, we have to use this curly braces. And in short, this is just a formatting option of displaying the string. I can use this particular string together along with flower braces so that I can display that particular variable. Now what is exactly happening over here? See, it is very simple. over here, you'll be able to see for I in range of 3, right? I'm iterating through another range over here, another iterables over here. Then I'm also running another iteration over here, right? So there are 3 elements over here. So first it will run this, then it will go inside this, and it will complete the inner loop, right? Inner for loop. Then it will go to the outside for loop. So first time when it gets displayed, this is going to get executed for the 2 times. Then it is going to go and increment the I to 2. Then again it is going to run it for 2 times for this particular J loop. If you don't know, if you don't understand, see over here. I'll show you with respect to the output. So here initially you can see when I is 0, J is 0. Because initially when we are running this particular loop, right? And then when we go inside this particular loop, J will run for 2 times. So J is running for J is equal to 0, J is equal to 1. Then you have I is equal to 1, then again J is equal to 0, J is equal to 1. Then you when I is incremented to 2, J is equal to 0, and J is equal to 1. So it is basically going to run with respect to all the inner loops, right? And here this for loop, every time it will be executed based on the number of range that I've actually given over here, right? Whenever we enter the upper for loop itself, right? So this is just an example of for loops over here, nested loops over here, right? Now let us go ahead and see some examples, okay? And this is where we will practice multiple things. The first examples that we are going to do is that let's say I'm going to write over here, calculate the sum of first n natural numbers using a while loop, using a while and for loop. Okay, so let me just go ahead and first of all show you with the help of while loop. Okay, so first we'll see with respect to the while loop, and then we will go ahead and see with respect to the for loop. Okay, what we need to do, calculate the sum of first n natural numbers. Okay, first n natural numbers, very simple. So now I will just go ahead and say, let's say that the number of n number, the natural number is 10. Then initially I will define my sum variable to 0. This will be my temporary variable because the addition that I'm going to do with respect to all the natural numbers, I'm going to save it in this particular variable called as sum. Then I will keep this temporary variable called as count is equal to 1. Okay, now let's go ahead. Okay, so here I'm going to write while. Okay, count is less than or equal to n, right? Unless until the count is less than or equal to n, I'm going to just go ahead and I'm going to use this sum is equal to sum plus count, right? So what we are doing over here, we keep on adding the count, right? Unless and until this is not equal to less than or equal to n. And after this, we will go ahead and write count is equal to count plus 1. We are incrementing the count variable also. And finally, when this for loop is while loop is getting completed, I will write sum of first 10 natural numbers. Okay, natural numbers will be equal to nothing but whatever sum we are probably getting over here, right? Just go through the statements. Here we have initialized how many number of natural numbers we are going to consider. Initially the sum is equal to 0, count is equal to 1. Now I'm saying, well, count is less than or equal to n. I'm going to increment this count continuously unless and until this gets satisfied. Then automatically internally we are doing the sum also. Okay, so here you can actually see the sum of first 10 natural number is nothing but 55. Perfect. So there's just like 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, right? It'll not go, it'll go till 10 because we have written less than or equal to n. Okay, perfect. So this was one of the example. Let's do it the same thing with the help of for loop. So I will write, so let me just go ahead and define this 3 variables again. Okay, so let's say for I in range, and here also I can just go ahead and write till 11 because I want to probably do from 0 to 10. Okay, and here I'll just go ahead and write sum is equal to sum plus I. That's it, right? And here I don't even have to write this count is equal to 1. Okay, because automatically this will get incremented. So here let me just go ahead and print the sum, and if I go ahead and execute, I'm also able to get it 55. Okay, so here I've shown you with the help of both while and for loop how you can calculate the first 10 natural number sum, and here you're able to see it. Okay, now let me do one thing. Let me show you one more example. Okay, now this time the examples will be talk about the prime numbers or display the prime numbers between 1 and 100. Now, what is prime number? Prime number is something which is divisible by 1 or the number itself, right? Now, here I'll just go ahead and write it down. And again, for this, I will use a for loop. So I'll write for num in range of 1, 101, right? Because we need the numbers between 1 and 100, right? If the first condition will be that, I will go ahead and write if num is greater than 1, right? Obviously, the number has to be greater than 1. So one condition is over here. We're going to use if, nested for loops and all, right? Please pause the video, try it by yourself, and then probably see the solution, okay? Now, if this is true, then what I'll do for I in range 2, num, okay? For I in range 2, num, that basically means from this number, from 2 to this particular number, whichever number we are specifically discussing, or from this for loop, which number I'm able to increment, I'll just go ahead and write this particular condition. If num percentile I, right, I is the same number over there, right, is equal to 0, then we are just going to break it, okay, and then we are just going to break and come outside this for loop, and I'm going to say else print number, okay. You just need to print this because if this gets satisfied, right, this is basically indicating that hey, I got a prime number, right, and then it is just going to display the prime number. So again, I'm repeating. First of all, I'm going to check a condition if number is greater than 1. Then we are going to write for I in range of 2, num. Okay, 2, num. So we are incrementing the so we are running through this particular 2, num. Whatever num is there, let's say the num is 3. So 2, 3. For range in 2, 3, then we can go ahead and write 3 percentile 2 is double equal to 0. The answer is no, right? If it is no, we are just going to go ahead and display this number, right? And if it breaks, it is just going to go outside this particular for loop. Okay, so that basically means if this condition is becoming true, right, that basically means it is not a prime number. Otherwise, we are just going to display the number in the else block. Okay, and one more thing about for loop is that along with the for loop also you can write else block, right? Else block. If something you don't want to execute it, but you want to execute compulsory at the end of the for loop, so you can also use this else block. Okay, so once I execute this, here you'll be able to see 2, 3. So 2 is a prime number, 3 is a prime number, 5, 7 is a prime number, 11, 13, 17, 19, 23, 29. All these are prime numbers. You can probably go ahead and check it out. Okay, these are like numbers which are only divisible by 1 or the number itself, right? So here you can actually see the example. Okay, now some more examples that you will be seeing as we go ahead, where we'll be using when we'll learn more about different data structures like list and dictionary. But at the end, conclusion that I really want to give after every lesson, right? And let me make a markdown cell over here. Okay, so conclusion is that loops are really powerful. Okay, loops are definitely very, very powerful. Okay, in Python that allows you to execute block of code multiple times by understanding using for and while loops along with the loop control statement like break, continue, pause. You can handle a wide range of programming tasks efficiently, and you'll be seeing that when we'll be discussing about more examples. But I really want to keep the video between 20 to 25 minutes where I show you multiple examples where I write each line of code in front of you so that you'll also be able to understand. So yes, this was it from my side. I'll see you on the next video. Hello guys, so we are going to continue the discussion with respect to Python, and now we are going to start data structures in Python. Some of the most common data structures that are used in Python programming language are like list, tuple, sets, and dictionaries. So in the series of videos, we are probably going to discuss about all these topics. In this video, we are going to focus more on list. So let me just go ahead and show you what is the video outline. So first of all, we will go ahead and show you how to. I will go ahead and show you how to create a list. Then I will also show you accessing list items, modifying list items, some of the amazing list methods that we use. Then we have operations like slicing list. How do we iterate over list? By using for loop and all. Then along with that, we'll also be seeing list comprehension, and then we will be seeing about nested list. All these things will be covered with a lot of practical examples, and I'll also be talking about what are the common errors that we will be getting. So before I go ahead, first of all, let us go ahead and just see the definition of list. So here you can see list are ordered mutable collection of items, right? Ordered mutable collection of items. What does mutable collection of items basically means? Like all items that are present in list, we can actually change it, okay? And they can contain items of different data types also, right? So these are the two main properties with respect to list. First of all, they are ordered mutable collection of items, and they can contain items of different data types. So let me just go ahead and let me show you that how do you define a list. Let's say I create a variable called as LST, and if I use these two brackets, and before that, don't forget to select a kernel. So right now I've selected the kernel based on the environment that I've actually created. So here you can see over here when I write list with some this empty square braces, and if I go ahead and print the type of this variable, this will give us an empty list, right? So this is a class type of list. So in order to create a list, it is very much simple. You can just use this empty brackets, right? Now, if I want to add elements in the list, let's say that I want to go ahead and create it. Like I may have multiple names over here. Let's say I have Krish, I have Jack, I have Jacob, right? So this is basically a list of names, okay? I may also have other elements, like I may have 1, 2, 3, 4, 5, any number of elements. I may also have different data types of elements over here. So here, if I go ahead and print names, so it's giving me a name error because I did not write names. So here you can see that I'm able to get a list of elements, right? So this is how a list is. Let's say that I go ahead and create a mixed list, mixed underscore list list. And here, let's say my first is a number, second is a string, third is a floating point, right? And fourth is a Boolean variable, right? So I may define any type of data type, and I may also print this. So let me just go ahead and print mixed underscore list. So I hope you got an idea about how to probably create a list of items, right? So one is directly we are using this particular empty brackets, or you can also go ahead and add elements over here with respect to any kind of elements, any different data types of elements you can basically add. Okay. Now let's talk about accessing list items. How do we access the list elements, right? So let's say that I create a fruits, right? Let's say that I'm going to create a fruits element, like a list of fruits. Let's say like apple, it can be banana, it can be cherry, it can be kiwi, it can be pomegranate, okay? Or let me just write a simple, okay, let's go ahead and see. Cherry is already written. Apple, banana, cherry, kiwi. Okay, I'm not able to remember more fruits names, right? So let's just keep it till here, okay? Okay, fine. Finally, I got one. Guava, right? So I'm just going to go ahead and create this list of elements. So here is my list of elements over here. Now, let's say that I want to go ahead and display apple, right? So in order to display it, all I have to do is that just go ahead and write fruits. And here you can probably see that I can actually use indexing, right? So whenever we create the elements inside a list, okay, so here this first fruit is basically present in the 0th index, then this is present in the first index, second index, third index, fourth index. So similarly, all the indexes, when I probably say all the indexes in Python starts with 0. If you know about our programming language, all the indexes over there starts with number 1, right? But here we are specifically going to use 0 is the index over here, right? But if I really want to just display apple, right? So I will just go ahead and write fruit of 0, right? If I'm actually trying to print this, so let me just go ahead and write print fruits of 0. It is nothing but apple. Let's say I want to probably get fruit of in middle cherry, right? So this will become 0, 1, 2. So if I go ahead and write fruits of 2, so I will be able to get apple and cherry. And there's some amazing techniques with respect to indexing also. So let's say that I want to pick up guava, right? So I can also go ahead and write print. One way is that I can go ahead and take 0, 1, 2, 3, 4. So I can probably go ahead and write fruits of 4th index. I will be able to get guava. Now this guava can also be taken through a different way. So let me just go ahead and write. So let's say that I'm going to write print of fruits. Let me just say and show it to you over here. So let me just go ahead and write fruits of okay. And now in this particular case, let me just go ahead and write -1. Let's see what will happen. See, -1 is nothing but it is basically talking about the last element itself, right? So I think I should be able to get both guava, right? So this is the amazing thing with respect to fruits, right? This list, right? You're able to probably retrieve any fruit or any items inside this list just by using simple indexing. Okay. Now let me just show you one more way of printing some set of fruits elements. So if I go ahead and write fruits, okay, and if I just use the index 1, okay, I'll be able to get banana. So I'm getting banana 0, 1. I'm getting banana over here. But what if I have a requirement? I need to get all the elements from banana till guava, right? So if I go ahead and just make one simple change over here, right? What I'll do, I'll say write fruits 1 colon, right? 1 colon basically means from first index till the end index, because I'm not giving anything after the colon. So if I just go ahead and execute this, here you can see banana, cherry, kiwi, guava, right? So this is one way, right? Now let me do one thing. Let me just go ahead and print fruits 1 colon, and let's say I want to get all the elements till this kiwi index 1. So here you have 0, 1. So right, 2, 3, right? So now if I go ahead and write 1 colon 3, that basically means it's just going to pick up this first index, second index. It is not going to pick up the kiwi index, right? And now if I go ahead and display it, so here you can see banana and cherry is there. That basically means the third index is not getting picked up. Till the third index, everything will get picked up, right? So if I don't write any element over here, so it is just going to take it completely till the end, right? And here also what I can actually do, let me just go ahead and show you one more thing. So if I go ahead and write print of fruits -1 colon, right? Now if I go ahead and execute this, you can see -1 colon basically means from -1 element till colon, right? Till colon is till the end, and this is just my last element over there, okay? But if I just go ahead and write -1 to, let's say, second index, so here I can see that you have to please observe here. -1 is nothing but this specific element, right? 2 is this, right? But I'm not talking about all these elements. Now, if I go ahead and write -1 to -3 or -3, right? Now, here also you'll be able to see this indexing is obviously a little bit confusion. Okay? There's a little bit of confusion over here because when I'm picking up the -1 element, this is what it is giving us. But I'm saying from -1 to -3, right? So there is no such element. And we'll talk more about this kind of examples and how to do this kind of indexing also when we are further discussing about many things as such, right? Right now, don't worry about this, otherwise you'll get more confused over here. I'll just keep it like this. I'll remove this particular code for some time, and later on, when you'll be seeing in the series of videos, we'll also be talking about those kind of indexing. Okay. Now, perfect till here, I think we have learned many things over here. Now, what I will be showing you is that how you can modify the list elements. Okay. So let me just go ahead here and show you modifying the list elements. Okay. Now, modifying the list elements is very simple. Let's say that I want, this is my fruits, right? So this is my fruits. I want to make sure that I replace banana with something else, right? Now, banana, it is in first index, right? So if I go ahead and write this, it is in first index. Let's say from this, I want to probably change this into watermelon, okay? and now I will just go ahead and print my fruits, right? So in that specific index, I'm writing watermelon over here, and I'm actually displaying it. Now you can see my fruits has changed banana to watermelon, right? So this way, in the indexing also, you can directly go ahead and probably replace this particular values, right? So this is how you modify any elements that is present over here. Not only that, let's say I want to go ahead and write like this: fruits, okay, fruits, 1 colon, okay. So 1 colon is basically giving you this answer. Now if I go ahead and just write, hey, please replace everything with watermelon. Now if I go ahead and see fruits, so here you can see I'm getting this error. Let's see what is the problem. Watermelon. Okay. Now what it has done is that from this particular index, it has replaced with this particular word, right? But here it is not considered as a word. Instead, it's taking this as character by character. We will also be seeing how we can add word to word, right? So in list, you have some amazing methods like append and all. We'll be talking about it as we go ahead right now. Okay, just after this section itself, right? So this is one of the problems that we see, right? Now let me do one thing. Let me again use that same fruits over here that I've actually defined. Okay, but you understood the problem. What has happened over here? As soon as I said 1 colon, right? So from first index, it has just added WATR. So it is not just considered this as a single word. Instead, it's considered character by character and it is adding it. Okay, so let me just go ahead and define my fruits again. Okay, now let me just go ahead and discuss more about amazing thing that is called as list methods. Okay, now this list methods is quite beautiful. We'll see to it and we'll be learning more about it. Okay, now let's say I want to, as I said, right, I want to append an element inside this. Okay, I want to add one element at the end. Let's say. So for this, I will go ahead and write fruits dot append, and here let's say I want to append orange. Okay, now once I write that, basically means this will add an item. Okay, to the end. Okay, it'll basically add an item to the end. Okay, and if I just go ahead and print my fruits, you'll be able to see this, right? So now here you'll be able to see apple, banana, cherry, kiwi, guava, and oranges over here, right? Now let's say that I have a requirement that I want to probably append any element at a specific index. Okay, so let's say I want to add, let's say I want to add watermelon in this first index. Okay, and right now in the first index, banana is there. So what I will do, I'll say fruits dot insert. Okay, insert, and I will give the index number. The first element will be the index number, and the second element will be whatever item I want to put. Let's say banana. Okay, and then I'm just going to print fruits. So here you can see apple, banana, banana. Okay, banana was already there, I guess. Yeah, banana was there. Let me do one thing. Let me add watermelon also. Okay, so in first index, I'm just going to add watermelon. So here you can see apple, watermelon, banana, banana, banana because I've added one time, right? Let's say that I hey, 2 bananas are there. I want to remove this, so I will go ahead and write fruits dot remove. So remove is another inbuilt function that is present inside this. So here I'm going to basically write banana. Okay, and now if I go ahead and print fruits. Okay, so here you can see banana has gone right now, but we don't have one more additional banana. Okay, let's say I want to also remove and let's say see whenever we are using this remove, right, it is basically removing the first occurrence of an item, right? Now let's say I want to remove and return the last item. Return the last item. Okay, let's say I want to do this. What do I mean by this? Let's say I go ahead and use one amazing inbuilt function which is called as pop. Okay, now pop basically means it's just going to pop the last element that is present in that particular fruit, and it's going to return us, right? So here I'm going to write popped underscore fruit. Okay, is equal to, and let me just go ahead and print it. So I'm going to print it over here, and let me just go ahead and write pop fruits. Okay, and let me just print it. Okay, let's because at the end of the day, once I probably print this, and I'll also print the remaining items that are there in the fruits. Okay, so here you can see orange has been popped. Why? Because the last element in this list of fruits was orange. When orange was popped, from this particular orange got removed. Okay, remove and return the last element. That is how you can specifically do it, and for that we use an inbuilt function called as pop. Okay, now let's say that I want to get an index of any fruit, right, based on the name of the fruit. So if I go ahead and write fruits dot index, and here let's say that I want to use cherry. I want to get the index of the fruit called as cherry. Okay, cherry, and this will basically be my index. And let me just go ahead and print the index. If I go ahead and execute, you can see that cherry is basically present in 0, 1, 2, 3, third index. So I'm able to get the output. Okay. Again, one more thing is that let me just go ahead and do one thing. Fruit dot append, or I will try to insert in the second index banana. Okay, banana is already there. And now let me do one more inbuilt function. I'll just go ahead and write fruit dot count, and here I will just go ahead and write. So it should be count. I will just go ahead and write banana. Okay, and let me just print this. Okay. Now what is going to happen is that you'll be able to see it just count the number of elements, and obviously after inserting this banana, right now if you see inside my fruits, there are 2 bananas, right? 2 banana and banana. So it is just counting that how many number of items in this specific in this particular list it is there, right? So here I'm just showing you different inbuilt functions just by using a list of items, and here you can see I've shown you a lot of coding with respect to this. Okay, now I may also do something like this. I may sort this entire list of items. So if I go ahead and write fruits dot sort, so here you'll be able to see now if I go ahead and print this fruits, you'll be seeing apple, banana, banana, cherry, guava, kiwi, watermelon. So automatically based on, so in short, this will sort the list in ascending order. Okay, it's just going to sort all the list in ascending order. And finally, here you have fruits dot reverse. Reverse is another function which will reverse all the elements over here. Now, if I go ahead and do this, right, now you can see all the list of the elements will basically get reversed, right? So this is nothing but it reverse says the list. Okay, and just I'm showing you what all different inbuilt functions are basically present over here. Okay, and then finally, if I want to clear the entire list, I can go ahead and write fruits dot clear, right? And now if I use this inbuilt function, so this will remove all items from the list. Okay, now if I go ahead and print fruits. So here you can see I'm getting an empty list. So till now we have discussed about mainly if I go ahead and show you with respect to the video outline, we have understood about creating list, accessing list items, modifying list elements. Then we discussed about list methods. Now we are going to discuss about slicing list. So let's go ahead and discuss more about slicing list. So guys, now let's go ahead and talk more about slicing list. So before that, I will go ahead and make some cells. So there's a shortcut. Just press escape and A. You'll be able to create as many number of cells as you want. Okay. Now what I'm actually going to do is that I am just going to take this numbers. Okay. So I'm defining these numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I will just go ahead and write some print elements. Let's say print numbers 2:5. Okay. Now let's talk about more numbers. Oops. :5. Okay. I didn't close this bracket, so that is the reason it was giving me an error. No worries. I'll go ahead and write print numbers 5:, and along with this, we will also go ahead and see print numbers : 2. Okay. double colon. So here we are also learning about double colon. Single colon, I'm just giving you an idea about it, but we'll also see with respect to double colon, and then we'll also go ahead and print numbers double colon -1. Okay. Now just pause for a second and just try to imagine in your mind like what will be the specific outputs. Okay, and then we will discuss further. Okay. So here you can see 2:5 is very simple. 0, 1, 2 from 2 to 5 elements. So 2, 3, 4, 5 is basically getting displayed. 0, 1, 2, 3, 4, 5. So this 3 elements will get displayed. Colon 5, 1, 2, 3, 4, 5 will get displayed. So it is basically coming over here till 5. Then you have 6, 7, 8, 9 from 5 colon to till the end. Now this is very much important. Double colon 2. What does this basically mean? And double colon 2 basically means from all the elements from first. And this 2 will be taken as a step size, right? So we will jump 2 steps ahead. Like from here, we'll jump 1, 2, then 3 will get displayed. Again, jump 2 steps, 5 will get displayed from. Again, from this jump 2 steps, 7 will get displayed. Again, jump over here, 9 will be getting displayed. So double colon. See, if I really want to make you understand about double colons, I will go ahead and write double colon. Double colon basically means all the elements, right? Now, if I'm writing, okay, fine, let's give the step size as 1. Then also I'll be getting the same output. If I give the step size to 2, so double jumps will be happening, right? This is basically the step size. Then if I write 3, then again 3 steps, like from here 1, 2 jump, and third, whichever will be the element that will get displayed. So 4, 7, 10, right? So I hope you got an idea about it. Now double colon 1 basically means what? Okay, so double colon is nothing but it is all the elements minus 1. Okay, from previous, take all the elements 1 by 1 and display it. If I go ahead and again write something like this, let's say I go ahead and write numbers, okay, double colon -2, right? So from back every 2 numbers, right? It'll skip every 1 number and display the other number over here, right? So this is basically called as a slicing, and some of the operations will be involving slicing whenever we want to retrieve some results, we want to modify them, do something, right? So we can actually use it, right? Now coming to the next thing is iterating over list. Okay. Now I've already shown you how to iterate over strings. Similarly, you can also iterate over list, right? So for that also again, I'll be going and using for loop. Let's say I will go ahead and write for fruit in fruits, right? And I'll just go ahead inside and print all the fruit items that I have, right? So here one by one, right now no fruit items is present or what? Okay, I've cleared that fruits, right? So let me do one thing. Let me just take numbers over here so that I'll be able to see through it, right? For number in numbers, right? So numbers is also a collection over here, list of collection, list of elements. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is also there. Let's say I want to iterate all this list with indexes also. So I want to iterating with index. So for this, I can use for index comma fruit for index comma number in numbers. Now once I use these numbers, right? Obviously, see, if I'm directly using this number, I know this is a list. But if I want index information also, I have an inbuilt function in Python which is called as enumerate. Okay, and if we specifically use this enumerate, that basically means we are also going to get the index number. So if I go ahead and print index comma number, now you'll be able to see all the indexes. So this is my 0th index. The first element is present in the 0th index. Then I have 2 which is present in the first index, then 3 in the second index, 4 in the third index, 5 in the fourth index, 6 in the fifth index, 7 in the sixth index, 8 in the seventh index, 9 in the eighth index, and 10 in the ninth index. So I have all these things, and just by using this inbuilt function, you get an access of the index number also, along with the list of elements that are present in that particular list. Okay. So this is one amazing thing about you can also iterate over the list. You can also iterate along with the index, right? Now let's go ahead and talk about one more amazing thing, which is basically called as list comprehension. Okay. Now list comprehension. Now guys, let's consider that. I want to do something, right? I want to probably let's say I'll write a for loop for x in range. For x in range, let's say I'm going to write 10. And here, what I'm actually going to do is that I'm going to probably create a list element. Let's say I'm going to create a list empty elements, and then I will go ahead and write list dot append. And let me just go ahead and do this. Okay. So just imagine what I've actually done. Here inside this for loop, I'm squaring every number and I'm appending in this particular list, right? And finally, I can go ahead and print this particular list. Okay. So in short, this is a code that I've actually written to square every numbers inside this particular range of numbers, right? So I'm getting 0, 1, 2, 4, 9, 16, 25, 36, 49, 64, 81. Now see, imagine in this line of code, right? I've written 3 to 4 lines right over here. I first of all initialized an empty list, then I'm putting a for loop, then I'm performing the specific operation. What if I can perform this entire list operation, because everything is happening inside the list itself, and we are creating a new list also over here, right? Obviously, if you're creating more list, again new list over here, again playing with different elements, more memory will be required. So Python actually helps us to play with list comprehension. Now in list comprehension, it tells you that you can perform all this operation, right, within a list itself, right? So now see this, observe over here. Now I will go ahead and write for x in range 10, right? So here, if I go ahead and execute this, okay, right now it is giving me an error because it is invalid syntax. I get it. Okay. Now let's do this. Okay. So first I've written for x in range of 10. So this is basically iterating through this. Now the next thing is that what kind of operation I'm performing. So I want to perform x square. So here, if I go ahead and write x square. So list comprehension basically has 2 important things. What we want as an output and what is the kind of operation that we are doing, right? So see, this is doing some kind of operation, so that needs to be displayed, and this is basically my iteration. So both of them are combined. If I go ahead and execute this, you'll be able to see that in a single list, I'm able to get the specific answer. So here, what did I do? I did not have to create other list item or list elements as such, right? All I did is that I probably executed my code within a line of code, and what I really want is x square. I've written it in forward, right? Now let's go ahead and see more examples with respect to list comprehension. So guys, we have just seen one example, and I know that you may be having some kind of confusion. So it is a better way that if I really want to make you understand about list comprehension, first of all, let's talk about a specific syntax, like what kind of syntax we specifically use. Okay. Now the basic syntax. Okay, let me just make this as a markdown. Okay, markdown over here. Okay, list comprehension. Okay, and this is important, so that is the reason I'm also going to show you the syntax over here. Okay, first of all, the basic syntax. Okay, now basic syntax is nothing but it looks something like this: expression for item in iterable, right? So that is what we have done for item in iterable, which is traversing everything, and this expression is going to perform on all the single items. Okay, this is the basic syntax. Okay, now I may also have other option like with conditional logic. Okay, if I want to apply some logic over here, so with conditional logic, the expression looks a little bit different. Okay, and let me just show you this particular expression also. Okay, so here you can see expression for item in iterable. If condition also I can put. So I'm putting if condition over here. So any kind of conditional logic is there, you have to probably put it at the last. Iterate whatever iteration you really want to do, you want to put it in the center, and any kind of expression that you want to perform, you can put it in the starting. Okay. Now, based on this, we will try to see some kind of example. Okay. So, but remember this is super important. Okay, and you have to use with respect to this itself, right? So, let's consider one example. So, let me go ahead and write basic list comprehension. Okay. Let's say I want to do a square of all the number. Okay. Square of all the number. Okay. Square of a set of numbers. So, I will write for x or for num in range of 10, right? And for every of this number, I just need to do num square, right? Square. Done. Now, if I go ahead and print this, in short, what I'm actually going to get, I'm going to basically get the square of this number. Now, what condition I've applied over here? Basic syntax for item in iterable, and then I have expression. Okay. Now, coming to the next one. Okay. Let's consider with list comprehension with condition. Okay, a specific condition over here. Okay, and let's say I will try to find out from a list of elements which are basically even numbers. Okay, which are even numbers. Now, let's say if I go ahead and write in for loop for I in range 10. Okay, if I go ahead and write if I colon 2 is double equal to 0, right? Then what I have to do? Print, or I will probably create a list and I'll append all the even elements, right? So let's say I have created a list, an empty list over here, and now what I'm actually going to do? I'm going to basically write list dot append, and here I'm going to basically write my I, right? So finally, if I go ahead and print my list, you'll be able to see that all the even elements will come, right, till this particular 10 number, right? But here you need to see how do I convert this into list comprehension, and I showed you one expression with conditional logic. Expression is over here, for item in iterable is here, and if condition is over here. Now the same thing I will try to convert this into list comprehension. So I will write for I, or for num in range 20, okay, or 10, okay. I have to display the number itself, so I will write number. I don't need to even apply any expression. But here I will go ahead and write one if condition. I will say, hey, if num percentile 2 or modulus 2 is double equal to 0. Now this basically becomes my even underscore numbers, right? Now here I do not have to even create a new list, right? All I'm doing it in one single line of code. So this way my execution will happen quicker, right? It'll be faster. So I hope you are getting this as an idea. Okay. Now one more thing is there. Okay, one more very important thing is there, which is again a type of list comprehension you can basically say, which is called as nested list comprehension. So let me just go ahead and write it down. So here you have something called as nested list comprehension. Okay, and it is good to know all these things, guys. I'm trying my level best so that you'll be able to understand multiple things. Okay, so here you can see, and here you can see. Now, what is so different when compared to this? Okay, now here we are iterating through two different iterables. So for item in iterable 1, for item 2 in iterable 2, then we are writing an expression. So that basically means if I have two lists, and then on top of that two lists, I want to perform any kind of list comprehension, then I can use this nested list comprehension. So let me show you one perfect example. Okay, let me just go ahead and write it over here, and let me write it as nested list comprehension. Okay, comprehension. So let me go ahead and create my list 1, and this will be 1, 2, 3. Okay, or I'll take one more element 4. Let me say this is my list 2, which will be nothing but A, B, C, D. Okay, so these are my 4 elements. Now let me do one very simple thing. Okay, I will try to make a pairs of list 1 and list 2 elements. Okay, so first of all, I will iterate through list 1. So let me just go ahead and write for I in list 1. Okay, then I will iterate through list 2 for J in list 2. Okay, and then I have to pair it, right? Now for pairing, I'll be using a tuple. I've not discussed yet about a tuple, but I'm just going to take this I and J and pair it together. Okay, just write it in this way. Okay, now you can see, or if you don't want to write like this, you can also use list over here. Okay, let's see whether this will work or not. And now I'm just going to print pair. Okay, up here I've written pair. Okay, so here you can see 1, 1, B, 1, C, 1, D, 2, A, 2, B, 2, C, 2, D. So it is just doing all the pairing, 1A, 1B, 1C, 1D, 2A, 2B, 2C, 2D. So this is what is happening. First of all, this will iterate, right? With respect to one element, then it will iterate all the elements, right? We can also write this in this particular way also, right? But again, a lot of lines of code we really need to write. But this is really, really powerful, and here you can actually see with the help of nested list comprehension, we are able to do it, right? Now, in Python also you have a lot of inbuilt functions, right? So we can actually use list comprehension with function calls. You can create your own custom function and all, but right now I'm going to show you some inbuilt functions. Okay, so inbuilt function we'll try to see. So list comprehension with this. Let's say, and I'll show you the code over here. So here I have words like hello world Python list comprehension. Now see, everybody focus. So I'm writing for words in words, and I'm just saying length of word, right? So it's just going to give us the length of word over here, right? And how easily we are able to see this particular output, right? And this looks amazing, right? And most of the things are basically very much simple over here, right? Now there is also one more list comprehension technique where you can use else block also. So I will give you that as an assignment. Please make sure that you do it. But don't worry, as we go ahead and learn more about the tuples and all, there also we'll be covering more about it. But I hope you got an idea with respect to list comprehension, and this was all about the discussion with respect to list. And I think I tried my level best to cover almost each and everything. Okay, and at the end of the day, you really need to try more and more to understand more examples. Unless you don't practice, I don't think so you'll be able to do any perfection in this, right? So more examples, more things. But at the end of the day, I would like to give the conclusion of the session and probably talk about it, because list is something really important. So the list. So here you can see I've given some conclusion with respect to the list comprehension. Powerful and concise to create list in Python. They are syntactically compact and can replace more verbs looping construct. Understand the syntax of list comprehension will help you write cleaner and more efficient Python code, right? So yes, this was it. I will see you on the next video where we'll be talking about the next data structure. Hello guys, so we are going to continue the discussion with respect to Python, and in this video we are going to discuss about our next data structure, which is called as tuples. Already in our previous video we have seen about list, and we had written a lot of code. If you probably go ahead and show you, we had written somewhere around 54 lines of code. We understood about list comprehension, we saw different methods, operations, and many more things. Now in this session, what all things we are going to discuss. So I have actually given you the brief outline of the video. First of all, you're going to understand about tuples, how to create tuples, accessing tuple elements, tuple operation, what is this immutable nature of tuples, and what are some of the tuples, common tuple methods that are used, how to pack and unpack tuples, nested tuples, and all these things we are going to see with a lot of practical example. Now before I go ahead, first of all, let me just give you a small definition about tuples, right? So tuples are ordered collection of items that are immutable, right? So we'll understand about this particular meaning, which is called as immutable. If I talk about list, it is an ordered collection of items, and the items can be of any type, and they are mutable, right? But here it is something like immutable. They're similar to list, but their immutability makes them different. Now, first of all, we'll try to understand how to go ahead and create a tuple. So for creating a tuple, right, we have to just use these two empty brackets. So let me just go ahead and write it over here. So this is my empty tuple, okay? And just by using these two brackets, right, I will be able to create it, right? And if I go ahead and display the print, let me first of all print this empty tuple, and then we will also go ahead and display our type of this particular empty tuple. Okay, so here you have this. If I execute this, you can see this is an empty tuple that is getting created. In list, we use two square brackets. In this, we are just using this rounded brackets, right? And then over here, you can see that I'm getting an empty tuple, which is completely empty. And if I go ahead and see the type of empty tuple, it is nothing but tuple itself, right? Now, if I probably consider list, right? So list, if I also use like this, right? And if I go ahead and create an empty list, so I can also use this class directly and create an empty list, okay? So this I missed in my previous video, so I'm just going to show it over here. And similarly, if I want to probably create a tuple, let's say this is my tuple, I can actually go ahead and use the same type of class and create an empty tuple. So both the ways I'm actually trying to show you so that you understand both these ways, right? So here you can see when I'm seeing the type of this will be an list and this will be tuple, right? So you can also use this method in order to create an empty list or tuples, okay? Inside this also I can put up elements, it is up to us, right? Now let me go ahead and add some elements into this particular tuple, okay? Now how do I add this particular elements inside this particular tuple, and how to do that, we'll be seeing a lot of methods, but here what I'm actually going to do, let me just go ahead and directly create a tuple, and if I go ahead and write tuple, okay, and here I can actually give a list like 1 2 3 4 5 6, okay, and now this list will basically get converted into a tuple. So if I go ahead and display these numbers here, you can see that I'm actually getting a tuple, right? So that basically means a list can be converted into a tuple, and even a tuple can be converted into a list, right? So if I go ahead and basically write like this 1 2 3 4 5 6, right? So this is my tuple itself. Now if I go ahead and write list and I close this particular bracket, so here you'll be able to see that I'm able to get a list, right? List of elements. So both of the ways you can basically do the type conversion, okay? Now as I said, in tuples also you can, let's say I'm going to probably go ahead and create my mixed tuple. Here also you can use different data type elements. Let's say I want to use numerical, I want to probably use string, I want to go ahead and use a floating point number, I can also go ahead and use my boolean variable, right? So now if I go ahead and print this, then also this will get created. The tuple will basically get created, okay? Now this is a basic information about tuple, how you can actually create and how you can proceed, okay? Now let me do one thing quickly. Let me go ahead and explain you about the next thing that we are going to discuss. It is nothing but accessing tuple elements, okay? Now for accessing tuple elements, what all things we really need to do, that we will be discussing, okay? Like I want to pick up any elements as such. So right now let me just go ahead and see, this is my numbers. Now here you can see that this is in the form of tuples. I have 6 elements. Let's say I go ahead and write numbers of 0, okay? Or let me just go ahead and write it in the len line. Next slide. So if I go ahead and write numbers of 0, so here I'll be able to see first element over here. This is my first 0 thing. I'm able to see it over here. Then I have 2 over here. Also you can see I'm able to pick up these elements, right? Similarly, if I go ahead and say that I'm just going to print this, okay? I want to pick up the last element, okay? Last element. Either you can directly write the index, or what I'm actually going to do, I'm just going to use -1, right? So I'll be able to get the last elements. Again, the indexing will be almost similar like a list. Even the slicing operation will be also similar like a list, okay? So let's say I go ahead and write numbers, and here I'll cite 0:4. That basically means I'll be able to get the element between 0 index till the third index. So same slicing operation, whatever things we have actually discussed. Similarly, if I go ahead and write numbers with double colon, right? I'll be able to see it. If I go ahead and write double colon -1, I'll be able to get the reverse of all the tuple values, right? But the return type will be always tuple, okay? So all the indexing and the slicing operation that we have actually done with the help of list, similarly you can actually do it with the help of tuples, okay? Then let's go ahead and see tuples operation. Tuple operations, okay? Now tuple supports various operations like concatenation, repetition, and slicing, okay? So we'll be discussing about that. Let's say I have numbers, 1 tuple, okay? And I'd also created another tuple which is called as mixed tuple, right? So this is what the elements, right? Now what if I just go ahead and write something like this, numbers plus mixed tuple, okay? So here in short, this is an arithmetic operation, but since we have 2 tuples over here, I will definitely say this as a concatenation, right? Concatenation basically means combining 2 things, right? So here you'll be able to see, I will just go ahead and write concatenation underscore tuple, and I will just go ahead and concatenate this. Now if I go ahead and print this concatenation, right? Concatenation tuple, you'll be able to see that I will be getting something like this. Now all this tuple, both the elements of this particular tuple has been combined. So I have 1 2 3 4 5 6, then 1 hello world 3.14 and 2, okay? Now let's say that I want to perform some operations, right? Let's say I want to go ahead and write something like this, okay? Repeat it, or let me do one thing. Let me just go ahead and create this. So I will just go ahead and do, okay, or I'll take this mixed tuple, okay, and I will just try to multiply with an operation 3. Now see what will happen. So here you can see mixed tuple had 1 hello world 3.14 and 2. Now this has got entirely repeated 3 times, right? So in this kind of multiplication operation, what is basically happening is that the entire tuple is basically getting appended 3 times, right? So that is the reason we are basically doing an operation over here. So so this is what is something different with respect to the calculation that we do. Now you may be thinking, Krish, what about if I try to do this with numbers, right? Numbers multiplied by 3. So here also the same thing will happen. So 1 2 3 4 5 6, 1 2 3 4 5 6, and 1 2 3 4 5 6. You may be thinking, Krish, wasn't it like you have to probably multiply all these numbers? That also we can do it, but we have to iterate it inside this particular tuple, get each element, and then perform the numerical operation. Okay, but right now with respect to generic concatenation and this kind of operation, here you can see that 3 times, n number of times based on this multiplication that we are doing, that many number of times this tuple will get appended with respect to the element. Okay, so these are some of the basic operations. Now let's go ahead and discuss about immutable nature of tuples. Okay, this is important, of tuples. Now, in the immutable nature of tuples, you need to understand one thing, and that is the first point that you have already learned, right? Tuples are immutable, okay? Meaning the elements cannot be changed once assigned, okay? Let's say that I go ahead and create my list, and I go ahead and write 1, 2, 3, 4, 5, right? Now, let me do one thing. List of 0, or if I go ahead and print this specific list, I will be, okay, there is an error, don't worry. Okay, so here you can see I'll be getting the specific element. Now, let's see this, okay? Now, what I'll do, I will go ahead and take the first index and replace with it Krish, okay? Now I'll go ahead and print the list. Now see what will happen. So here we are changing the element, and this second index or this first index element is got replaced with Krish. So this basically means lists are mutable. That basically means the element can be changed once assigned. Now similar operation, if I try to do with the same numbers that we had, right, in the form of tuple, if I go ahead and say, hey, number of 1, what is number of 1, 2? If I try to assign some value, let's say I try to assign a value called as Krish. Here it says that, hey, tuple object does not support item assignment, and this is what immutability comes into picture. Tuples are immutable. The elements cannot be changed once assigned. Okay, so here you can actually see what I exactly mean to say, right? And this is very much important. That basically means once you have defined a tuple, you cannot change the element inside that. Okay, once it is assigned. There are ways how you can do it. First of all, you can take the tuple, convert into a list, and then change the element, and then finally convert back again to the tuple if you want. Okay, that is how you can actually do. Okay, but by default, you'll be seeing that tuples are immutable. Perfect. So till here we have understood. Now let's go ahead and discuss about tuple methods. Okay, and now in this tuple methods, we will be seeing 2 important methods in tuple. So let's go ahead and see this. So let's say this is my tuple number. So one of the example that I would like to show you, one of the method that is commonly used with tuple, and there are only 2 methods that we specifically use. Okay, numbers dot count. Okay, let's say I want to count how many number of times 1 is present. Okay, so let me just go ahead and see this, and it is only present 1 time. Let me just go ahead and make a code over here, and let me just display the numbers. I have 1 2 3 4 5 6. Okay, so this count function is like it will just try to count how many number of times the element that I've given over here is present in the specific tuple. And the next thing is that I will go ahead and print numbers dot. Let me just go ahead and do one function which is called as index. Now let's say I want to understand what is the element present in the index third, right? And if I go ahead and execute here, you can see that in the third index 0, 1, 2, 3, right? Or sorry, what is the element, like where is this third element present? Like in which index this third element is present, right? Or this 3 is present. Again, let me repeat it. Numbers.index. Index is a function over here, and with respect to index, what it does is that it returns the first index of the value. Okay, whatever value I'm actually giving you, it is just going to return the index of that value. So here you can see 0, 1, 2. So 3 is basically present in the second index. Okay, so I hope you got this two methods easily and you have understood it. One is count and one is index, and these are the two common methods that I specifically use with tuples. Okay, now let me talk about one amazing thing. Okay, and that is basically called as packing and unpacking tuple. Okay, packing and unpacking tuple. Again, this will be really handy whenever you are developing projects and whenever you are writing the code, right? So let me just go ahead and write packed underscore tuple is equal to, and I will define the elements like this: 1, comma, and let's say this is my string. So this will be like hello. Then I have 3.14. Okay, and I'll just go ahead and print my packed underscore tuple. Now once I do this, here you'll be able to see that I'm able to get it. Now whenever I define the numbers in this way, like comma separated, right? By default, what it is going to do is that whatever number of elements that I've given, it is going to pack them in a tuple itself, right? So that is the reason we say it as we are packing a tuple whenever we get this. Now, how do we unpack a tuple? So this is with respect to packing, okay? Packing. But how do we unpack it? So unpacking a tuple, and how do we do it? So here we know that there are 3 elements inside this tuple. Let's say I have 4 elements or 5 elements. Let's say in this case there are 3 elements. So I'm just going to create 3 variables. Let's say ABC is equal to, and here what I'm actually going to do, I'm going to use the same packed tuple. Okay. Now what will happen if I go ahead and print A? Okay, and let me just go ahead and print B. And similarly, let me just go ahead and print C. So here you can see 1, hello, and 3.14, right? So you're able to see this. And this is nothing but it's called as unpacking a tuple, right? Now, there is also some very important things that you really need to understand, okay? With respect to unpacking, we can also use star, okay? So let's say unpacking with star. Again, this is something new that you'll be able to see as new Python version will be coming. Some of the amazing features. So let's say I have a numbers, and in these numbers, I define a tuple, 1, 2, 3, 4, 5, okay, and 6, okay? Now, let me do one thing. I will create one variable like this, and I use star. Let's say star will be middle, and my third variable will be last, okay? Now, why I'm creating this, you'll be able to understand. Now, see, if I go ahead and display the number, I'll just go to assign this particular numbers over here. Now, let me just go ahead and print first. Then I will go ahead and print middle. Okay, sorry, I'll remove the star over here. I'll not require star. And then finally, I will print the last element. Okay, now see what will happen. Over here, I know 6 elements are there, but I'm just using 3 variables just to unpack, and I'm unpacking with 1 star. I'm using in the middle variable 1 star. Okay, now see what will be the output. Okay, so the first one has given me 1. This is fine. Now the middle star, what it is done, right? The star middle, it is taken all the remaining elements till the last element. See 2, 3, 4, 5, and the last number is basically giving you the 6th, right? So what the star does is that from wherever you're probably starting, right, till the last element, right, before that last element, all the elements will be picked up. Okay, so this was about unpacking. 3 variants I've actually shown you: packing, unpacking a tuple, and unpacking with a star. Okay, let me just go ahead and create more cells so that you'll be able to will be able to execute more code. Okay, now let's go ahead and see some example for nested tuples. Okay. Tuples inside a tuple is basically called as nested tuples. List inside a list is also called as nested list. So let's say if I go ahead and write like this, I can go ahead and create any number of list inside a list. Okay. Let's say I have elements like 1, 2, 3, 4. Here I have 6, 7, 8, 9, and let's say I have 1, 1, hello, hello, 3.14, C. Okay. Now this is what? This is list inside a list, right? So here is an example of nested list. Okay. Because see, I did not take in the previous session of list. The reason is only that whenever is the right opportunity, right, we should include this topic over there, right? And that is how you'll be able to understand all the other topics itself, right? Because whatever operation we specifically do in list, similarly only we also do it in tuple also with respect to accessing elements. And the difference is immutability and mutability, right? Now let me just go ahead and write list of 0. Now list of 0 basically means what? This is my 0th index. This is my first index. This is my second index. Okay. So if I'm writing list of 0, you will be able to see that I'm able to get 1, 2, 3, 4. But let's say that I want to pick up third element. Now to pick up third element, what I really need to do, I have to use another index. And this time, this will be nothing but 0, 1, 2. So this will basically belong to my second index, right? So here you can probably see that I'm able to get the third element, right? So this is some common example, right? Let's say I want to also use slicing operation. I want to get the elements between 1 till 4. Okay, so I can also go ahead and write like this: 0 colon 3. Okay, if I go ahead and write it, so see, I'm able to get 1, 2, 3. So slicing operation can also be applied in nested list. Okay, list within a list. Okay, and it is not like only you need to have a list. You can also have tuples. You can also have multiple things, right? So let's say I am going to probably go ahead and define this as tuple. Okay, tuple. Okay, or let me just show you another example so that this code remains, and I'll paste it over here. Okay, and let me do one thing. And here you have this. And here you have this. Okay. Now, if I'm executing this, let's say I want to probably get from my second index 0, 1, 2, okay, second index. And let's say I want all the elements between 0 to third index. So here I'll be able to get 1, hello, and 3.14. So inside a list also you can have tuples. Okay, it is up to you, however you want to create. But whenever we talk about nested tuples, let me just give you one basic example. Here we are just going to create tuples inside a tuple. So I have 1, 2, 3, ABC, true, false. Okay, so these are my tuples over here. Now we will try to access the elements. Access the elements inside a tuple. Okay. Now let me just go ahead and write print nested underscore tuple of 0. So if I go ahead and execute it, I'm able to get 1, 2, 3. Okay. If I want to just pick up C, let's consider that I want to just go ahead and pick up C. Then how do I write? I'll go ahead and write print nested underscore tuple, and here I'm going to specifically write first index, right? First index will basically get me all the elements over here, and this will be my second index, right? So here if I go ahead and execute it, I'm able to get C, right? I can also iterate through this nested tuples, right, by using a for loop. So iterating over nested tuples. Okay, and here you'll be able to see for sub underscore tuple in nested underscore tuple. Okay, I'll first of all go to the nested tuple, and then I'll take the item in the sub tuple, and let me just go ahead and print it. Let's print the item one by one, right? So print item, and here I'm just going to write end is equal to with a blank statement, so that whenever it is printing, it should print along with this blank a new line also. So now if I go ahead and execute, see, first tuple is basically getting printed 1, 2, 3, ABC, and then true and false. So that is what I have, right? So this was example with respect to tuples. We have seen different operations. We have seen about packing, unpacking. We have seen the inbuilt methods. We have seen why do we get an error, what is immutability, everything we have actually seen, and we have also seen some of the examples with respect to list, right? But overall, if you probably see, right, tuples are a kind of data structure. Again, it will be specifically used when you do some kind of data analysis and all. Some or the other way, whenever you're writing the code and all, you will be using this tuple extensively. Now, let me do one thing. Let me go ahead and finally write the conclusion so that you have this conclusion in mind where all tuples are. Tuples are versatile and very useful in various in many real-world scenarios where an immutable and ordered collection of items is required. They commonly use in data structure, function arguments, and return values as dictionary keys. Understanding how to leverage tuples effectively can improve the efficiency and readability of your Python codes. So I hope you like this particular video. This was it for my side. I will see you in the next video where we will be learning about the next data structure that is called as sets. Thank you. Take care. Bye. Hello guys, so we are going to continue the discussion with respect to Python, and now we are going to discuss about our new data structure which is called as dictionaries. So in this video, this is the entire video outline where we'll be discussing about the introduction to dictionaries. We will be creating dictionaries with the help of Python, how to access the dictionary elements, modifying dictionary elements. Then we'll be seeing some of the amazing dictionary methods that we usually use while we are developing projects. Along with that, we'll also be iterating over dictionaries. Then we will be discussing about nested dictionaries, then dictionary comprehension, and finally, we will be seeing some of the common errors that we usually face. Now, in this, it is very much important that we probably do a lot of practicals. So that is the reason I will be showing you each and everything with the help of coding. Now, let me go ahead and first of all, let's see the definition of dictionaries. So dictionaries are nothing but it is an unordered collection of items. They store data in key value pairs. Okay, so there all the data is basically stored in key value pairs. Key must be unique and immutable. So once you specifically define a key, it cannot be changed. Values can be changed, and a key must always be unique. Okay, and it can include strings, numbers, or tuples, which while values can be of any type. Okay, so let me just go ahead and I hope you have just understood the definition. But again, to make you understand much more in a better way, first of all, we will go ahead and discussing about creating dictionaries. Okay, now with respect to creating dictionaries, first of all, what we are really going to do over here is that create an empty dictionary. Now already you know if I use square braces, okay, and before that make sure you select the kernel. So if you are basically using this square brackets, then you basically create an empty list. If you are using tuples, you create an empty tuple. Now in case of dictionary, we use flower braces. Okay, now let's go ahead and define and create our empty dictionary. So here you can see if I go ahead and print type of empty dictionary, you will be able to see that I will be getting a class which is called as dictionary. So in order to create an empty dictionary, all we have to do is that we have to specifically use this flower braces. Okay, another way how we can actually create our empty dictionary is that by using this dict class. Okay, and here we will initialize it as a method. So once we initialize it, here you'll be able to see now again I will be getting a complete empty dictionary. Okay, so right now it is a complete empty dictionary. So these are the two ways of specifically creating an empty dictionary. Now as I've already said that dictionary is all about key value pairs, right? Now whenever we talk about key value pairs, let me just give you an example. So key. So initially we'll start writing in this flower brackets. So first of all, what we're going to do is that we are going to give my key name. Let's say one of the key name with respect to student information is name. And let me just go ahead and write the name called as Krish. Okay, so Krish is the name. So this basically becomes the key. This basically becomes the value. Okay, now the next thing is that I will go ahead and use my another key which is called as age. Okay, and here we are specifically going to use a value, let's say 32. Okay, third, I'm just going to use another key which is called as grade. Now if I go ahead and write this, you'll be able to see if I go ahead and print the student, this is a complete dictionary where I have three keys, that is name, age, and grade, and the values are Krish, 32, and 24. Now if I go ahead and print the student, so this basically becomes my entire dictionary, right, which has this key value pairs. If you want to also check out the print of type of student, you will also be able to see that I'm able to get a dictionary over here. Okay, so this is how you specifically create a dictionary with the help of key value pairs. Okay, now let me just show you one more thing here. When do you get an error? Because as I said you, that key should be unique. Okay, so let's say if I go ahead and copy this and paste it over here, and again I use the same name. Now what is going to happen? Okay, and I'll just go ahead and print student. Let's see what is going to happen, because you really need to understand whether we'll get an error or whether it will just print out. So here you can see only two keys are basically getting their name and age, right? Name is having the value of 24, age is 32. Now what has exactly happened over here? Now when I'm writing name is equal to Krish, this was one of the key that I have already defined. Now if I'm again defining this particular key, you know, in the upcoming like in the key value pairs, then what it is going to do, the value is going to get replaced. Okay, but it is going to consider as one key itself. So which is the recent value that you have replaced over here, the value that is what is getting displayed. So always please make sure that here you don't have to always create the key with the same name. I'll not say this as an error, but here you can see that I can just write single key is always used. Okay, instead of multiple keys. So this is one super example, and this will be very much important because see, if you know about databases, now NoSQL databases like MongoDB, like Cassandra, over there, all key value pairs will be specifically used, right? All your data will be stored in key value pairs. So it is important that we always need to have this key unique, right? Now let me just go ahead and let me talk about accessing dictionary elements. Okay, now with respect to accessing dictionary elements, now what I'm actually going to do, let me just go ahead and make this as I'll just copy this. Okay, and let me copy this over here. Oops, not here, sorry, here, and let me just make this grade as A. Okay, now this is my entire dictionary, right? Now if I want to access any value, let's say I want to access the value of grade. Okay, now how do I do it? We definitely have to use this key. So what I will be doing is that I will just say student of, I want the grade of this particular student, so I will just give the key name over here, and let me just go ahead and print it. Okay, so here once I do the print over here, right, I should be able to see the grade. Similarly, let's say I want to go ahead and get the age, so I will go ahead and write student of age, right? And if I go ahead and print it, it is 32, right? So this is one of the method of accessing. I'll write it down over here, accessing dictionary elements. Okay, this is one of the easiest way to probably do it. There's also one way where we'll be able to access the values using the default get method that is provided by the dictionary. Okay, get method that is provided by dictionary. Now how to do this? I will just show you. Okay, so first of all I will just go ahead and write print let's say I want to get the grade, right? What is the grade of this particular student? So I will just go ahead and use dot get, and here I'm just going to give my key name, that is dot grade. Okay. Similarly, let's say if I want to go ahead and print student dot, and let's say I want to probably let's say that there is no, like, over here the key that are available are name, age, grade, right? Let's say I will go ahead and search for last name. Okay, I know the key is not present over there. So let's see what is the value that I will be getting. Okay, and by using get, we will be able to get the value anyhow. But if I execute it here, you'll be able to see first student grade, I got A, student age, I got 32. Again, when I'm writing student.get of grade, I can get A. But when I'm searching for last name, I'm not getting anything, right? I'm getting it as none. Now let's say that if I don't find any key, I want to probably give a default value. So for that, I will go ahead and write print student dot get. Okay. And here I'm going to specifically write last underscore name. I know last number underscore name key is not available, but I will give a default value if it is not available. So I'll write not available. Now let's see the value that we're going to get. So see, over here last name was not present in this particular key, so I'm getting the default value which I have provided it over here as not available. So before it was giving us none, now it's probably giving us not available, right? So this is how, with the help of key, you will be able to access it. And two ways I've actually shown you how to access dictionary elements. Either you're directly calling the key, or you're using the get method, right? Now let me just go ahead and let me talk about the next method that is called as modifying dictionary elements. Okay. Now with respect to modifying dictionary elements, one very important key that I really want to write, right? Dictionary are mutable, right? So you can add, update, or delete elements. Okay, so this is the most important thing about dictionary. But you cannot like all time your key needs to be unique, right? At any point of time. So let me just go ahead and show you some of the examples over here. So let us go ahead and discuss about modifying dictionary elements. So here already let us go ahead and print this students, right? And here you can see the name is the key name is basically having the value Krish. Age is 32, grade is A. Now let me do one thing. Let me just go ahead and add a new key. I'll also be showing to add a new key and also updating, let's say, age. So here now, if I go ahead and write student of age, and let's say the age is now 33, okay, and I'm just going to print the student. Now along with that, what I'm actually going to do is that I'm going to add a new key, and the new key will be something like address, okay. And let me just go ahead and write the address as area, okay. So this is the new key that I'm specifically adding. Now I will go ahead and print the student. Now here you can actually see that the first key age has got updated to 33. Now once it got updated, I again added a new key over here, which is called as address. So now I will be able to see the address area that has been added to the same student dictionary. Okay. Along with this, we can also go ahead and delete any key, right? So what I'm actually going to do is that I'm going to delete the key over here. Okay, let's consider that I'm going to delete the grade key. So let's go ahead and see that. So here, what we have actually done, we have updated the value for the key, right? Here we have added a new key and value, and in the next statement, what I'm actually going to do is that I'm going to delete the key. So in order to delete the key, I just need to use this del keyword, okay, that's available in Python, and I will be using the student, and let me just give the key name. So if I go ahead and write like this will basically delete the key and value pair. Okay. Now if I go ahead and print the student, you will be able to see that I will now have the entire key, right, grade has got deleted along with the value, and I just have the remaining key, that is key value pairs like name, Krish, age 33, address, area. Okay, so this is how you delete the key value pair. So these are some of the operations and how you can modify dictionary elements. Okay, now let me just go ahead and show you some of the common dictionary methods that we use. Okay. Now you'll be also seeing more examples because after this I will be also showing some use cases examples. Okay, so there again we'll be discussing more about dictionaries. Okay, now some of the important dictionary methods. Okay, so first of all, let me just go ahead. Let's say you just want to get all the keys of that particular dictionary. Okay, so I will go ahead and write keys is equal to student, which is my dictionary, student dot keys. Okay, and let me just go ahead and print all the keys over here. Okay, then let me just go ahead and write values is equal to student dot values. Okay, if I want to get the values, right, of all the dictionary that I have, basically in the dictionary all the values if I want all the values, how can I get it? So this first code that I've actually written, this will actually help you to get all the keys. Okay, and this will actually help you to get all the values. Okay, and if I go ahead and print the values, I will be able to see the values over here. One more, let's say I want to get all the key value pairs, let's say in the form of dictionary items. Okay, how do I get the key value pairs, right, in that case? So let me just go ahead and write, and I'll define a variable called as items. And if I go ahead and write student dot items, right, and this will actually help me to get all key value pairs. Okay, now let me just go ahead and print the specific items. Okay, so here you can see that let's see the first one. Okay, student.keys, I'm getting all the keys, so name, age, and address are the key. When I wrote student.values, I got all the values, I'm printing it. So Krish 33 in India. And when I want all the key value pairs, so like this, I'm able to get it, right? So this will be a new type, is called as dictionary items, which will be in the form of list of tuples. So these are nothing but tuples, right? Tuples, right? I will be able to access this particular tuples also, and it is a list of tuples. Okay, so here you can see name, Krish, age 33, address, India, right? Now one more thing I really want to do is do a shallow copy. Okay, now let us discuss about shallow copy over here. So guys, now let me just go ahead and show you the working of shallow copy. And this is something really, really important. And trust me, you should never do this mistake whenever you're implementing in any kind of project. You have to make sure that whenever, and you need to remember this concept because this can be a very small mistake whenever you're developing projects. Okay, now I have student dictionary over here, right? Now let me do one thing. Let me create another variable. Let's say I will go ahead and write student underscore copy, and I will assign the student value over here. And as you all know, what is present in the student? The key value pairs, right? Now if I go ahead and print student, and if I go ahead and print student underscore copy, okay, student underscore copy, what am I getting? I'm getting the same value. This is perfectly fine, and obviously since I'm copying this particular value to another variable, so this will also be a dictionary that will be having the same value over here. Okay, but now what I will do, I will just go ahead and take student name value, right? Student name value, and I will assign some other value itself, right? Let's say Krish1. Okay, now let me just go ahead and print student, and let me print the same student underscore copy. What do you think should be the name in student underscore copy? Should it be Krish1 or Krish2? Okay, I'll make it to Krish2. Okay, let's say I'm changing the name of this particular student right over here to Krish2. Now since I'm making the change to this student dictionary, since I made a copy of this in student underscore copy, then you may be thinking, okay, student underscore copy should still have Krish1, but it does not happen in that way. If I go ahead and see the output, you'll be seeing that since student also got the name as Krish2, since we had assigned the value to student underscore copy, so here also we are getting Krish2. And this is a big problem, right? So how do I make a separate copy? Whenever I probably want to make a copy for this particular dictionary to another variable, in such a way that after that, if I update this, the same update should not happen in your copy variable. So for that, I will be showing you about shallow copy. Now in shallow copy, what we do is that, let's say I go ahead and create my student copy one variable, I will go ahead and write student dot copy function. Okay. Now this copy function is responsible for doing the shallow copy over here. In short, if you really want to understand, this will basically allocate a different memory. It will take this variable and it will give the reference of this variable to another memory, which will have that entire value that we really want to store. Okay. Now if I go ahead and print student underscore copy one. Okay. And if I want to go ahead and print student, right? And if I execute it, now here you can see, okay, I'm having the same value. But now let me just update the student name. Okay. If I go ahead and update the student name, let's say if I go ahead and write Krish3. Okay. Now if I go ahead and print both of them, will I get the same value of the name? The answer is no. See, I'll execute this. Now in my student underscore copy one, I still have Krish2. In student, I have Krish3, right? And why this was possible? Because of the shallow copy itself, right? So just get an idea about shallow copy. Shallow copy in turns, provides a different memory location, so that whenever we change one of the variable, it should not impact the other one. Okay. So just a smaller thing to understand over here, because this will be important when you're doing the coding. Now let's go ahead and discuss about iterating over dictionaries. Okay. First thing, you can use loops to iterate. Like how did we do in the case of list or in the case of tuples? So here also we are specifically, okay, I'll write you can use, okay, loops to iterate, and we can iterate over dictionaries. And in dictionaries, if I probably talk about, we have keys, we have values, or we have items. Items basically means the combination of key and value pair, right? So let me just go ahead and show you the same example. Let's say that this is my student variable, okay? And for this particular student, I will go ahead and iterate through each and everything. So first of all, I will try to show you iterating over keys, okay? Now iterating over keys, for keys in, again, we'll use a for loop, and I will just go ahead and write student.keys. When I write student.keys, obviously you'll be able to see that I'll be getting the keys itself. If I go ahead and print the key, you'll be able to see, keys, sorry. You'll be able to see name, age, and address. These are the keys that I've actually defined. Similarly, you can iterate over values. For that, what you need to do, again, copy the same thing, right? Paste it over here. Instead of student.keys, now you go ahead and write student.values. Okay? And once I go ahead and write it over here, I can print it over here itself. And this is what you will be able to get a value. Krish3, you'll be able to get 33 India. Okay? Now, if I want to iterate over key value pairs, then what we really need to do, I will be using two variables in my for loop. One is key, comma, value, and student.items. And now I will just go ahead and print by using an F string. Okay, so this is one way of formatting, sprint formatting. I can go ahead and write my key. Along with this, I can go ahead and write my value. If I go ahead and see this is my age, Krish3, name, Krish3, age 33, address India. So you can also iterate over the key value pairs. And just by writing student.items, you get that value in tuples, right? In list of tuples. So all these things you can basically work, and you can basically iterate over the dictionaries. Now talking about the next one, here we are going to go ahead with, let me make some cells. Okay, so we are going to talk about nested dictionaries. Okay, now nested dictionaries, a dictionary inside another dictionary. Okay. And usually, if I talk about databases, MongoDB, right? NoSQL database. Over there, everything is stored in key value pair. Whenever we say key value pair, later on we can read that, convert that into a dictionary. And I may have any number of records in the MongoDB database, right? So let me just go ahead and do one thing. Let me go ahead and write students. And let me just show you how you can create key value pairs. Okay. So let's say this is my first key. That is nothing but student1. And I will just go ahead and write my key value pair. Here, the first thing I will go ahead and see name. Name is, let's say, Krish. Age is, let's say, colon 32. Okay. And age 32. And here I'm specifically creating this, right? Sorry, it should be colon, not equal to colon 32. Okay. This is my first record. Yeah. Now let me go ahead and create a second record. Let's say I may have student2 data. And now with respect to this particular student2 data, I may have name. Name is nothing but, let's say, Krish, or I'll just say Spider-Man, or Peter Parker, or anyone, right? So Peter, right? Age is nothing but, let's say, 35, right? So here you can see key value pairs, right? And this is nothing but, this is basically a nested dictionary, right? Now if I go ahead and print students, you'll be able to see that, hey, it looks like a dictionary. Key value pairs, again, we can have nested key value pairs, right? But these are just like kind of records, like how we upload it in MongoDB or in any other non-SQL database, NoSQL databases, right? Now, how do we access this nested dictionaries? Access nested dictionaries elements. Okay, so I will just go ahead and print, right, students. And here I'm going to use, let's say I want to read the age of Peter Parker. Then how do I write? So I will just go ahead and write student2. Okay, and the next bracket will be specifically name. Okay, or name or age. I can also get name. If I want to print, I can print name. Let's say if I go ahead and print this entire information along with age, here I will be getting age or name of Peter Parker, and here I'll be getting the age, right? So if I go ahead and see Peter and 35, right? So here, with respect to the nested dictionaries also, like how we read in nested list, similarly we can go ahead and do that. Here the main thing is that we only have to call the key names, and automatically you'll be able to get the value names, right? So this is one amazing way of playing with nested dictionaries. Okay, now again you can try multiple examples. You can create your own nested dictionaries, any level of nested dictionaries. There's no limit as such. Inside name also you can again go ahead and create another nested dictionary if you want. Okay, now let me just go ahead and show you one more thing. Iterating over nested dictionaries. Okay. Now for, let's say I will go ahead and write for student underscore ID. Okay. Since I require ID and information, so let's say I will go ahead and write like this. Just see this. Okay. Student underscore info. Okay. I will consider this as ID and this as entire info. Okay. And if I go ahead and write students. Okay. Dot items. So what will student.item give me if I go ahead and execute a code over here? What will students.items give me? It will give me dictionary in the key value pairs, right? Like student one will be one key and this will be an entire value, right? Inside this can be a key and this can be a value, but it will be giving you in this particular format. Now, if I iterate over this nested dictionary, this I will consider as my ID and this I'll consider as my value, right? So that is the reason I've written from student underscore ID, student underscore info, right? So this can be a temporary variable, right? Now I will just go ahead and print, okay? So one print, I'll just use an f string, and inside this f string, let me first of all go ahead and display my student underscore ID, okay? And this will basically be my student underscore info, right? Now I may want a scenario wherein I traverse through or I iterate over all the elements that are inside this, right? So let me do that. So I will go ahead and write for key, comma value, okay, in student underscore info, right? I need to iterate through this, and this all information are present inside student underscore info. Now inside this also, I will be able to find out keys and values. So I will go ahead and print f, again my key, and this will be nothing but it will be colon, again my value, right? Now let's go ahead and see. So there is an error for key comma value in student underscore info dot items. I missed out dot items because I am not getting too many information out of it. So see how it is printing this first information. This is my student. All the information is over here. Then I took this info and I iterated to every key and values, right? So name is equal to Krish, age is equal to 22. Then again it went to the for loop. It found out the another student ID, that is student 2 with this name, and now it is printing name is equal to Peter and age is equal to 5. So this is how you iterate over nested dictionaries, and you can play with different elements as you want. Okay. So again, any level of nesting, let it be, right? You can iterate through each and everything, and just by using dot items, you can get the key value pairs. Okay. Now let me just go ahead and talk about dictionary comprehension, like how we discussed about nested list comprehension. Similarly, we'll discuss about dictionary comprehension. Okay. Now, dictionary comprehension, how does it work? And let's say that I want to just print what is the square of a specific number between 1 to 10. Okay. So let me just go ahead and create a variable. Squares is equal to, and again, what is the mechanism? See, list comprehension we basically write like this, right? In dictionary comprehension, we use angular braces, right? So first thing first, always remember we need to write. You can write a for loop. You can write any condition over here. So let me go ahead and write for x in range of 5. Okay. I'm iterating between 0 to 5, and what I want to display something like this. X is equal to x square. Okay. I'm basically squaring each and every number, and that is what is my x value. And this way, it will probably display me. And this is the way how key and value pairs displays, right? So this is my key, this will be the value, this will be my key, this will be the value as we keep on iterating. So if I just go ahead and execute this print squares, again, you can, one assignment I definitely like to give you, just go ahead and write this entire thing with a simple for loop, okay? And then you try to convert this into a dictionary, right? Dictionary comprehension. So here you can see now I'm able to get a key value pair. So this is my 0 is my key, 0 is the value, 1 is the key, 1 is the value, 2 is the key, 4 is the value, and we're doing the squaring of it, right? Squaring of each and every number. Now let's say I want to probably go ahead and just find out the squares of only even number. So here I will also show you by writing conditions. So let me just go ahead and write conditional dictionary comprehension. Okay, comprehension. Now, the best way over here is that I will go ahead and create even variable. Now, first of all, for x in range of 10, let me just go ahead and take 10 variables. Okay, I know what I need to display, x square. Okay, but I will write one more condition. If x modulus 2 is double equal to 0, I will go ahead and print my events. Okay, now let me just go ahead and execute it. So this is 0 colon 0, 2 colon 4, 4 colon 16, 6 colon 36, 8 colon 64. Right. So this is in short giving me the square of only even numbers. Right. Now, these are some of the examples. Again, dictionary comprehension, you can, like, how do you execute with respect to lists? Similarly, you can also do it with respect to dictionaries. Only the thing is that you need to have the output over here in the form of key value pairs. Okay. So this was one of the most amazing thing. Okay. Let me just show you some of the practical examples that may be beneficial for understanding. Some more practical examples. And in the next video, I will also talk about some of the amazing use cases where all these dictionaries will be used. Okay. So practical examples. Okay. Now with respect to this practical example, I'll give you a task. Use a dictionary. Okay. Use a dictionary to count the frequency of elements in list. Okay. Now we'll go ahead and see this. Let's say I have numbers. Numbers is nothing but it is in the list format. 1, 2, 2, 3, 3, 3, 4, 4, 4. Okay, so these are my numbers. Now you need to write a code using dictionary to count the frequency of every element in the list. Like 1 is present 1 time, 2 is present 2 times, something like this. So I will go ahead and create. First of all, you try it out. Okay, just pause for at least 5 minutes and just try to write whatever is possible by you, and then go ahead and see the solution. Okay. Now let me just go ahead and create a frequency empty variable. Then I will go ahead and write for number in numbers. Okay. First of all, I will iterate through each and every number. Then I will go ahead and write if number in frequency. Okay, the number is basically present in the frequency, then it is fine. Then what we do, we basically take the frequency of number and we keep on incrementing it, right? Plus is equal to 1. Now what exactly this is basically doing? This is with respect to the key. And with respect to that particular key, I need to just keep on incrementing the value, saying that hey, it's present 1 time, 2 times, 3 times. Like when it 2 times basically comes, right? So first time it will be 0, and then it will go to 1, 2, 3 like that. Okay. Else, if it is coming for the first time, then we should basically assign that value to 1, right? Otherwise it will keep on incrementing. So number is equal to 1. Now, let me just go ahead and print the frequency. So here you'll be able to understand how many number of times 1 is present, 2 is present, and 3 is present. Just see this code, observe this code. Okay. If I go ahead and execute it, now here you can see numbers, it is iterating. If number is in the frequency, initially it is not present. So what it will do, it will go over here, take this number, and it will assign the value 1. Then it will go again back to the next number, 2 is present, number is not present in the frequency, it will again go back to the loop, and again it will update 1. Then again it will go back, okay, then the next number is 2. This time it is present in the frequency. So it will go inside this, frequency of 2 is equal to plus is equal to 1, right? Plus equal to 1. So that basically we are just going to increment 1 with 1. So it will become 2. So how many number of times 2 is present? Only that much will be remaining. 3, it will increment till 3, 4, it will increment till 4 because there are 4 number of 4s. Okay. So this is how you specifically get one amazing thing. Okay. Now let me just show you another one example, and this is probably we have not discussed also. Let's go ahead and merge 2 dictionaries into one. Okay, there may be scenario that I may have 2 dictionaries and I really want to merge them into one. Okay, this is one kind of hack that I really want to show it to you. So dictionary 1, and this is what we'll understand when we understand about functions, because there is one very key important parameter which is called as positional argument and keyword argument. Okay, why we use asterisk, mask, and all. I'll just discuss when we discuss about the function. So now let me say that hey, there is dictionary elements over here. A is equal to 1, and this B is nothing but equal to 2. Okay. Similarly, I may have a different dictionary, the second dictionary here, B colon 3, and C is colon 4. Okay. Now if I go ahead and write merge dictionary. Okay. Now see, if I go ahead and try to merge this dictionary, I will use two amazing things over here. One is asterisk asterisk dictionary 1, okay, comma asterisk asterisk dictionary 2. Now the best thing about this asterisk is that any number of key value pairs, right? If I'm giving two double asterisks, any number of key value pairs that is probably going to consider come, it is just going to take that as a key value pair and it is just going to append it inside this particular dictionary. Okay, this is basically called as a keyword argument. Okay, and over here you can see in dictionary 1 and dictionary 2 both are keywords argument. Okay, so keywords argument basically means any value that is present in the form of key value pairs. Okay, now if I go ahead and print this merge dictionary, and we'll discuss more about that in functions. Okay, so here you can see that it has merged very much easily. Okay, so I hope you got an idea about dictionaries. We've discussed so many different lines of code I've written over here in front of you, and almost each and every topics with some examples and all I've actually explained in a way that you should be able to understand in a very lame language. So I hope you like this particular video. This was it from my side. I will see you in the next video. Thank you. Take care. Hello guys, so we're going to continue discussion with respect to Python, and in this video we are going to see some amazing real world examples using list in Python. Now guys, you may be using a lot of applications, you may be using a lot of apps, some or the other way there are many smaller modules where specifically list can be used. So over here I'll be showing you some of the examples. Yes, we are not going to develop a complete end-to-end project like kind of thing, but it's more about understanding what applications specifically this kind of data structures list is used. Okay, so the first example that I'm actually going to do is something called as manage a to-do list, right? So we will try to create a list which will keep the track of all the tasks that you're planning to do. Okay, so let's say I will just go ahead and create a variable to-do list. Okay, and inside this let's say today my task is I've opened my app and I've probably selected, okay, today I need to buy groceries. Let's say I need to buy groceries. The second task that I really want to do is that clean the house, okay, which is necessary, clean the house. And let's say the third task that I have is something called as pay bills, right? Now, let's say after some time, I had to get some kind of task. I got some more task, and now I want to add that particular task to my to-do list. So right now in the to-do list is already a list. So we know some of the inbuilt methods that we have already discussed, like how we can make sure that how we can add more tasks in our plate, right? So what I will do, I will just go ahead and use this to-do list dot append, right? And inside this append, I can probably go ahead and say, okay, schedule meeting is one of the tasks. I need to schedule a specific meeting with someone. Okay, so this can be one of the tasks. And after finishing my work, let's say I want to go to a run, so I will go ahead and append another task over here, something like go for a run. Okay, go for a run. Okay, so this is my another task that I really want to do. Let's say that I have done out of all these tasks, I have started my day, and the first task that I've actually done is clean my house. Okay, so what I will do is that after I probably in my app, after I complete this particular task, I will make sure to remove that particular task. And once I removed, right, a completed task in the backend, what kind of code will be written? So from my to-do list, right, which will be in the session, we'll talk more about session and all. I will just go ahead and remove clean the house task over here. So I will just go ahead and copy this entire thing, and I will just go ahead and say, hey, this is completed, so please remove this particular task from my list. And then let's go ahead and check, okay, whether this particular task after removing it is present or not. So here I'll say checking if a task is in the list, okay, and here I'll say, hey, if let's say pay bills is there, okay, pay bills is there in the task, okay, in to_do list, then I will say print. I'll send a reminder for me, hey, don't forget to pay the utility bills. Let's say this is my utility bill, okay, utility bills. Okay, so this is just like a reminder that I'm actually getting. And let's say after finishing all the work, how many tasks I really want to probably how many tasks are remaining if I want to print it, right? So I'll just go ahead and write print. This is my to-do list that are remaining, to-do list remaining, and I will just go ahead and print for task in my to-do list. Print. Let's go ahead and print with the help of f string. F is basically a formatting string, and this will just go ahead and display my task, right? Now, obviously, I'll be able to see that from my task, this clean the house should not be there, and I should have both the tasks that should be appended in my to-do list. So let me just go ahead and execute it. So here you can see, hey, don't forget to pay the utility bills, because I got a reminder saying that over there, because pay bills is still there in my to-do list. Then the remaining to-do lists that are remaining that are like buy groceries, pay bills, schedule meeting, go for a run, right? So all these specific things are there, and I will be able to keep a track of it. So extensively, I know in a bigger application, you'll be seeing that a to-do list specifically uses list, because with the help of list, you can actually remove it, you can add it, you can append a new task over there, and everything can be created through it, right? So whichever programming languages you specifically go ahead with, list will be a common data structure that will be used extensively. Okay, now let's go ahead and see another example. So here you have something called as organizing student grades. Okay, and now I will just go ahead and copy and paste it over here, code for you. So here you can see organizing student grades. So I have some grades over here, 85, 92, 78, 90, 88. So I'm adding a new grade. Let's say a new grade has actually come. So I'll go ahead and append a grade inside this. Then we'll go ahead and calculate the average grade. So this is my average grade. Find the highest and the lowest grade. Let's say by using inbuilt function like max or grades, I'll be able to get the highest grade. And another inbuilt function, I'll be able to get the lowest grade. So this is how I will be able to see my highest and lowest grade, right? So such a simple example, but here you can also see that extensively list is basically used. And just by using this inbuilt function like sum, right, which will basically get applied in a collection, specifically in a list, right over here, you'll be able to see that I'm able to calculate sum of grades, length of grades, and then I'm able to calculate the average one, right? So this is another one example with respect to organizing student grades, and here you can see average grade is so much, highest grade is so much, lowest grade is so much. So that is what I'm actually doing to calculate the average of the students. Okay. Now one more example that I've actually taken is managing an inventory. Okay. So managing an inventory basically means I'm trying to just manage an inventory whenever we do an e-commerce site. Inventory is the major thing that will be managed by the entire company itself, right? So here you can see. Let's say in my inventory I have apples, bananas, orange, grapes. Okay, so these are all items that is present in my inventory, and then I'm adding a new item which is called as append strawberries. Okay, now with respect to this particular strawberries, this is a new item that has come, and I'm appending it. Whenever there is one item that has been ordered by someone, so once we deliver it, we have to remove that particular item. So we have removed that particular item called as bananas. Let's say bananas was ordered by someone, so I've just removed this. Okay, after the delivery done, checking if an item is in stock. So if I'll say item is equal to oranges, if this item is present in inventory, I'll go ahead and say, hey, they are in stock, otherwise they are out of stock. Then we can go ahead and print the inventory. So here you are able to see that we are able to manage everything in the form of list. Yes, the scale of data will be quite huge, but internally these all data structures will be specifically used. So this is another one amazing example. So if I go ahead and execute it, here you can see oranges are in stocks since orange was already present over here, and then inventory list you can actually find apple, oranges, grapes, and strawberries. Okay, now this was one more example, a good one. Now I hope you are able to understand what all beautiful use cases are definitely there. Now this one, I'll just give you the task. Please go ahead and explore it. Okay, and just try to see whether you're able to understand it or not. Okay, so this is the code collecting user feedbacks. Use a list to collect and analyze user feedback. So here is my user feedback. Great service, very satisfied, could be better, excellent service. Let's say another feedback is added, not happy with the service. Okay, so we are just counting the specific feedback. So I'll say 1 for comment in feedback if great in comment.lower. Okay, now see here we have also used something amazing, right? So I'm saying for comment in feedbacks, we're exploring it. Okay, if a great word is present in that comment, okay, if in all these comments great is present, so we are just going to do the summation with respect to 1. Like if anytime great is present, I'm going to take 1, right? Or excellent in comment dot, right? So we are just going to do how many number of times great or excellent is present. We're just going to keep on adding it up. Okay, so here you can see positive feedback count we are able to get. So this is the variable, and then finally you can see print user in feedback, comments in feedback, and we are printing it. I hope you are able to understand. So over here with respect to the output, positive feedback count is 2. That means if great and excellent is present over here, we're just going to count it down. Okay, so 2 times we have actually found out. So user feedback like great service, very satisfied, could be better, excellent experience, and the last feedback was not happy with the service, so that is also appended over here. So these are some of the beautiful examples, and again, list is something I think the most common data structures that may be used everywhere. Probably whenever we are working with large applications. So I hope you understood this video. I hope you got an idea with respect to the real world example, and this was it from my side. I'll see you in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to Python, and in this video we are going to discuss about the most important module that is called as functions. So what is the entire video outline in this video? I will be discussing about what exactly is functions, why do we require functions. Along with that we'll also be seeing about calling a function, defining a function, how do we define it, what is the syntax of it. Then along with that we'll be discussing about functions parameter, default parameters, and then what is variable length arguments. So there are some very important arguments like positional argument and keyword argument. We'll be discussing about that. Then we will also be discussing about the return statement. So we will be covering each and everything with the help of again code, with the help of Python. Each and everything we'll try to write it down with multiple examples, and I'll be making sure that you understand this, because this is one of the most important thing. Because whenever we are writing any data science projects or Python projects, we will be definitely using a lot of functions. So first of all, let's go ahead and define the function. A function is a block of code. Okay, again I'm repeating it. A function is a block of code that performs a specific task. A functions help in organizing code, reusing code, and improving readability. Okay, so it is a block of code that performs a specific task. It helps in organizing code, reusing code, and improving readability. One of the best syntax, if you really want to check it out, right? So this is a syntax. So here I'm just going to give you the syntax. This function is an empty function. I just written it for just to make you understand. So first of all, a function starts with a definition keyword. Then you have the function name, and if any parameters that you're defining, so we have to define the parameters. This is docstring. Docstring is just to use to write some kind of comments what the specific function does, so that any developer will be able to understand it. Along with that, we will go ahead and write our function body. Function body is more about all the code that we are going to use inside the function, and then finally we return some kind of value. Okay, it is not necessary that return should be there. Some of the functions may not have return value, but some of the functions will definitely have a lot of return value. Okay, so this is the basic syntax. Now let me just go ahead and tell or talk about why do we require function. Okay, why functions? This is important for everybody to understand. Let's say I am creating a number variable, and I go ahead and write a code which will be able to check whether the number is even or odd. So suppose if I go ahead and write if num modulus 2 or percentile 2 is double equal to 0, then obviously I'll say, hey, print the number is even, right? So I'm just going to write the number is even. Else what I usually do is that in this I will go ahead and print and write the number is odd, right? So here what exactly is basically happening, we're just going to check whether the number is even or not. And obviously if I go ahead and execute, this condition will be true because the number is even, and I'm going to get the answer the number is even. Okay, now let's say in my project I want to write this piece of code, and I need to reuse this piece of code in multiple places, because in multiple places I'm going to check whether the number is odd or even, right? Now in this case what I have to do, I have to copy the same code, use it in multiple files, Instead of this, a better way of reusing the entire code will be with the help of functions. Now what I will do, this entire code I will write inside a function. Now the best way to write is that, let's say I will go ahead and create my definition keyword. I will say, hey, my function name is even or odd, okay? And this will specifically take a parameter which is called as number. And now I will go ahead and write my condition inside this, right? So as soon as I go ahead and press enter, that basically means I'm inside my function, right? So automatically the indentation goes inside this function block, right? Now the first thing is that I can go ahead and write my docstring. The docstring will be like, hey, this function performs finds even or odd. Okay, even or odd. So this is what I'm specifically writing over here. So this becomes my docstring. It is not compulsory that you really need to write a docstring. You can leave it completely empty, and you may also not even write any of these things. But it is a good practice that we should definitely write some information about the function itself. Now I will go ahead and write my code inside this. Now I will go ahead and write if num is nothing but the same parameter that I'm actually getting, and this is basically my parameter. If num percentile 2 is double equal to 0, I will go ahead and print the number is even, or I will go ahead and write else print the number is odd, right? So here you can see I've defined this entire function. Now I'll just go ahead and press it and execute it, right? So as soon as I execute it, I have actually created my first function, right? And this is amazing. And if you have also created it, always make sure the indentation is managed. If the indentation is right, then everything is going to work fine, okay? Let's say if I miss out the indentation, I execute it, I will be getting an error. It will be saying, hey, expected an indent block after the if statement. And this is what we have actually done. Okay, so I'll just Control Z. Yeah, now we are fine. I'll go ahead and create my function even or odd. Now in order to call this function, so let's call this function. Now whenever I want to use this code to find even or odd, I will just call this function. Okay, in order to call this function, just go ahead and call the function name. And here you just need to provide your parameter, right? So let's say the number parameter that I'm giving, I want to give it as 24. Now if I go ahead and execute it, here you can see that automatically it is printing the number is even, because as soon as I give the parameter, it went over here, it went and checked all this condition, whichever is true, it printed it, right? A very simple way of creating a function and calling a function. And why do we require a function? Because everywhere we cannot write the code, we need to reuse this kind of code. So whenever you think, okay, I have some set of code block which I really need to reuse it, I will try to create that entire thing inside a function itself, and I'll reuse it, right? So through this, the most important thing will be that it helps in organizing code, reusing code, and improving readability. Improving readability, why? Because you're also writing some amazing docstring over here, so that we'll be able to understand. Because in a company, many people will work, many people will write different code over there, multiple modules will be built. Okay, so this was a basic example with respect to function. I've also spoken about a parameter, like what exactly is a parameter, how do you give a parameter in this. Now there may be a scenario that I may also have multiple parameters, so let's work with multiple parameters. So here I will go ahead and write function with multiple parameters. Okay, and parameters you can give integers, string, whatever things you require. So I'll go ahead and write definition add. Let's say I want to go ahead and create a add function to add two numbers. So I will go ahead and write definition add a comma b, and let's say I go ahead and write my docstring. Again, not compulsory. I can also leave it like this, okay, just to show it to you. That is the reason I'm writing. Okay, so I will go back over here, press enter. So I'm inside this particular code block. Now I know that I have to add two variables, right? So I will create one way is that I will create a variable c, a plus b, okay, and then I can return the c output from that particular function. Okay, return c plus c, which is nothing but a plus b. Whatever sum is there, we are just going to return it. A better way of writing the code, instead of writing c, I can directly write return a plus b. Right. So here what we are doing, we're just returning the sum of a and b. Now all I have to do is that create a variable and add. Call this add function. Here I'm going to give 2, 4. Now what is going to get, what value result is going to get? As soon as we call this function 2, 4, it will just return 2 plus 4. Whatever will be the result, like 6, it will be stored over here. Now if I go ahead and print the result, here you'll be able to see that I'm able to get the 6 value. So here you can have any number of parameters and code whatever things you're writing. You can basically use this parameter and write any code that you want. Okay. So it is up to you what kind of function that you are building. And as we go ahead with multiple examples, if we see in the future, and in the upcoming videos, we'll be writing very complex functions. There's something called as decorators, lambda function, many things will be probably coming. One by one we'll be learning. First we'll start with basics, then slowly we'll be building the blocks with respect to the learning, and then we'll be continuing on. Okay. Now let me just go ahead and show you and talk about one very important thing which is called as default parameters. We can also provide default parameters within our function. Okay. Now what exactly is default parameters? Let's say I create a function. Okay, I create a function saying as definition greet. Okay, definition greet. This function is responsible. Let's say I give a name over here, right? Let's say one parameter is name. Okay, and here I'm just going to write print. Okay, I'll use f string and say that okay, I want to probably write some information. Let's say I want to say hello, whatever the person name is. Okay, so I'm going to just go ahead and print this. Okay, and this is what is my definition greet. Greet is just more like you're welcoming someone. Okay, welcoming someone. Now what I will do is that I will just go ahead and call this function. So I will go ahead and write greet, and let me say that Krish has entered somewhere. So I will just give the Krish parameter. Like let's say you're entering a restaurant, and as soon as you write Krish over there in one of the applications, and suddenly I'll get a message saying that hello Krish. Okay, or welcome, something like this. Welcome to the paradise. Let's say this is my message. Hello Krish, welcome to the paradise. So as soon as I give this parameter, automatically this will get replaced over here. Okay. Now I may also give one parameter. I may also give some parameters with a default value. Okay, with a default value. Now what does that particular mean? Okay, let's say I just go over here, and this time I don't give Krish. Okay, I'll just try to execute this without giving any parameter. So here you can see I will be getting an error. Hey, greet missing one requirement positional argument. Okay, we'll talk about what exactly is positional argument more about it. But here you can see that I've given this particular name parameter over here, but I'm not given any parameter when I'm calling it, and that is the reason I'm getting this one missing one required positional argument. Okay. Now in order to solve this problem, what I can do, I will say since I'm not giving the name, I may give a default value to the name. Let's say if I'm not giving it over here, then what will happen? It'll first of all go and see whether the greet name is going to guest is given or not. Now, if I go ahead and execute this, see, I'm not giving any parameter, but the default parameter, it will take it as guest. Okay. So if I go ahead and execute it, here you can see, hello guest, welcome to the paradise. Let's say if I go ahead and give the name, okay, over here, let's say the guest is not interested to give the name, so by default, it will take it as guest. But if I'm giving my name, it will just replace the guest will get replaced with Krish. Okay. So this is some good example with respect to the default parameters, and this is how you can also assign default parameters. Now, we are going to discuss about the main topic, which you will be seeing in function. That is nothing but variable length arguments. Okay. Now, in the variable length arguments, here we are going to discuss about two things. One is positional and keyword argument. Okay. Positional and keyword argument. Okay. Keywords, arguments. Okay. Now, let me tell you one very important thing. Let's say that I have in a function many parameters as such. Okay, and let me just define one simple function that is called as definition print underscore numbers. Okay, and here inside this, let's say I have like this. Okay, number 1, number 2, number 3, number 4, number 5, like this. I have many parameters in short. Okay, it's just not one single parameter. I'm basically having many parameters. Okay, so what I will do, instead of just writing all the parameter names, right, I will use one very simple positional argument which we denote it as star args. Okay, now it is not necessary you need to write star args. I can go ahead and write star crash also. Okay, but it is always a good practice. What is followed throughout the entire world, the same practice we should also do. Now in this particular case, I'll just show you it's star crash. Then we will go ahead and write with the documentation, like what is the best practices argument we specifically use. Like positional arguments is basically given by star args. As I said, it need not be args. I can also write crash. Okay, now I will go ahead inside this particular function. Now here, what I will do, as you know, the star crash will be having multiple parameters. So what I will do, I'll just go ahead and write for numbers in KRSH, okay, which is my argument. I will go ahead and print numbers, okay. Okay, I'll go ahead and print number. Okay, now see this. Okay, so this becomes my function. Please observe very carefully. Okay, now my print underscore numbers function when I'm calling. Let's say I have 1, 2, 3, 4, 5, 6, crash. It can be anything. Okay, so these are all the parameters that I have. You can see it is a set of parameters, and these parameters are basically called as positional arguments. Okay, positional arguments, one after the other. Now, if I go ahead and execute, now see the magic. This all the parameters will be referenced by star crash. Okay, so crash will be a variable which will be referring all these particular positional arguments. Now, if I go ahead and execute it, now clearly here you can see for all the numbers it is being able to iterate through this, right? 1, 2, 3, 4, and it is displaying it something like this. Okay, because here I just use 1. So this star crash is basically referring to all the positional arguments, right? Positional arguments basically means all the arguments that is given over here. Okay, now as I always said, the best practice would be I will go ahead and write this and I will say args. Okay, so args is the kind of positional argument that we basically use. Okay, so here I'm going to write positional arguments. Okay, why it is important? Because I may have many number of arguments over there. Okay, so I may directly use this specific thing. Okay, now the other thing will be that, okay, this is fine. If I go ahead and execute it, and if I execute the same thing, okay, I will be able to get the same answer. Fine, perfect. 1, 2, 3, 4, 5, 6, crash. Now there is also one more important function which is called as keywords argument. Okay, now what exactly is keyword argument? Okay, let me just go ahead and create one more function. Okay, let's say I'll go ahead and write definition print underscore detail. Now how it is different from positional argument, you'll be able to understand. Keyword argument is given by double star, and you can write any parameter that you have. So usually the best practice that is basically used is KWARGS. KW basically means keyword argument, right? ARGS is a simple positional argument. Now inside this, let me do one thing. One thing that you really need to remember, in keywords argument, all the keys or all the parameters will be in the form of key value pair. Okay, again I'm repeating it. In keyword arguments, all the parameters will be in the form of key value arguments, right? Key value pairs. Now you know if it is in the form of key value pairs, that basically means you'll be able to access this like how we access dictionaries. So I may go ahead and write for key comma value in KWARGS dot items, right? Dot items, right? If I go ahead and execute this, what will happen? If I go ahead and print it, so it will be nothing but f key colon value, right? So I'll just go ahead and execute this. Now, how do we provide a keyword argument? It's very simple. Let's say I want to just go ahead and print these details. Let's say my first parameter is nothing but name. Okay, I've not defined it anywhere, but during runtime I'm just giving name, crash, age, 32, and let's say city or country. I'll go ahead and write country is nothing but India. Okay, now if I go ahead and print all these details, so directly see if all my values is in the form of key value pair, where I'm using a key name, I'm using a value name, key value. So all these parameters will be referenced by star KWARGS. Okay, star KWARGS. If all the parameters are just written like this, where it does not have any key name, then this basically becomes a positional argument. Okay, now let's combine both of them and let's see how things work right now. Okay, so I will just go ahead and write definition. Okay, and how do I specify my positional key argument? Nothing but star args. So this will be my first parameter, this will be my second parameter. Now in my first parameter, I will go ahead and write, and let me just go ahead and display this. And for args, I'm just going to display this values. Okay, let's say I'll not take numbers because I can display anything, right? For val in args, print val. Okay, and here also what I'm going to do, just to make it much more better, I'm going to use this f string, and here I'm just going to use this indication. And I'm going to write over here, right? So what I've done over here, for val in args, print val. Okay, for key comma value in KWARGS.items, we are just going to print this. Now the best way is that I will go ahead and write over here something like positional argument, okay, and this will be my value. Now see, now I'm using both of them, right? Now how this function is able to identify, right? Let's say I'm giving print underscore detail. Let's say I give my positional arguments like 1, 2, 3, 5, okay, and here I will go ahead and write crash, okay. So this basically becomes my positional, all the positional arguments, and between them I will just go ahead and give this keyword argument. Let's say go ahead and give it anywhere that you want to give. Okay, now out of all these parameters, it will be able to identify. Okay, let's see what is the error that is probably coming over here. Positional argument cannot appear after keyword argument. See, this is the error. Now the main problem over here when we write like this, right? First of all, always remember we need to specify all my positional key arguments. Now I'll go ahead and write my keyword argument. Now if I go ahead and execute the details, see, initially first argument is positional argument, second, third, fourth, till here, and this is all that you'll be able to see is my keyword argument. So this is very much important to understand the differences between positional and keyword argument. In keyword argument, you have all the parameters in key value pairs, like how we have specified over here. In positional, you just have something like 1, 2, 3, 4, 5 with respect to only the names that will be there. We'll not be assigning any key names, right? So this is the most important thing with respect to keyword and positional arguments. I hope you were able to understand. I hope you are able to understand the difference between them. And it is very much important to know this because next in the upcoming session we'll be seeing I'll be defining functions where I'll be having multiple parameters over there, and then we will also be seeing that. Okay. Now let's talk about the last topic for this video, that is called as return statement. And I hope I've already spoken about it. In return statement, our function returns something, right, after the entire statement is executed, right? So let me just go ahead and do it. So here I'm going to create my multiply function. This will be a comma b, and here I'll just go ahead and return a multiplied by b, right? So here we are returning some value after the function is getting executed. Now in order to execute it, so I will go ahead and find my multiply function. Let's go ahead and write 2, 3, and finally I get my output. So functions can return multiple values also. Let's see whether this function will be able to return multiple value or not, right? So let's say I will write c is equal to or let me just define this function once again, okay, and let me execute it over here. So here I'll say, hey, return a comma b comma a. Okay, let's see whether we'll be able to return this. So in Python, a function can also return multiple values. So here we are returning a comma b comma a. A comma b is nothing but let's say we 2 comma 3 are given, so 2 comma 3 is 6, multiply when we are doing it is 6, and a value is 2. So we can also return multiple statements, multiple parameters, multiple parameters from a function. Okay, and that is what we basically use. We need to use this return variable. So I hope you're able to understand this. This was it from my side. This was all about functions. In the upcoming session, we are going to learn many amazing things about function. There are many things like lambda function, next state function, high order function. We'll be discussing about them. So yes, this was it. I will see you all in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to Python, and now we are going to see some of the examples. Already in our previous video, we saw many topics regarding functions, and there are a lot of advanced topics that are going to come. But before that, I thought, why not create some examples and show you how we can probably solve those, right? So first example over here is that we need to create a function for temperature conversion. So temperature conversion basically means we need to convert Celsius to Fahrenheit or Fahrenheit to Celsius. So how do we define a function? We'll go ahead and see. So let's go ahead and see this example. So first of all, I will go ahead and create my function. Let's say I'll write convert underscore temperature. So this is my function over here, and here I will give two parameters. One is temperature, and one is the unit that I really want to convert it. Let's say if I give the unit over here as C. That basically means I need to convert this entire temperature from Celsius to Fahrenheit, right? And if I give the unit as F, right? So I need to convert the temperature from Fahrenheit to Celsius, right? So let me just go ahead and give a doc string. So this function converts temperature between Celsius and Fahrenheit. Okay. So this is what is my definition of this particular function over here, and we will go ahead and write our code, right? So here, let's say I will go ahead and write if unit is double equal to capital C, right? If I'm giving this particular unit, that basically means I need to convert my temperature from Celsius to Fahrenheit. So I'm going to return temperature multiplied by, and I'll do the operation 9 by 5, okay? And here, let me just give the bracket 9 by 5. I need to first of all multiply it. Then I will go ahead and do the addition plus 32. So this is the formula of converting a Celsius to Fahrenheit with respect to the temperature, okay? So this is the simple formula that we specifically use, and this in turn will be converting Celsius to Fahrenheit, okay? Fahrenheit. Okay. Then let me go ahead and write elif. Okay, so here we're going to use everything, whatever things I've learned. Let's say there's some examples that I'm going to use dictionaries, some examples that I'm going to use list and all. In this particular case, you can probably see that I'm also using if elif, right? So if elif the unit is double equal to Fahrenheit, okay, then I'm going to basically return, okay, and for this particular temperature, I need to minus first of all 32 and then multiply it by 5 by 9. Okay, and this will basically give us our Fahrenheit to Celsius, right? So this is the formula. If you go ahead and do the Google search also to convert Celsius to Fahrenheit, so this is the formula that you usually get. Okay, so that's it. This is what it is, right? And if I don't give any information for our third parameter, we need to also handle that. That is, if I'm not giving any unit, so I'll just go ahead and return none. Okay, none. So done. So here I'm going to basically use this function. Now let me go ahead and call this function as convert temperature. And if I go ahead and write like a value, let's say temperature, I'm going to give 25, right? And this is in Celsius, right? Then I'm going to go ahead and print it, right? And I'll be basically getting converted. We are converting this from 29 degrees Celsius to Fahrenheit. The next one that I'm actually going to do is print. Okay. Again, I will go ahead and call my convert temperature. And here I'm actually going to give 77 comma F, right? And this I will be able to get the answer. Let's see whether it works. Yes, 25 is nothing but 77 degree Fahrenheit, and 77 degree Fahrenheit is nothing but 25 degrees Celsius. So this is how the conversion is done, and I feel that formula is absolutely right, what you have right there. And here you can just see based on units, we are able to do it. So this is our first example. Now what I'm actually going to do is that I'm going to show you one more amazing example, which is called as password strength checker. Okay. Now what exactly is this? Let's say that we are creating our user ID or login, and over there we specifically give passwords, right? And it is and most of the people just write password as 1, 2, 3, 4, 5. So we need to have a strong password check. Okay. So I'll be giving some of the check over here to just making you understand whether it is a weak password or a true or just a very strong password, right? So first of all, I'll go ahead and write my definition is strong password. So this function will be responsible in checking whether password is strong or not. Okay. So here you can see I'll just go ahead and write my doc string. This function checks if the password is strong or not. Okay. Now let me go ahead and write. Let's say first condition networks criteria I want to put with respect to the password. My password should be minimum of 8 characters, right? So I will go ahead and write if length of password is less than 8. Is less than 8. So that basically means I'm going to just say, hey, this is a very bad password in short. So I'll just go ahead and say false, because this function that I'm actually creating is basically checking whether the password is strong or not. So right now the password is not strong, so I'm returning false. Then let me just go ahead and write another condition. If not, okay. So if not is one condition, if not any, okay. So here we are just going to see whether this character is having any digit or not, right? Whatever character, whatever password we are specifically giving, whether it is having any digit or not, right? So what I'm actually going to do, if not, is basically like comparing whether there is not present or not, right? Something like that. So I will go ahead and use a for loop for character in password. So we will go ahead and see each and every character, and here I will just go ahead and see whether this character is having any digit or not. Okay. So each digit is a function that is present in every character or string, right? So I'm just going to compare for every character in the specific password whether it is having a digit or not, right? If there is not any digits, right? So what I will do, I will again return false. Okay. Please see carefully what kind of condition I'm using, right? So this is just like any function, an inbuilt function that is present in Python, and we are iterating through each and every characters in that password, and we're seeing whether it is a digit or not, right? And this is digit is a kind of function that is available in strings. Okay, so this is one of the check that I really want to do, right? Then I will also be checking with respect to the password is lower. If all the characters is lower, then also we should return it false, saying that hey, it is not exactly a good password, right? So I will go ahead and write if not any. Again, I will go ahead and write my next condition, and here this time I will say hey for char in password, and here I'm going to check, right? And what I have to check over here, whether my character is lower. So is lower is one of the function that is again present in Python. Sorry, for character in password, right? Okay. I'm just checking whether the character is lower or not for all the characters that are present over there. And if it is present, I'm just going to return the false. Okay. So guys, now we have written the condition still here. We have also checked like all the characters should not be lowercase. Okay. Now similarly, all the characters should also not be uppercase. And we'll also check for that, right? So here I'm going to write if not any, and this time I'll be using cat dot is upper, right? So there are a lot of functions with respect to strings which I can specifically use over here. And let me just go ahead and write for char in password. Okay. And this we'll go ahead and check it out, and we'll again write return false. Okay. Now this is there. Now let's think of more things. let's see for any special characters. So for special character, I would like to add many special characters that are probably present, right? If not any, let's say in our character, if there is no special character like this, then also I can say that, hey, this is basically a weak password, right? At least it should have one upper, at least it should have one digits, so this kind of condition. So here I've used all special characters over here for character in password, and then if it is not present, we are just going to return false. If everything satisfies, then we will go ahead and return true. Okay. So here all return false are there, and then here return true is there, right? So if all this condition is false, then if all this condition does not get satisfied, then we are just going to return true, saying that, hey, this is super amazing password and it is a strong password. Now let me just go ahead and call the function. So calling the function over here. Okay. And let me just give some of the things over here, right? So I'll go ahead and write print is underscore strong password. And let me just give one example. Let's say I have a capital letter and I will write a small letter, again a capital letter, and this is weak password. Okay. But here you can see that I'm not having any special character. Other than that, I think everything is getting satisfied, right? And digit is also not there. So I should definitely be getting false for this. One more way is that I can go ahead and print, okay, is strong password. And let me just go ahead and use some special characters. So I will go ahead and write str, and let me just go ahead and use 0 over here, okay, and I will be using ng capital P WD, and let me use one special character like exclamation. Okay, now let's see whether both of them, I think this should basically be giving me false and this should be giving me true. Okay, so now if I execute this, here you can see since I do not have a digit or a special character, I'm actually getting false. Here I have both a digit and a special character, so and that is the reason I'm also having a capital letter over here, so that is the reason I'm getting true. So this is one amazing example with respect to password strength checker. Just with the help of one function, we are able to do this kind of validation, and we are able to execute it. Okay, now let's go with the third example. Now this specific example I've actually selected just to make sure to show you like how in the real world application this can be used. So calculate the total cost of items in a shopping cart. So here we are going to define a function. So I'll go ahead and write def calculate underscore total underscore cost, and here I'm going to give my cart. Okay, now this cart will basically be having a lot of items over there, and we can also give in the form of dictionary. So right now I'm just going to do pass because first of all I'll see what kind of data I have. Okay, so let's just go ahead and show you some of the example with respect to cart data. And since we have already learned about dictionary, so we will go ahead and write cart is equal to, and we'll create a list, and this will be a list of dictionaries. Okay, so let's say my first item is something like with key value pairs, like name is equal to let's say I have apple. Okay, then I have price, which will equal to 0.5. Then I have specifically quantity. Okay, and this quantity will be equal to 4. Okay, now I'll go ahead and create my next example, and let's say this $0.5 I've written like that, right? Obviously, so here let me just go ahead and name should be banana. Okay, price will be $0.3. Let's say quantity, I'll say six bananas. This is the price, and let me just go ahead and again add one more item over here, right? Now let me just go ahead and write one more like orange. Okay, the price will be 0.7 and quantity I can write as 3. Okay, so this is my cart. Okay, with respect to all the items that I have. Then I will just go ahead and write my function over here. So let me just go ahead and create a temporary variable. Total cost is equal to 0. Now all I have to do is that I have to explore. I have to probably go through this each and every cart, take the price. Okay, and see this price is basically for one quantity. Okay, so we will go ahead and multiply with this many number of quantities. Okay, and again we have to retrieve the data from this particular dictionary, and then we will be doing the total sum. Okay, so now let me just go ahead and write from item in cart. So I will go ahead and explore this. Okay, so I will just go ahead and write total cost is equal to or plus equal to. Okay, so just like an operation where we are adding something. Then here I'm going to write item of price. Okay, item of price. So this for every item of price we are just going to multiply with the item of quantity. Okay, so let me just go ahead and write it down. Then I'll be getting my total cost. Then I can go ahead and return the total cost. So this function is just going to multiply the price with respect to all the quantity for each and every item. Now quickly let me just go ahead and call the function. So here I'm going to write calling the function. Okay, and here I will write total underscore cost is equal to calculate total cost, and here I'm going to give my data as cart. Now let's go ahead and execute it. I'll press shift enter. And here, okay, let me just go ahead and print this total cost because we have not displayed anything. Now here you can see 5.889. So this is my total cost, right, with respect to all the items that I've actually bought. Okay, and this is amazing. I'm able to see the total cost of my entire cart. So here we have just created a function which is taking the cart items, and cart can be given as a dictionary list, whatever things you really want. Then we'll iterate through each and everything and we'll calculate the cost. Perfect. Let's go ahead and see one more example. This time, what we are basically going to do over here is that we are going to check, we are going to create a function which will be checking if a string is palindrome. Now, what does palindrome basically mean? So if you just want to understand about palindrome, right, some of the examples, let's say if I use this string ABA, if you read it from the front direction, it is ABA. If you read it from the backward direction, it is again ABA only, right? So from front and back, both are same. Okay, so we are going to basically write a function which will be able to do the check for any string from whether from the front it is equal and from the back it is equal with respect to the characters that we have. It should be same. Okay, so here let us go ahead and define a function. So I'm going to write is underscore palindrome. So I'll just go ahead and write a function is underscore palindrome, and here I'm going to give my string. Okay, now the best way to do is that whatever string I write, right, between all the spaces, first of all I should remove it. So I'll take the string, I'll write s.lower because I have to also do the lowering of all the characters, and let me just replace all the empty string, okay, with as string, right? With like I should just remove that empty spaces. Now, the best way to do this is that I hope everybody knows in string we have discussed about slicing operations and all. So I will just go ahead and write colon -1. Okay. Now, if this string is if I'm see this is what I'm getting the reverse of a string, right? If I'm writing this particular code, I just need to compare this with my s, right? So if I go ahead and write s double equal to, this will either give true or false. This is basically the reverse of this specific string itself, right? So if both of them are equal, then we can definitely say that it is a palindrome. Now let us go ahead and see here. I will go ahead and call is palindrome. Now in Google also you can search for different text, right? So I will use a sentence which is called as a man, a plan, canal, Panama. Okay. Now, if you read from here, right, and if you read from the reverse, it is almost same. See, a man, right? So if it is starting from a man, so here also from backwards, if I read a man is over here, right? Then again a plan, so a is over here and plan is still here, right? So if you read this particular sentence, it is reverse. Again, it is almost same, right? So let's go ahead and print this. And next one, I will just go ahead and take one sentence which is not palindrome. So let me just go ahead and write hello. So in hello case, I don't have the same sentence from forward or backward. Right? It is not equal. So first one should be giving me true, and second one should be giving me false. So here you can see it is true, and the second one is basically false. So this is one amazing example with respect to palindrome. And just by using the string operation, slicing operation, how easily you are able to do it. Okay. Now the next example that we are basically going to see is something called called as factorial of a number using recursion. Now, what is recursion? Recursion is nothing but if I create a function, that function inside the body of the function will be called again and again. Okay. And if I talk about factorials, let's say I would calculate 5 factorials. So it is nothing but 5 into 4 into 3 into 2 into 1, right? So this basically is the operation of any factorials, right? So I have to write a function which will be factorial. And let's say I want a factorial for 5, right? So first condition will be that if n is equal to 0, right? Then what I need to do, I just need to return 1, right? Because 5 into 4 into 3 into 1, right? So 3 into 2 into 1, it should be like that. If I'm starting from 5, it should end till 1. So if n becomes 0, I need to just return 1, okay? Else, I will go ahead and just use one simple return n multiplied by factorial n minus 1, right? So here I am calling this particular function, right? So initially if I give 5, right? So what will happen? This condition will become false. So it will just go ahead and write 5 multiplied by factorial of 4. Then again, factorial of 4 when it is called, it will be 4 into factorial of 3. Then 3 into factorial of 2. Then 2 into factorial of 1. Then 1 into factorial of 0. When 0 comes, return 1. So it will be multiplied by 1, right? So now if I just go ahead and call the function, it will be nothing but I can just go ahead and write factorial with respect to 5. And here you can see this is my output. If I want factorial for 6, this is the output. Here you can see, and I'm able to get it, right? And this is what is called as recursion. In recursion, inside a function, you're calling the same function unless and until based on this condition, it will keep on executing. Okay. So there are two more examples: function to read a file and count the frequency of the word. Okay, I know I have not discussed much about file operation yet. Okay, but I really want to show you, like, let's say that I have one file over here, sample text. I have written 2 lines of code. Hello world, how are you? My name is Krish. Okay, as we go ahead, we'll be discussing more about reading file and doing file operation. But here, I just want to give you an example, like how we can create a function to do this task. Okay, so first of all, what I'll do, so my task is very simple over here. I will try to read a file and count the frequency of each word. Right, so how many times each word is present. Okay, so quickly we'll go ahead and write definition count underscore word underscore frequency. Okay, and now I'm just going to give my file path. The best way to read file path is by using with open function. Open function is there in Python where you can specifically use and open any kind of file. So I'll go ahead and write word underscore count, and I know that since I need to count the frequency of each word, so I need a dictionary over here. So this will be an empty dictionary. Now I'll go ahead and write with open my file underscore path, and this will open in my read mode. Okay. So for read mode, I will give it in string. Okay, and there is also like write mode and all, which we'll be discussing as we go ahead in the upcoming sessions. And then we will go ahead and write as file. And then we will go ahead and write for line in file. Okay, and we are just going to write words is equal to line dot split. Okay. Line dot split. So we are splitting it based on new line characters. We are going through this particular file, right, with respect to that. Okay. Now once I get the words, right, once we by using this particular line of code, we will be getting words because every space it will try to calculate, it will split it, and it will retrieve all these words. Okay. Now once we get the words, what I will do is that I will go ahead and write for words in word. Okay. And here I'm going to basically write word is equal to word dot lower. Okay. So I'm going to do the lower operation. First of all, I really need to make small for all the words. Okay. Then let's say I want to probably do dot strip operation. Okay, and if you don't know about dot strip, you'll be able to understand whenever I give any specific words, it should be able to split based on any kind of character because I need each and every word. So I'll be using some special characters like colon, slash, exclamation, everything. I'll be using this even like it should also split HE also separately, right? So that is the reason I've given this also. And if there is exclamation, everything, I'll try to strip it and I'll try to get the word. Okay, then I'll just go ahead and write word of count, and I'll take that specific word. Okay, please focus on the logic. Okay, logic is super important, and logic you become better when you keep on practicing. Then I'm going to write word underscore count dot get, and here I'm going to write word comma 0. Okay, word comma 0, and then we are going to add it with 1. Okay, so I'm using this get function which is available in the dictionary as I have already shown you, and I'll go and search for the specific word. Okay, if it is not present, then the value will be assigned to 0. Otherwise, we're just going to increment with 1. And we have already seen dot get in our previous videos when we discussed about dictionaries. And finally, once it does it, I'm just going to return my word count, and it needs to be with respect to this particular width, right, in the same line. Now let me just go ahead and call the function. Here, first of all, I need to give my file path. Okay, file path is very simple. In the same working location, I have sample.txt file. So this is the same file. It is present in my same folder location, that is functions. So I'm just going to go ahead and call this. Then I'm going to use word underscore frequency is equal to count underscore word underscore frequency, and then I'm just going to give the file path. Okay, so this will basically be my file path. Now after this, I will just go ahead and print the word frequency. Now see, each and everything is done. Let me execute, and always make sure, guys, indentation is the main key thing. Many people may face problem if your indentation is not correct. Okay, so now if I go ahead and execute it, cannot access local variable word where it is not associated with a value. So let's see where is the error. So word frequency of word, frequency of file path. If I'm going inside this particular function, inside this it is going to for words in word. Okay, okay, it should be opposite. Okay, so I'll just go ahead and write this because I have to access words. So here you can see hello is present, one word is present, everything is present one. Okay, so let me just go ahead and save it, and let me write again Krish. Okay, so Krish is present 2 times. So if I go ahead and execute, I should be getting Krish 2 times. So here is Krish. Okay, a simple example of a function to read a file and count the frequency of each word. So here we have taken a sample file and we have read it in the read mode, and we have counted each and every word. Amazing function again, and I hope you're learning many things out of it. Okay, more about the file operations we'll be discussing. There's a separate section that will be coming up as we go ahead. Now, final task. This is for you. Anyhow, I'll be giving you the code. Okay. So here the question is very simple. You need to validate the email address. Okay. So let's say that you there is a subscription emails that you really want to get from a company. Let's say there is a page, and people will go ahead and write any email and just click on start subscription, right? If they want the free materials or anything as such. Now the problem is that someone may not put a valid email address. So we also need to do the valid email check. So for this, I will already give you this particular code. Okay, and you can go ahead and write out and just try to understand it. Here I've used every special characters. Okay, it should be matching this pattern, right? Like let's say one of my email address is some username @ it can be gmail.com, right? So similarly, this is my first regular expression, right? It can be between A to Z, capital A to Z, 0 to 9 plus. Then again @ will be there again. You can have Gmail, you can have Hotmail, you can have Yahoo, anything as such, and then finally .com. Right, so this will be the entire matching for the regular expression. I will talk more about regular expression as I go ahead. Now, if I go ahead and check this, you'll be able to see it. Here you can see this is my true email. This is a valid email. This is not a valid email. So just go through this and check it out. The reason why I'm including some new things so that you get excited by just seeing all this kind of application. So I hope you like this particular video. This was it from my side. I will see you on the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to Python, and in this video we are going to discuss about lambda functions in Python. Now, what exactly is lambda function? Lambda function is a small anonymous function defined using the lambda keyword. Now whenever we talk about anonymous function, it can be basically said a function without a name, right? So they can have any number of arguments, but only one expression. Okay, and they are commonly used for short operation or as arguments to higher order function. Now, here, let me discuss about 2 to 3 keywords. First of all, anonymous function. Anonymous function is basically a function without a name. And in order to create lambda function, we specifically require lambda keyword, and they can have any number of argument, but only one expression. One expression basically means one logic, right? So here is one of the syntax I've given it over here, like lambda arguments colon expression. Now let me just show you with some of the good practical examples so that you'll be able to understand how does lambda function basically work. Okay. Now let me do one thing. Okay, let me just go ahead and create a function. Just call as definition a comma b. Okay. Now what I'm actually going to do over here is that I'll return a plus b. Now here obviously I created a function which is taking two numbers, and here clearly you can just write 2 comma 3, and here you'll be able to get an answer. Let's say the addition of two numbers 2 comma 3 is 5. Now over here, this is just a basic function, right? And inside this, you just have one expression, one logic that you have written, or one operation that you have written over here, right? And for this, you have created entirely one entire function. You have written a definition keyword, a comma b, all these things you have specifically written. Now what it says is that if you have just one expression, and let's say you have multiple parameters over here, then instead of just creating a wholesome function over here, you can create an anonymous function, which is also called as lambda function, a function without a name. Now, if I really want to convert this function into a lambda function, see the syntax, okay? So first of all, I will go ahead and write lambda, and then the second parameter that over here it is asking is argument. So what are arguments I'm giving for this particular function? It is very simple. It is a comma b. Okay. Now with respect to a comma b, I need to go ahead and write my expression. Expression is what task or what operation I'm actually doing. Okay. So once I execute this, so you can see that this becomes an anonymous function or lambda function also. So here I will just go ahead and create a variable, and this addition variable will be my lambda function. Okay. If you don't believe me, let's go ahead and see this type of addition. Okay, and we'll try to print it. So here you can see it is a function. Okay, lambda function is not saying, but here you can see that it is a kind of lambda function itself. A function without any specific name, like we did not use any definition. We have just created a variable. Now in order to call this, okay, all I have to do is that just call this variable, give the parameters that I want. Let's say I want to give 5 comma 6, and let me just go ahead and execute it. So here you can see automatically with the help of this lambda expression, entirely the operation is basically happening. Here, these are my arguments, and this is the expression that we have specifically given, right? So I hope you're able to understand and how beautifully, just by understanding the syntax, we've just given the values over here, and you're able to see the answer. Okay, let me do one more thing. Okay, let me just go ahead and create one function. Let's say I'll create a function which is called as even. Okay, and here I give a number. Okay. Now with respect to this number, I'll just go ahead and put a condition. If num modulus 2 is double equal to 0. So in short, I'm just checking whether the number is even or odd. Then I'm just going to return the value as true. Okay, perfect. Now let me just go ahead and give the value. So here I'm going to call a function write even 24. So here I'm actually going to get true. Okay. Now similar, if I want to convert this into a lambda function, let me just go ahead and create a variable even 1. I'll be using lambda. I'll give my parameters. What is my parameters? Arguments that I need to give? Only num. Then I'll write my colon, and all I have to basically do is write my expression. And the expression is over here, simple num modulus 2 is double equal to 0. Right. Now this even 1 becomes my variable. So now if I go ahead and just go ahead and write 12, now it is going to give me true because 12 is basically an even number. Right. And here you can write any variable. It is not necessary that you only need to write number. Okay. You can write A, you can write B, you can write C, whatever things you specifically want to write. Okay, based on that, you can actually do that. Now, let's try with some more examples. And here, this time I'm going to take multiple parameters. Okay, so let me just go ahead and create one function which is called as addition. Let's say, and here I'm actually going to give my x comma y comma z. So these are my parameters. I'm just going to return x plus y plus z. Okay. Now, when I'm actually doing this, if I'm calling my addition function, so here you'll be able to see that I'll give my values. So let's say 12, 13, 14. If I execute it, the sum is basically 39. Now let me show you how you can actually convert this into a lambda function. I'll create addition one variable, and now I'll be using a lambda function. And with respect to the specific lambda function, what I'm actually going to do, I'm going to give my arguments, which all is required. Let's say x, y, z. Then I'll be giving the colon, and I only have to write expression, and I've already shown you how to write it down, x plus y plus z, right? So this is it. And if I go ahead and call my addition 1, so here you'll be able to see that if I give my values 12, 13, and 14, I should be able to get 39, right? So through this way, I am not wasting much time to probably create a function. Instead, just by using a lambda function or anonymous function, I'm able to do all this kind of expression operations, right? Again, to repeat, guys, lambda function where only a single expression is there, we can actually convert that entire function into a lambda function itself. Lambda function has more amazing features, but for that we really need to understand about map, and there are two functions which called as map and filter. So in upcoming videos, we'll be discussing about this map function and filter function, and I'll just give you one example right now just to make you understand what exactly map and filter basically does. Okay, so yes, in the next video we'll be discussing more, but I just want to give you the expression, a power of lambda function with map. Okay, so let's say I want to probably go ahead and create a list, right? And with respect to the list, I have values like 1, 2, 3, 4, 5, 6. Okay, now let's say that I want to find the square of each and every number, right? If I want to find the square of each and every number, or let's say I want to just go ahead and see that, hey, let's say I'll just go ahead and create a variable. Let's say square underscore numbers. Okay. Now in order to find out square for every number, right? What is the kind of function we'll define? Let's say I'm going to define definition square. Okay, square. And here I am going to give my numbers, or let me just give single number. Then what this is going to do? Return number double star square, right? So here we are just giving a square. And if I give two number, I'm going to get the square of that particular number. This is fine. And this is only for one number, right? Now, if I'm giving for a list of number, then what I have to do? I'll give this number as a parameter over here. I'll write a for loop, iterate through each and every number, and do this particular operation and return it, right? But is there a better way? Instead of iterating it throughly, probably writing more couple of lines of code for this, right? Is there a better way? So we can specifically use this map function. Map function, what it does is that it applies a function to all items in the list, okay, right? Or any collection also. Okay, so what does this basically mean? And I will show you along with the map function. Okay, so now, along with the lambda function. Now let me just go ahead and create this lambda function. So first of all, I will go ahead and write lambda. I know what is my operation. My operation is basically squaring, right? So I will create a argument. So argument I will be requiring a number x, and the expression will be x squared. Okay, so this basically becomes lambda, right? Now, map basically requires the first parameter in map is basically a function. The second parameter is iterables. So this actually is my lambda function, or you can also call this particular function, but right now I'm giving my lambda function over here. And the second parameter that I'm actually going to give is nothing but my numbers, right? So here is basically my map, right? Now, at the end of the day, if I execute this, this basically creates a map object at this particular memory location. And map usually uses a lazy loading technique. That basically means still it is not completely initialized. So to make it initialized, I will convert this into a list. Now see the magic, okay? For every number in this particular list, automatically you're able to get the square, right? Isn't it beautiful? So I will just try to show you like how you can use map, lambda, and there's also one more function which is called as filter, right? And I'll explain all these things in my upcoming video. So yes, this was it from my side. I will see you all in the next video. Thank you. Hello guys, so we are going to continue discussion with respect to Python, and in this video we are going to discuss about the map function. Okay, so what exactly is a map function? It applies a given function to all the items in an input list or any other iterable and returns a map object, an iterator. This is particularly useful for transforming data in list comprehensively. Now, best example to show you that why do we exactly use map? Let me just go ahead and write a code for you. Okay, so let's say I will just go ahead and define one method which is called a square. Okay, so what a square does is that it takes an input and it just multiplies, or it does a square of that specific input, or it multiplies it with itself, and it gives us the result. Okay, so if I go ahead and try to put any number over here, let's say square of 4 is nothing but 16. If I go ahead and ask square of 10, then I should be getting 100, right? Now this is fine, right? Here it's very simple. I'm just giving an input and I'm doing the square of it. Okay, now let's say if I have a list of numbers, or let's say I have a numbers in the form of list, or it can be in the form of tuple. Let's say in this particular case I have all these numbers 1 2 3 4 5 6 7 8. Okay, now I want to apply the same operation for each and every number. One way is that I may probably give the list directly over here, then I may put a for loop, right? Iterate to each and every element, and then probably do the multiplication and append in a separate list, right? So for doing this specific operation, I need to do so many things, right? I need to create an empty list and again do the append operation inside that. Iterate through all these particular elements. Now, instead of doing all those things, we can directly use map, right? Now let me show you what does map usually take. Okay. Now I want to perform these operations on all these elements. So map usually takes two input parameters. Okay. One is the function name and one is the iterable. Iterable basically means the collection, right? So in this particular case, if I'm calling map, so first parameter that I'm going to give is square. So square is my function. I don't even have to use brackets over here. And the second thing that I have to give is my iterable, that is my numbers. Okay. So if I go ahead and execute this, here you can see that it has created a map object at this specific memory location. Now since I want, let's say, all the values in the form of list, so I will just go ahead and convert this into a list. Okay. So if I convert this into a list, so here you'll be able to see the output. Right? Now what this is going to do is that it is going to take each and every number. The map is going to take each and every number, call this particular function, and basically just for each and every number, it is just going to do the square. Right? Now if I go ahead and see the answer. So this basically becomes my list over here. So I have to use this brackets since, okay, now let's go ahead and see this. So here you can see for every number 1, 4, 9, 16, 25, 36, 49, 60, it's just squared up each and every number. So this is one basic example of using map, right? So it applies a given function to all the items in an input list, like in this particular case it is list, or it can be any other iterable. Okay, now this is amazing. Let me just show you more functionalities, and this time I will be using lambda function with map. Okay, lambda function with map. And obviously lambda function, you know that if there is a single expression, you can just go ahead and apply lambda. Okay, so I will take the same operation. So let's say this is my numbers. Okay, now how do I apply? Instead of this particular function, I'll apply lambda function and I'll give the same number. So again, I will go ahead and write list, and here I'm going to use the map function. The first parameter will be my lambda function. Lambda function is nothing but it is an anonymous function. So I'll just go ahead and write lambda. Now what is the kind of operation that I really want to do? So input argument will be one x parameter, let's say any x parameter, and here I'm just going to multiply x into x, right? And this is my entire lambda function itself, right? Now the second parameter is nothing but my numbers, which is my list. Now if I go ahead and execute it, here you'll be able to see with the help of lambda function also, we're able to execute this. Okay. Now this is also very much simple, very much easy. Here you can write any kind of operation. Let's say I want to just add 10, I want to add 100, I want to do the multiplication, division, anything that I really want to do, I'll be able to do it. Okay. Now let's say that, okay, fine, this is fine. Okay. Can we map multiple iterables? Now the question is, can we map multiple iterables? Okay. And that is what we are going to discuss over here. So let me go ahead and write numbers 1. Okay, numbers 1. And here I'm just going to create 1 2 3. And then I'm just going to write numbers 2, which is equal to 4, 5, 6. Okay. Now, since I have two iterables over here, and what I really want to do is that take each and every element from this iterable and keep on adding both of them. Let's say my final output should be a list of elements where I'll be adding the first element, second element, and third element. So my final answer should be 5, 7, 9. Okay. So can I do that with the help of map and lambda function? So here I'm just going to go ahead and create added underscore numbers. Okay, and here I'm going to just go ahead and use map. Along with that, I'm going to use my lambda function. Let's say I'm going to take two parameters, right? This will be one parameter, this will be the other parameter. So I will just go ahead and use x comma y. And now my expression will be very simple, right? I'm just going to add both these numbers. So it should be x plus y, right? Now the second parameter that I would give is my numbers 1, right? So it will be my numbers 1. Now second parameter also I can actually give, right? So second parameter will be my next list, right? So here I'm just going to go ahead and paste number 2. And this all needs to be converted in list. Okay. And now if I go ahead and print my added numbers, so here you can see that I'm able to get 5, 7, 9, right? So this is one amazing example directly what I'm actually doing. Now there are multiple things that we can do with map. Let's show you one more operation. So here now I try to use map to convert a list of string to integers. Okay, I'm going to do this. Okay, now let's say that I have this entire code. Okay, I'll just show you this code. Very simple. So here is my string numbers. What I'm actually doing, I'm just applying map. The function will be int. So typecasting is basically done on all the string underscore numbers, which is in the form of list. And here you can actually see I'll be able to get the output. So there are a lot of options that you can specifically do with the help of map. Again, you can use inbuilt function like int, like string.upper, anything that you really want to do. And one thing you have to make sure, whenever you're using function, I don't have to use any brackets, right? So like lambda function I've called, square I've called, square is already defined over here. I don't have to use any brackets. Okay. Now let me just show you one more good example that how I can apply inbuilt function with the help of map. So let's say these are my words. Okay. The first word is apple, and let's say that these all are in smaller character. Then I have banana. Then I have cherry. Okay. Now what I'm actually going to do, I'm just going to create my upper words, and here I'm going to use list of map. Okay. And now I know that in string there is a method is called as dot upper, and I need to apply this str.upper on each and every words, right? So I'll just go ahead and write words. So once I do this and once I print my upper underscore words or word, I'll be able to see this. See, apple, banana, and cherry is there. Okay. Let me just do one more thing, one more best thing over here. Let's apply to a list of dictionary. Let's apply a map function to a list of dictionary. So I will go ahead and create a function which will be saying get underscore name. Okay. So here I will be giving my dictionary. Okay. This person will be a dictionary, and I will return person of name. Okay. Now this is fine for one dictionary item, right? But what if I have a list of dictionary item? Let's say that I have a list of dictionary item which I will define over here. So let's say I'll go ahead and write people, and let me quickly go ahead and define over here, and let me go and write name colon. Okay. And name will basically be Krish, comma age will be nothing but colon 32. Okay. So this will be my first name item or people item, and then let me just go ahead and say name colon is equal to Jack. Okay. And then I have the age as 33. Okay, so this will be my second item. Okay, now I want to perform this not only to one item, instead all the items, right? So let's say I've just taken 2 over here. Now how do I do it? First of all, I will use list, then I will use map. The map first function will be get underscore name. Okay, then I'll be applying this to my entire iterable. And here I have list of dictionary items, right? So if I go ahead and see the output, here you can see from these 2 records I've explored Christian Jack, and it is being given me in the form of list, right? This is one amazing things that you'll be able to see over here. At the end of the day, you can apply even multiple functions if you want. You can create multiple functions and apply to the same list of elements. So in conclusion, if I really want to talk about map, so here one thing is that a map is used. It is used in various places. So I'll just give some kind of conclusion over here. So map function is a powerful tool for applying transformation to iterable data structures. It can be used with regular functions, lambda function, even multiple tables, providing a versatile approach to data processing in Python. So by understanding utilizing map, you can write more efficient and readable code. So it is quite efficient, in just single line things without iterating. You're using these particular efficient data structures, and at the end of the day, you just need to make sure your code is much more readable, efficiency is there, performance is there with respect to this. So I hope you like this particular video. This was about map function. I'll see you on the next video. Thank you. Hello, so we are going to continue discussion with respect to Python, and in this video we are going to discuss about filter function. Now, what exactly is filter function? So filter function constructs an iterator from elements of an iterable for which a function returns true. It is used to filter out items from a list based on a condition. So finally, just to understand what does filter function do, it is used to filter out items from a list or any iterable based on a condition. Okay. So in order to make you understand, let me just go ahead and quickly write a code for you. So here I'm going to create a definition. Let's say this is my function which will tell whether a number is even or odd, right? Or let's say this particular number is this function is just going to check whether the number is even, and it is just going to return true or false. So here if I'm giving num, okay, and let's say that I'm going to write my condition if num percentile 2 is double equal to 0, then what we are going to do, we're just going to return true, right? So perfect, this works absolutely fine. We have seen this kind of function a lot. So now if I just go ahead and give my 24, so it is just going to give me true because this is obviously a true number. But let's say that now I have a list of elements, and here I have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like this, 11, 12. Okay. Now I want to apply the same operation on top of this particular element, and I want to just filter out which satisfies only the specific condition, right? So now focus on the last statement. It is used to filter out items from a list based on a condition, right? So this is my condition, and I want to filter out from this specific list, right? So how do I do it? Yes, I can actually do it. I can just iterate through all these particular elements inside this even function, and then I should be able to do it, right? I should be able to get true, probably append it in another list and get the values. But let's do this with the help of filter, okay? Now in filter, if you know about filter, right? Filter usually takes first parameter as again function. So in this case, even is my function, and the second parameter will be my list, okay? Now what this filter does is that whatever condition I've written inside this particular function, only that will get applied into this, and the elements will be taken from the list only which satisfies this condition, right? Which is returning true. Only that elements will be taken out. Okay. So here when I say filter even of list, and let me just go ahead and probably convert this into a list, you will be able to see that I'll be getting all the elements that are only even, right? So this is a basic example to understand about filter function, right? So it applies a kind of filter on the list that we specifically have. Okay. Very easy with respect to this. Now let's go ahead and see more examples, and this time I'm going to take filter with a lambda function. Okay. So lambda function, and I'll try to use the same thing, or let me just use some other things. Like let's say this is my number variable. I have like 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then I'll say, hey, do a filter and try to just take out greater than 5. Okay. Greater than 5. Okay. Try to create a filter something like that from this particular list. I should only get numbers that are greater than 5. So now I will just go ahead and write list. I will go ahead and use filter function. Now let me just go ahead and define my lambda function, right? Lambda function will be very simple. If I go ahead and write this lambda expression, this will be my argument. Argument, and I'll be writing my expression that is x is greater than 5, and on which list I'll basically apply this entire thing in my numbers, right? So this entire function is going to get applied on this particular list. Now once I go ahead and print it, you'll be able to see that I will only be getting the elements greater than 5, right? So this is one amazing thing with respect to list, and here with a simple just logic how you're able to use filter. Even in the previous video we saw about lambda also. Now I will show you filter operation with multiple conditions. Okay, so here I'm going to say filter with a lambda function and multiple conditions. So just to make you understand what all things are possible. Okay, so multiple conditions. Now as usual I'll take these numbers, okay, right, and let's say I will write a variable even, and it should be even. I'm writing to check, okay, even and greater than 5. Okay, so this is my variable that I'm actually going to create. Two things I'm actually doing over here. First of all, I will check whether the number is even or not. Will filter out based on the number is even or not, and it should be greater than 5. So in this, I will again use list. I will again use filter. Okay, and along with that, I will use my lambda x colon greater than 5. Okay, so this is my one condition, and I will go ahead and use one logical and. So and operation over here I will use, and this will be x percentile 2 or modulus 2 is double equal to 0. So these are my two conditions. If it is getting satisfied, this will get applied to all my numbers, list of numbers that is available over here. So inside this lambda function, what we are doing, we are applying two expressions. One is x is greater than 5, and the other one is x modulus 2 is double equal to 0. Right now, if I go ahead and print, so what it is going to do, first of all, it is going to check whether it is even or not, and then whether it is greater than 5. So out of this elements, you'll be able to see that I'm able to get only 6 and 8. Remaining all elements are odd or less than 5. Perfect. Let's go ahead and see one more way of doing this. Okay. Now let's say that I want to apply a filter operation not only on list, let's say on dictionaries. Okay. So here I will just go ahead and do this. Okay. I will say, hey, apply filter to check if the age is greater than 25 in dictionary. Okay. So here you can basically see I will just create some data, and again I've already created this kind of data. So let me see from my which functions. Map function, I think I've actually used this kind of data. Yeah. So this is my people data. Okay. So here I have specifically people data. I'll use this same thing. Okay. Just trying to save time. Okay. Now from this, I will create a function where I'll say age greater than 25. Okay. And let's say I'll just make some more data over here. I will copy. I'll put over here. I'll say Jack. Then along with this, I'll say John. Age will be 25. Okay. And then what we're going to basically do, we're going to create a function here. We're going to give the person information, one item person information, and then we're just going to return the person of age, right? And this age should be greater than 25. And based on this, either it will return true or false, right? Now we are just going to apply this with the help of filter, and we will use this particular function. So I'll say filter, and this will be my age greater than 25 along with my people, because I need to apply this on my entire collection, that is iterable, and then I'll try to convert this into a list. So if I go ahead and print it, so here you'll be able to see name, age, age 32, and 33, because this particular condition checks only and returns only the age. Based on the age condition greater than 25, it will return those specific records. And yes, from this particular filter operation, you'll be able to see that I'm able to do this, right? So these are some of the amazing operations that you can do with filter. So I would definitely like to put some kind of conclusions, and I'm doing that particular thing with respect to every video that I record in this. So here, these are some of the conclusions. So here you can see the filter function is a powerful tool for creating iterators that filter items out of an iterable based on a function. It is commonly used for data cleaning, filter objects, and removing unwanted elements. By mastering filter, you can write more concise and efficient code for processing and manipulating collections in Python. So yes, this was about filter. Now, as we go ahead, we'll be discussing about, and again, we'll be reusing all these things. But I think you got a clear idea about functions, different types of functions, anonymous function, lambda function, map function, filter function. So yes, this was it from my side. I will see you all in the next video. Thank you. Hello guys, so we are going to continue our discussion with respect to Python, and in this video we are going to discuss about modules and packages. Now in Python, already it is an open source programming language, and as you all know that it has a lot of packages, through which you can actually use those packages. There will be a lot of different inbuilt functions that will be available in those packages, so that you don't even have to write the code completely from scratch, right? So just by using these modules and packages, you can actually use the functions that are available over there and quickly write down the code, right? So here, modules and packages helps organize and reuse the code. So let me just show you and let me talk about some of the important modules that we specifically use. And there are a lot of modules over there, and as you will be seeing, as I will be probably going ahead with more tutorials, you'll be seeing different packages that I'll be using. So first of all, I would like to show you how do we import a package, right? So this math, right? So let's say I'm importing math. This math is just like a package or a module, and inside this, I'll just say that this is a package, and inside this you have a lot of inbuilt functions, specifically mathematical operations that you really want to do. It will be available over here. So in order to import any package, we just need to go ahead and write import and that the package name, okay? And let's say if this package is not installed, then we have to probably install this particular package, okay? I'll show you one of the example. Let's say that I want to use NumPy. NumPy is an amazing package which works with array. I'll show you how to install it and probably go ahead. So here I have imported math. Now math has a lot of inbuilt function. Let's say I'll go ahead and write math sqrt. So this is basically a function which will do the square root of a number. So if I give the number over here and if I execute it, here you'll be able to see that I'm able to get the square root of 60. Okay. Similarly, you'll be seeing I will have different functions inside math, right? Let's say I want to use square root also, right? So how do I import square root function from this particular package? So I can just go ahead and write from the package name, right? So let's say from math import import sqrt, and let's say I want to use one more function that is available inside math, so it will be pi. Okay, so there are two functions that are available inside math. Okay, and if you want to probably go ahead and check it out, you can just go ahead and write math dot, and these are all the inbuilt functions that are available with respect to this particular package, right? Math dot, and here you'll be able to see it. Okay, so let's say I want to use the square root of pi, so I've imported both these functionalities over here. Now I can directly call this functionality or call this function. So I will just go ahead and write sqrt. Let's say I want the square root of 16, and then I want the square root of 25. Let's say, or I want also to probably print, what is the pi value? Okay, so pi, everybody knows how much is the value, right? 3.142. So if I go ahead and execute over here, you'll be able to see square root of 16 is 4, square root of 25 is 5, and pi is definitely 3.141. So similarly, in every packages, you may be having multiple functions which you can directly use it. And in order to import it, you just need to remember this particular keyword from the package name. Import any function that you want that is available in that particular package. Okay. Now let's say that you don't have a package right now. Let's say there is one more package which is called as NumPy. So I will go ahead and use NumPy. I will talk more about NumPy as we go ahead in the upcoming sessions. So there will be a detailed video on NumPy and pandas. NumPy is specifically a library that will be used whenever you want to create arrays, you want to apply different operations with respect to the arrays. So that where this particular package will be used. So if I am using NumPy, let's say I'll go ahead and write import NumPy as np. Now what this np is nothing but it is an alias. Okay, alias. I don't even have to write everything NumPy dot. I can directly use np dot. So that my code, I don't have to completely write the entire package name. So that is where we specifically use the alias. Now let's say that I'm importing this, and if I import this, I'm getting an error, no module name NumPy, because obviously I've not installed NumPy. When you create an environment by default in Python, a virtual environment, some of the packages, some of the modules will get installed, but not every module will get installed, right? So let's say that I want to probably go ahead and import NumPy, and for that I need to install. So what I will do in the requirement.txt, I'll go ahead and write NumPy, okay, and I'll save this, okay. Now I'll go to my terminal, okay. Now let me just go ahead and show you in my terminal. So my terminal will be over here, and I am in my command prompt. I'm inside my Python basics, so I will go cd dot dot. I'll go back because this is entirely this requirement.txt is present in this Python folder, right? Now I'll go ahead and write pip install -r requirement.txt. This is one way that I can directly write, or I can also go ahead and write pip install NumPy. Okay, so if I go ahead and install pip install NumPy, you'll be able to see that hey, my installation will start taking place, and this will basically get installed in my venv environment. Okay, so this is how things you basically do, and now you can see my NumPy has got installed. Okay, now I'll close this. Okay, and what I will do, I'll go again back to my statement. Now let's go ahead and import this. Okay, now here you'll be able to see that my import is successful. Okay, now let me just show you one simple operation where I will be trying to create an array, and here I will give 1 2 3 4. So if I go ahead and execute, I will basically get an array. We'll discuss more about the NumPy, but since we are just discussing about basic Python modules and packages, we're discussing over here, right? Now this is like there'll be a lot of inbuilt modules. Okay, let's say from math I want to import every module, right? So what I can do is that I will go ahead and write from math import star. Star basically means it is importing all the functions that are available in math, right? I don't have to specify, right? Now I can directly go ahead and call sqrt. Okay, let's say I will go and call sqrt. So sqrt is an inbuilt function that is available in math, and since we have done import star, automatically I'll be able to see the output. So here you can see I'm getting the answer as 4, right? And similarly I can go ahead and probably print my pi. Okay, and up also I will just go ahead and use a print statement. Okay, print statement, and then we are uploading this, and here you can just see by import star that basically means we are able to access all the functions that are available inside this particular package or module which is called as math. Perfect. I hope you're able to understand till here. There are different libraries that we'll be seeing when we'll be doing the coding, but just get an idea in this particular video. What I'm actually trying to show you is that how do you import a package or a module, an inbuilt module that is already available, inbuilt packages that are already available like math, NumPy. If there is no library as such, you can probably install it. Okay, now the most important thing, how do I probably create my own custom package? Okay, now let me show you one thing over here. Okay, let me just go ahead and create one folder, and this will basically be my package. Now let's say that this is my source code that I'm going to write. Okay, I want to define my own custom you can basically say custom module or custom package, which I should be able to call in any other files. Okay, because here you can see that I'm importing math, right? And this math may be available somewhere, right? It is available in our venv environment. All the packages are available, and we are importing from there, right? Now similarly, I can also go ahead and create my own custom things, right? So let's first of all start. So let's say this is my package folder, and here I'm going to create some modules. So first file that you actually require in this is init_init.py. Okay, so this .py file, why this init _init.py is that? It is a special file. Okay, so here I'll just go ahead and write a comment for you so that you'll be able to understand. Okay, so this is a special file. Okay, init underscore underscore py, or let me just use a multi-line. Okay, and I will go ahead and use this. See this. Okay, I will close it over here. Now this init underscore init dot underscore underscore dot py is a special file used in Python to define packages and initialize the namespace. Okay, so let's say that I've actually created this. Now let me just go ahead and create any file that I want. Let's say I will just go ahead and write one operation, or let's say that I am creating a calculator, and so here my maths.py file is there. Okay, now inside this maths.py file, what I will do, I will just go ahead and define a function. Let's say I'm going to write definition addition a comma b. Okay, so what this function basically does is that we are just going to return a plus b. Okay, we know that in math also, right, some operation is also there, inbuilt sum operation is there, but I'm just trying to show you. So inside this package, you will be able to see that math.py file is there, and inside that there is a function which is called as addition. Now, very important thing that you really need to understand. Over here, this package folder .math, right? It becomes our module, right? Since we are using this underscore init.py, and always remember, inside a folder, if you want to initialize this entire folder and define packages, right, or define modules, you have to probably use underscore init.py. Even though it is empty, just keep it empty, but you need to have this file. Now I'll show you how I will call this particular function by importing this, right, from this particular package. Okay. Now this is my entire package. Now I'll go back to my import.ipynb. Now here I will go ahead and write from packages, right? So see, from package I'm getting dot. What is my file name? Maths, right? Import, right? From package.math. See, from package.math. And remember, this needs to be in the same folder location. Then only you'll be able to call it, right? So from package.math, right? .math is basically this folder. I'm going to import addition. So let me just go ahead and copy this. And here you'll be able to see, I will just go ahead and copy this, right? Now after calling this, I can just go ahead and call this function. Right, and here I can give 2, 3, and if I execute it, you'll be able to see that I'm actually able to get the output. So I hope you're getting an idea, right? How do you probably create your own custom module, right? And from package.math, how I'm importing addition, right? And if you don't want to write like this, okay, let's write it in another way. From package import math, I can also write like this. Okay, I import maths. Now, in order to call this, I can go ahead and write maths.addition. Okay, and here I can call 2, 3, right? So this how you can probably create any number of files inside this particular package folder, right? Since I have underscore init.py. When I create only this file, then only this becomes a package or a module, right? And then I can actually call this anywhere that I want. I can build my own custom function. I can build any number of custom functions. Let's say I'll go ahead and write definition subtraction, and here I'll give a comma b, and let me just go ahead and write return a minus b. So once I've updated subtraction, so what I will do, let me just show you how to call. See, in IPynb, obviously you know how to call it, right? By just importing addition, maths, whatever things you specifically require. But mainly when we are developing projects, we have to call all these files in some py files. So let me just go ahead and create one more py file, and here I will just go ahead and write test.py. Okay, test.py already exists. Let me just check. Okay, here we'll create test.py. So test.py is over here. Now in this test.py, I will try to call from this particular package. So how do I call it? So here I will write from package.maths. Okay, import start. Okay, now what I can do, I can basically call my addition. So I'll go ahead and write print addition, and here I'm going to say 2, 3, and let me just go ahead and write print subtraction with 3, 4. Okay, or 4, 3. Okay, now I will just go ahead and show you how to execute this. So I can directly execute .py file. Always make sure you have to be inside this folder itself, right? This 5 modules. If you want to execute any test.py file, like any py file, you have to make sure that you have to go to that folder location and run it. So here I will just go to cd 5 modules. Okay, now in order to execute it, I will write python test.py. Now see, here I'm able to get an answer. For addition, I'm getting 2, 3. For subtraction, I'm getting 1. Okay, so this was just an idea where I've actually created the packages, my own custom packages, math.py file, any number of function that I want to, and I've shown you how to call it in IPynb file. Along with that, I will also have shown you how to call it in test.py file. So this in short talks about the most important thing, that how an import is basically done. Right? We'll also talk about one important thing which is called as sub package imports. Okay, and with respect to sub package imports, the thing is that let's say that okay, I have this packages. Okay, now let me just show you one more thing. Okay, I have this packages. Now I will click this. I'll create one more folder. Okay, and this inside my packages. Okay, so this is my package folder. I'll create one more folder, sub packages. Okay, now if I also want to make this as a package and probably call it somewhere, here also I have to use underscore init underscore .py file. Okay, now I can go ahead and create any operation that I want. Let's say I want to probably go ahead and write math.py. Okay, now math.py is nothing but we'll specifically be using this. Let's say instead of math, I'll just use some other file name so that we'll be able to distinguish it. Let's say mult.py. So this package is responsible in performing any multiplication operation. So let's say I'll go ahead and define my function, and I'll say, hey, this is my multiply. Here I'm going to give a comma b, and this is basically going to return a star b. I know the functions are very simple, but the core idea is to understand how to call all these packages. Now, perfect. This mult.py is present inside this sub package. Now, what I will do in my test.py, I will try to call this particular package. Okay. Now it will be interesting. So here you'll be able to see from package. Okay. Dot maths dot sub package. Okay. Sorry. From package dot sub package dot mult. Okay. I'm going to import my multiply function. See how step by step we went. So packages, first there were packages, then we went to sub packages, then we called this mult.py. And remember, we are only able to identify it unless and until this underscore init.py file is present or not. If this particular file is present, then this makes this particular folder as a package. Okay, by default. So now let me just go ahead and call this over here, and let me go ahead and print my multiplication. So here I will be calling my multiply function with 4, 5. Now if I just want to execute it, how do I execute it? I'll just go ahead and write python test.py. Okay, so here you can see initially I got 5, 1, and 20. Right. So addition 3 plus 2 is 5, 4 minus 3 is 1, and 4 multiplied by 5 is 20. So I hope you got this specific idea. I hope you're able to understand about packages and all. This was it from my side. And here I've shown you both the things, how to call default packages that are open source packages that are already available, right? So I've actually used this NumPy, math, and all. And the second thing that I've actually shown you how to call any other packages that are available in any other folders or functions that you're probably defining. So yes, this was it from my side. I will see you all in the next video. Thank you. Hello guys, so we're going to continue discussion with respect to Python, and in this video we're going to discuss about standard library overview. Now Python has a lot of libraries and packages which is completely open source, and you can definitely use them while you're coding your projects or developing something, right? So in this video I'll be showing you some set of libraries. Obviously it is not possible to cover all the libraries because there are more than 300k plus libraries, I guess. So it is very much difficult to cover each and everything, but just to give you an idea how to use some of the libraries, I'll be talking about them. So first of all, I'm going to show you about array. So array is one important library which will actually help you to create array itself, right? So here if I go ahead and define my array variable, and if I just go ahead and write array.array, right? And here in this particular array, we have to give two parameters. Okay, one is a temporary variable. Let's say I'm giving I, and then if I give 1, 2, 3, 4, so here you'll be able to see type code. I basically means integer, type code, and your initializer, right? So with respect to it, returns a new array whose items are restricted by type code. Okay, so here it is basically going to print an array with these integers. Okay, so you can see over here that I'm able to get this particular answer, right? So this is one. I've already spoken about math, so let me just go ahead and again show you with respect to math. So here I'm going to use math.sqrt, one common function that you have over here. So if I go ahead and want to find out the square root of any number, I'll be able to find it out. Then let me just go ahead and print, okay, math.py, and here you'll be able to see that I'll be able to get an answer. Okay, perfect. Now let me just talk about one more inbuilt library that we have, which is called as random, and this is most commonly we use it. Okay, so all we have to do is that go ahead and just do import random. Okay, and then we will go ahead and print. Over here, random, we specifically use two important inbuilt functions. So let's see which all inbuilt function is there, which is called as randint. Okay, randint basically means it provides any random integer based on the value that we give over here. Like, let's say if I give 1, 10, so it is going to give a random integer between 1 to 10, only one single number it is going to give you, right? It will be between 1 to 10. It will just pick up randomly and it will be giving you a number, right? And in one more function that we specifically use in random, which is called as random.choice. Let's say if I have multiple choice over here, and from that I want to select any choice in the case of string or anything as such, in the case of collection, sorry, then I will be able to use this. So let's say apple is there, banana is there, and over here you'll be able to see that cherry is there. Okay, so if I go ahead and execute it, so here you'll be able to see that, okay, randint, I'm able to get one value, and the value will be between 1 to 10. Okay, random choice is nothing but from the collection what choice it is basically picking up. Okay, so if I again execute it, this may change. If I again execute it, this may change, right? It may not be all the time same, so it is randomly picking up these particular values. Now we're going to talk about one very common library that we use, that is called as OS, right? So that is used for file and directory access. Okay, directory access. We'll be talking about file handling and more operation. There also we'll be using this. So let me just go ahead and import it. So this is called as import OS, and let's say I want to go ahead and print in which current working directory I'm working in my project. So I can use os.getcwd, get current working directory. Okay, and if I can execute it, here you can see that I am in this particular folder location. That is my Udemy final Python, and this is my fifth module, right? So I'm inside my fifth module, and automatically I'll be able to see that which working location I'm there. Let's say in this particular working location, I want to probably go ahead and create a folder. So I will go ahead and write os.make directory, right? So they are make directories, different functions there. Let's say I want to go ahead and write test dir. So this will be the directory name. As soon as I execute it, now you'll be able to see that I'll be having a folder which will be of text directory. Okay, one assignment that I really want to give: go ahead and find out the function that is used to create any file. Okay, so that you can actually go ahead and do it. Okay, now let's say I want to do some high level operations on files, right? High level operations on files and collection of files. Okay, let's say for that I will be using this import shut util, okay, il, and this function, let's say that I want to create util over here, and let's say that I have one source.txt file. Okay, so here let's say I have one source.txt file, and let's say here I go ahead and write hello, how are you, I'm good, I'm fine, welcome to the course. Okay, something like this. Now inside this standard library, by using this, let's say I will go ahead and do an operation which is called as copy file. Okay, I will copy this file that is nothing but source.txt. Please make sure that you are in the same working location, and then let's say I will go ahead and create my another file which is called as destination.txt. Now let's see whether we'll get an error saying that whether there is a file or not. So here you can see destination.txt is there. Did I get it? Yes. This is my destination.txt. This is my source.txt. Automatically the copy from source.txt happened in the destination.txt. Okay, so this is another important operation that we specifically use in this. Okay, so let me just close this. I think many files has got open. Okay, but I hope you are able to understand it what we are trying to talk about. Okay, now the next thing is that let's talk about one very important or common thing that we will be doing. It is nothing but data realization, like converting a dictionary into a JSON, right, or converting any data frame. What it is, we'll discuss more about it. Let's say that we want to convert that into a JSON. JSON is very much important because whenever we create an APIs, let's say whether we are retrieving any data from the database, specifically NoSQL database, the return type of the data or the response, or we are interacting with any API, the response will be in the form of API itself, right? The response will be in the form of JSON, right? So in order to work with JSON, so we usually import this JSON library, and let's say that I am creating one data. Okay, let's say the name is Krish. Okay, and here what we're going to do is that we're going to basically write the age will be equal to 25, right? So right now this is just my dictionary. Now if I want to convert this dictionary into JSON, so I will use the JSON.dumps. Okay, and when I write JSON.dump on this particular data, I will be getting JSON in the form of string. Okay, which is basically required. Okay, now let me just go ahead and print this. Okay, so I will go ahead and print JSON_str. Okay, now once you print it, and let me just go ahead and print the type of this also, so that you will not get any confusion. So type of JSON_str. Okay, now let's say I want to convert this back into this kind of dictionary again, right? So for that, one operation that I use is JSON dump. One operation will be JSON.load, right? So whatever JSON, let's say when I'm interacting with an API, I get some kind of JSON in response. That will be always in the string format, which I've actually converted. Now if I want to convert this back into a dictionary and probably do any kind of operation over here, so I can actually go ahead and use JSON.load operation, and here I will give my JSON string. And now this will basically be my parsed data is equal to this one, right? And now what I'm actually going to do after this is that I will go ahead and print my parsed data, and I'll also go ahead and see the type of it. So I'm going to see print type of parsed_data. So if I go ahead and execute it, here you can see initially this was my it got converted into a string, so the class is string. Then again we converted back into a dictionary, right? So JSON, whenever we get in the form of API from an API, it will be in this particular string format. We can just load that particular information, convert that into a dictionary, and perform data serialization. Okay, so this is one very good example of probably writing each and everything over here, and this is what is all about data serialization, and we'll be using this a lot as we go ahead. Okay, now let me just go ahead and talk about one more standard library which is called as CSV. Okay, whenever you need to work with a CSV file, right, and there are a lot of files which we'll be learning, and we'll be using pandas and all. There we'll be learning more different kind of operations and all. Okay, so I'll go ahead and just import CSV, and now with open, right, with open, and here I'm going to specifically use, let's say, I will create an example.csv file, okay, and then let me just go ahead and write the mode, right? So open has, first of all, you need to give the file name, then what mode you really want to open it. Let's say I want to open this in write mode, so I will go ahead and write W. There is also something called as W plus mode. So W plus is nothing but write append, okay, and here I will go ahead and say, hey, use the new line as this, okay, so it should be as this, and I will open this as a file object, okay. Now by using the CSV dot, I will go ahead and write inside this particular file. So there is a writer function, right? We will write inside this file, and this will basically be my writer. Now I can go ahead and take any data and write each and every row. So here what I'm going to do, I'm going to basically write writer dot write row, okay, and let me just go ahead and give the row. So first row will be my column names, name, comma, age. I have to give this in the form of list or collection. Then I will go ahead and write writer dot write row, and I will start writing my second row. And now I will start with my data. So let's say Krish, and here I'll be able to put 32, or I'll go ahead and put integer, right? Now this in short, what it is going to do is that it is going to create an example.csv file, okay, and there it is going to insert two records. One is with the column name, comma, age, and the next one is with respect to the data, okay. Now what I'm actually going to do, I'm going to write with open, okay, and here I'm going to specifically write example.csv, because once I create this particular CSV file, it is in the right mode, right? I'll create the CSV file. Now we'll try to read it, okay. Now I'll change the mode to R, okay, and now what I will do, I will basically read the entire file, the CSV file. So I'll create a reader is equal to csv.reader function is there, and I will give the file name, okay, whatever file is over here. Then since I will be having multiple rows, so I will go ahead and write for row in row reader, and we will just go ahead and print the rows. So what we have actually done, we have created a CSV file, we have printed two records, and then now we are opening the same CSV file and we are reading the data, right? So let's go ahead and execute it. So here you can see, let's see first of all whether the CSV file is created or not. See, example.csv is created, and here is my two records. You can also open this with Excel file, okay? And now I'm reading this, and I'm also displaying it over here. So perfect. This is one very important function that we can actually use, okay? So you can actually go ahead with seeing this, okay? Now one more function that one more standard library that we specifically use is datetime, okay? Now with respect to datetime, you can go ahead and import something like this from datetime import. So datetime is again a module, so I'll be importing from datetime import datetime. Along with that, I can also import one more function which is called as time delta, okay? Time delta. Now if I want the current time, so I can go ahead and write datetime dot now, okay? So datetime dot now will specifically give you the current time or current date, okay? Then let's go ahead and print now, okay? Let's go ahead and print now, and then let's say I want to probably currently what is the time in yesterday, one day back, right? So I can actually use time delta. So let's say yesterday I will go ahead and write is equal to now minus time delta. Let's say that I'm going to go ahead and calculate difference, and here I'm going to use one parameter days is equal to 1. I'm saying that hey, go one day back, and with respect to that, just try to calculate the entire delta itself, right? So like one day back, what will be the time, right? So here I'm going to just go ahead and print yesterday. So if I go ahead and execute right now, the time is 11:37. I can see the watch; it is perfectly fine. And yesterday, one day back, it was 11:37. I'm just doing currently divided by minus time delta of day is equal to 1. And yesterday time will be something like this, right? So this is also one very good thing with respect to this. Okay. Now one more standard library that we can specifically use and which is common is nothing but time. Okay. Let's say I'm writing a code. I want to make the program sleep for some couple of seconds, right? So for that I can use time. So import time, and let's say if I go ahead and print time.time, okay, and let me just go ahead and say, hey, after this you just sleep for 2 seconds, sleep for 2 seconds, and then again let's go ahead and print time.time. Now if I go ahead and execute it, here you can see it sleeping for 2 seconds, and then I got this specific thing, right? This is what it is more about, and you'll be able to see that, wow, we're able to do some amazing thing with respect to this. We're able to make the program sleep for some seconds also, okay? Now, one more common libraries that we will be using is something called as regular expression. So for regular expression, there is a library, again, which is called as import RE, okay? Now, regular expression basically helps you to match a specific expression in the top of a sentence. You can do it on an entire data set and do many things. Let's say that I define a pattern, okay? Now, with respect to this particular pattern, I'm saying, hey, use this pattern, something like this, okay? I'll say, hey, go ahead and use this. It'll be /d plus, okay? Let's say this is the pattern that I select, and I'm having a text, okay? There are 123 apples, okay? Then I will say, let's go ahead and match whether this pattern is there or not, okay? Digit plus, okay? Whether this pattern is there or not. So in order to do that, I will just go ahead and write re.search, and here we're going to use pattern, comma, text, okay? So let's go ahead and print match dot group, okay? So if I go ahead and use dot group, so here you'll be able to see the answer where this specific D plus pattern is getting matched. So here you can see that 1, 2, 3 is present, and D is basically digits, right? We're just going to see that where digits are specifically there, right? And we are going to get over here. If I go ahead and write over here another 1, 4, 5, 6, so here you'll be able to see that after getting this continuous digit match, then it will stop over there because the match is successfully done over here, right? So match is successfully done, so we don't have to check the forward one. So this is some of the things that we specifically use in regular expression. Now this can be a lot more complicated. It is not you always have to probably use this, right? It is other things also you can probably check, okay? So I hope you were able to understand this. These were some of the standard libraries. Again, there are a lot libraries as I always said. Okay, there is no limit as such. It is up to you how much you can try. You can practice, keep on practicing, and based on different scenarios you can use this. So I hope you like this particular video, and this was it from my side. I'll see you in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to Python, and in this video we are going to talk about file operations. We will be performing various file operations with the help of Python programming language. We will be playing with both text and binary files, and we'll also be understanding how to probably create files, how to write inside that, how to read the file content, and many more things. So let's go ahead, and first of all, let me just go ahead and do the first task, that is read a whole file, right? So for reading a whole file, again, we will be using with open method, right? And here I'm going to give my file name. Let's say that I'm going to give example.txt, and the first second parameter inside this open, we will specifically use this r parameter. R basically means read, okay? And then also other parameters which we'll discuss, like write, write append, read append, append, right? Sorry, not read append, it is append separately. Then we have w plus operation where we can both read and write a specific file. So we'll be seeing one by one. So let us first of all start with read. So this will be my read operation, and I'll create a object of file, and then from line in line, okay? So from line in file. So inside this particular file, how many lines are there? Like in example.txt, we'll keep on reading it. And now let me do one thing. Instead of writing, instead of just going line to line, initially we'll just go ahead and create a variable called as content, and we'll take this file, and then there's an operation which is called as dot read. So what dot read is basically going to do is that it is just going to read the entire content of the file. Okay. So right now I've not created the file, that is example.txt. So we will go ahead and execute it. So here you can see that I'm getting an error saying that hey, no such file or directory in example.txt. Right. So this is the first error we usually get whenever we are directly trying to read. I'll be showing you other ways also, but there what will happen is that if I'm trying to read it, right, first of all it will create a file and then we will be able to read it. Okay. Now here what I'm going to do. So this is the file handling part. I'll go ahead and create one example.txt file. Okay. And with respect to this example.txt file, I'll just go ahead and write hello, how are you? Okay. And I'm good. Okay. Something like this. Krish is my name. Okay, and welcome to the course. Okay, something like this. So now I'm going to perform all these things. I'll be reading specifically from this example.txt, and now let me just go ahead and execute it. Okay, you'll be able to see that now I'm reading the entire content, right? So with example.txt, this is basically opening this particular file in the read mode. Okay, we'll not be able to write if you are opening with the help of read mode, right? And then we are just reading the entire file content. Now I may also have a scenario that I want to read a file line by line. Okay, I just want to read it line by line. Now how do I read it line by line? So here we're going to specifically use with open operator, right? Here I'm going to use my again example.txt file, and this will specifically open in read mode. And now I'm going to use this particular object as file. Now since I have to read all these things line by line, so now I can go ahead and use my for loops, so that file will be over here as an iterable loop because I have so much of content over here, right? So for line in file, right, I'm just going to go ahead and print my line, okay? And what I'm actually also going to do is that if I go ahead and execute this, so here you can see example, okay, example spelling is not right, so I'll just make it right. Now here you can see that when I'm reading line by line, it is also taking the new line characters, right? So here, because when I see this, right, if I go to the next line, so here a new line is basically getting added. So that is the reason you'll be able to see this space. Now let's say I want to go ahead and remove this particular new line character. So for that, I'll be using an operation which is called as dot strip, okay? So this dot strip operation removes the new line character. Perfect. So this is what we are able to do it out of it. Okay. So this is what is there, right? And we are able to get the output. Now let's do some more operation. Now what I'm actually going to do over here is that let's say that I want to probably open a file for writing something inside it, right? So here, let me go ahead and write writing a file. Okay. And here I will also make sure that I will show you overwriting clauses. Okay. Over here, right? Now let me do the same thing with open function, and I'm going to basically open this, and here I'm going to use example.txt, right? And this will basically be my write byte mode and as file. Okay. And then I will go ahead and write file.write. And let me quickly go ahead and write hello world. Okay, I'm writing this hello world with a new line character. Okay, so file.write. Write is a method which will specifically help me to write anything inside this file. And here you can see that I'm using W mode over here. W mode is nothing but write mode. Okay, now this is the first line that I'm going to add over there with a new line, and then I'm going to add file.write. This is again a new line. So let's say I'll just go ahead and write this is a new line. Okay, and let me just go ahead and execute this. So let's see what will basically happen. Now as soon as I execute this, already in example.txt I have this content. So if I go ahead and execute it, here you'll be able to see that the entire content got overwritten, right? So overwritten basically because I have just opened this particular file for the write mode, and it will just consider okay, the file is completely empty. And when we write file.write, it is just going to overwrite completely from this particular content. And again, this is a problem out there. We should never be doing like this. Instead, if I want to write a file, write a file without overwriting, okay, without overwriting, then I'll be using a different approach. So let me just go ahead and do it. So I'll say from open. Okay, and here I'm going to specifically use example.txt, and let me just open this in another mode which is called as append mode. Okay, now in this append mode, what will happen is that if I go ahead and write anything, so if I go ahead and write file.write, append operation taking place, okay, and if I go ahead and execute it now, so here you'll be able to see this operation is taking place. Now if I go ahead and see in the example.txt, this is the new thing that is getting appended, right? I may also want to write it in the next line, so you can just use /n over here and do it, right? And now here clearly you can see that I'm able to append any text. Okay, let's say I'll go ahead and write /n again. I'll try to append this. Okay, so here you'll be able to see again it is getting appended. Now along with that, what I'm actually going to do is that again let's go ahead and append this. So here you can see it'll go to the new line because I had used /n before, right? So the file operation is basically taking place, and here you're able to append it. Okay, now there may be also scenarios that I want to write multiple lines. Okay, multiple lines specifically. So writing a list of lines to a file. So let's do this. Okay, again let's say this is lines. Okay, these are my list of lines. So here I'm just going to write, okay, this is my first line /n, then the second line /n. Okay, and let's go to the third line /n. Okay, so these are my three lines that I really want to add. Okay, let me make some cells and let me copy this thing entirely. Okay, and let me do this operation over here. Okay, now what I'm actually going to do, I will just go ahead and open my file. Okay, and I will try to open this same example.txt file in my append mode. Okay, in my append mode, and I'll create an object as file. Now in order to write all the lines right inside this particular list, there's again a function which I can actually use, which is called as file.write lines, and all I have to give my list over here, right? So once I execute it, you'll be able to see that now first line, second line, and third line has got appended. Okay, so apologies for this particular spelling kind of error, so you can actually make the changes as based on your grammatical things that you have, right? So I'm just making sure that I try to show you more amazing features with respect to this. Okay, now this was with respect to text file. Now let's go ahead and discuss with respect to binary files. Okay, how to work with binary file. Binary files are usually, if I probably see the extension, it is basically a bin file, right? So if I go ahead and create a file over here, you'll be able to see if I go and write example.bin. Okay, so this is what we basically say it as binary files. Okay, let me just go ahead and append something over here, hello world, something. Okay, some information over here, and this will be in the form of binary files. Now I'll go ahead and show you how you can read or write binary files. In binary files, we usually update bytes. Okay, bytes is very much important. So I'll just keep this as empty right now with respect to binary files. So let me just go ahead and write. So here I'm just going to write to a binary file, I'll be using this kind of bytes, okay, with open example.bin in write byte mode, okay. So now my this operation will become, it will not be read or write, it will be read byte or write byte, okay. Since I'm going to write, so I'm going to basically use it as write byte. Now if I go ahead and execute it, so here you'll be able to see in the bin, this is what I'm actually able to get, okay, in the form of bytes, okay. So this is one of the operations that you can see over here, right. Similarly, if you want to probably read it, again we can use, instead of writing R, we can also use RB, okay. So RB as file.read, and we are just going to print the content, and this is what I'm able to display. Right now in bin file, it should be looking like this, and this is what I think hexacharacters for the same thing what we have actually written, okay. So this was one of the most beautiful thing with respect to file operation. Now as I said, let's do some of the things, right? Some practical examples and all, how to probably solve it. Okay. Let's say I want to read the content from a source text file and write it to a destination text file. Okay. If I want to do this, I can go ahead and write it. Again, for this, it is very much simple. I will first of all read from a file. So let's say I'm reading from my example.txt and I'm writing it to a destination.txt. So I'm not created destination.txt. Let's see whether we'll get an error or not. So here is the content that I'm getting, source underscore file.read. And when I write destination underscore file.write content. Okay. So if I execute it here, automatically you'll be able to see that I'll be creating this destination.txt. And this was my example.txt. Okay. This is one of the operation. One more assignment that you can probably take. Okay. Please make sure that you do this. It'll be important. Okay. And read a text file. Okay. And I've already done this, I think, for you all, but I'll give you this as an assignment. Read a text file and count the number of lines, words, and characters. And this is the code. So first of all, you try it from your side. Anyhow, I'll be giving you the code. Okay, you can give the file part example.txt and just go ahead and do this. Right. So this is the function that is got created. We are reading the lines. We are doing the summing up of all the lines itself. Okay. So this is one assignment you can probably take it. Okay. So I think we have discussed so many things about it, but let us go ahead and discuss about one more operation. Okay. That is nothing but writing and then reading a file. Okay. This kind of operation. Okay. So what I'm actually going to do, I'm going to basically use with open again, and let me just go ahead and write example.txt. Okay, and this time I'm going to open this file in W plus mode. W plus mode is nothing but, if you don't know about W plus mode, I'll just give a statement over here so that you'll be having this as a markdown. The W plus mode in Python is used to open a file for both reading and writing. If the file does not exist, it will be created. If the file exists, its content is truncated. That is, the file is overwritten. Okay, so here you'll be able to see that I'm using W plus mode as file. Okay, and here I'm just going to go ahead and probably write the data to the file. So let me just go ahead and write file.write, and here I'm just going to say, hey, hello world. Okay, this is going to overwrite it. Okay, and then I will go ahead and write file.write. Okay, this is a new line. Okay, this is done. Okay, perfect. Now after we write, we will make sure that we move the file cursor. Okay, what right now the file cursor will be pointing to the second line. Okay, it will be pointing to the second line that is over here. But we need to move the cursor to the first one so that we'll be able to read it. Okay, so move the file cursor to the beginning. And how do we do this? We just use one very important method which is called as file.seek. Okay, now this seek, if you probably go ahead and see this, if I give it to 0, so it is just going to move the file cursor to the beginning. That is just like a 0th character or 0th index, right? Then we can go ahead and read the content of the file. Right, and then I'll go ahead and print the content. Okay, first of all, I'll show you what will happen if I commented this out. Okay, will it display anything? Okay, so let's go ahead and run this. So here you can see I'm getting hello world. This is a new text line. Okay, let's see what is getting printed. So print content is basically happening over here. Let me see whether my example.txt has got loaded. So example.txt, this overloaded. This is basically giving me a new sentence, hello world and all. And here you'll be able to see that I'm printing the content. Okay, just a second. Okay, so the thing is that I did not read the file. So previous variable only it was showing me. Now let me do one thing. Okay, file.read. Okay, now I did not read the file, right? So what I'm actually going to do, see, I'm just commenting this. Okay, and we are writing these two lines in my example.txt and we are reading it. If we do not write this line of code, what will happen? It will not display us anything. Okay, and here you can see in example.txt this two line has got appended because the cursor will be pointing here. We have to make sure that we have to take the cursor over here, right, to the first one. So that is the reason you'll be able to see once I probably remove this, and if I execute it, now you'll be able to see that I'm actually able to get both the line. Okay, so this is what you'll be able to see with respect to this and how amazing this is, right? Again, let's say that you want to do multiple times read and write. Always make sure that you try to use this file.seek and make it to the beginning one, right? Yes, this was it. I think I had probably taken a lot many things with respect to file handling. But yes, as we go ahead and see multiple use cases, as we go ahead in the upcoming sessions, we'll be seeing more different kind of operations. So yes, this was it from my side. I'll see you all in the next video. Thank you. Now the next task that I'm actually going to do over here is that let's go ahead and create a new directory. Okay, so create a new directory. I'll be doing this. Let's say I will, again, you need to import OS. So let's say my new directory is something like this. Okay, let's say this is my new directory called as package. Okay, I want to create a package folder over here in the same working location that I'm actually writing a package folder over here in the file handling folder itself inside this. So all I have to do is that I'll just go ahead and write os.makedir, and I'm just going to give my new directory information. And let me just go ahead and print this. I'll use an f string and say that directory, and here I'm going to specifically use this new directory name is created. Okay. So this will be my message. So here you can see directory package created. Okay, and here you can probably see I will be able to get this package folder. Okay, and this is how you can create a new directory with the help of OS. Okay, let's say that I want to list all the files from a directory itself, right? So next task will be that listing files and directories. I want to list all the files and I want to list all the folders that I have inside a folder itself where I'm actually working. So I will just go ahead and write items is equal to os.list.dir, and here I'm just going to use this dot. Okay, dot basically means we are specifically looking at the current working location, whichever folder it is inside. Okay? And it will just list and it will give you the entire information. Okay, so let's go ahead and display this entire item. So if I go ahead and print items over here, so here you'll be able to see I have this particular file, a destination txt, example.bin, package. So all the folders inside this particular folder it is able to give me. Okay, pretty much amazing, and definitely we use this kind of file a lot because I may have a scenario that in my project I need to probably read all the files and folders and I need to probably do some kind of operations, and I can actually do that. Okay. Now talking about one more very important concept, that is nothing but joining paths. Okay. And this is the most important feature of using this OS package, because this path will be different when terms of coding in Windows, separately coding, you can just hard code it, right, in Linux or in Mac. So by using os.path, we can specifically use this. Okay. Let's say that I want to probably create, I have a directory name which is called as folder. Okay. and then let's say I have my file underscore name, okay, and this will be my file.txt. Now, how do I create this particular path? That basically means inside my folder there is a file.txt, right? If I want to probably get the full path or relative path also, I can say I can just write os.path, okay, dot join. Then I can actually use this directory name, okay. Oops, just a second. I can directly use this directory underscore name, comma. I will go ahead and use file underscore name. Okay, so this basically becomes my full path. So now if I go ahead and print my full path, you'll be able to see, hey, this is my path that I'm actually getting, right? Let's say I want to completely get it along with my folder location, then I can copy this entire thing again. Okay, I can paste it over here, and here I can also do os.getcwd, current working directory along with my directory name. Okay, so if I go ahead and write this, now here you can see this is my entire path, right? I can also do this. If I want to just have the relative path, I can just use these two variables. Okay, and this is how things are amazing over here, and you'll be able to see it. Now, in our previous tutorials, we have seen, right, whenever we are trying to open a file, first of all, we need to create that file, right? But here, we will try to manipulate, or let me just show you an example. Okay, so here, what I'm actually going to do, I'm going to create an example file. So let's say this is my example1.txt. I will say, hey, if os.path.exist, okay, if this particular path exists or this particular folder exists, then I will just go ahead and write print f. Okay, print f. Here you can actually see the path, this specific path exists. Okay, that is going to mean that folder also exists. Else, I will just go ahead and print f, the path does not exist. Okay, so here if I go ahead and execute it, here you can see that the path example1.txt file does not exist because I don't have that specific file. Now let's say if this file is not there, what I can do, if it is not there, or if this file does not exist, I will go ahead and create that particular file with, again, with open command or with any kind of command I can go ahead and do it, right? So this is very much important, and this kind of condition needs to be used in our coding environment whenever we are making some assumptions of a specific path itself. Okay. Now this is fine. There is also one more way to check whether the file is present or not. Okay. So here I will show you. So I will just go ahead and write this command, checking if the path is a file or directory. So there is one more method over here. So here you can see import os. I'm using path is equal to example.txt. Now this file, right, os.path.is file of path. So is file, it is going to check whether this path is a file. If it is a file, then it is going to say it is a file. If this path is a directory, so for that I have is directory function. Then it will go and say that hey, this path is a directory. Else this path is neither a file or a directory. So if I go ahead and execute it, I will go ahead and see this, right? So here it shows the path example.txt is a file. Okay. So this is how things are basically working over here, and you'll be able to see that hey, yeah, this particular file is a file because example.txt is a file. Okay. As I already told you, okay, relative path is something different. Relative path basically means this file inside this particular folder file.txt. If I'm seeing this becomes a relative path. Okay. And the absolute path is a complete path. Okay. Let's say for any folder location I want to get the absolute path. Okay, getting the absolute path, because I may be requiring some of the other thing over here. Okay. So here what I will do, let's say that this is my relative path. So this file is basically present inside this folder, which is called example.txt. Now I will go ahead and create my absolute path. Okay, and for this I will go ahead and write os.path.appspath. So appspath is one method over here, and then we can use this relative path. Okay, now if I go ahead and just print my absolute path, here you'll be able to see the complete path. I'll be able to get it, right? Again, if you do not want to go ahead and do it this way, you can specifically go ahead and join all these particular things along with the directory name. But I feel this is again better when compared to that one. So I hope guys you were able to understand all this file path operations specifically with the help of OS. Again, there will be multiple examples which we'll be seeing, but most of the common operations that we usually do in the code is probably discussed over here. This will be the most useful operation or most useful library when you're working in an end-to-end projects, working with different files, working with different directories over there. So there we are going to extensively use it, right? So please make sure that you practice this more, see different examples with respect to this, and yeah, this was it from my side. I will see you all in the next video. Thank you. Hello guys, so we are going to continue discussion with respect to Python, and in this video we are going to discuss about exception handling, right? And I hope you have heard about this particular term and what exactly is an exception handling. Exception handling in Python allows you to handle errors gracefully and take corrective actions without stopping the execution of the program, right? And here in this specific lesson we are going to cover and we'll be seeing some of the keywords like try, except, else, and finally blocks. And we will be seeing how we can handle the exception that rise in our program, and we have to handle it in such a way that we do not break the entire execution of the program, right? Now there may be scenarios. Let's say that I'm using an application over there, a user is filling some kind of form and it does not give the right kind of input. So in that particular case, I will not just stop the execution of the program. Instead, I will say, hey, I will raise an exception. I tell the user, hey, try to put some proper information over there, right? And make sure that you always try to put this kind of information to make that entire form get submitted. Okay, so we are handling it gracefully, right? We're not stopping the execution of the program. Now let's go ahead and understand what are exceptions. And you really need to understand the differences between errors and exception. Exceptions are events that disrupt the normal flow of a program. They occur where an error is encountered during program execution. Common exception include zero division error. So here we have something like divide by zero, file not found error, value error, type error. These are some of the examples. Okay, now let me just show you I'll just show you some amazing examples and how do I handle it with the help of exception handling. I will try to talk about it. Okay. Now let me do one thing. Okay. Let me just go ahead and write a is equal to 10. Okay. So this code, I think it will work perfectly because we have assigned the variable. But if I go ahead and write a is equal to b and if I just execute it, so what is the error that I'm getting over here? Right? Error is very simple. It is saying, hey, name b is not defined. So what has happened over here? This is a kind of error that has actually happened. And as I've already told, they occur when an error is encountered during a program execution. Here, obviously, I know the error is like name b is not defined. So an exception is basically getting raised over here. And this name error is one kind of exception, right? It is one kind of exception. Like how I've written over here, zero division error, file not found error, value error, type error. So name error is also one kind of exception that is probably getting raised over here because we have not defined b. Okay. So how do I handle this? Let's say that I'm not defined b over here. And obviously, this kind of error that I probably see, it is suitable for a coder, right? A coder will be able to understand. Okay, if I'm in this particular line of code, I'm getting this kind of exception, right? But if an end user is using some kind of application, if he or she sees this, right, they'll not be able to understand. So it is always better that we handle it gracefully by providing a good message, right? So how do I handle this? So what I will do in order to handle exception handling, right? Let me just go ahead and write. I'll be using over here try, except blocks. Okay, it is just like try catch block in other programming language. So first of all, I will go ahead and write try. Okay, now what does try mean? Try basically means inside this block, I will go ahead and write my block of code where exception may rise. Okay, so let's say right now the exception was rising in this particular, right? A is equal to b, right? Now what I will do is that when I write a is equal to b, right? Obviously we know that an error will come over here. Now in order to handle this error, what I will do, I will just go ahead and write except, okay, and I will just go ahead and write my print statement. I'll say, hey, the variable has not been assigned, right? The variable has not been assigned. Okay, so this is my custom message that I'm saying, hey, if this particular error, see, when this code gets run here, exception got raised, right? And this exception will be caught by this except block. And when it will get caught, here is the print statement. This is the print statement that will get displayed, right? So if I go ahead and execute it once here, so here you'll be able to see, hey, see, the variable has not been assigned. Now this is a very good message when compared to the previous message where we had read statements and all for the end user, right? And obviously we know that what is the kind of error that we have got over here is equal to b. See, this is the error that we are getting. Name b is not defined. It's not like that I cannot display this. I can also display this. Let me show you how we can display this. So what I will do, I'll just copy the same thing. I will paste it over here. I know what kind of error or what kind of exception it is throwing. It is a name error exception. So I will go ahead and call this same exception. Okay, this is one type of exception over here, right? And let me just go ahead and make my alias, right? And I will just go ahead and say, hey, print ex. Okay. So what I'm actually doing when this kind of error is falling, right? When this kind of error is getting raised, a name error is getting raised, I'm handling those kind of exceptions with the same exception handler over here, right? And this name error is a class which handles this kind of exception, right? I hope you're able to understand it. So now if I go ahead and execute it, see the same message is getting displayed. Name b is not defined, and here also we're getting name b is not defined. Why? Because I have used the same class, right? That is name error, which is responsible in catching this specific exception, right? So this is one amazing example which you can easily understand, right? Now similarly, I may have other kind of exception, right? So let's go ahead and do this. I will go ahead and write, hey, let's do this. Okay, I will go ahead and write result is equal to 1 divided by 0. If I execute this, you see what kind of error is coming, right? This is called a zero division error, right? Zero division error. Now, zero division error is again a kind of error that we are getting it, and this is also kind of exception, right? And we can also handle this exception. How do we handle it? I will go ahead and write my try block, okay? And here my code will be there. Now I know if this exception gets raised, I'm going to basically call except, and my exception handler will be, or my class name that I have to use, which will catch this kind of exception is zero division error as ex, okay? Ex is just an alias, and we'll go ahead and print ex, okay? Now you can see division by 0, right? And apart from this, I can also go ahead and write another message saying that, hey, please enter number. Please enter the denominator greater than 0, right? So I can go ahead and write this. So this way, I'm able to get more beautiful messages, and I'm handling it gracefully. You know what I say? What do I mean by gracefully? I'm not stopping the execution of the program. I'm not giving that entire red section that you always are having a fear, right, of that. I'm giving a proper message over here saying that, hey, this is the exception that got raised. You need to fix this. Please enter the denominator greater than 0. So again, the person will go ahead and make sure that he'll understand, and then they'll go and write this particular denominator greater than 0, right? Now all these exceptions, one more thing, right? So here you can see that all these exceptions that are there, like zero division error, file not found error, value error, type error, these are derived from a main exception class. Okay, so let's say that I don't know, there may be some kind of exception that may be happening. Okay, let's say that over here again, if I go ahead and write a is equal to b, right, and let's say I am going to just write it 1 by 2. Now here you will be seeing that. Okay, or let me just go ahead and write like this. I will copy this. Let's say I go ahead and copy this, and I'll go ahead and write 1 by 2. So obviously zero division error is not going to get caught, right? So now if I go ahead and write a is equal to b, now I know a is equal to b is going to give me a name error, but will this exception get caught right now? The answer is no, because I have just written zero division error over here, and I'm catching it in the except block. Other than that, I have not used name error, right? This exception never handled it with the help of name error, right? So I'm not written it in the except block, right? So that is the reason I'm getting this particular error saying that the name b is not defined, right? So how do I handle it? So see, one more thing is that, and sometimes it happens in such a way that there may be different exceptions that may be occurring, right? And all these exceptions that we learn, like zero division error or name error, value error, this is derived from one single parent class, right? We'll talk about more classes and all. That is nothing but exception. This is the base class of exception. It can handle any kind of exception, right? So if I go ahead and write as ex1, okay, and now let me just go ahead and print ex1. Now we'll see, since I'm getting an error over here, obviously you'll be seeing that this exception is not getting handled over here because this is a zero division error. But this exception will probably handle because this is the main parent class of exception, and every exception will be derived from this particular exception class, right? Like zero division error will also be derived from this, name value error will also be derived from this. So at the end of the day, you'll be seeing that this exception will be handled over here, right? So if I go ahead and execute it once again, so here you can see name b is not defined. From where it is basically coming, right? So here it is basically coming from, right? Main exception class, main exception got caught here, right? If I execute it, see, it is getting caught over here. So you can write any number of exceptions, but always make sure that the last exception class that we are using should be in the last section, right? We should not write this before zero division error or any other kind of exception, because this is the parent class from which all the exceptions are basically getting derived. Okay, and this is how we handle different kind of exceptions, right? So I hope you've got this particular idea. But here what we have actually done is that we handled multiple exceptions, right? So let me just go ahead and show you one more example. Let's say I go ahead and try over here. I'll create a number, okay, and this will be my int. Okay, and just go ahead and write input, and here I will go ahead and write enter a number. Okay. Now once I enter a number over here, let's say that I go ahead and divide this. Result is equal to 10 divided by num. Okay, 10 divided by num. Now I will go ahead and catch or write this except block. Remember, except block is basically to handle all the exception that rises inside this try block, right? So I will just go ahead and write except. Okay. Now inside this except, let's say that I will go ahead and use one value error. Okay. Value error, and here I will just go ahead and print. Let's say value error is specifically if I do not write a proper number over here, right? So this is not a valid number, not a valid number. Okay. Similarly, I will go ahead and write except, another except block, and let's say here I'm just going to use zero division error. Okay. And this will basically say, hey, print. You can't enter denominator greater than 0. Okay. Now see how I'm handling, right? This is the block of code where the exception will be handled, exception will be raised, right? And this exception, like error, will be coming over here, and we will catch this particular exception either over here or either over here, right? So let's see this. So if I go ahead and execute it, let's go ahead and say that I've given the number as 0. Now what will happen if I press enter? Just imagine, obviously zero division error will get caught. So here you can see enter denominator greater than 0, right? Let's say that if I go ahead and execute it, and this time I give a string, I give a value called a string, Krish. So now what will happen? The value error will get caught, and this is not a valid number, right? So here clearly you can see that I'm able to handle it. Now there may be different kind of errors. So what I'll do finally, I'll just go ahead and write except with exception as ex, and I'll just go ahead and print ex, okay, over here, just to manage all the other errors. So let's say if I'm giving 34, this will get executed perfectly because I'm dividing the result by 10 by that specific number. Okay. So here was an example to make you understand about try catch block, or we also say try except block. Okay. Now I just want to also show you one more example, and here along with try except, I'm also going to show you else block. Okay. Now let's go ahead and see this. So here is my try. Okay. I will go ahead and create my number, and this will be input. And here let me just go ahead and write enter a number. Okay. Enter a number. Then I will just go ahead and say result is equal to 10 divided by number. Okay. Let's say this is there. Okay. Now one exception that I'll try to handle is value error. and zero division error. Okay, so I've written it over here. Let's say if both this error are not coming, that basically means this has got executed successfully, right? In the worst case, I will also go ahead and write my exception. Okay, so that basically means if this is also not getting caught over here, then that basically means the code has got successfully executed. Okay, without any exception. Okay, but finally, let's say that I want to display this particular result value. Okay, now the result value can be displayed over here, and I will try to use one amazing try-catch functionality right over here, which is called as else. Now, let's say after this particular code has got executed, if exception is not happening, I want to close this entire try except with making sure that some lines of code needs to be executed anyhow. Okay, so there will be an option of writing else block, and this else block is nothing but it is you can just say that okay, at the end of the day, after this gets executed successfully, it has to execute this. Okay, so if I go ahead and write in the else, so let's say in the else I go ahead and say, hey, the result is this specific result. Okay, so I'm just displaying the result over here, right? So if I go ahead and execute it, now see what will happen. Okay, now what will happen? I will give the input, let's say 23. If I press enter, okay, you'll be able to see 23, no exception will be raised. Now when no exception is getting raised, so obviously this will get skipped. But at the end of the day, this has to get executed, right? So else is something like it has to probably get executed. Let's say if there is an exception over here, then one of the exception block will get executed and it will come outside of this try except block. But if this gets successfully executed, anyhow it is going to execute this else block. So if I go ahead and press enter, so here you can see the result is 0.434. Okay, let's go ahead and execute this once again, and let me just go ahead and write 0. Now in case of 0, what will happen? Zero division error is there, so you can't divide the number by 0. So I press enter, that is the error. But here you can see else block is not getting executed. So that basically means whenever an error happens or exception happens, it will get handled in the except block. At that point of time, else block will not get executed. But if none of the exception gets raised over here, then what will happen? Else has to execute anyhow. Okay, so this was an amazing example with respect to else, right? So where you'll be able to see that okay, if I'm not getting an exception, then it will execute. Okay, otherwise if I'm getting an error, this is just going to stop and it is not going to execute this else block. Okay, this is how you will be able to understand. Now this is fine. Let's try something more. Okay, now this time what I'm actually going to do, I'm going to use try except else. And I'm also going to use one more amazing functionality or one more block, which is basically called as finally. Okay, now let's see one example with respect to this. Now what exactly is finally? We'll discuss about this. Okay, I will just write a code and the same kind of code I will just copy and paste it over here. So see this. Okay, so here is my number, right? And here I'm probably dividing it. If exception does not happen over here, then directly else has to get executed. Okay, else will get executed only when error is not there. Okay, again let me repeat it. This is going to get executed only when there is no error over here. Right? If there is an error, it will be handled by this kind of exception. I'll also go ahead and write this exception over here so that I will bring up multiple condition of exceptions. Okay. Now finally is something. Finally is a kind of block. Whether error may be coming or not in this particular block of code, it has to execute anyhow. Okay. So let me repeat it again. We have already discussed just a while back about else, right? Else is something like this. If no error is probably coming over here, then we will go ahead and execute this. If error is probably coming up, then else part will not get executed since it is getting handled in the exception block. In case of finally block, whether the error may be coming here or not, it has to execute. Okay. Now let me just show you. So let's say if I go ahead and write 12. In case of 12, obviously it is a good number. It is a proper input. So no error is getting handled. So else block will get executed. The print result something will come. And after this finally block will also get executed. So if I go ahead and press enter, so here you can see the result is 0.833 and execution complete. Okay. Finally is also getting executed. Now in case of let's say in case of error, let's say if I go ahead and write over here 0. Now in case of 0, what will happen? Zero division error is coming up, right? So else block will not get executed, but finally block will definitely get executed. So if I go ahead and press enter, you can see you can't divide by 0, that is zero division error, and finally it basically gets executed, which is called as execution complete. Now you may be thinking, Krish, where in the real world scenario this will come, right? Where do we specifically use finally block and all? Let me just give you one example, guys. Let's say that in try block, I am connecting to a database, okay? Now in this particular database, let's say I got some connection issues, user password issues and all, right? Or let's say that I've connected to the database, then I did some kind of operation, there I got an exception. I handled that particular exception, right? But at the end of the day, I need to close the connection of that particular database. So I can write the code over here in the finally block, right? Because at the end of the day, if I'm getting an exception, so that exception is basically getting handled. But if I come out of that particular block, I need to make sure that that entire connection gets closed. And that is how we can specifically use this try, except, else, and finally block. Okay. Now this was some of the ways of handling exceptions. And again, any kind of errors that you'll be seeing, there'll be different exceptions which you can probably check it out. Okay. Again, guys, the thing is that unless and until you don't practice, you won't be able to become perfect. Please make sure that you have this all indentation techniques that is basically getting aligned. You can have multiple exception blocks. You can have multiple, but you can also use this else and finally block also to handle more diversified code errors. Okay. Now let's see some kind of practical example. So first of all, I will just go ahead and show you file handling and exception handling. Okay. This is most commonly used. Okay. So let me just go ahead and use a try block. I will go ahead and open my file. So let's say file is equal to open. Now you remember, right, in previous videos when we were discussing about file operation, we tried to open a file which is called example.txt, but that file was not present over there, and it gave us an error. It gave us an exception saying that hey, those file does not exist. Okay, so we'll try to do the same thing over here. So here I'll just go ahead and open my example1.txt file, okay? And here I'll open this in read mode. Let's say, and right now if I go ahead and show you in exception handling, there is no file called as example1.txt. Okay, then I will just go ahead and write content is equal to file.read. We'll read the file inside that, and we'll go ahead and print the content. Okay, so this is my try block where the exception may rise. Right now I will go ahead and handle this exception. So I know that this is a kind of file not found error. Okay, and because if the file does not exist, so this kind of exception I'll be able to see. So here you can see the file does not exist. Okay. Now anyhow, in the finally block, let's go ahead and write this in the finally block. In the finally block, I'm going to make sure that at the end of the day, I need to close this particular file. Right. So I'll write if file in locals. Okay. Now what exactly is locals? Return the dictionary containing the current scope local variables. Okay. If it is not present in the local, okay, and the file is not closed. Okay. I may get an exception over here also in the read also, right? So that is the reason I'm writing this particular condition. If these two are if that file is present in the local variable and it is not closed, I will go ahead and close this file because I cannot make this file open. There may be some kind of issue. Similarly with respect to database connection. So I will go ahead and print file closed. Okay. At the end of the day, whatever may happen in the exception, right? In the finally block, I'm going to close this particular file. Now, if I go ahead and execute this, you'll be able to see the file does not exist is coming, right? So here, automatically, the exception is basically getting handled, right? And let me do one thing. Let me just write is equal to b over here, and let's say that okay, fine. I have some kind of file. Okay, I have some kind of file. Let's say here, example1.txt. Okay, I have this file. Okay, I have this file. It is an empty file. Now what will happen when I get e is equal to b? I know it is not a file found error, so I will just go ahead and handle it with the parent class exception as ex. Okay, and I will just go ahead and print ex. Okay, but at the end of the day, I know the code will be giving me an error over here. But what I'm doing, because here I will be reading the file, right? So the file is in the open state yet. So when this error comes, I know this will not get handled by this, but instead it will get handled by this. In the finally block, I'm making sure that I'll close the file. Okay, so that is how we will specifically do. So here you can see that I'm actually getting an error over here. Now instead of this and, I will just go ahead and use or. So once I've used or, here you can see name b is not defined and file close. Okay, so we are at the end of the day, we're just closing all the specific files. Okay, some kind of errors will definitely be coming up. So we should always make sure that whenever we are opening the file, at the end of the day, we need to close this file. So I hope you are able to understand this entire thing, and you're able to understand with multiple examples. I've shown you each and everything. Step by step, we have executed each and everything. So yes, this was it from my side. I will see you on the next video. Thank you. Anyway, so we are going to continue the discussion with respect to Python, and in this video, we are going to talk about the most important module that is called as OOPS, where we'll be discussing about classes and objects. Now, object-oriented programming is a programming paradigm that uses objects to design application and computer programs, right? OOPS allows us for modeling real-world scenarios using classes and objects. Now, any end-to-end projects that you're specifically going to create, we really need to use classes, we need to use objects. This increases the reusability of the code, and if I talk about developing real-world use cases, we will be able to use it efficiently, like we'll be able to develop that application efficiently with the help of classes and objects. Now, to give you a basic example of class, let's see the definition of class. So class is nothing but it is a blueprint for creating objects. Okay, it will be having separate attributes and separate methods. Okay, let's say that I go ahead and create a class. Okay, so let's give a basic example over here how to create a class. We'll see this. So here we use a keyword which is called as class, and here we will give it the class name. Let's say that I'm going to create a class name which is called as car. Okay, now car is nothing but it is a class. Okay, and it is a blueprint of creating objects. Now I'll show you how to create an object. Okay, so let's say that this is I'm just writing or I'm creating an empty car. Right now, when I say creating an object, right, car may be of different type, it may be of different brand, right? So I may go ahead and create, hey, first of all, I'll go ahead and create an Audi object, right? So Audi object, it is a type of car, so I will go ahead and use the same blueprint and create this particular object, right? Similarly, I may go ahead and take a different variety of car. Let's say this is BMW, and here I may again use this as an or instantiate from this particular class, right, to create this particular object. So this is nothing but if I go ahead and print what is the type of Audi, right? So you'll be able to see that if I execute this, it is nothing but it is also class, but this is exactly an object over here, right? The reason why I'm saying it as an object because we have instantiated from this specific class which is called as car. Okay, and similarly, we can just imagine, right, what class is. It is a real world entity. Okay, and it is also called as a blueprint. And just by using this specific car, I can create different objects which may be using the features of this specific car, right? Like we have Audi, BMW, and all. Okay, now let me just go ahead and probably explain more about it because I've not still discussed about attributes and methods, which we also called it as instance variable or instance methods. Okay, so if I probably also go ahead and print this Audi, so if I go ahead and print Audi, what will I get? It will be showing that hey, this is a car object at this specific memory location. Okay, and similarly, if I go ahead and print BMW, right? So here also you'll be able to see yes, it is showing that yes, it is a car object at this specific memory location, right? Now let me just go ahead and include two more important things. Let's say I will go ahead and write instance variable and methods. Okay, methods. Now let me just take another class. Okay, let's say that I'm going to create a class called as dog. Right now, dog is a blueprint, right? And in order to define the attributes over here, right? See, one way, if I probably take this Audi and all, right? If I just go ahead and write Audi dot, let's say I'm going to go ahead and define one instance variable that is present inside the class. Let's say Audi has some windows, right? I'll just go ahead and write 4, right? This windows is basically 4, right? And if I go ahead and print Audi dot windows, then I will be able to see that I'm able to get the answer as 4. So Windows is a kind of attribute that is present inside the car. And for Audi, it may be that I may have 4 windows. For some other car, I may just have 2 windows. Like let's say that I'm taking a very smaller car over there, which is just like a Tata Nano. Okay, it may be having 4 windows, but let's say that there is a new variety of car that may have 2 windows. So I can change that particular attribute values. And this is how we specifically define, right? This is nothing but this is the type of attributes. But initializing attributes like this is not a proper way. The reason is very much simple. Why this is not a proper way? Because see, whenever I create another object, let's say that I'm going to create another object. Let's say this will be a Tata car, and now I'll go ahead and initialize with car object, right? I'll go ahead and create this particular object. Now I'm going to go ahead and write Tata dot doors, right? So this will be my another attribute, and let's say there are around 4 doors over here, right? But if you see, with respect to Audi, I did not create an attribute called as doors, whereas over here I created something called as windows. In Tata, I did not create an attribute called as windows, right? So if I go ahead and print Tata.windows, will I get anything? Let's see. So here you can see that I'll be getting an error saying that the car object has no attribute windows, right? So defining the attributes in this way is not a proper way. So I will just show you another way how we can clearly define all the attributes and methods in the first hand while we are initializing or while we are creating the object itself, right? So I'm going to take an example with respect to dog, okay? And here there is one very important function. See, if I go ahead and write dir directory of this specific class that is called as Tata, okay? Here you'll be seeing there will be a lot of different inbuilt methods, right? And each and every inbuilt methods will be doing something else, right? Now since you can see that I have created an attribute called as doors, you'll be also able to see that this doors will be available over here, right? Inside this particular directory. I will be talking about different over here methods, right? What functionalities it usually does. But here I'm going to talk about one method which is called as _init__. Now what this method is all about? This method is called as constructor. Okay, constructor. Now what does this specific method do? So if I go ahead and write definition __init__, if initially I'm going to define any attributes, I can make sure that with the help of this particular constructor, at the first hand, I'll be able to define all the attributes that will be available inside this particular class, right? Now in order to define it, let's say in dog, right? Let's say I have 2 attributes over here. One is name and the other one is age, right? So while I'm initializing or while I'm creating the object from dog class, I have to make sure that I have to give these 2 attributes, okay? During the runtime, I have to give these 2 values during the runtime when I create the object, okay? Now the best thing over here is that this is basically my parameter, right? And internally, I will go ahead and create some instance variable. Now this instance variable are like some kind of properties that are available inside the dog class. Okay, and you know that I have to basically take this particular name and assign this name itself because during the runtime I'm going to put this particular value. Now obviously I've written the same name, so the variable name is almost same. So let me just go ahead and write one more parameter which is called as self. Okay, it is not compulsory you always need to write self. Okay, you can write anything over here. You can write Trish, you can write your name also. But self is a keyword which we specifically use, worldwide in terms of good practices. We use self keyword, right? Now this self keyword will be responsible, in probably accessing the instance variable inside the class itself whenever we create an object. So here what I'm going to write, I'm just going to say self.name. Now this name that you'll be seeing, which is along with self.name, this name is nothing but it is my instance variable that is available inside the dog class. Okay, and this name is what is the parameter that I'm passing while creating the object. Okay, so here there are two parameters. One is self.name, and the second one that I'm actually going to go ahead and write, it is nothing but self.age is equal to age. So this way I am initializing my entire class with a constructor. Now, if I go ahead and create the object, okay, now let's go ahead and create the objects, right? You'll be able to see that as soon as I go ahead and write, hey, let's go ahead and create my object dog1, this will get initialized from dog, okay? And here I'm going to give two parameters. If I execute like this, it will tell me, hey, you're missing two required positional argument, name and age, because name and age is not given. As soon as I call this, what is internally going to happen is that it is going to call this constructor first, okay? Because of this constructor, it is going to take all these values that is required for the instance variable. So here I need to provide two parameters. Let's say here I will go ahead and write buddy, and the age is 3, okay? Now, if I go ahead and execute this, print dog1, okay? You'll be able to see that I will be able to create a dog object at this specific memory location. Now, this instance variable is there, right? Name and age. Now, let's go ahead and retrieve this dog1.name, and the next one is print dog1.age, right? So now if I go ahead and access these values, you'll be able to see that I'm able to get that value, which is called as buddy and 3, right? Similarly, I can go ahead and create any number of dogs objects, right? So I'll go ahead and write dog2, and again, I will be using dog, and I'll go ahead and give my parameters over here. Let's say I will give something like Lucy, and the age is 4, and I will be able to print the same thing over here. That is nothing but dog2.name, and similarly print dog2.age, right? So here you'll be able to see that I will be able to access this instance variable over here. Now, the best thing is that we have defined the instance variable initially in the constructor so that we cannot create any more. Whatever things is defined in the constructor, only those number of instance variable itself we can create. If tomorrow I require any more instance variable, I can just go ahead and write self dot that particular instance variable and I'll assign the value based on the parameter that I pass over here, right? So this is the best practice that we specifically use with respect to creating instance variables, right? Now let's talk about instance method, right? Now instance variable, whenever we talk about it, is some kind of properties that talks about dog, right? So over here, name and age are just like my properties for this particular dog, right? These are nothing but these are some kind of attributes, right? Similarly, there may be methods, which we also call it as instance methods. Like a dog may be barking, right? It may be doing some kind of functionalities, right? It may be running at a specific speed, something, right? So those are nothing but those are basically instance methods. Now let me show you how you can actually go ahead and create the instance methods, right? So now I'm going to define a class with an instance method. So let's go ahead and define a class with instance methods, okay? Now in order to define a class with instance method, again I will go ahead and write class dog, okay? Now as you know that I will be using my init constructor, so I will go ahead and write definition underscore init underscore. Here I will use a self keyword. Let's say that there are two parameters or two features that I'm going to use, that is name and age. These are my two instance variable. I can also say it as properties, attributes, anything you can specifically talk about, but all these parameters are basically talking about this dog class itself, right? These are the properties of them, right? And this is what I'm going to pass in the runtime. Now I'll go ahead and create my properties. So I'll go ahead and write self.name is equal to name, then I'm going to write self.age is equal to age, okay? Now this is fine, right? Now, once I create my constructor, now I'm going to create some instance method that is related to dog. Let's say the dog will be barking, right? So, and different dog can bark in a different way. So here also I'll be using the self keyword. The reason is very simple. So that inside this method also I'll be able to use this instance variable. Okay, that is the reason we provide this self keyword over here. Now I will go ahead and write print. Okay, some functionality or some print statement I will write over here, and I'll go ahead and write self.name. Right, self.name basically means the same attribute I'm calling it over here. Says woof. Right, so this is the sound a specific dog makes in generic. Okay, so here you can actually see over here. Right, and if I probably just consider this is one of the instance method. Okay, now what I'm going to do, I'll go ahead and create my object. Let's say that this is my dog1, and here I'm just going to call dog. And let me just give the values. Here I'll be giving buddy, comma 3 is the age. Now I can use this object and call this particular function, right? Method, right? This method is nothing but it is basically called as bark. Okay. Now if I go ahead and just execute this, you'll be able to see that I will be getting that print says buddy says hoof, right? Now tomorrow I'm going to go ahead and create my another dog2. Okay. And let's say this dog2 is basically having the name as Lucy. Okay. And the age is 4, right? If I go ahead and just go ahead and call this dog2.bark. So here you'll be able to see that I'll be able to see get Lucy says hoof, right? So buddy says hoof, Lucy says hoof. Now this is the function, and based on different dog types, you can just consider that the object is nothing but different dog types, right? They're using the same properties and they're using the same methods, and this will be relative to that specific object. So that is the reason over here in the definition we have clearly written as a class is a blueprint for creating objects, and it has its own attribute and methods which can be used by this objects, right? So I hope you got an idea with respect to this, and I hope you're able to understand this. Okay. Now let's design a better example for you. Okay. So here we're going to take this example which is called as modeling a bank account. Okay. So now let's go ahead and do this. Okay. So here you'll be able to see I will define a class for bank account. Okay, first of all. Now, you know, in a bank account, you'll be able to withdraw money, you'll be able to deposit money, and you'll be also able to see the balance in the money, right? So here, first of all, how do we design this entire application with the help of classes? So I'm just going to use class with respect to bank account. Okay, it is always a good practice that you use capital letter whenever you are defining a class. Then I'm going to use my constructor, that is underscore init underscore. Let's say that what all parameters I'm going to probably give over here. One is owner information, and the next is balance. By default, whenever we create an account, the balance will be 0. Okay, so by default, I'm giving some values over here. Then I will go ahead and write self.owner is equal to owner. So and again, guys, you may be thinking, should this particular attribute be same to this particular parameter name? Answer is no, right? You can write as your own, but I'm just following the good practices that many of the developer usually follows. Then I'll go ahead and write cell.balance is equal to balance. Okay. Now here you can see that I've created my bank account. Perfect. These are my attributes, right? Owner and balance. We also call this as instance variable. Now the next thing is that I will go ahead and define my instance method. So first of all, we'll go and create one method which is called as deposit. And here I'm going to give self, and one parameter that I will give is amount. Okay. Amount is like how much we really need to deposit as the parameter I'm giving. Okay. Now whenever I try to add money in my account to deposit, I have to probably increase my balance. Now in order to get the excess of the balance, again I have to use self.balance keyword plus is equal to this specific amount, right? And this is what we are basically doing with respect to the deposit function. And I will just go ahead and print and go ahead and write, hey, amount is deposited, new balances. I'm just going to write some print statement, new balances, cell.balance. Okay, cell.balance. I cannot directly use balance because this is nothing but it is an instance variable that is available over here. Okay. Now the next function that I'm actually going to create is nothing but withdraw. So I'm going to write withdraw, definition withdraw, and here I'm going to use self comma amount. Okay. And with respect to this, if amount is greater than cell.balance. Okay. I'm just saying that hey, if I'm withdrawing, first of all, I need to check whether the amount is greater than cell.balance. If the amount is greater than self.balance, and if I'm trying to withdraw, then obviously this should not be allowed. And I'll just go ahead and print, hey, insufficient funds. Insufficient funds. Okay. And finally, I'll close this, right? Now, if this is not satisfied, then what I will do, I'll just go ahead and write my else condition. And this time, I have to subtract it from my balance account. So I will go ahead and write minus equal to the specific amount. Okay. So I hope you're able to understand this. Now, if the amount is greater than self.balance, I'll say, hey, it is insufficient funds. But if this is not true, if the amount is less than self.balance, I should be able to withdraw it. So here you'll be able to say that I'm writing self.balance minus is equal to that specific amount. And here I will go ahead and print and say that by using an F string, say that, hey, this amount is withdrawn. Okay. New balance is self.balance, right? So this is perfect. So I've created two instance methods along with that two instance variable. And finally, one more method I will go ahead and create, and you can create any number of methods. I will say, hey, get balance. Okay. And here I will again use the self keyword, and all we have to do over here is that I will just go ahead and write return self.balance. I just need to return the balance in my account. Okay. Done. Now you'll be able to see the balance amount and all, everything is there. Now let's go ahead and create an object. So I will go ahead and create an object. Now you can perform any kind of operation that you really want. So while creating an object, I have to make sure that I create an account. So first of all, I will go ahead and write bank account, okay, which is my class. And when I call this particular bank account, I have to give two attributes, that is owner and balance, right? Owner over here is nothing but I'll go ahead and say Krish. And initially, let's say my balance is I am depositing around 500 rupees, okay? Or let's say 5,000 rupees, okay? Now let me just go ahead and print the account dot balance. So this is Krish account, right? So here you'll be able to see that I'm getting 5,000 rupees. Now let's say that I want to call this instance method, okay, when I want to withdraw some money. Okay, so first of all, let's go ahead and do some deposit. Let's say that I got my salary and my salary is 100 rupees and I've deposited it. Okay, so if I go ahead and print, or if I just go ahead and execute this, you'll be able to see that I'm getting a message saying that, hey, 100 is deposited, new balance is 5100, right? Now let me just go ahead and withdraw some money. Let's say that I want to withdraw, account.withdraw is nothing but I want to withdraw 300 rupees. So I'll just go ahead and execute it. Now here you can see, hey, 300 is withdrawn, new balance is 4800, right? Now finally, if I want to get the complete account balance, I should be able to just call print account.getBalance, and that is what I'm actually going to execute it. And here you can see I'm getting 4800. So here in just front of you, I have designed the entire bank account with respect to all the operations with the help of class, instance variable, and instance method. So I hope you are able to understand this completely with respect to this particular example of bank account and all. As we go ahead, we'll be talking more about different examples, right? This is just to give you an idea of how powerful these classes are. But please make sure that always make sure you keep a note of all the indentation, how to probably create it. You need to understand very much clearly that this init is nothing but it is a constructor. These are my instance variable, these are my instance methods, and I can probably go ahead and write any number of instance methods that I want. And the importance of self keyword is to use this kind of instance variable wherever we want inside this particular instance method, right? Out of this class, I cannot use self keyword. That is very much clear, right? So I hope you are able to understand this entire video. So finally, I will just write some conclusions saying that what all things is important with respect to why this classes are important. So here, object-oriented programming is very, very much important. It allows you to model real-world scenarios using class and object. In this lesson, you learn how to create a class and object, define instance variable and method, and use them to perform this operation, right? So yes, this was it from my side. I hope you like this particular video. I will see you in the next video. Thank you. Hello guys, so we are going to continue our discussion with respect to Python, and in this video we are going to discuss about inheritance in Python. Now this inheritance is a fundamental concept in object-oriented programming that allows a class to inherit attributes and methods from another class, right? So in this specific video, I will be talking about how you can implement inheritance with the help of Python. We'll be discussing about single inheritance and multiple inheritance, and I'll be showing you multiple examples. So let's go ahead and let's see. Now inheritance is basically derived from the real world scenario, guys. I hope, like let's say you will be inheriting your parents' property, it may be house, it may be land, but the vice versa will not be possible. Your parent will basically not be inheriting your property, but instead it will be going to your children, right? So this kind of scenario, so this is based on the real world scenario, and similarly, the inheritance property in Python also works in the same way, okay? So let me just go ahead and show you one specific example of inheritance, and then I will show you how you can probably create a child class and probably inherit the parent class altogether, right? So I will first of all start defining my parent class, okay? Now here, let me just go ahead and define one class which is called as car, okay? Now car is my class, okay? So I can also go ahead and write like this, okay? Class car. Now, first of all, as you all know, whenever we define a class, we need to probably create a constructor. So let's go ahead and create this underscore init underscore. And here I'm going to use one parameter that is self, and the other parameters that we are going to provide while we are instantiating the object of the car class, like windows, doors, right? Engine type. So let's consider that these are some of the attributes that we are going to pass, and let's go ahead and create some of the instance variables. So I will go ahead and write self dot, and first thing is that windows, right? I'll go ahead and create the first attribute that is windows, and I'll assign this value to the windows that I'm passing over here in this init method, okay? Then we'll go ahead and write self dot doors, okay, where I will be passing the doors value, and finally I'll go ahead and write self dot engine type, okay, engine type. And again, I've already told you, this name need not be same as this. You can write anything over here, but these are the attributes or instance variable, right? So is equal to, we'll go ahead and write engine type, okay? Now this is my car class, and this is what I have in terms of attributes and all. Let me just go ahead and define one instant method also. Let's say with the help of car we usually drive. So here what I'm actually going to do is that I'll go ahead and use self keyword, okay, and let me just go ahead and print, okay, and let me say that the person will drive the car. The person will drive the which car? Okay, so let's say that the person will drive the petrol car or engine type car, right? So here I will just go ahead and write engine type, okay, and here I'm actually going to use this F string, okay, engine type. Now engine type I cannot directly use it over here because I have to use self dot, right? Because engine type is an attribute over here, right? So the person will drive the engine type car, okay, and I have to probably, if I want to use this attribute over here, I have to use self dot, okay. So inside this is my parent class, okay. I've defined a class with an init method. The attributes are windows, doors, and engine type, and one instance method which is called as drive. And here I'm saying that hey, the person will drive whether it can be a petrol car or diesel car based on the values that we provide, right? Now once I probably go ahead and create this class, let's consider this is my parent class. Now I can go ahead and write car one is equal to, I will go ahead and find my car, okay, and here I'm going to give the values. Let's say the number of windows are 4, number of doors are 5, and let's consider the engine type is petrol, okay, petrol car, okay. And now I will go ahead and print car1 dot the method that is drive, right? Now, if I go ahead and execute it, here you'll be able to see that, hey, the person will drive the petrol car. And obviously, drive does not return anything over here, so that is the reason it is giving you none, okay? But in short, over here, you can see that I'm just writing car1.drive, so it is just going to display this, the person will drive the car, okay? Perfect. If I just remove the print method, then you'll be able to see that I'll be able to get only one message, okay? That is print, the person will drive the petrol car, because this drive method is not returning anything. But this is fine, right? This is very much easy, and here you can actually see that what all things we have basically done, right? We have given a car class, and probably we have defined the init method, we have defined a method over here, right? And we are able to create the objects, right? This is perfect. Now, let me do one thing. Now, see, there are different types of cars, right? I can just consider this car class is a blueprint of a car object, right? This is the blueprint where it has this many number of attributes, this many number of methods. Now, let me just go ahead and create one class which is called as Tesla, okay? Now, this Tesla car that you're probably seeing over here, obviously it needs to inherit from the car blueprint itself, right? Because in this Tesla also, I'll be having windows, I'll be having windows, I will be having doors, I will be having engine type, right? And there may be some additional feature that may be available in Tesla. So I don't have to again go ahead and define this entire thing. Instead, what I can do, I can just inherit this car class, and I can inherit these properties along with I can inherit these functions or methods, right? Because I don't have to recreate the entire class completely from scratch. If it is inheriting this particular car class, which is a blueprint, it will be able to inherit all these attributes and methods, right? So let's go ahead and do this. So in order to make Tesla inherit car, so I will just go ahead and write over here as car. So this is how you basically write. First of all, you really need to write your child class, like class Tesla, and then whatever things you will basically write in the bracket, this is basically inheriting that particular class, okay? Now, we will again go ahead with defining our init function, because here also we'll be having an init function, right? So definition underscore init underscore. So this is my constructor inside the Tesla. And here also we require attributes like windows, doors, okay? So we need to pass it during the runtime. Then you have engine type. And finally, these all attributes are already available over here, right? So there may be additional attributes that may be available in Tesla. So I will just go ahead and say is self-driving, okay? And this will be a Boolean value. Let's consider this, okay? Is self-driving. So Tesla, you know that it has the self-driving functionalities, okay? Now, fine. Now, the main thing is that I need to create the attributes for windows, doors, and engine type. And I know that car already has this kind of attributes, right? So I don't need to go ahead and write self dot, right? What I can do is that I can just use the super keyword, right? If I use the super keyword, that basically means I'm saying, hey, I'm trying to call super basically means I'm just trying to call the parent class over here. And from the parent class, I will just go ahead and call my init method, okay? So here, what does super underscore init basically mean? That basically means that we're just calling this init method from the car class, right? Parent class, right? And that is the reason we're just writing super dot underscore init. Now, over here, the next step will be that you know what all attributes I'll be getting from the parent class. One is windows, okay? So let me just go ahead and write windows, doors, and then you have this engine type, right? Then you have this engine type. So this three values or attributes I should be getting from this car class, right? So I don't have to again define it. But what about my self is self-driving? So I will just go ahead and write self dot is self-driving, okay? So let me just go ahead and create this variable self dot is self-driving. Oops, self dot is self-driving, and I will assign it to is dot self-driving. So this is the attribute, and this only attribute we'll try to create inside the Tesla class, okay? And remaining all we are in short inheriting from parent class, right? Now when we are inheriting this, obviously it is true that we'll also be able to inherit this too, right? So let's see this, okay? Now I will go ahead and probably I've created my init method over here, and now what I will do, I'll create another function which supports self-driving, right? Let's say self-driving. So here I'm just going to write self-driving, and here I'm going to say self, okay? Perfect, right? So this is the method, or this is the instance method that we are going to create inside this Tesla class, which is the additional thing when compared to the class blueprint, car blueprint. Sorry. Now here I'm just going to print something and write over here Tesla supports. Okay, I can just go ahead and write self dot is. So here I'm just going to use my f string. Always focus on using this f string, then only you'll be able to use this particular. You'll be able to basically write in this way. So self dot is drive. Okay, so here you have this entire thing. Okay, now Tesla supports self-driving, true or not? Tesla supports self-driving. So here I'll say self-driving. So this will basically give me a value like true or false. Okay, now this is my entire Tesla car, right? And this is my child class, which is inheriting the car class, right? Now once I execute this, now let's go ahead and call this. Okay, so first of all, I will just go ahead and write Tesla 1 variant, and I will go ahead and initialize it. And now what are parameters I need to give? Windows, doors, and engine type. So I'll say, hey, windows are 4, doors are 5, engine type is electric. Let's say electric. Okay, and whether it supports self-driving or not, I'll just go ahead and write true. Okay, now after giving all these parameters, you'll be able to see that if I go ahead and print Tesla 1 dot self-driving. Okay, and I call this function. Let's see what it says. So here you'll be able to see that it is printing Tesla supports self-driving is equal to true, and this is what we are given. So what happened once we call this particular child class with Tesla and all these values? What it is going to do is just go ahead and call super init, and it will pass all these parameters over here. And this init will make sure that all the attributes will go ahead and initialize with those values, like self dot windows, doors, and engine type. Now once that is done, then we'll go ahead and initialize the attribute is underscore self-driving, which will be assigned to true, and then I can probably call this particular function. Not only this, now in the parent class I have this drive function, right? So I can also call that. See, I will go ahead and write Tesla 1 dot drive function. Okay, if I go ahead and call this, here you can see the person will drive the electric car, right? And this is how you can probably see that a single inheritance works like, right? And you understood the main mechanism. If you really want to inherit any parent class, how you have to probably use this init method, how you have to call this super init method, how to define the new attributes, how to initialize those new attributes over here, during the runtime, and along with that, you can actually go ahead and create any more methods that you want. Okay, and this is what is an example with respect to inheritance. And this inheritance, I will just say it as single inheritance because only one child class is inheriting the parent class. Okay, now let me just show you an example with respect to multiple inheritance, but I hope you are able to understand. Okay, so here will be multiple inheritance. Okay, now multiple inheritance means what? When a class inherits from more than one base class. Okay, when a class inherits more than one base class. Okay, now what does this basically mean? Let's go ahead and create one base class. Okay, let's say I will go ahead and create animal. Okay, so animal is one class. Okay, and here I'm just going to use my init method. And here let me just go ahead and write self, name. Name is what I'm going to pass as an attribute, and I'll go ahead and create my attribute self.name is equal to name, right? So this becomes my animal class. Okay, an animal class. Let me just go ahead and create one function which will be like speak. Okay, and here I'm going to use self, and let me just go ahead and probably print something. So here I'll just go ahead and print. Okay, subclasses must implement this method. Let's say I'm just going to write this. Okay, now this is done with respect to my class, right? Now what I will do is that I will go ahead and create another base class. So this is one of my base class. So here I'll write base class 1. Okay, base class 1, because see what, when a class inherits from more than one base class. So this is my base class 1. Now let me just go ahead and create my base class 2. So base class 2. Okay. And here I'm just going to copy this, and here you can see I have this pet class, and I'm creating this init method with self, owner, and I'm saying, hey, self.owner is equal to owner. Okay. Now let's go ahead and create my derived class. Now derived class will be something like inheriting both these classes. Now in order to for child class to inherit both these class, I will go ahead and create class dog. Okay. And this time, in order to inherit both the classes, I will go ahead and write animal, comma pet. Okay. So this is how you basically give in comma separated inside these brackets. Then what I will do. From animal, I will be taking this name attribute. I will be accessing this speak. Along with this, from pet, I will be getting owner, right? So here, if I want to use this owner attribute and name, all I have to basically go ahead and write. I'll go ahead and create my init method. Okay. And here I'm going to give self, comma, name, comma, owner, right? And here, let me just go ahead and write animal dot underscore init. Okay. So this is also another way of probably calling it, right? Let's say I want to get the attribute of name from animal, right? So this name is basically present in animal. So instead of just writing super dot, I can just write the class name dot init. And here I can actually give self, comma, name. Okay. So this is one way. The other way is that again, I will go ahead and do it for the other class, pet underscore init underscore. And here also I'll go ahead and write self, comma, owner. Okay. Self, comma, owner. See, what is the difference between before the methods that I've discussed? Here I've used super because I just had one parent class. But since here I have two parent class, like base class 1 and base class 2, right? I need to use one attribute from this particular attribute itself, from this particular class animal, and one more from this another base class. So what I'm doing, I'm just writing animal dot underscore init. I'm calling the animal init method, and there I'm passing this particular parameter, and then I'm calling pet underscore init, and then I'm passing the parameter over there. And when it goes to this init method, then this attribute gets the value of this, right? This is how the entire flow goes. Now finally, let me just go ahead and create a speak method. So I'll just go ahead and write a definition speak, and here I'll go ahead and say it is a self. Now let me just go ahead and return. So return will be an f string, and let's say here I'm going to basically write self.name says hoof. Okay. Self.name says hoof. Okay, and this is what is basically getting printed. So let me just go ahead and write a return over here. Okay, now it should be working fine. Now let's see this, how this will work. Now we'll go ahead and create an object. Okay, create an object just to see that whether it is working fine or not. So here first of all I'll go ahead and call dog is equal to, I will initialize from dog. Here I'm just going to write the name will be buddy and the owner belongs to Krish. Okay, let's say. Then I will go ahead and print dog.speak, and if I go ahead and execute this, you'll be able to see that I'll be getting buddy says hoof. See, there is also a speak method over here, but since we are directly calling it from the dog class, so this speak method will be given more priority when compared to the parent class, right? So that is the reason it is saying buddy says hoof. Okay, then I will just go ahead and print my f owner. Owner will be nothing but it will be self dot dog dot owner, right? Dog dot owner. Okay, so let me just go ahead and execute it. So here you'll be able to see that owner is nothing but Krish and buddy says hoof. So here what we are doing, here we are creating two parent class, two separate base class, okay, and we are inheriting them from a derived class, and this is basically called as multiple inheritance, okay, or we can also say it as multiple inheritance. Yes. Now let's do one thing. Let's create an amazing use case, and this use case will be about modeling a complete library system. That we'll discuss in our next video, where we'll be modeling a complete library system. Here there will be using single and multiple inheritance. So yes, this was it from my side. I hope you like this particular video. I will see you on the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to Python, and we are going to continue the object-oriented programming series. And in this video, we're going to discuss about polymorphism. Now, polymorphism is a core concept in object-oriented programming that allows objects of different class to be treated as objects of a common superclass. I know there will be a lot of confusion when you read this sentence, but just go ahead and read the next line. And if you are not even understanding over here, don't worry, I will show you a lot of practical examples which will actually help you to understand each and everything. So it provides you a way to perform a single action in different forms. Okay, polymorphism basically means multiple form. Okay, if you split this word, it is basically called as multiple form. Okay, and here it is written polymorphism is typically achieved through method overriding and interfaces. So let me just go ahead and talk about this, and let me just give you a good example to make you understand. Okay, but it is my duty to probably write this kind of definition so that you also know the definition with respect to this. Okay, now what does method overriding allows a child class? So here I'm just going to give you this comment. See, or let me make this or remove this completely, and let me make add a markdown over here. So here you can see. Let me just go ahead and execute this. Method overriding allows a child class to provide a specific implementation of a method that is already defined in the parent class. Okay, that basically means, let's say if I'm defining a parent class, okay, over there I have defined a method, right? Let's say the method will be like, if I probably create a dog class, the method is speak. Okay, so one dog makes a sound, wow, woof woof. Then let's say that I'm inheriting that particular dog with some child class. Now that particular dog makes a louder sound, woof 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 woof. So there, what we are doing, we are overriding the functionality of that particular method, right? So method overriding is nothing but it allows a child class to provide a specific implementation of a method that is already defined in its parent class. So let me just go ahead and take one specific example, and here you'll be able to understand. So first of all, I will go ahead and create my base class. Okay, now this base class will be my animal class. Okay, so let's say that this is my animal class. And I'm just going to create a function that is called as speak. And here I have not written any constructor because I'm not defining any attributes. Okay, so let's say that I've used speak and with the self parameter, and it is just going to return something like the sound of the animal. Okay, something like this. Now this becomes my base class. Now let me just go ahead and derive my derived class. Okay, or write down my derived class 1. Now in this derived class, let's say I will go ahead and derive, I'll create a child class which is called as dog, and it is basically inheriting from animal. Okay, and then we go ahead and define the definition speak, and here we go ahead and define self, right? Now, see, the method is same over here, right? If we are inheriting this particular class, you'll be able to see that, okay, fine, this is the method that I have right over here. And I can also go ahead and return my own definition. So let's say the dog makes a sound like oof. Okay, so this is the sound that the dog makes. So what I have actually done, this method is there, but different implementation. So here method overriding allows the child class to provide a specific implementation of a method that is already defined in the parent class. So this method is already present over there, but the child class has provided its own specific definition or implementation, right? Now let me just go ahead and create another derived class. Okay, derived class, and this time I will go ahead and create a class that is called as cat. And let this get inherited with animal. Okay, animal. Now here I can again go ahead and override the functionality of this method, and here I can say, hey, it returns meow. Okay. It returns meow. Now let's go ahead and define our or create our object. So here what I'm actually going to do, I'll just go ahead and write dog is equal to dog. Okay. Now if I go ahead and print dog.speak, which method it is going to just call? It is just going to make sure that it calls this specific method, right? And similarly, let's say that I go ahead and create my cat. Okay. And let's say that here I will just go ahead and print cat dot speak. Okay. Now if I go ahead and execute this, here you'll be able to see that, hey, I'm getting, when I go ahead and execute dog.speak, I'm actually getting hoof. When I'm executing cat.speak, I'm getting meow. And this is what method overriding is all about. The same method is getting overridden in the derived class with its own implementation, right? And I can also do one thing. Okay, after doing all these things, I can also create one additional function. So function that demonstrates polymorphism. Here, what I'll do, I'll go and create a function, and this is a public function, not inside a class. Okay, not inside any class. So let's say that I'm going to create animal speak, and here we will provide an attribute of the class or an object of a class. Okay, and then we can just go ahead and write print animal.speak method. Okay, now this animal that I'm actually providing, it's an object of this specific classes. Now after defining this method, I can just go ahead and write print. Okay, and I can go ahead and say dog.speak, or let me just go ahead and sorry, it should be animal underscore speak, and here I will just be providing dog. Once I probably define this and execute it, here you can see that I'm getting poof, right? Because as soon as I call this function, here we are giving the object of this particular class, and inside the same .speak method is basically getting called, right? So this way also you can probably show polymorphism. But here what we have done method overriding. We are just overridden all the functions over here from the base class till the child class. Okay. So this is one example over here. Now let me just show you another way where I will be showing you polymorphism with functions and methods. Functions and methods. Okay. Now polymorphism can be also implemented using function and methods to process objects of different types in the same way, right? So here let me just go ahead and show you one base class. Let me just go ahead and create one base class. Here the class name will be shape. Let's say that I'm going to define shape. Now let me just go ahead and write definition area. So I'm going to create a function which is called as area, and here I'm going to give my self keyword. Okay, self keyword. Now let's go ahead and return the area of the figure. Okay, I'm just going to probably give a print message, and this is basically present in the base class. Okay, now what I'll do, I'll go ahead and create my derived class. Now see this. Okay, again here I'll also be implementing function overriding. Okay, so this will be my derived class 1. Okay, let's say that I'm going to probably create a rectangle, and rectangle will inherit shape. Okay, and if for rectangle definitely what we require in order to calculate the area, it is nothing but width and height. So I'm just going to create my init method, and here I'm going to give self, comma, width, comma, height. This is what I'm going to pass in the runtime. I will go inside this. Now let me just go ahead and create my parameters or attributes. That is nothing but cell.width, cell.height, and then we'll go to the next sentence. Oh, sorry, this should be assigned to width. Okay, then we will go ahead with cell.height, which will be my another attribute, and this I will assign it to my height. Okay, now I will go ahead and call this area function. Right now, here what I'm doing, I'm overriding this area method because the functionality will be a little bit different over here. Right? How to calculate an area of a rectangle? It is nothing but it'll just return self.width multiplied by cell.height, right? This is what we are specifically doing. Now let me just go ahead and call the derived class 2. Okay, so here we have completely redefined, or we have overridden the entire function, right? So it's like all the functions are basically having multiple forms. As we keep on making sure that once our derived class inherits the parent class, we are basically redefining this entire function, or we are overriding the functionality. Okay, now let me just go ahead and create another derived class, and this time I'm going to create it as circle. Okay, this will again inherit shape. Okay, shape. So let me just go ahead and inherit shape, and now this time I'll be using an init function, and this will be a constructor. And here what I require in order to calculate the area of a circle, I just require radius, right? So here I'm basically going to write self, comma, radius. Okay, now let me just go ahead and write self.radius is equal to radius, right? So here you'll be able to see that I'm able to just get this particular parameter. I'm able to create it. Now here also the area definition will be, the function will be different, right? So how do I calculate the area over here? I'll just say return, right? It is nothing but pi r square, right? Pi is nothing but 3.14 multiplied by radius into, sorry, self.radius multiplied by self.radius, pi r square, right? Done. And this will basically give me the area. Now what I will do along with this, I'll just go ahead and write a function that demonstrates polymorphism. And here is what I will be writing. So here let me just go ahead and write print underscore area. And here I'm actually going to give the shape, which will be an object, okay, of a specific class. And we'll just go ahead and print with my f string, the area is nothing but shape.area, right? Shape.area, which will be my function. Okay. Now this is what we are going to just print it, right? Now let me just go ahead and create the objects. So first of all, what I'm actually going to do, I'm going to create a rectangle object. Go ahead and use rectangle, right? Basically use 4,5. In case of circle, I just need to provide my radius. So let me just go ahead and define circle with radius. Radius is, let's say, 3. Now if I want to go ahead and just call the area function, I will just go ahead and write print underscore area, and I will give the object that is rectangle. Okay, rectangle. And similarly, I will go ahead and call print underscore area, where I will be giving circle, right? And this is how we execute it. And here you can see the area. Okay, the area is 20 and 28.25. So this is the area with respect to the area of the rectangle, which we basically write length into breadth. So nothing but 4 into 5. And if I go ahead and calculate pi r square, so I'm actually going to get 28.25. Right. So this is one amazing example. And here you can see that we have used functions. We have defined another function that demonstrates polymorphism over here. And this is one of the amazing examples with respect to this. Okay. And here also we are basically playing with the same method name but with different definition. Okay. Now let me just introduce you to see. I've already written over here something like this, right? Polymorphism is typically achieved through method overriding and interfaces. Now let's talk about these interfaces. What is interfaces? In other programming languages, we basically say interfaces. In Python, we say it as abstract base class. Now what exactly it is? Let's discuss about it. So polymorphism with abstract base classes. Okay. Now abstract base class, if I really want to define it, okay, it's very simple. Let's go ahead and see the definition. I'll paste it over here and let me just go ahead and write this. Okay. Important topic altogether. Okay. Abstract base class are used to define common methods for a group of related objects. They can enforce that derived class implement a particular method, promoting consistency across the different implementation. Okay. So abstract base class, that is the reason we say it as ABC. Okay. Let's do one thing. Okay. Let's show you an example over here. I will be defining two important things. First, I will write from ABC. Okay. Now what is this ABC? We are basically using abstract base class. We are going to import ABC. Okay. Along with that, we will be importing abstract method. Okay. This abstract method is a kind of decorator. Okay, I'll be talking about what exactly is decorator as we go ahead, right? But just consider right now, this is what abstract class is all about. You know, it is just used to define a common methods. Okay, so I will just go ahead and define an abstract class. How do I define an abstract class? This is what I'm going to show you. Abstract class. Okay, now abstract class here I'll say, hey, let's create a class called as vehicle. Okay, and this I'm going to inherit to the abstract class, which will be like an empty class itself, right? So this abstract class, afterwards I define it, I will be defining an abstract method also. See, in order to just give you a simple definition of abstract class, it is like a complete empty class. You know, there if you're defining also method, it will be initially empty. Okay, so that is the reason why we have written that abstract based classes are used to define common methods for a group of related objects. Here, no definition will be there much. Okay, so with respect to this, now I've created this particular class. I'm not putting any definition, but let me just go ahead and create an abstract method. Okay, abstract method is just like an empty method, but it is kind of common class that is probably going to happen in each and every class because we are going to inherit this kind of abstract class onto this, right? So here, what I'm going to write, I'll just go ahead and write define start engine. So this will basically be my function, and here I'm going to use my self keyword, and since it is abstract, it needs to be empty, so I'm going to just write pass. Okay, so this is how I've actually created my abstract class. Along with that, I've also created my abstract method called a start engine. Now what I will do for my derived class 1, I will inherit this. Okay, so let me just take class car, and here I'm just going to use vehicle. Okay, now you know that I've defined my abstract method is completely empty. Now I can, since I'm inheriting vehicle, I'll also be inheriting this particular method, and I can define my own function. So that is the reason we'll go ahead and write definition start underscore engine. Okay, start underscore engine self, and we're just going to return over here car engine started. Okay, some information. Car engine started. Okay, and here you can define your own init method also inside this particular class also, right? Define any number of parameters that you want. Okay, now similarly, if I go ahead and create my derived class 2, you'll be seeing, hey, let's go ahead and create this particular class called as motorcycle. Okay, and here I'm actually going to give my vehicle. Okay, vehicle class, and let's go ahead and inherit it. And if I go ahead and write definition start underscore engine, here I'm just going to return motorcycle engine started. So here you can see this function is having a different definition inside motorcycle class, and it has a different definition inside the child class. Okay, then let me just go ahead and create the object of the class. So create objects of car and motorcycle. Now see, I will just go ahead and create it. Okay, and we can do the same implementation like this also, right? So I've inherited over here. Let me just go ahead and define one function that will demonstrate my entire polymorphism. And now I can just go ahead and start this vehicle and just let me define my car. If I go ahead and execute it, you can see that automatically it is being able to call this called as start engine, and here we are able to display it. So here I've actually shown you polymorphism with the help of method overriding. Along with that, we have also seen with the help of abstract class. So this two you definitely need to know. And again, ending this session, I will try to provide some conclusion, which is a good habit. Okay, so here with respect to the conclusion, you should know why polymorphism is important. It is a powerful feature of OOP that allows the flexibility and integration in code design. It enables a single function to handle objects or different class, each with its own implementation of a method. By understanding applying polymorphism, you can create extensible and maintainable object-oriented programs. Okay, but here we are just seeing that what all features it has with respect to polymorphism, right? So yes, this was it for my side. I hope you like this particular video. I'll see you in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to Python, and in this video we are going to talk about encapsulation and abstraction. Now this will be two videos. In this specific video we'll dedicatedly discuss about encapsulation, and then in the next video we'll talk about abstraction. Encapsulation and abstraction, they are very important concepts in object-oriented programming, and it will be helpful to design a very good maintainable and reusable code whenever we define all these things and use all these things in a project. Okay, so if I probably go ahead and read this, here you can see encapsulation involves bundling data and methods that operate on the data of the single unit, while abstraction involves hiding complex implementation details and exposing only the necessary feature. Okay, so abstraction involves hiding complex implementation detail and exposing only the necessary feature. So we will be discussing more about this in the next session, because there will be specifically discussing about abstraction. But if I talk about encapsulation, it is nothing but it is a concept of wrapping data, variables, and methods together as a single unit. It restricts direct access to the same object, to some of the object components, which is a mean of preventing accidental influence and misuse of data. Now, what does this basically mean? Restrict direct access to some of the object components. And here we are basically saying, hey, it is a concept of wrapping data, that is variables and methods together as a single unit. So let me just go ahead and show you some of the example over here. And as I said, in this video, we're just going to talk about encapsulation, and in the next video, we'll talk about the next part, that is abstraction. Okay. So encapsulation we can do with something called as getter and setter method. Okay. Now, before I go ahead and make you understand about getter and setter method, let me just go ahead and talk about three important access variables. One is public. Okay, and I hope you may have seen this in other programming language, in C#, in C++. So public, protected, and private variables. Okay, we'll talk about this, what exactly it is. Okay, now let's go ahead and do one thing. If I'm going to create a class, let's say I'm going to create a class called as person. Okay, and let me just go ahead and write definition in it. Definition. This is my constructor. Here I'll take self, name, and age. Okay, now here you can see that if I go ahead and write self dot underscore name. Okay, or just let me write self dot name is equal to name. Okay, this variable or this instance variable that we are actually creating, this is basically called as public variables. Okay, public variables. Okay, this instance variable, public variable. I'll talk about it, why we say it as public variable. And similarly, if I go ahead and define this self dot age is equal to age, this is also a public variable. This basically means I can call this, or I can use this particular variable from outside of this specific class. Okay, that basically means, okay, let's go ahead and see. I will go ahead and define person, and here I will just say, hey, the name is Krish, and here the name is age is 34. Okay. Now, when I say public variable, public access modifier, also I can say, see, I can also call this as public access modifiers. You know, we'll also discuss about protected and private access modifiers. Okay, we can also talk like that, variables or access modifiers. Okay. Now, here you can see that there is one very important statement. It restricts a direct access to some of the object components. Here, if I go ahead and print, okay, person.name, okay, I will be able to print it. Okay, here I'm able to get Krish. Now let's see. If I go ahead and use this person, okay, and if I try to understand inside these objects, what are the different inbuilt methods or variables that are probably available over here. So if I go ahead and use this dir function, and if I just go ahead and execute it, here you'll be able to see, hey, and here this is what we use, right? Definition underscore underscore init. This is the constructor. So here also you'll be able to find this method is there. Okay. And along with this, you'll also be seeing there'll be two more variables that are available. That is age and name, right? And these are nothing but these are my public variables, right? Or instance variables, which is specifically over here at public. The reason why I'm saying it as public because here you can see that I'm able to see this particular variables directly over here. Okay. And I can use it from anywhere of the program just by using the object. I can use it in different functions anywhere I want specifically. Okay. Now one thing that you can probably do, right? I can probably create a function. I can go ahead and write get underscore name, and I can give the object over here, let's say person, and I can go ahead and return something like this, return person dot person.name. Okay, and I will go ahead and execute this. Okay, now let me just go ahead and print this. So here if I go ahead and write get underscore name, and if I just call it with respect to this particular person, here you can see that I'm able to access this particular name from outside the function, outside the class itself, right? Now there may be a scenario where I may want to define some of the variables in such a way that outside this class I should not be able to provide it as an access. Okay, because there may be some very important variables, right? And those variables I don't want to change it. Once we are initializing it, we don't really want to change it in the later stages. Okay, if you want to just change it, we should only be able to change it while we are creating the object, right? And I don't want this particular variable to be as an access over there, right? So that is the reason why what we do is that we use something called as protected and private variables. Now let me just show you one example of creating a private variable. Right now, if I just go ahead and see directly a person, I'll be able to see all these variables are publicly available. Now I'll just go ahead and copy the same thing. Let's see this. Okay, I will just go ahead and copy this. I'll paste it over here. Okay. Now instead of just writing underscore underscore, let's see, I'm creating a person class. I'm using name and comma age as a parameter while I'm giving it over here. Now instead of writing like this, I will use double underscore. Okay, double underscore name. And here also I will go ahead and use double underscore age. Now what is this double underscore name? This becomes a private variable. If you want to define a private variable, I have to write double underscore. And here also I will go ahead and write the private variable as double underscore. Okay. Now if I go ahead and execute this, okay. Now see focus over here. Okay, I'll remove all this particular code. Okay. And let me do one thing. Let me just go ahead and execute this particular code. Okay. And let me just create an object. So I will go ahead and create an object, and here I will write person, and let me just go ahead and give my values Krish and 34. Okay. And let me just make this spelling correct. So it should be person. Okay. Now if I go ahead and check dir with respect to this particular person. Now see, here you can see that I'm not able to see this particular variable, right? Do you see this? Or let me do one thing. Let me just create one more public variable along with this. So here I will go ahead and write self dot name age. Let me just go ahead and say that gender. Okay. So gender is equal to, I will go ahead and assign this particular gender variable, which I'm actually providing over here. Okay. Let's say that this information. Now here you can see this is a public variable and this is a private variable. Why I'm saying it as a private variable? Because I'll just tell you in some time. Okay. Now let's go ahead and update it over here. Let's say that I'm writing this is male. Okay. If I go ahead and execute it, here you can see directory of person. Okay. It takes 3 positional argument, but 4 were given. 3, one is name, age, and self.gender is equal to gender. Let's see why this is an issue over here. Self.gender is equal to gender. Okay. I did not execute this. Maybe. Okay. Now it should work. Right. Now here you can actually see that I'm able to see this particular public variable. I'm not able to see all this underscore name and underscore age below this. Right. I'm not able to see. Why? Because that is a private variable. And wherever private variable will be displayed, it will be displayed over here in this format. Right. So here you can see when I write underscore person underscore age, the private variable basically becomes in this particular way. Right. It will get appended along with the person class. Right. So I'm not getting this direct variable anyway. Underscore age is nowhere present. So this basically indicates that this is a private variable. Okay. Now let me do the same thing. Let me just go ahead and create a function and let me say, hey, get underscore name. And here I'm actually going to write, I'm going to give an object called as person. And I'm just going to say return person dot underscore name. Okay. I'm just going to return this. Now let me do the same thing over here. Okay. Let me just copy this entire thing. Let me call this person and let me just go ahead and call this particular function get underscore name. Okay. And if I go ahead and see this, and if I just give this particular parameter, will the name get printed? The answer is no. Why? Because it's saying that hey, it has no attribute underscore name. The reason is very simple. Because this is a private variable, and you will not be able to access this. You'll definitely not be able to access it because if I go ahead and see inside the directory, I'm able to see that hey, my person the underscore age has been in this particular name, right? Yes, in this directory you're able to see, but as a developer you're able to see. But as a common person will not know that hey, my private variable has got converted in this particular name, right? And that is the reason you're not able to access it. So here we are restricting, right? What happens with the help of access modifiers or encapsulation? We are restricting some of the variables because I don't want anyone to see this particular variable or directly access this variable because these are some very important attributes in a class which I should not be changing frequently. Yes, as a developer I can definitely see it. What I can do, I can just go ahead and copy this and I can print it over here. Okay, I can do that as a developer, but this is not a good practice. The reason we create a private variable because it is saying to your fellow developers, hey, this is a private variable and it should always be remaining hidden. Now, if I go ahead and execute like this, I'll be able to get the answer, right? I'll be able to get 34, right? Or if I want to probably display the name, I'll be able to get this particular name, right? But if I directly call with underscore name, it will not be possible because I'll be getting that particular error, right? So what does private variable basically say? That a private variable cannot be accessed from outside the class. Very simple. It cannot be accessed from outside the class. Can we access it inside the class? Yes, we can do it. And for that only we'll be using getter and setter method, right? So private variable is something like which you cannot access outside the class. Even you have a derived class that can also not access it. Okay, so this is one of the very important property in encapsulation, and this is where we discuss about private and public variable. There is also one more variable which is called as protected. How do I define protected? So protected is nothing but I will use the same thing, and let's say instead of writing double underscore, I'll just write single underscore. So this is what a protected variable is like, right? A protected variable or access modifier is like. Okay, a protected variable basically says that hey, you cannot use it outside the class. Like outside the class basically means we cannot access this underscore name outside the class, okay, but we can access it from a derived class. So let me just go ahead and write, let's say if I go ahead and say employee is my another class, okay, employee is my another class, and if I say hey, this is inheriting person, so here I've created a class employee which is inheriting person. Now what I'm actually going to do, I'll just go ahead and write my init function, right? So here I'm going to write my init function, and inside this particular init function I'm just going to pass all the parameters like let's say age, gender, okay, and what I'm actually going to do over here, I'll go inside this, and now I'm going to just write super dot, and since I'm inheriting all the attributes from the upper class, so I'll just go ahead and write this self comma name comma age comma gender, okay. Now here you'll be able to see that if I have this class employee, right, I should be able to access this particular values, okay? And that is what protected variable is all about, right? Whenever we create a protected variable in one of the classes, only its derived class will be able to access it. Other than that, you won't be able to access it outside that particular class, okay? So once I probably create this derived class, now from this derived class, I should be able to access all these variables. So what I will do, I'll just remove all these things, okay? I will not be requiring over here. Now let me just go ahead and create my employee, okay? And here I'm going to define my employee, okay? And let's say that I'm going to give some values like Krish, 34, and here I'm going to give the gender as male, okay? Now I will just go ahead and print employee dot underscore name, right? So once I execute it here, okay, 5 parameters is required. So let's see which all parameters. Name, age, gender. Over here, I'm given name, age, gender, and here you'll be able to see that underscore name, underscore age. It takes 4 positional arguments, but 5 were given. Let's see where it is. 4, 5 were given. So self is over here, employee person is over here, employee is over here, and this is nothing but employee dot underscore name. Okay, guys, one mistake that I've done over here, I've used self keyword, so I should not be using this. Now I think it should be displaying it. Okay, so employee dot underscore name. Here you'll be able to see that I'll be able to get this particular output. So in the case of whenever we define a protected variable, it is just like, so it is not anything is compulsory in Python. It is like a very it is a kind of programming language where there are no strict rules. But most of the concepts that we learn, right? Let's say that if I'm trying to create a private variable, if I'm trying to create a protected variable, in case of protected variable, I have always make sure that this variable will only be accessible only from the derived class. In the case of private variable, nothing should be accessible outside the class. And public variable is what you should be able to see that you'll be able to access it from anywhere, right? So here I have actually shown you the example of all these things with respect to private variable, with respect to public variable and all. And let's say that if I am creating a private variable, if I'm not able to access it from outside the class, can we access it from methods that are present inside the class? Okay, and that is what we are basically going to do now. Okay, and we're going to learn encapsulation with the help of getter and setter method. So let's go ahead and write encapsulation with getter and setter. Okay. Now, what I'm actually going to do over here is that, first of all, I'm just going to create my class. So let me just go ahead and write class person, and this will be definition in it, underscore, underscore. And here I'm going to basically write self name age, okay. And here you can see self dot underscore underscore name. So this will basically be my private variable. I will go ahead and initialize it. Private access modifier or variable, okay, or variable or variable. Okay, and see, it is very simple. I need to probably not display this anywhere. It should be restricted within the class itself. That is what is my aim, right? Then I have self underscore age, which will be equal to age itself, and here I'm going to probably say that this is also my private variable. Okay, now in order to access this particular variable inside the class, I can definitely do it. And for this, we'll be using something called as getter method for name. Okay, so we'll go ahead and create one function which is called as get underscore name, and here we're going to use the self keyword, and with the help of the self keyword, wherever we use, we should be able to access the underscore underscore name. So here I'm going to return self dot underscore underscore name. Okay, so this is basically my getter method for name, right? So here you can see that I will just be exposing this particular method to the outside world because this is a public method, right? I will not be exposing underscore underscore name. With the help of this particular method, I should be able to get this, right? Now, here is what I will talk about, one very important thing, right? Have you seen a washing machine? So if I'm probably working under a washing machine, in washing machine, we'll be able to see buttons, we'll be able to see how to start, we'll be able to see that where we need to put the clothes, right? But internal working is completely hidden, right? And that is what over here, same thing we are doing. The internal things are probably hidden over here. Only the things that matter to us, just like the function name is available for us or visible to us, right? So here you can see that just by calling this particular method get underscore name, I should be able to get the name itself from this particular function. This is called as a getter method. I may also have setter method. Setter method for name, right? Now this setter method for name, what it does is that this will help us to change any values that I give to the name. The name, which is basically a private variable, right over here. So this is my private variable. I need to probably change that particular value. Let's say, so I can just use self underscore underscore name is equal to name, right? So with the help of getter, we are retrieving the data. With the help of setter, we are changing the name itself. Okay. Similarly, let's say that I want it for the age, and I can also do that, and probably use a getter method for that and setter method for that. So first, I will do a create a getter method. Okay. And here you can see I'm getting the age, just writing self dot underscore age. And now in the case of setter method, let's say that I want to probably put or change any age, right? So what I do, I first of all check the condition. If age is greater than 0, then only I will go ahead and change it. Otherwise, say age cannot be negative, right? So this is just one example with encapsulation with getter and setter. And we're completely hiding the main variables that we have, right? And we are only exposing this particular function, that is get underscore name and set underscore name. Now let me do one thing. Let me just go ahead and call all these functions, okay, and then you'll be able to understand. First of all, I'll go ahead and create an object. Let's say this will be person, and here I'm going to use Krish. Here I'm going to use 34. Okay. Now you will be able to see here what I'm actually going to do is that access and modify private variables using getter and setter. Okay. This is what we are going to do because obviously we cannot use directly the private variable outside the class, right? So here I'm going to just print person dot get underscore name. So if I want to go ahead and display get underscore name, I should be able to display it. Then if I go ahead and print person dot get underscore age, so I should be able to get that also. And then I will just go ahead and write person dot set underscore age, and here I'm going to basically write 35, right? And then I'm going to print person dot get age again, get underscore age, so I should be able to see the age now. Okay, yeah, and then I will go ahead and set the age, let's say to -5, so that I get the other error that I have actually written. Now initially I'm creating an object, then I'm probably displaying the name, displaying the age. So Krish and 34 will be the answer. Then when we set the age, then it'll get replaced with 35, and then we can actually see this, right? So Krish 34, then we you can see over here is that what we're doing. We are printing, you're setting this age, and then you're printing that particular age, and then when you're setting it to -5, you can see that it is showing age cannot be negative, right? So this is what is all about encapsulation. We have discussed about all the access modifiers like public, private, and public, private, protected. You understood that private variables cannot be accessed outside the class, so that is the reason we create getter and setter method. Public variables can be accessed much easily. Protected needs to be accessed only from the derived class. But again, in Python, nothing is compulsory. As I showed you, when I check the dir directory of that particular object, right, I should be able to see all the private and public variables, right? And just with the help of those names, I can directly call it. But it is always a good practice that we should follow whenever we are implementing things. So yes, this was it. In the next video, we are going to discuss about abstraction. Thank you. Take care. Bye bye. Hello, so we are going to continue the discussion with respect to Python, and in this video, we are going to discuss about a new topic which is called as abstraction, which is one of the most important core pillar in OOPS concept. Now, what exactly is abstraction? Abstraction is the concept of hiding the complex implementation detail and showing only the necessary feature of an object. This helps in reducing programming complexity and effort. Let me talk about some good examples so that you'll be able to understand what does exactly abstraction mean. Okay, let's consider one thing, very simple thing. Okay, with respect to abstraction, if I just want to give you a real world example, I hope everybody uses a washing machine, right? And if you are using a washing machine, in washing machine, you will be having all the options to start the washing machine, how much or what timer you have to probably run the washing machine. You have an option to set the timer. Along with that, you'll be seeing that you'll be having a dryer part, where you'll be able to dry the clothes itself, right? And just with the help of a click of button, you will be able to do that specific operation. Now, that buttons that is visible on that washing machine is the thing, or is the feature of that particular object that is visible to you. Remaining all the complex implementation, how the washing probably takes place, how that particular, as soon as you probably click start, what is the internal process that is going to happen, that all complex implementation is completely hidden, right? And this is what can be taken as a real world example with respect to abstraction. Not only that, you can also consider an example with respect to mobile phones, AC remote, your laptop, your desktop, you'll be able to see buttons are there. Okay, you'll be able to see, hey, if I go ahead and probably if I go ahead and click on shutdown, automatically how the system is getting shut down. If I open a specific application, how that particular application processor is basically allocated in the processor, in the RAM, how much memory is basically getting allocated. So everything is happening in the backend over there, and there are some kind of complex implementation that is happening in the backend, and that is completely hidden, right? Now, in order to make you understand about abstraction, so let me just go and talk with respect to code. So here I will go ahead and say, hey, from ABC, I'm going to import ABC. So this ABC is nothing but it is for the abstraction. It is just for abstract class, which we specifically use. And let's say if I want to define an abstract method, okay, I will go ahead and define an abstract method. I'll talk about why this method is very much important and all. Okay, so first of all, let us go ahead and define my abstract class. Now, what is this abstract class? Let's say that I go ahead and define my vehicle class over here. Okay, now when I'm defining my vehicle class here, I will be considering it as ABC. And always remember, the difference between a normal class and an abstract class is that here I will be inheriting this ABC class, right? And which is nothing but it is for the abstract class itself, right? Or you can also say abstract base class. Okay, this is nothing but abstract base class. Here you can actually see we are inheriting that. Okay, now let's say inside this particular class I have some definition, and the definition can be anything over here, right? Let's say that I will go ahead and write with respect to vehicle, I will say, hey, I have a function which is called as drive. Okay, and I will go ahead and print and write some information like the vehicle is used for driving. Okay, something like this. I'm just writing some examples over here. Now, this is a normal method. Now, let me go ahead and define an abstract method. Usually, when we go ahead and define an abstract method, this will be a complete empty function. Okay, and the best thing about abstract is that it is created in such a purpose that whenever a child class inherits this vehicle base class, it says that, hey, I am giving you a functionality with respect to drive. Okay, and I am giving you one abstract method which you can do the implementation with your own way. Okay, that is what is basically given. So this abstract method is just like giving you the necessary feature of an object, and it is just hiding the complex implementation detail, right? So here we are just trying to provide you a way. So let me just go ahead and again repeat this. Okay, now let's consider that I'm going to probably write an abstract method over here. Now, in order to define an abstract method, we'll go ahead and write definition start engine. Let's say this is my start engine, and I will go ahead and write self over here. And let's say that this is my empty class. Okay. Now in abstraction, what happens is that, as I said, this is my abstract base class, and this is how we create an abstract method, which will be completely empty. Now, if I probably go ahead and create my child class, and let's say the child class is inheriting the vehicle class. Now, before inheriting, always let's say that if I'm inheriting this abstract base class, which is nothing but vehicle, which is also called as an abstract class, here it says that you can inherit this car class can basically inherit the vehicle class, but there will be one condition: you will be able to use this particular method. But to use this method, we have to write our own definition, right? That the car will basically be writing its own specific definition over here. Okay. So in order to show you over here what I will do, I will just go ahead and write definition start underscore engine. Okay, start underscore engine, and here we will just go ahead and write the self keyword, and let's say here we go ahead and write car engine started. Okay. So car engine started. So here you can actually see that I'm actually able to write the code. Right now, what I'm actually going to do, see, now I'll just go ahead and initialize something. I'll create a function. Let me go ahead and create a function saying that operate vehicle. Okay, so this will be my function, and this will basically demonstrate our entire process of abstraction. So I will go ahead and just type operate vehicle, and here I'm going to probably write vehicle. Okay, vehicle dot start underscore engine. So vehicle spelling needs to be correct. Start underscore engine. So here is my start underscore engine. Now let me define this. This function is created and it is outside the class. Okay. Now let me just go ahead and write car is equal to car. And now let me just go ahead and call this operate vehicle with respect to car. So here you'll be able to see that what has basically happened. Here this start engine is getting displayed. Now you need to understand where does abstraction come into mind, right? Here we are just saying that hey, there is one functionality. Okay, there is one functionality which is available for you, right? And this is basically defined in the form of an abstract method. And this abstract method, if it is present, if we really need to create an abstract class, we have to inherit this ABC, right? ABC library that we have imported over here. Now, if any child class wants to inherit this particular abstract base class, we have to make sure that we will be able to use this particular function. But along with that, you have to make sure that you have to go ahead and implement this particular function with your own way. And that is what we have actually done over here, right? If I go ahead and also write over here something like this vehicle, let's say if I go ahead and write vehicle dot along with this dot drive. So drive will also be able to access it, right? We'll be able to access it. Now if I go ahead and execute it, you can see the vehicle is used for driving. So the derived class is also able to use this. But with respect to this abstract method, which is where the abstraction is basically getting applied, where we are just showing the features of this particular objects, right? We are just showing this particular method, but the complex implementation can be overridden by all the derived class that is specifically using them. And that's what is basically done over here, right? So this actually gives an example, or it makes you understand about the abstraction method over here with respect to the Python, and how you can actually create an abstract class, how you can basically create an abstract method, and how abstraction is basically implemented over here. But in short, if I really want to discuss, abstraction is the concept of hiding the complex implementation detail and showing only the necessary features of an object, right? So yes, this was it from my side. I hope you like this particular video. I will see you all in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to Python, and in this video we are going to discuss about magic methods. Now till now we have discussed so many different topics regarding classes, regarding OOPS, we have discussed about function overriding, method overriding, we have discussed about encapsulation, abstraction, so many things we have discussed. and where some or the other way you have definitely seen this magic methods. So what exactly it is, we'll go in depth, we'll try to understand it, and we'll see coding examples with respect to this. So magic methods in Python is also known as dunder methods, which is nothing but double underscore methods, right? They are special methods that start and end with double underscore. This methods enable you to define the behavior of the object for built-in operations such as arithmetic operation, comparison, and more. Some of the examples, if I probably go ahead and make you understand, some of the examples are something like this. See, I will just go ahead and write like this. I think you should be able to see it. It is not showing double underscore, but I don't know why. So let's see. Okay, I'll just make these changes and let's see whether we are able to see double underscore. No, it is not double underscore. So let me just go ahead and take this entirely over here. Okay, and I will take a code. Okay, or use a triple quote. Okay, if I want. First of all, I will go ahead and select a kernel so that you will be able to understand what I'm actually talking about. Some of the examples with respect to this kind of operators are nothing but like this, right? So magic methods are nothing but like underscore underscore init underscore underscore. This basically means you initialize a new instance of a class, right? Basically the constructor. You also have some operators or some methods like underscore underscore str underscore. It returns the string representation of an object, right? And similarly, some of the examples are over here. And if you really want to see this, you will also be able to see this because once I probably create a class, let's say I'm going to create a class person, and inside this I'm just going to write pass. Okay. And now if I go ahead and create an object for this particular person, so here you'll be able to see this class. Okay. Now if I go ahead and write directory of person, right, you'll be able to see all this, right? So these are nothing but these are called as magic methods, right? And we can use all these magic methods, and these magic methods are by default used to here it is very clearly written that why it is used to. It is used to define the behavior of an object for built-in operations such as arithmetic, comparison, and many more. Let's say I want to use underscore underscore str. This will just return a string representation of an object, right? So let's say that I want to just go ahead and print the person object. So by default, you'll be seeing that hey, I'm getting this message, and this message is basically getting displayed from this particular function that is nothing but underscore underscore str underscore underscore. And there are something like you can also override this specific method, and that is what I'm actually going to show you over here. Okay. Now let's go ahead and explore some of the basic magic methods, and then we will try to override them also. So let's say that I'm writing definition underscore underscore init underscore underscore, and here I'm going to write self comma name comma age. Okay. Now once I write this, I'm just going to write self dot name is equal to name. Okay. And along with this, I'm just going to say hey self dot age is equal to age. Okay. So we have defined this over here, and I think okay, I did not write the class or what? It got deleted, I guess. So class person. Okay. Person. And then let me just go ahead and press this def, and here I'm just going to press enter. Make sure that you have this indentation. If indentation is not there, then it'll be a problem. Okay. Now I've defined this particular person class. Okay. Now let's say that I go ahead and define my person object, and let me just go ahead and write the name over here like Krish, comma age is 34, and I'll just go ahead and print person. Okay. Now when I'm printing person, by default I will be getting this information. Okay. This particular object is created at this particular memory location. Let's say that I want to override this kind of message, so I have to override this underscore underscore str method. So what I will do now, I'll just copy the same thing over here. I'll paste it over here, and now I will just go ahead and find another function, another magic function over here, and this will be nothing but str underscore underscore. Here also we'll give self. Okay. And now along with this, what I'm actually going to do, I'm going to return some kind of message. Now I'm overriding the default functionality of this magic method. So here I'm going to basically write return f, and let me just go ahead and write this is nothing but my self.name. I'll just try to display the self.name, and along with this self.name, I'll just go ahead and write comma self.age years old. Okay. And I will just go ahead and display this years old, and let me just close these brackets over here. Okay. So here you can see that now I have changed the functionality of this magic method that is underscore underscore str, which is responsible in displaying the information regarding the object, right? Now if I go ahead and execute it, now you'll be able to see that this message is getting executed. Before, the default message was something like this, right? And obviously you know over here why underscore underscore str is used. It is used to return a string representation of an object. And now when I'm actually using this, and you can see that I've overridden the functionality and I've written my own way of printing the message, and that is what is basically getting displayed, right? Similarly, you can also use different functionalities. Let's say one more functionality is that is present is nothing but underscore underscore repr, and this is basically for I've written it over here. If you go up, right, why it is specifically used underscore underscore, it returns an official string representation of an object, right? So if I go ahead and take this, and now I want to return and write my own string, I can go ahead and write. I can say person. Let's say I will define something like this. Name is equal to self dot name. Okay, self dot name, and here I will go ahead and write age is equal to self dot age. Okay, something like this. I want to display in my own way. Okay. Now if I want to call this function also, I can also call it. So I will go ahead and write print repr. And with respect to that, I will just go ahead and call this particular person over here. If I execute it here, you can see person name is equal to Krish, age is equal to 34. So this is how in my own custom string representation I've displayed it. So magic methods, there are some very important functionalities which will be doing default implementation for objects. If you really want to override it, just write that particular magic method in this particular way and override it based on your comfort and your application. So I hope you like this particular video. This was about the magic methods, and I've also shown you that how you can override to change the behavior of the object. And I've just taken some of the examples. You can take any number of examples, and all the magic methods you'll be able to see over here. And further, you can do Google and probably find a lot of different operations like GT, doc, and all. So in the next session, also I'll be discussing about operator overloading. I will be talking more about this magic method over there. Right. So yes, this was it. I will see you all in the next video. Thank you. Hello guys, so we are going to continue discussion with respect to Python, and in this video we are going to discuss about operator overloading. Now in our previous video when we were discussing about magic methods, right? So here you will be also able to see some of the function or methods or magic method which is called as underscore underscore equal underscore underscore. This is nothing but this is a default, you can basically say this is a default method for any comparison or operation, right? So like when we say, hey, if you really want to do any comparison operation, we usually use double equal to, right? So if I want to override that particular functionality, then I have to override this particular function. Let's say I also use a lot of different operations like 1 plus 1, 2, right? So 1 is an addition operation. Now how do I probably take this plus and override this particular operation? I'll be showing you that. If I'm doing 1 minus 1, so this is a subtraction operation, how we can actually override this. So that is what we are basically going to do. And along with this, we know that, okay, I also have this kind of condition, 12 is greater than 6, right? So why it is giving us true. So this is nothing but this is greater than or equal to. Can we override this particular operator also? That we'll be seeing, and that is what we're going to see in this particular video, how we can perform operator overloading. Some of the best example over here is that you have this underscore underscore add underscore underscore. This nothing, it does, but it adds two objects using the plus operator. Similarly, you have for subtraction, you have for multiplication, you have for true div. This is for the division operation. Then you have equal sign compare if two objects are equal using the double equal to operator. And similarly, you have less than. You also have greater than, which you can basically use underscore underscore gt underscore underscore, right? So that is what I'm actually going to show you each and everything over here. So underscore underscore, you can basically write it over here. So let's say if I go ahead and write underscore underscore gt, this is for the greater than. If you want to override that particular functionality. basically. Now let me just show you over here, and we will try to overload some of the operations with respect to addition, subtraction, and all. Okay. So first of all, I'm going to define my class, which is called as vector. So this is my I will just go ahead and define my class, which is nothing but vector. Now inside this vector, I will be writing my init function. So here you basically have init function, and with respect to init function, let's say I'm going to create two variables, x comma y. Now if I go ahead and write cell.x is equal to x, and here I'm going to write cell.y is equal to y. Okay. Now I'm going to just go ahead and add my add function over here. So let me just go ahead and use this definition add underscore. And here I have to probably give two parameters, self comma other, right? So here what I'm doing, I'm just giving one more additional parameter. Now what I'm actually going to do over here is that in this addition operation, I'll just change this entire operation itself. So I'll say, hey, go ahead and return, okay, vector class over here, and inside this vector class we'll give self.x, okay, plus other.x, okay. I'm just putting some kind of operation, okay. I'm doing some kind of operation over here. Self.x, okay, not z x plus other.x, and here what I'm actually going to do again, I'll go ahead and write self.y plus other.y. That basically means what I'm actually going to do. This other will be another vector itself, which will have x and y coordinate, and I'm just summing it up with the x that I'm actually giving, and along with the y coordinate that I'm actually giving, right? So I'm just going to sum it up with respect to this particular other, right? Similarly, what I will do the same thing for let's say subtraction, for multiplication, and all. So here I will go ahead and define my another function, and here you can see I'm doing subtracting over here. I'm doing subtracting over here, right? Other will be another vector, okay? We'll see to it once we probably initialize and call the function. Now along with this, what I'm actually going to do is that I'm also going to make sure to change my equal to functionality, okay? I'm going to overload this particular operator itself. So here with respect to equal to, I'm saying return self.x double equal to other.x and self.y double equal to other.y. It will be either true or false, okay, based on the comparison that is basically happening. And finally, to represent this entire string, we'll be using underscore repr, and here I'm just displaying the vector with self.x and self.y. Okay, just a simple operation, and just to show you that how I'm overriding each and everything. So finally, we go ahead and create objects of the vector class. Okay, and here we are just going to write v1 is equal to vector 2 comma 3. Okay, and then I will be going to create my vector v2, and this will be nothing but 4 comma 5. Okay, now this is my v1 and v2 vector. Now let's see, okay, what kind of operation will basically happen. If I go ahead and write print v1 plus v2, we have already, you can see that I've already changed this plus underscore add operation, right? So if I go ahead and print it, so what is the output that I'm actually getting? See, v1 is nothing but, so here you can see that I'm adding both this, right? 2 plus 4, 6, 3 plus 5, right? So that is what I'm printing it with respect to the addition operation. So that is what is basically happening, self.x, other.x. So in short, I have modified this entire functionality for the addition of vectors. That is the main purpose over here, okay? Please make sure, that is the reason I had written initially all the code. This is nothing but, I'm doing mathematical operation for vectors, which is not available right now. So I have defined my own custom one. Here what we have done, here this is one coordinate x comma y, and this is the other coordinate x comma y, right? And when we do add operation, this is going to get considered, v2 is going to get considered as the other option, right? Then I'm going to take this as x and y coordinate, and this will be my other x and y coordinate. And this is what we are getting over here, and we'll be able to add those vectors, right? So next, I will go ahead and write v1 minus v2. Similarly, print v1 multiplied by 3. Okay, so if I go ahead and execute it, first of all, v1 minus v2, what it is going to do, self.x multiplied by other. So sorry, this is multiplication. So self.x minus other.x. So we are just going to subtract it. 2 minus 4 is 2, and 3 minus 5 is minus 2. Sorry, 2 minus 4 is minus 2, and 3 minus 5 is minus 2. And here you'll be able to see that with respect to multiplication operation, I am just multiplying with this particular number, v1 multiplied by 3. So I have x and y coordinate. So x multiplied by other number over here 3, and y multiplied by 3. It is nothing but 6 comma 9. Right. So this is how you can entirely overload all the operators based on your assumption. You can take up different operators and definitely make sure that you try to convert them based on your vectors or based on your requirements that you like. I'll also give you one more example which you can do it as your assignment. That is nothing but overloading operators for complex numbers. You can just go ahead and explore this particular code. Now it's time that you have to give some amount of time, and here we have also used trueDiff and see what all things we are basically doing. If I talk about complex number, there will be an imaginary number, so there will be a real number, it will be an imaginary number, and based on that we have written this code. So just go ahead and explore this, and let me know whether you're able to understand or not. So finally, I would like to add some conclusion saying that matching methods and operator overloading are some amazing powerful feature in Python, allowing you to completely customize the operator functionalities itself based on your application development that you really want, right? So yes, this was it from my side. I hope you like this particular video. I will see you on the next video. Thank you. Hello guys, so we are going to continue a discussion with respect to Python, and in this video we are going to discuss about a Streamlit app. If you don't know about Streamlit, it's an open source app framework for machine learning and data science projects. It allows you to create beautiful web applications for your machine learning projects altogether. And the best thing over here is that you even don't need to know HTML, CSS. Just by using the components of Streamlit, you'll be able to create beautiful web pages, right? And right now, since generative AI has become very much famous, Streamlit has been extensively used over here to create chatbots. Okay, so we'll be discussing all about this. As I said in this video, we will try to understand from basic. We'll see what are the important components with respect to Streamlit and how you can get started with Streamlit. Okay, so let's quickly go over here. So here it is. I've given this particular definition. So it is nothing but Streamlit is an open source app framework for machine learning and data science projects. It allows you to create beautiful web applications for your machine learning and data science projects with Python scripts. Okay, so first of all, we will go ahead and import this library. And for that, I really need to install in the requirement.txt. So I'll go ahead and update it over here. So let's quickly go ahead and do the installation. So pip install minus r requirement.txt. Over here, you can see that the installation will be taking place. So here, once the installation takes place, you'll be able to see I'll be able to start using this particular library. So here, let me quickly go ahead and open one of the .py files. So here, I'll just go ahead and write streamlit.py, or let me just go ahead and write app.py file. Okay, and this is where I'm going to write my code. So here you can see the installation has taken place. Now to start with Streamlit, what I'm actually going to do over here is that I'll go ahead and import Streamlit as st. Okay, so we're going to import this as st. st is the alias, and this is the library that we're using. Along with this, let's go ahead and import pandas as pd. I'll be importing pandas. I'll also import numpy, so that I'll be using some of the basic applications. And in order to start with the Streamlit web application, or here I will first of all show you some of the important components. One of the components is nothing but title, right? So let me just go ahead and write this title over here, and I will just use this st.title, okay, st.title, and let me just go ahead and write something like hello Streamlit. Okay. Now we will go ahead and execute this. So in order to execute it, you know that this app.py is inside your 14th Streamlit folder, and which is inside this entire Python folder. Right now I'm in my Python, so I'll go ahead and write cd14 Streamlit. And in order to run this app.py file, right, I will just go ahead and write Streamlit run app.py. So once I execute it, here you'll be able to see that I'll be getting this option which is called as allow access. So I'll click on this and my web browser will get loaded, which will look something like this. So here is the default message. That is nothing but a title. And the best thing over here is that I did not write any h1 tag or anything as such. I just use this ht.title component. Okay. And if I go ahead and inspect this, you'll be able to see that this will automatically get converted into an h1 tag, right? And these are some of the different containers which will be created by that same code that we have seen, right? That is ht.title. Okay. Now this is very much easy. Let me just close this, and here you can see by default it will be running in this localhost, and the port is 8501. So this is how you run the Streamlit app by just writing streamlit run app.py. Okay. Now let's go to the next step and let's display a simple text. So here I want to display a simple text. Okay. Now this simple text I can go ahead and write it in my page. So I'll go ahead and write ht.write, and I'll say, hey, this is a simple text. Okay. This is how we write in the page of the web app that we are specifically creating with the help of Streamlit. Okay. Now let's go ahead and create a simple data frame, and we will try to print this data frame. Okay. So here I will just go ahead and write df pd.data frame. So I have my first column, I have my second column, and these are all my information. Okay. Now let's go ahead and display this data frame. Display the data frame. Okay. Now displaying the data frame, again I can go ahead and write ht.write, and I'll say, hey, here is the data frame. Okay. Let's see how the data frame will get displayed. So I'll go ahead and write ht.write again. So write is a function which will be able to display this particular data frame. Okay. So once I display this, the next thing what I can do is that I can also create my line chart. Okay. I want to probably go ahead and create a line chart. So I'll go ahead and create a line chart. Okay. Now in order to create a line chart, again we have to use st, and then we have something called as st dot. Here you can see line chart link button, everything is there. So we will go ahead and use my line chart, and let's create a chart data. Okay. So this will basically be my chart underscore data. I will create some data over here, some basic data. I'll go ahead and write, hey, this is nothing but pd.data frame, and let's go ahead and create it. Okay. So pd.data frame, here I'll say, hey, go ahead and use np.random numbers, use 20,3. That basically means how many rows and how many columns. That is 3 columns and 20 rows. Okay. And then I will just go ahead and create my columns also. So columns will be nothing but, since I have only 3 columns, so I will go ahead and write a, comma b, comma c. Okay. So once I execute this, I will be able to see this line chart, and inside this line chart, this will be nothing but my chart data. So let's go ahead and execute it. So I will just go ahead and delete this, and let's save this. And here I'm just going to run streamlit run app.py. So once I execute it, this is my web browser that has got opened, and here you can see how beautiful chart it is being able to display. This is my data frame altogether, right? I can also expand it. I can also download it, right? If I download it, I can download it in the form of CSV file. So here is also my chart, which looks really awesome. I can save this as a SVG, PNG file, right? You can also open in Vega Editor, compile Vega, view source, anything that you want. Okay. So this also looks really good, and here you'll be able to see all this particular information. I can also zoom in, zoom out. Okay. Now this was a very easy way of creating this quick application, and here I did not even have to use much HTML, right? So this really becomes very much easy for a backend developer who really wants to develop a quick POC, an interactive POC, and probably show it in front of anyone, right? So this is one example. Let me just go ahead and play with some more examples. Okay. So I will close over here, and this time I will just go ahead and create one more file, and this time we are going to work with widgets.py file. Okay. Now with respect to this widgets, we'll create some more widgets. We'll use some more widgets. So here widgets basically means we will try to create some more interactive application, and for that Streamlit also provides some amazing basic widgets. Okay. So first of all, I will go ahead and import Streamlit as ht. Okay. So once we define this, okay, then I will just go ahead and write my ht.title. So ht.title, let's say Streamlit text input. Okay. Like we have an option of putting text input. So let's say I will create a variable name, and I will go ahead and write ht.text underscore input. Okay. So this basically means I can give an input in my text box. Let's say here I'm going to say enter your name. Okay. Now if I execute this over here, you'll be able to see that. I will just go ahead and say if name colon. Okay. That basically, what does this basically mean, right? If name colon. That see, when I run this particular widget.py file, right, when it opens the Streamlit app, it will initially show me a text box. And if I'm putting some information, and if I'm pressing enter, that entire information will get saved in this particular name variable. So if I go ahead and write if name, then here you can see ht.write, and here I'm going to just go ahead and call this. Okay, so let's say I'll go ahead and write hello, and this should be my whatever name that I'm actually giving, and it should display this, right? Now let's run this. Okay, here this time I'll go ahead and write Python widgets.py file. Okay, so if I go ahead and execute it, oh sorry, I should not write Python, but instead I should write streamlit run widgets.py. This is the command that we usually use in order to run this particular file. Okay, so let me repeat it: streamlit run widgets.py. So once I execute this, here you'll be able to see that I'm getting this particular information. Now here, as soon as I write my name, Krishna, I press enter. So here you can see that Streamlit has no attribute right. So that is the problem because I wrote two W's, right? So I will quickly go ahead and fix this issue. Now let me run this again. And here you have my browser. Now let me go ahead and write my name, Krish Naik. Okay, and let's press enter. So here you can see this is the message that is getting displayed. Perfect. Now let me do one thing over here. Here I'm not just going to stop over here. Okay, I will also try to use some kind of slider. Now in order to use the slider, let me do one thing over here. I will just go ahead and say, hey. Let's create a slider. So for creating a slider, I'll say, hey, let's create a variable called as age. I'll say ht.slider. And with respect to this particular slider, this is again another component that we can use over here, which will be an interactive component. And here I'll say, hey, select your age, and the age value will be between 0 to 100. And here you can see the third parameter that I have, that I'm actually giving is 25. Okay, we'll run this, and then you'll be able to understand it. Okay. As soon as I probably select this, what I will do is that I will just go ahead and write ht.write. Your age is something like this. Okay. Now let's go ahead and reload this. Okay, so here you can see select your age. So once I go ahead and update this, so minimum is 25 that I can select over here, and initially if I reload this, you'll be able to see that it's pointing to 25, right? I can also reduce it, but minimum first of all it shows 25. Then I can select any age, and automatically this updation will basically happen. Now this is one of the amazing component that is probably present over there. There's also a component which is called as select box. Okay, now in order to select box is just like using a drop down box. Okay, so here you'll be able to see that in order to use the select box, let's say I will go ahead and create this something like this. Okay. So I'll say, hey, this is my options. I want to go with Python's, Java, C, C++, JavaScript. So this will be a list of options. I'll say ht.select box, choose your favorite programming language, and I'll give the options over here. So this will basically be my choice. And here you can go ahead and write that particular choice. So I'll save it. Let's go ahead and execute it again. So I will reload it. So here you can see, hey, I can go ahead and select any of this particular language like JavaScript, and automatically you're able to write it. So this looks like a very good form because I'm not writing much information over here, right? It's very much simple. It's very much easy that I'm able to get this entire information, right? Let's try one more thing, okay? Let's try data frame in short, and let's see how it gets displayed. So here I've already shown you the data frame anyhow. So let me just take this particular data. I will go ahead and import pandas as PD. Import pandas as PD. Okay. So the main thing over here is that there are a lot of interactive components that are available. So here I'm creating my data, I'm converting that into data frame, and I'm writing htdoc_write. Okay. So again, if I go ahead and reload it, so this is my entire data frame, and you can actually see this particular data frame, right? So like this, I can quickly go ahead and create my entire form itself. Okay. I also have an option to probably create an upload button. Okay. For the file upload. So here, what I will do, in order to create an upload button, I will go ahead and write uploaded_file. So this will be my another component, and I'll just go ahead and write st.fileuploader. And I will say, hey, choose a CSV file. Okay, choose a CSV file. And I can basically go ahead and choose this, and I'll say, hey, let's keep the type as CSV. If I want different other files, I can probably keep this in the form of list. It is up to you. Okay, and you will be able to do this, right? So finally, if you go ahead and see if uploaded file is not none, okay, I can go ahead and write df is equal to pd.read_csv, and I will give my uploaded file over here, and I will just display that particular uploaded file in the same page. That is nothing but df. Okay, let me do one thing quickly. I will save this entire CSV. Okay, so I'll say, hey, df.to_csv, and let me just save it as sample data.csv. The reason is that I just wanted one sample data. That is the reason. Okay, so I will go ahead and execute it. So this may have got created. Let's go ahead and use this particular CSV file. So I will go to this particular website, and I'll go back to over here. I'll click on browse. I will go inside this, and let's go ahead and upload this. So once I open it, here you can see that I'm able to display it, right? Which is again good altogether, right? So these are some of the important components. Again, I would suggest go to streamlit.io. I think this is the most easiest framework that I've seen. There are a lot of components which you can go ahead and check it out. And as you'll be seeing that if I create any videos, like let's say, oh yeah, I want to play with text, I can go ahead and play with text, images, videos. So charts, widgets. So I've just discussed about widgets. They are also charts. You can use different charts. You can use different graphs. You can even use page navigation. So in short, just by using this, you'll be able to create your entire, the web application that you actually require. So this was it. Now in my next video, what I'm actually going to do is that I'll just try to develop a machine learning application, an interactive machine learning application, and show it to you. Okay, I know if you have not learned about machine learning, don't worry. But just to give you an example, how does this Streamlit app looks like with the help of a end-to-end machine learning project, I really wanted to show you that. Okay, but again, if you don't know any machine learning algorithms, so I'd suggest please go ahead and check some of the algorithms, and automatically you'll be able to understand it. Okay, so yes, this was it from my side. I will see you in the next video. Thank you. Hello guys, so we are going to continue discussion with respect to Streamlit app. Now in this video, I'll just try to show you and project, again a machine learning project, and just to give you an idea like how easily you'll be able to create any web app with the help of Streamlit. Okay, I know you may not have seen any machine learning algorithms yet. I would suggest at least you have some idea about some of the machine learning algorithms like random forest and all. But here in this problem statement, I'm going to solve a classification problem statement, right? So this is just to show you, I'll give you an idea like how to probably develop an end-to-end project with the help of Streamlit. So first of all, I will go ahead and import all these libraries, that is Streamlit, pandas, and sklearn.datasets, and sklearn.learn.ensemble. So first of all, I need to go ahead and install this scikit-learn. Okay, so I will just go ahead and I have to import one very important library that is called as scikit-learn, which is nothing but this is the same as sklearn. So for that, I need to go ahead and install this. So here I will open my terminal, and I'll close this. Okay, so let's quickly go ahead and do the pip install minus our requirement.txt. So here you can see requirement.txt file is not visible. The reason is very much simple because I'm inside my Streamlit folder. So I'll just go ahead and write cd.dot. Now let me go ahead and do the installation. So once I do the installation, my scikit-learn will get installed, and then only I'll be able to use this sklearn.datasets and sklearn.ensemble. And this is one of the classification algorithm that we are going to use. Okay, so it is going to take some time till the entire installation of this particular library happens. Okay, and you always have to do this installation in your same environment where you're working. Okay. Now, I'm going to use this load iris dataset. This dataset has 4 important features. That is nothing but petal length, sepal length, petal width, and sepal width. So I'm going to use that. So here, let me just go ahead and create one of the function. Okay. Now inside this function, I have written definition load_data. I'm going to initialize this load iris over here. This is going to give me my dataset inside this iris folder. Okay. And then I'm going to convert this into a data frame just by writing pd.dataframe. And here I've given iris.data, and the column name is iris.feature_names. Okay. So don't worry if you're not just able to understand this right now, because later on we'll be having this detailed discussion when we discuss about all the algorithms. But in short, this is my independent features. This is my feature names, right? All the feature names, and this is my data that is available over there. Okay. Then this is my target feature. That is nothing but df of species that I've actually created, right? And then we are returning both this information over here. Okay. Let me make sure to write important decorator which is called as st.cache, and I'm writing this so that every time we load this, we should be able to save this entire data into the cache, and will not each and every time load this from this particular library. Okay. So here is my, let's go ahead and call my df, comma target underscore name. So this I'm going to call it from my load underscore data. So I will just go ahead and write load underscore data function. Okay. Now, I'll just give you an idea over here how I'm going to apply the machine learning algorithm. So over here, we are just going to apply model is equal to a random forest classifier. Okay. So I'm going to use this particular model, and this model will be requiring an input and output feature. So here, in order to train, I'll just go ahead and write model.fit, and let me just go ahead and write the df.iloc, which will be taking the independent. This is all my independent features, and this is my output feature. Okay. So basically, I'm just going to take in my x-axis all my independent features, excluding the last feature. Okay. Last feature is my dependent. So last feature is nothing. It is the species. Right. So this basically becomes my independent feature over here, and this will basically become my dependent feature over here. So that is the reason I'm doing model.fit. Now, in order to select and make this diagram or make this application interactive, I'm going to use this st.slider, and I'm going to use with respect to sepal length, sepal width, petal length, and petal width, where my values will be between min to max. Right. Whatever sepal length minimum is there, whatever sepal length maximum is there, I will be able to slide it. Okay. And I will take all this input data, whichever input data I select. Okay. I'll take the sepal length, sepal width, petal length, and petal width in the form of list, and then we will do the prediction So here in the next step, we basically do the prediction. Okay, this is just to give you an idea what exactly we are doing. Okay, and one thing that you really need to see that, okay, it's okay if you don't understand this, but because in the later stage you will be able to understand it. But just I really wanted to show you the power of how an application will look like. Okay, so finally we will go ahead and write down all the particular predictions and predictions pieces. Okay, so let's go ahead and execute it. So in order to execute it again, I will just go ahead and open this. You'll be able to see. Okay, let me just execute this entire application. So I'll go ahead and write cd 14 streamlit, and let me just go ahead and run this streamlit run classification.py. So if I go ahead and execute this here, this is how my browser will look like. See. So this is getting loaded with respect to the data set that I have. So it says that hey, st.cache is deprecated and will be removed soon. We can use st.cache underscore data. Okay, so let's go ahead and use this. Okay. So I will reload it. Okay, perfect. Now see, right now I'm not selected any. Now let's go ahead and select my sepal length, sepal width, petal length, and petal width. So here you can see my predicted output is versicolor. So this is the kind of plant that I'm actually getting, right? If I go ahead and change my sepal width again, if I go ahead and change my petal length, if I go ahead and reduce my petal width, so see it is showing setosa. If I go ahead and increase my sepal length, it is showing setosa. If I increase my petal length, if I increase my petal width, I'm getting virginica. So how beautifully, this is just like a machine learning application which will be in the left hand side just by with the help of slider. You're using this and just by doing this automatically, machine learning is able to give this, right? And obviously, if you do not understand the machine learning algorithms, don't worry, we will be covering that. But the main intention of this particular video is just to show you the power of the Streamlit and show you that how beautiful this is with respect to showing the predictions, right? And here I did not write much HTML code and all. It was very much easy to probably display this entire things. And this code that you see over here, if you just see step by step, we have used components like slider. We have created this st.cache data so that it does not every time load this. Instead, it takes the cache data from there. With respect to the prediction, I have this, and we are writing the prediction in the screen itself, right? So yes, this was it from my side. I hope you like this particular video. I will see you on the next video, but this is just an example with respect to the machine learning algorithms and how easily it will be able to display, right? So yeah, I'll see you on the next video. Hello guys, so I'm quite excited to start the NLP series, that is natural language processing for machine learning. In this video, we are going to see the entire roadmap, like how you should go ahead and prepare for natural language processing. And NLP is an amazing domain, amazing tech part with respect to machine learning or deep learning. A lot of research is basically happening in natural language processing itself. So let me go ahead and let me just share my screen and let me go ahead and let me explain about the roadmap, like how you should basically go ahead with the preparation. So to begin with, till now, probably if you know machine learning, okay, so in machine learning, you have actually seen, right, we solve two different kind of problems. One is supervised, that is supervised, and the other one that we basically solve is something called as unsupervised machine learning. Now, in most of the supervised machine learning use cases, where we specifically solve two different kind of problem statements like classification and regression, right? In all this problem statement, right, what we have seen is that, let's say if we have some specific set of features like F1, F2, F3, F4, like this, it can be a number of features. These features are usually called as independent features, right? So if I probably talk about this, these are my input features, or I can also say this as my independent features. Independent features, right? And similarly, I also have my output feature, which is my dependent feature, right? Which is my dependent feature. So what is our aim in a supervised machine learning model is that, with respect to these features, we obviously will be having a lot of data points. In the output, it can be a classification problem or a regression problem. And over here, I may have continuous values, or I may have classified points like ones and zeros. It can be binary, it can be multi-class. Okay. So let's say if I have this kind of data points over here, what is our main aim? We usually create a model. Okay. We usually create a model and we train the model with this data, right? So we basically create a model and we train this particular model with this specific data set, right? With this specific data set, then our model will be able to make, or it will be capable to make some predictions whenever I give this kind of input data. Now, in machine learning, specifically, if I talk about these features, right? Now, F1 can be a continuous features, F2 can basically be a categorical features, and it can also be different types of features over here. And during this particular scenario, let's say that some of our features are completely made up of text. Let's say one basic example that I really want to give is about spam classification. Let's say this is my example over here, spam classification. Now in spam classification, what are features we may have? We may have, let's say, my main aim is to basically detect whether an email that comes to me is a spam or not spam. Okay, so let's say that this is a classification problem that I really want to solve. Now in this scenario, some of the features that I may have, one feature is that I may have something called as email subject. Okay, I may have the next feature as email body. And my output feature is basically whether this mail is spam or ham. Ham basically is not spam. So let's say over here, I'll give you one example. Let's say the email subject is like billionaire. So here you can see that it is a completely a text, right? Email body, it can be like you won a lottery of, okay, I'm just giving you an example. You won a lottery of $1 billion. And I think you get this kind of emails, right? Now, obviously, when you get this email, in real world scenario, we will be classifying these particular points, and this will basically be a spam. So I'll put a category as 1, or I can also put it as spam itself. Now, here, one thing that you can notice over here is that whenever in our input features we have a continuous variable and we have a categorical variables, and obviously we have different techniques to convert these categorical variables into continuous values, right? There are techniques like one-hot encoding, there are techniques like target encoding, ordinal encoding, all those techniques are there, which we basically do it in feature engineering. But let's say that if my entire data is a text or a sentence like this, right? In this particular scenario, it will not be that easy for a model to understand, right? Obviously, because the model cannot understand human language, right? Right now I've written in English, tomorrow it can be in Chinese, day after tomorrow it can be in some other languages. So model is not directly capable of understanding this particular text. So what should we do in this particular scenario? So we have techniques where we can convert this all text into some meaningful vectors. Meaningful vectors. Now, what are vectors? Vectors are just like numbers only. But understand those vectors represent some meaningful information with respect to this particular text. Okay. And whenever your input data is in form of text or sentences, we basically use something called as natural language processing, so that we'll be able to process this particular data and we'll be able to make the model understand to solve use cases like spam classification. Right. So this is the entire context behind NLP. And why it is so much popular? Because nowadays you see a lot of examples. Alexa, right? I think many people use Alexa. Many people use Google Home, right? many people use some automated device, like let's say the AC is running, right? And you say, hey, switch off the AC, switch on the AC. How that particular machine is able to understand that? It is all because of natural language processing. Google is extensively doing some amazing research with respect to NLP, and they're coming up with some amazing things. Yes, we will be learning both with respect to machine learning, and as we go, we'll also try to learn with respect to deep learning. But just try to understand. In this video, we are going to understand the roadmap, like how we should go ahead and prepare with respect to the NLP. So again, I'm going to write the roadmap of NLP. Okay. And again, we're also going to use different libraries. I'm just going to draw a pyramid kind of structure, and we will go in the bottom to top approach. Okay. So let's go ahead and let's try to understand what should be the roadmap of NLP. Initially, to begin with, I'm just going to create a small block. Okay. To begin with, this first block is basically, initially you need to know one programming language. So let's say that I'm going to probably go ahead with Python programming language. Super important, right? With the help of Python programming language, we'll obviously be able to solve a lot of use cases of NLP. But when I go to step one, so this is basically the step one. The step one is nothing but it is basically called as text pre-processing. And this text pre-processing initially will start with some basic things. Like whenever we have this kind of text data, what are the text pre-processing things we need to do? How we can basically clean that particular text data? All those things will basically come in text pre-processing. Okay. The techniques that we are probably going to apply in this is like tokenization. Tokenization is a concept wherein you convert a paragraph into a sentence into a words, different things. We're also going to learn techniques like lemmatization. We're going to learn techniques like stemming. We're also going to introduce words like something called stop words. All these things will basically come covering in the text pre-processing part one. So this is basically the step one. Okay. I'm just going to write this as step one. Super important. And initially we'll be starting with this. Okay. And again, the entire detailed syllabus, obviously, I'm going to make video by video to make you understand each and everything. But on the 1,000 feet over here, I'm just giving you this. There are a lot of topics inside this which we really need to be familiar with. Now coming to the second one. Okay. So the second one, we basically say it as text pre-processing step two. Okay. So again, this is also text pre-processing technique, but we try to increase the complexity of it, and it tries to solve more problems. So here in the text pre-processing two, here we focus on converting the text data into vectors. So here I'm just going to write it down. This is my step two. Here I'll write, or I can basically write text pre-processing part two. Here we are going to learn topics like bag of words. Okay. TF-IDF. We're also going to learn things like unigrams, bigrams, a lot of concepts like this, which we are going to cover. Again, this is again a text pre-processing technique, but again, understand what is the main aim. The main aim is basically to convert, or let me just write like this, step one and step two, instead of writing like this, I will just write it in a simpler way. Okay. So here we are basically focusing on cleaning the text, right? Cleaning the input. In this particular step, we are trying to focus on converting our input text to vectors. And this is a super important step because this vector should be able to make sure that the context of the statement should be able to get captured, right? So at the end of the day, in NLP, with whatever techniques right now it is there, like transformers, BERTs are there, which is quite advanced techniques. If you are able to convert this input text into some meaningful vectors, you'll be able to solve those particular use cases in a better manner, right? So this is basically the second step where we focus on converting the input text into vectors. Still, there are more advanced techniques of text pre-processing, which I will go with the third step. And here we focus on, here I'm just going to write it as text pre-processing with respect to part 3. Okay. And here what all things we basically focus on? We use more advanced techniques, which is like word to vec, average word to vec. And this is also a technique to convert the input text into vectors. Now you may be thinking, Krish, in the second step also you have written the same thing, in the third step also you have written the same thing. Yes, guys, understand, as we go from the second step to the third step, this conversion of the input text to vectors, it is better than the approach that we basically use in DOW, as bag of words, TF-IDFs, unigram, bigrams, right? But as a learner, we really need to know all these particular steps, right? Now, over here, we focus more on techniques like word to vec and average word to vec. Here, the word to vec and average word to vec is again a kind of a deep learning technique, but we will try to learn this and we'll try to understand how it basically happens, okay? Now, coming to the next step that we focus on, right? If we continue understanding the entire roadmap, here we also focus on understanding RNN, LSTM RNN, GRU, okay? GRU RNN. Now again guys, this is a deep learning technique which is basically used for handling or solving text related use cases like spam classification, text summarization and many more things. So again over here, these are some neural networks you should be familiar with in the roadmap before basically when we enter into the deep learning part. This is super important to understand, and again as I said, this is a part of deep learning technique, okay? But since I'm writing about the roadmap, I really need to mention about all those things. Now coming to the next one, there's also a technique which is called as word embedding, okay? So this is also an amazing way to convert input text into vectors. Internally, if I talk about this particular text pre-processing, it also uses techniques like word embedding. Okay, so this is also a technique, but this technique is basically called as word embeddings. And word embeddings internally uses some amount of word to vec, but we can train our own word embedding techniques. Okay, so again, this is a technique of converting input text into vectors. Now, similarly, we have techniques like transformers and BERTs also. So coming to the next one, this is basically transformer. Again, this is an advanced technique. I just really wanted to mention all these things to you so that you'll be able to understand BERT. So if you really want to become a pro, you really need to go with this particular pattern and try to complete till BERT and try to see the application of that. But as we go up from bottom to top, the accuracy of the model keeps on increasing because, and remember one more thing, the size of the model also increases, right? Whichever machine learning models or deep learning models that you're probably trying to create to solve the NLP use cases, it will keep on increasing as you go towards transformer and BERT. Now, initially, as I said, we are going to learn with respect to NLP with respect to machine learning, NLP for machine learning. So what all things we are going to focus on? We are going to focus on these 3 things first. And when we'll start deep learning, we will probably focus on these 3. Okay. So here, I'm just going to write this. Important thing is that all these 3 steps will be the part of machine learning. And now when I say machine learning, we will be using libraries like NLTK. And there are also libraries like Spacey, which will actually help us to perform all the tasks which is available over here in the bottom 3, right? But we'll focus on one library that is called as NLTK. So suppose if you know NLTK, I think learning Spacey is also very much easy. In the case of deep learning, we will usually go with libraries like TensorFlow or PyTorch. So both libraries are quite amazing with respect to this. As you know, TensorFlow is now an open source, PyTorch is an open source. TensorFlow has been created by Google, PyTorch has been created by Facebook, right? But at the end of the day, what is the main aim? Your input data is in the form of text data, and you basically have to perform some amazing kind of text pre-processing where you convert the input text data into vectors, and you are able to solve amazing use cases of NLP using both machine learning and deep learning. And this is a brief idea about the entire roadmap, like how we are going to prepare. In the next video, I'm going to discuss about some of the amazing use cases this, what all things we can basically do with the help of NLP, right? So all those things we'll be covering in the upcoming video. So yes, I will see you all in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to NLP, and in this video we are going to discuss about some of the amazing use cases, and these use cases we use it every day in our day-to-day activities, right? So let me go ahead and let me share my screen and let me talk about every use cases one by one. We'll be discussing about it, and this will give you a clear idea about what is natural language processing. Now here I've opened my Gmail tab. Now in this specific Gmail you'll be able to see that let's say that I really want to write some email, right? So I'll say hello Krish, okay, and let's say I made a spelling mistake, okay, I wanted to clarify. So I have actually written a wrong spelling. So here you can see that automatically the spelling has been corrected, right? And this is all because of NLP. And in this also we can, like suppose if we receive an email from someone, right? We can also write an automated email from them. So that basically means it will basically tell us that what kind of text it will auto-generate and it will give it for us, and we can actually send it. So I wanted to clarify about the data science, and let's say I'll write course, okay? Now let's see what it basically gives. It can also give you a suggestion like this, and now you can basically select the course, right? So this is also one amazing use cases, and we use it every day. Now let's say I go to my LinkedIn. So here Rudra Pratap Singh is one of my students, and automatically we can see that 2 tags automated replies there in the LinkedIn itself. And this is also an amazing application from NLP, so that if you really want to just provide this any of this particular 2 tag, you can just click it and you can reply back. So in this, in short, is saving you a lot of time. Now similarly, if I go with respect to one more application, that is Google Translate, and I hope everybody uses this. Let's say that I just go ahead and write one language. I'll just say how are you, right? And I probably want to convert this into Arabic, right? Okay, so it looks something like this with this specific language. Suppose if I really want to convert this into Hindi, so then you can basically say that automatically the text is becoming like kya haal hai, right? In Hindi we basically say kya haal hai for how are you. So this is also happening because of NLP. Amazing application. And we use this, and in most of the websites also, right? Let's say in LinkedIn, if somebody's posting in some different language, below only you'll get an option of something called a C translation. So once you click that particular thing, and automatically gets converted to English. Not only that, let's say that I'm just going to go ahead and search for Krish Naik. So Krish Naik is my name. I'm a YouTuber. I'm also a co-founder of Finding.ai. But here, if I probably go and select on images, now here you can see that it is already been able to detect my image, and it is in turn converting the text into images. It is understanding the text, and it is basically thinking, okay, it knows that it's talking about myself, and based on the web, right, it is being able to capture all the images that is available in the web. So this is also an amazing thing. And probably if I go ahead and select videos, here also you'll be able to see all the videos of in my YouTube channel, or probably in all the other public platforms that I have, which is being accessible by web. So this is an also amazing example, text to image, text to video, and a lot of research is also currently going on with respect to different companies. There's an amazing company which is called as Hugging Face, and Hugging Face have actually created an amazing models and solutions for solving question answering. It has basically question answering models, summarization, text classification, translation, like all these particular use cases are there. And you can see that how many different kind of models it has. Like for question answering, right, it has 2,380 models. Summarization has 588 models. For text classification, it has this much models, right? And here you can see that how many companies are basically using this: Google AI, Intel, SpinRage, Microsoft Grammarly, right? All these things are basically using this. And again, this is an amazing application of NLP itself, because all these applications are in short taking the text data only and performing different kind of tasks on top of it. So one more amazing thing that I really want to show you as an application with respect to Alexa and Google Assistant. I have some of the Alexa home configured over here. I can control my ACs and lights. But with respect to Google Assistant, a simple application, I can go and open it. So here I have my Google Assistant. Now here you can see that. Hey Google, do I have any doctor appointments tomorrow?
Sorry, I can't find anything on your calendar that matches that.
So now here you can see that already it is being able to retrieve from my calendar and it is able to see whether I have a doctor appointment or not tomorrow. So this way, it is really, really easy finding all the tasks with respect to most of the critical things, right, that we do in our day-to-day activities. So we use extensively NLP a lot in our day-to-day activities, and this is what we are going to learn in this specific course, how we can build this kind of models, what kind of text processing actually happens. So get a correct idea behind it, how this application also works. Okay, so yes, this was about the second video of mine with respect to natural language processing and machine learning. I will see you all in the next video where we are going to start the syllabus. I will see you all in the next video. Bye-bye, take care. Hello guys, so we are going to continue the discussion with respect to natural language processing. In this video, we are going to cover some of the basic terminologies that is required in NLP. You really need to understand these terminologies because I'm going to repeat these terminologies again and again when we are discussing the other topics. So the topic that is going to get covered in this video is about corpus, documents, vocabulary, words. You really need to know all these topics, what exactly it is, with some basic examples. Now, usually, whenever we get a paragraph is usually called as a corpus. Okay. With respect to documents, whenever you have any kind of sentences, you really need to understand that the sentences are also usually called as documents. What about vocabulary? Vocabulary is nothing but all the unique words that are present in this paragraph. That is basically called as vocabulary. Usually we have a dictionary, right? We usually say that what is the vocabulary in that particular dictionary? All the unique words are the count of all the unique words, or all the unique words that is present in the dictionary. It is called as vocabulary. And with respect to the words, all the words that are present in a corpus, that we will basically define all those things specifically as a specific words itself. So these are the basic terminologies that you really need to understand. As said, in this video, we're going to discuss about something called as tokenization. And tokenization is a very important step whenever we try to solve any kind of use cases with respect to NLP. Now, what exactly is tokenization, right? So let's say that I have a paragraph. I write over here that my name is Krish. My name is Krish, okay? And I have an interest in teaching. I have an interest in teaching machine learning, NLP, and deep learning, and DL. Now, let's say that if I have this specific text, this text I can consider basically as paragraphs. So this will be entirely corpus. Okay. So this is my entire corpus that is available, which is nothing but a paragraph of words, right? So if I probably combine all these words, it becomes a paragraph. Now, tokenization is a process wherein we take either a paragraph or a sentences and we convert this into tokens. Right? Now suppose let's say I want to perform a tokenization on this particular paragraph, and over here from this paragraph the tokens that are usually generated, it will basically be called as sentences or documents. So let's say that I will be applying a tokenization on this, and with respect to this, let's say that I'll try to convert this entire paragraph into sentence. So I may also add one more line over here. Let's say full stop. I'm just writing one more full stop over here. Okay, and I will also write that I am also a YouTuber. Okay. So these are the two sentences that is present in this paragraph. So with respect to this particular tokenization, if I perform a tokenization on this paragraph, it will basically create sentences. My first sentence in this particular case will be, my name is Krish. Okay, and I have interest in teaching ML, NLP, and DL. Okay, so this is basically my document one or sentence one. My next sentence that I'm going to probably write over here, because the full stop is over here, right? So when we convert from a paragraph, when we do tokenization from paragraph into sentence, it will be looking for this kind of characters like full stop or exclamation. I'll show you practically how this can be actually done with the help of Python programming language. So the second sentence that I will probably be having is like, I am also a YouTuber, right? I am also a YouTuber. So again, if you really want to understand what exactly is tokenization is a simple process wherein we are converting where we are converting a paragraph into sentences. Now, there may also be a scenario that let's say that I have some sentences, okay? And on top of this, I can also perform tokenization again. So let's say on top of this, I'm performing a tokenization. Now, this tokenization technique that I'm probably applying will convert the sentences into words, right? So let's say I say over here, it is basically getting converted into words. So each and every word will be a separate word. So my will be a separate word, name will be a separate word, is will be a separate word, Krish will be a separate word, and will be a separate word, I will be a separate word, have interest in teaching. All this will be a separate words itself, right? So this process is also called as tokenization. So in short, words can also be a token, sentences can also be a token, right? This is very important to understand. And why it is required? Because this is a part of text pre-processing. Because each and every word in NLP needs to be converted into a vectors. So we really need to take up each word and try to do this kind of pre-processing. And there are a lot of steps like cleaning and all, which I will also be showing you. But in this video, we are going to try to understand about tokenization. So I hope you've got an idea about corpus, you've got an idea about sentences. Now let's go ahead and understand about vocabulary, which is also called as unique words. Okay. Now let's say I have two sentences. I like to eat apple juice. Sorry. How can we eat apple juice? I like to drink apple juice. Okay. Here I will again continue and I'll write my friend likes mango juice. Okay. Now let's say that this is my entire paragraph. Okay. Now in this paragraph, you know how many sentences are there? There are two sentences because there's a full stop over here, right? So I will just divide this into tokens. So let's say I'm going to perform something called as tokenization over here. Okay. And this will get converted into tokens. And right now, the tokens that is present over here will be sentences, right? So my first sentence will be I like to drink apple juice. So this is my first sentence. And second sentence is nothing but, because there is a full stop, my friend likes mango juice. Mango juice. Now see, when we have the sentences, obviously you can go and count each and every words, right? Let's say how many total number of words are over here. So if I probably go and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So if I again count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So total I have 11 words. But if I try to count the unique words, how many unique words are there? If I make the count again, so I will be one unique word, like another unique word, 1, 2, 3, 4, 5, 6, 7, 8, 9. See, like and likes are two different words. So I'll say 9, 10. But this juice is getting repeated. So the total number of unique words will basically be 10 words, right? Let's say instead of this likes, there was something called as like. At that point of time, the number of unique word will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? I will not count like and juice. Right? But already likes is there, so it will be counted as a separate word. So whenever I get this unique word as 10 words, that basically means in my dictionary, in my complete paragraph, this is my vocabulary. So this is all the possible words that I have. Right? That is the 10 words. Right? Now since I've converted this into like, so I'm just going to make this as 9 words. I hope you're able to understand the basic differences between corpus, documents, vocabulary, and words, right? So this entire thing is super important when you're learning about tokenization. Again, if somebody asks you what is the definition of tokenization, you can just say that tokenization is a process to convert either a paragraph or a sentences into tokens. If I convert a paragraph into tokens, that basically means I'm converting a paragraph into sentences. I can also convert a paragraph into words, right? So if I'm converting into words, single words becomes a token. And if I'm trying to convert a paragraph into sentence, every sentence will be a token, right? So I hope you're able to understand this. Now in my next video, I'll try to show you with the help of NLTK library how you can perform tokenization with the help of Python. So yes, this was it. I will see you all in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to NLP. In our previous video, we have already seen about tokenization, we have understood about basic terminologies like corpus, paragraph, we have understood vocabulary, we have understood about words. Now let's go ahead and do some practical things, how much we'll be learning with respect to theory. So first of all, I'll just go ahead and open my Python free notebook file. So here, first of all, and for this, right, we are going to use libraries like NLTK. Now NLTK is one amazing library. Let me just go through this and let me just show you. NLTK is a leading platform for building Python programs to work with human language data. So if you really want to work with NLP, things like tokenization, converting a sentence into vectors can be easily done with the help of this NLTK libraries. There's also one more library which we basically say it as Spacy. So if I probably search for Spacy NLP, so here you'll be able to see that. Again, these are all completely open source libraries. You can also use Spacy, and I will also be showing you with the help of Spacy how you can perform different things, right? So Spacy is also there, NLTK is also there. One important assignment that I really want to give it to you is that try to find out the differences between NLTK and Spacy, and just let me know probably in the comment section of this particular video or in the upcoming videos. Okay, so this one task I want to really give it to you so that you try and try to understand what is the difference between these two open source libraries. Now to begin with, since we are going to initially start with NLTK, what I'm actually going to do, I'm first of all going to install NLTK. Now here you can directly install it from here, or you can also open the command prompt and directly install NLTK, right? So what you have to do is that just write pip install NLTK. Once you do this, automatically the installation will be done. So what I'm actually going to do, I'm going to basically install from here, and I'm going to show you a tokenization example. So let me write it down, tokenization example. Okay. Perfect. So this is the tokenization example. So here you can see that collecting NLTK requirement already. This is done. The installation has been done. A new release of pip is available. I don't want to update it right now because this pip will almost cover each and everything right now. Right now, this is perfect. Now what I'm actually going to do, I'm going to show you how we can perform tokenization. Like let's say if I have a paragraph, how I can convert it into sentences, and then how I can convert it into words. All those things I'll be discussing, and multiple ways of tokenization also I'll be showing you. Okay. So let me go ahead and let me make few cells so that I can directly go ahead and execute it. Now one thing over here. Yeah. Let's go ahead and let's start. Now over here, first of all, I will try to define my own corpus. Okay. Corpus basically means paragraph. So let's say if I really want to create a multi-line comments, I have to basically use this triple quotes. I will write hello, welcome, comma. Okay, I'm just giving some sentences over here so that you'll be able to understand. Okay, so hello, welcome to Krish Naik's tutorials, or let's say I'll just write iNeurons, right? Or I will write something like this: Krish Nayak NLP, Krish Nayak's NLP's tutorials. Okay, and this is my sentence. Okay, and I can continue with my second line. So I'll write, please do watch the entire course to. I'm just writing exclamation. I'm using different characters over here to become expert in NLP. Okay, so this is what I've actually done. I've basically defined a simple corpus, which is just like a paragraph which has around 2 sentences, and I'm just going to use this particular corpus. So let's go ahead and see this corpus. Now, once I see this corpus here, you can see that even though I'm just printing this, right? I can also print this. See, then the slash n will go. Slash n indicates the new line. Okay, so if I'm probably printing corpus here, you'll be able to see the text how it is basically visible. Now, with respect to tokenization, the first step that I'm actually going to do is that I'm going to convert a sentence into paragraphs. Okay, so I'm going to basically convert a sentence into paragraphs. So for this, how do I convert it? And with the help of NLTK, it is definitely possible. So I will write from NLTK dot tokenize. Okay, and I'm going to just import. Okay, so in NLTK there's a library which is called as tokenize, and if I import the sent underscore tokenize, so what sent underscore tokenize does is that it tries to convert a paragraph into sentences. So this is the function that we are basically going to use, or functionality that is we are going to use, which is present inside NLTK.tokenize. Okay, so you can just say that this is a kind of package inside this, and I will initialize this package in order to convert a sentence into a paragraph into a sentences. So here I'm just going to write send tokenize, and let me just go ahead and give my corpus. So once I give my corpus, here you can see that it is giving us a list of sentence. So yes, you can see over here, this is my sentence over here. Hello, welcome to Krish Nayak's NLP tutorial. So here you can see this is my first sentence, and this is my second sentence, and from exclamation also it has divided it because I'm getting 3, right? So here you can see hello, welcome to Krish Nayak's NLP tutorials, full stop. As soon as it finds full stop, it is just going to make a next sentence. So here, wherever slash n was present, it is using that, and wherever exclamation is also present, it is basically making sure that a new sentence is getting created with respect to that. And that is what send tokenize actually does. If you really want to find out the definition of this, here you can see that you can also provide different languages. What are languages it supports? You can just go ahead and have a look onto that. And if you don't find much documentation out of it, so what you can do over here, you can just go and search for NLTK send tokenize, right? Send tokenize. So you will be able to find out the documentation page directly, and you can refer it from here, right? There are different tokenization. See, send tokenize is there, word tokenize is there, which we are basically going to discuss. Right now, we are going to focus on this. Okay. So in short, it returns the sent tokenized copy of text using NLTK's recommended sentence tokenizer. And the current class it uses this called as punct send tokenizer. So along with the full stop, it is making sure that wherever exclamation is basically coming, it is going to make as another sentence. So this is perfect. We are able to get this, right? Now I will go with the next tokenization. And before that, what I also want is that if I probably save this in a list of sentences, so let's say this sentence is also called as documents, which I've already discussed in my previous class, previous session, right? So if I probably go and see these documents, this is basically my list. You can also check out with the help of type. So type documents, right? And if I probably want to iterate through this, let's say from sent in documents, for sentences, for sentence in documents, I can also print the sentence parallelly, right? So here I can just define it as sentence. So this is my first sentence, second sentence, and third sentence. This is perfect. We were able to do with respect to the sentences. Now let's go ahead and do it with respect to the word tokenize. So next tokenization technique, what I'm actually going to do is that next tokenization is that I can convert a paragraph. I can convert a paragraph into words. I can also convert a sentence into words. Sentence into words. Okay. Perfect. Now for this, what I'm actually going to do, first of all, let's go ahead and see with respect to paragraph. So already you know that with respect to converting a paragraph into words, I'll be using again another library. So I can write from NLTK dot tokenize, from NLTK dot tokenize. Okay, spelling mistake is there. So tokenize. I'm going to import word. Let me just write it down. Word tokenize. Okay. So here we can basically use this word tokenize over here, and let me just execute it over here, and let me go ahead and write word tokenize. And here, if I directly give us my corpus, here you can see that each and every word has been divided. Hello world and hello welcome. Here you can see all characters like comma, full stop has been treated as a separate character altogether, or separate words altogether, right? So here you can definitely clearly see that each and every word has been splitted with respect to this. Only one word that is not having this, right? So if I probably go and see over here, hello, welcome to Krish Nayak's. So this kind of word has not been splitted. This all is being considered as a single word. But if I consider with respect to full stop, with respect to exclamation, with respect to comma, it has been considered as a separate word. So here also you can find it out with respect to this, right? So this is very, very simple with respect to converting a paragraph into words. And why do we do this? Because each and every word will have a different importance, and we really need to perform some pre-processing on top of it. So right now, initially when you get it, you know, which are the important words you have to take it, you have to pre-process, you have to clean it, you know, and that is the reason why we specifically focus on each and every word. Okay. So this was about the word tokenize, and now with respect to sentences also, you know that how you can basically do. Just go over here and just paste it over here for sentences in this. Now here you're printing the sentences, right? Now what you can basically do in that is that after you probably get the sentence, after you get the sentence all together, you can just directly apply word tokenize, right? So here you can basically write word tokenize on sentences. So you will be able to print everything over here, right? So hello, welcome to this. Please do watch the entire course. This is there, right? Perfect. So here we have seen that how we can basically convert a sentence into words, right? Now you can also do one thing over here is that you can use one more library. Let me just talk about one more library. Probably you have seen that. So I'm going to just write word punct tokenize, and in this word punct tokenize, what we are basically going to do is that if I try to apply this, if I try to initialize this word punct tokenize, and if I try to provide my corpus, let's say, so here you just try to find out the difference. And one difference that is clearly seen is that this apostrophe s has also got splitted. Before it was not getting splitted, right? See, apostrophe s was a single word, but now you can see that it has been splitted. So that is the reason why we are using these punctuations. This punctuation is basically making sure that the punctuation will also be treated as a separate word. Perfect. So this is good. There's also one more technique which is basically called as a tree bank word tokenizer. And also again, I'll try to tell you the difference what exactly it is with respect to tree bank word tokenizer. So I'll just try to execute it, and you try to find out the differences with respect to that. Let's see how much you'll be able to do. So I'll write from NLTK dot tokenize import tree bank tokenizer. So I will initialize this tree bank tokenizer. Okay, let's say that I'm initializing this into tokenizer, something like this, something to one variable, and then I can basically use a function which is called as tokenizer dot tokenize. And once I give my corpus, here you'll be able to see that I'm actually able to get it. Okay, now just see over this. What is the difference with respect to this? You will definitely be able to find out some difference when comparing with this specific thing. Okay, so just let me know what is the difference that you are able to see. I know there's a very minute difference. So let me tell you the answer. You can just pause for some time, but you can check it out. But let me tell you an answer. With the help of pre-bank word tokenizer, here you can see that full stop will not be treated as a separate word. It will be included in the previous word itself. Now here you can see that full stop was a separate word. Here also you can see that full stop is a separate word, right? But with respect to the last word, right, full stop will be separate. Because here you can see that, right? If I probably see the sentence, right? After this we have a new line, right? And after this our sentence is getting closed. For the last full stop only, it will be considering as a separate word. But with respect to this particular full stop, it will be considering as a part of this. It will not be considered as a separate word. Only this is the difference with respect to this. And again, it can be handy in some of the use cases, but not in all. But in a generic way, we basically most of the time use word tokenize or send tokenize, right? So yes, this was it with respect to the tokenization example. I hope you like this particular video. Please make sure that you practice. You have to really practice a lot with respect to this. You can take your own example, try out with different sentences. With that, you will be becoming better with this specific algorithm. So yes, I will see you all in the next video. Thank you. Hello guys, so we are going to continue our discussion with respect to natural language processing, and now we are going to move towards some more techniques with respect to text pre-processing. Already in our previous video, we have seen tokenization. We have seen that how we can convert a paragraph into sentences and then probably a paragraph into words, or converting a sentences into words, right? So in short, we have seen that how we can actually do tokenization with the help of NLTK. So in this video, we are going to focus on something called as stemming, which is a very important process altogether. And what exactly is stemming? I'll also provide you the definition. We'll also see a lot of examples with respect to that, and we'll also try to see the different types of stemming. So I've opened a file over here, so here you can see regarding the stemming, and I've also given the definition. Now let's understand what exactly this is with some good examples. Now first of all, we'll see the definition. Over here it shows that stemming, and this definition is taken from the Wikipedia. So stemming is the process of reducing a word to its word stem. Okay, this is super important, guys. To its word stem, that affixes or suffixes or prefixes or to the roots of the word known as lemma. Okay, stemming is important in natural language understanding and natural language processing. Now, what exactly this is? I'll tell you some examples. Let's say I want to just create some cell below. Okay, over here, if I have a lot of text, right? Let's say that I'm trying to solve a sentiment, or I'm just trying to solve a classification problem. And the classification problem is very simple. We basically need to find out whether the comments on the product is a positive review or negative review, right? So when you're solving this kind of problem statement, so in this, what we'll be having in our data set, we'll be having the comments or reviews, I can say. I'll be having reviews, and based on this particular reviews, and this reviews will obviously be some kind of text data, and we need to basically create a model where then we can basically classify whether it is a positive review or negative review. That's very simple. Now, usually in this reviews, let's say that I have some of the words like eating, okay, or it can be eat, right, or it can be like eaten, right? It can be different kind of words, but at the end of the day, it actually represents the same thing regarding eating, right? So this is basically eat. Eat is the root word, or I can also say it is the stem word stem of all the words, right? Because eat is very much common. And having this variety of words for a problem statement will not impact much with respect to finding the output like positive or negative review. Try to understand what I'm actually trying to say. Over here, I may have different kind of words like eating, eat, eaten, or there may be also other words like I can also make a combination of like going, gone, right? Gone, goes, right? At the end of the day, it is basically talking about go, right? So go is a word stem of all these words that are present, right? So it is not necessary that we need to have similar kind of words again and again, because this increases the number of input features in short, because each and every word represents a vector. As we'll see, as we'll go ahead, after text pre-processing, we'll try to convert this text into vectors. So having this similar kind of words, instead of having this similar kind of words, I can just have one word that is just like go, right? And we'll try to solve the problem with respect to that. So stemming is actually helping us to do the same thing. So finding this word stem can be actually done with the help of stemming, and there is also a concept which is called as lemmatization. We'll try to understand the difference as we go ahead. But first of all, let's go ahead and see that how with the help of NLTK we can perform stemming. Okay. So what I'm actually going to do is that I'm just going to take some examples. Let's say that I have all these words. Okay. So I'm just going to remove this, and let's say that I have all these words. Now right now you have words like eating, eats, eaten, writing, writes, programming, programs, history, finally, and finalized. Okay. So I'm just going to execute it, and let me make some more cells. Okay, so I'm just going to delete this cell because I don't require it. Okay, I'll just create a cell below. Okay, and let me press escape, and let us go ahead. Right. So here you can see all these particular words are there. Now let's see how we can find out the word stem of all these particular words with the help of stemming. The first stemming technique that we are probably going to use is something called as Porter stemmer. Okay, Porter stemmer, and there are again different types of stemming techniques which I will probably be showing you, and then we'll be able to understand that what all things it will be able to give us. Okay, now in order to apply this Porter stemmer, it is very much simple. In NLTK, already those functionalities basically present. So I will just write from NLTK dot stem import Porter stemmer. Okay. So once I initialize this, here you can see this. I'm going to use this Porter stemmer, which is just a kind of class. And for this, we have to initialize it. We have to initialize an object for that. So let me just create an object, and this will basically be my stemming. And once I do this, now in the next step, what I'm actually going to do for each and every word, I'm just going to apply the stemming process. Okay. So it's very simple. How do I do it? I will just iterate it. So I'll say for word in words, right? And here I'm just basically going to write print, and let me write it down as word plus. I'll just give some type of marking. This is the word, and the stem part will be nothing but I'll be using the same object stemming dot stem. There's a functionality, there's a function called as stem, which will actually, whenever we push any words inside this, it will do the stemming thing. That basically means for eating, probably it may give you eat. For eats, it may give you eat, right? So something like that. So I'm just going to give my word over here. So once I execute, now here you can see that perfect. Eating is coming as eat, eats comes as eat, eaten is coming as eaten only, writing is coming as write, which is good, writes comes as write, programming comes with program, programs is nothing but program. History, here you can see history is becoming HISTORI. So here it is a major issue, right? Now I'll also talk about the disadvantages. Finally becomes final, finalized becomes final. This is there, right? Now let's say that over here it looks good, right? Probably for eaten, you can see that nothing has happened. It is given the same word. But if you see some words like history, now here you are actually getting history. All right. So the entire meaning of this particular word has actually changed, and this is the major disadvantage of stemming. When stemming is basically applied, for some of the words, you may not get a correct exact meaning. The form of that specific word may change. So this is the major disadvantage with respect to stemming. Let me show you some more examples. Now suppose if I say stemming dot stem, I'm just going to apply this particular stem word on a word called as congratulations. Okay, and if I execute it, here you can see the meaning of the word is basically changing. It should have told like something like congratulate, right? But here you can see congratulate. It is basically changing the form of the word. Now the word does not have any kind of meaning, right? So this is again one major disadvantage of stemming. Okay, similarly, if I probably try to show you something like stemming.stem, and if I probably write something like sitting, so here you'll be able to see. Let me just write it down. Sit. Now see, for sitting, it is giving a very good word. So that basically stemming works for good number of words, but for some words, it does not give us a good answer, right? So this is a major disadvantage of stemming. This all will get fixed with the help of lemmatization. But whenever you have any kind of problem statements like classification problem, review classification, or you really want to see whether an email is a spam or a ham, right? Whether it's a spam or not a spam, we should definitely go ahead with using stemming, you know. And again, some of the words will not come in the right form, but yes, instead of using porter stemmer, we have other different kind of stemmer techniques which we can definitely use to improve it. Okay. Now let me go with respect to the second one. Now with respect to the second one, I'm just going to delete this cell because we don't require it. The second cell is that which is called as the regis stemmer class. Now this regular expression stemmer class, it is nothing but this is a class with the help of which we can easily implement regular expression stemmer algorithm. So we can just provide a regular expression and it will be able to apply the stemming purpose in that. Okay. So it basically takes a single regular expression and remove any prefix or suffix that matches the expression. Perfect. Now what I'll do, I'll just create a cell below, and again I will make some more cells, and I'll try to show you some example. Now first of all, we need to initialize this. So I'll write from nltk.stem import. What is the name? Regex, right? So I'm just going to write regex stemmer. Perfect. Then we basically need to initialize it. So I'll say reg underscore stemmer is equal to regex stemmer, right? So I've initialized it. This is perfect. It's giving us an error saying that regular expression is required. Now this is super important. Now let's go ahead and press shift and tab. Now here you can see the first parameter that goes is something called as regular expression. Okay, and this is some minimum value. We'll try to understand what exactly it is. Now here you can see a stemmer that uses regular expression to identify morphology affixes, right? Understand this morphological affixes. I'll try to show you an example. If you don't know the meaning of this, any substring that matches the regular expression will be removed. So this morphological affixes is basically in short a regular expression which will match whatever words we are basically giving, and if it matches, it will get removed. Okay. Now let's take some example. Okay, over here, and here you can see that this param min is the minimum length of the string to stem. Okay, so if the minimum length is somewhere around 4, then only you'll be able to apply this. So I'm just going to apply the same thing, and I'm going to paste it over here. Okay, so here is my reg stemmer. Now what I'm actually going to do, I'm just going to write reg.stemmer. Now you should understand over here what I've actually given. I have given ing dollar. Okay, here I'm given s dollar, e dollar, able dollar. Okay, so I've given all this regular expression, and this will make completely sense when I'll be implementing it. Now you see, just pause the video and just let me know what is the output that you feel we'll be getting for this. Eating. Now eating, you should see over here, ing is there, a regular expression is there. So but dollar is also there. Okay, this is super important. Dollar is also there. Now, if I try to execute this, I'm able to get something called as eat. Okay. Now, in short, what this is happening is that this is basically saying that whenever on the last word it is ing or it is s or it is e or it is able, just try to remove that. Now, the next example that I really want to give is that let's say I have this particular word ing. Okay. So here you can see ing eating. Right. What do you think the output will be? Whether it will be eat or whether it will be something else? Okay. So here, if I try to execute it, here you'll be seeing ing eat. Why? Because the regular expression says that only in the last with dollar. If I probably remove dollar, if I just execute it, now see everything will get removed. Okay. I just want in the starting, so I'll just use this. So here you can see ing eating. So this will not work. Okay. So we can basically have something like this. And we can basically check how we can actually remove it. So this is perfect. So here you can see wherever ing is there, it is getting removed. Perfect. So this is good. We have done this. Okay, ing eat. Now let's say that I also want to try something else. You can definitely try with different word. You can use this able, e, s, whatever regular expression you can basically write. You can go ahead and write it, and you can check it. Okay, so this is with respect to regular expression stemmer class. Now the next one that we are basically going to discuss, and let's see where this is. Porter stemmer. This. Again, it is written the same thing. I don't want to write the same thing. I'll go ahead with something called as snowball stemmer, and this is also an amazing technique, and this is a better technique when compared to. Okay, so snowball stemmer, I think I've given the definition somewhere here. No. Okay, snowball stemmer is again a stemming technique, but in this snowball stemmer, it performs better than this porter stemmer. Okay, that is the reason why snowball stemmer had actually come. Initially, we came up with porter stemmer. We saw that a lot of words were getting messed up. So that is the reason why we use snowball stemmer, because it gives a better accuracy when compared to the porter stemmer. When I say accuracy, better form of a word. Okay, now for using snowball stemmer, what I'll do, I'll write from scalar.stem import snowball stemmer. So here you can see, I'll just write snowball from scalar. Oh, not from scalar. Sorry, from NLTK. Because it is basically present in the NLTK, right? So from NLTK.stem import snowball stemmer, and I'm just going to import it. Then we're going to initialize with respect to snowball stemmer, and let's see what are the parameters. So here, first of all, snowball stemmer is also provided with different languages like Arabic, okay, Danish, English, Finnish, French, German, Hungarian, Italian. So you can use basically all these words. Okay. So for right now, I'm just going to use English. So what I'm going to do is that I'm in quotes. I'll just say English. Okay, and I'll just use this. And finally, I'll basically use a snowball stemmer over here. I'll just create a variable. Okay, and just execute it. Perfect. Now the next thing is that I will just use another condition. So you can for word in words. Okay, and I'll just write for words in words. So I'll write snowball stemmer dot stem on word. Okay, but I'll print this in a better way so that you'll be able to understand it. So print word plus, and this will be like this, something like this. Just for formatting purpose, I'm writing this so that it'll look good better for you all. And here I'm just going to write the word, right? So same thing what I did in the thing. So here you can see that I'm getting eating as eat, eats as eat, eaten as eat, right? This is all fine, right? For history also it is not being able to give the correct form, right? Then you may be thinking, Krish, then what is the difference, right? But let's see with respect to some porter stemmer, where this porter stemmer will give some bad results or bad form of the word, and where the snowball will give us a better form of the word. So for this, I'm just going to execute this line of code. So here you can see when I'm applying the stemming was for the porter stemmer, right? When I apply stemming.stem on fairly and sportingly. So what is the output that I'm getting? I'm getting fairly and sportingly, right? Li. But if I try to use the same word with respect to snowball, right? Here you'll be able to see. Just let me write a snowball stemmer. Here you will be able to see I am getting some amazing answers. Snowball stemmer. Okay, let me just remove this. I think there is a problem with respect to this. Now it will work. Okay, snowball stemmer, comma. I will just copy this and I'll apply to the same word, something called as sportingly. Okay. So now, if you probably go and see, I'm getting a good output, which is like fair and sport. So altogether, you will be seeing that snowball stemmer, when applied to various other words, performs better than stemming, right? So here, see, auto stemmer is obviously a technique where you'll be able to find out the word stem, but for many of the words, it is not being able to give good answers. Some of the examples are like fairly, sportingly, and all. Now, in order to overcome this disadvantage, snowball stemmer is basically used. And again, guys, understand these are some techniques which will actually help you to find out the word stem. And when it is specifically getting used in text pre-processing, you really need to clean the data. You need to make sure that the data is ready so that we will be able to convert it into vectors in an efficient way, right? So in this part, we are seeing about stemming. And again, one major disadvantage of stemming is that obviously, see, even though snowball stemmer is performing exceptionally well, but some of the words like history, there'll be also something like going, right? So suppose if I probably write this, right, snowball.stem, right? And if I use going, I think going, whether it will give us good or not. So going is performing well. If I write goes, so here you can see for goes also it gives us a bad word, right? Even stemming.stem, if I probably try to see this, right? So in short, how much we try, right? For some of the words, obviously the form of the word is changing. So this is one of the disadvantages with respect to stemming. And understand that for use cases like chatbots and all these techniques cannot be used. So for that, we have to go ahead with something called as lemmatization, because lemmatization solves all this particular problem because it has the dictionary of all the words, all the root words that is basically there. So whatever word you basically give, it will be giving you a good grammatical form of the word. Like if I'm giving goes, it'll be go. If I'm giving fairly, it'll be fair. You know, if I'm giving eating, it'll be eat. So that kind of disadvantage is getting removed completely with the help of lemmatization. And that particular part we'll be seeing in the next video. So I hope you have understood till here. Please make sure that you try, practice with different examples. And yes, this was it from my side. I will see you on the next video. Thank you. Hello guys, so we're going to continue the discussion with respect to natural language processing. In this video, we are going to discuss about lemmatization. In our previous video, we have already seen something called as stemming. We understood that stemming is the process of reducing a word to its word stem, right? And we understood what is the disadvantage of stemming, because for some of the words, right, when we perform stemming, we do not get the correct form of the word, and the entire meaning of the word actually gets changed. And please remember this word, which is called as word stem, right? So in short, this is a kind of algorithm which tries to find out the word stem. But for some of the words, it is working absolutely fine. We have seen different types of stemming techniques like protostemmer, legacy stemmer, snowball stemmer, and we also found out that snowball stemmer was better than protostemmer. So all these things were covered. Today in this video, right now in this video, we're going to discuss about lemmatization, and the lemmatization technique that we are going to use is something called as word net lematizer. I've already told you what is the disadvantage of stemming, because the words that we are getting is not in the correct form. The meaning of the word is basically changing. So in order to prevent that, we use something called as lematizer, and in this we have something called as word net lematizer. Now, what is lematizer? Okay, lemmatization technique is like stemming. The output we will get after lemmatization is called lemma, which is a root word. Understand this, which is a root word. Like suppose if I have eating, then it will become eat is the root word, right? If I probably talk about history, history is the root word, right? If I talk about goes, go is the root word, right? Over here we are getting the stem word, right? In stemming, right? It will probably apply an algorithm, and with respect to that, it will try to find out the stem word, right? Word stem, we basically say this as. But here we get the root exact word. So again, the main aim of lemmatizer is to give you the exact form of the word, which is meaningful, and it does not change the meaning as it was happening in stemming itself. So here you have, rather than the root stem, the output of the stemming. Now again, I'll repeat the definition. Lemmatization technique is like a stemming. The output we will get after lemmatization is called lemma, which is a root word rather than the root stem, the output of stemming. After lemmatization, we'll be getting a valid word that means the same thing. So suppose if there are words like eating, eats, eaten, it will become eat only, right? So it will be giving you a meaningful word which will represent many words over there. Okay. So NLTK provides word-led lemmatizer class, and I'll try to show you with respect to this. And understand, guys, this lemmatization occurs, or it gets performed with the help of this word net corpus reader. So there will be a dictionary kind of words which will be comparing from there, and we'll be able to do the word net lemmatizer very much properly. So first of all, let's go ahead and see that how we can basically implement it. So first of all, I will try to import from NLTK stem, import word net lemmatizer. Okay. So I'm just going to import this, and this word net lemmatizer again helps us to perform lemmatization. So first of all, I'll create an object. So I'll write lemmatizer. And here I'm just going to write wordlet lemmatizer. So here if I see this, it is nothing but wordlet lemmatizer. So let me just go ahead and execute it. So this has got executed perfectly. Now one thing that you really need to see that, okay? So I will just be writing something called as, let's try some easy word, okay? So lemmatizer is equal to, I'm just going to say dot lemmatize. So there's a function which is called as lemmatize, and here I have to give my words. So let's say if I'm giving going, and if I try to see the answer, I'm actually getting going. So that basically means that it is trying to find out the root word with respect to this. But let's go ahead and see the functionality of lematize. In lemmatize, we give two important parameters. One is word, and this is something called as post tag. Okay, I will talk about this post tag. Right now, it is written as n. N basically means this word that I'm actually passing. It is being treated as a noun. So you may be thinking, how many post tags will be there? So let me just write down a comment over here. Okay, so here you have different post tag. For noun, we give it as small n. For verb, we give it as v. For adjective, we give it as a. For adverb, we give it as r. Now, what I'm actually going to do by default right now, the post tag is n. Right. So with respect to n, I'm getting this output. Okay, let's say I change it to v, because I just want to show you whether this will be changed or not. Now, when I give post tag as n, I'm just saying that consider going as a noun keyword, but going is not a noun keyword, right? But if I consider with respect to verb, now you see with respect to verb, I'm able to get a good lemmatization that is like go. Okay, similarly, if I probably try to see with respect to a adjective, so here you can see I'm getting going, right? And obviously this going is a kind of verb, right? It's not an adjective. And let's say if I try to go with respect to adverb, here also I'm getting going, right? Now with respect to this going word, right, I feel verb is the correct one which we really need to select it. Now let me do one thing. All the words that I had copied over here, right? Let's apply this entire lemmatization on this entire words. Okay, so I'm just going to execute this and execute it. And again, I'm just going to write this for loop. Okay, and I'm just going to copy this. Instead of writing stemming.stem, I'm just going to write lemmatizer dot lemmatize. Okay, and I'm just going to apply for these words. Now see this: eating is becoming eating, eats becomes eat, eaten, eaten, writing, writing, writes, write, programming, programs, programs has become program. Because again, by default in this lemmatize, remember that I've given my post tag as n, right? We are considering that all these words are basically noun. Okay, so programming, programs, history, finally. So here you'll be seeing that lemmatization has not occurred that much. We're not done any kind of, we're not able to find out because it is being considered as noun. And in noun, whenever we give noun, suppose let's say that all my words has names, and in names, obviously those lemmatization does not occur, right? So if I have like Krishna, if I have Sudhanshu Kumar, if I have this kind of words, which is name, right? In short, this is nouns, right? We have some famous place name like Taj Mahal, India, places name and all, right? So this all will be considered as nouns, right? So that basic difference you really need to know in order to understand. understand this. Let's say that I want to again convert this into adjective. So here you can see eating has become eats, eats, eat, writing, everything is same, right? But now let me try with respect to verb, because most of these words are basically verbs itself, right? So here you can see eating has become eat, eats has become eat, writing, write, programming, program, this history. Now you can see this, right? History is becoming as history only. In stemming, we should get something like history, right? So this is quite amazing, right? Finally, and this all. And we could also see that in stemming, right? We also have some of the words which are not actually being able to perform well, right? Like fairly and sportingly and all, right? And even goes, right? So suppose if I probably go ahead and write something like lematizer dot lematize, and let's say I'm going to write something like goes, right? So I'm going to get go, which is good, right? And here I can also play with post tag, right? So let's say if I'm using a v post tag, and I'm going to get go. Let me go and try with this. So here I'm just going to write lematizer, okay? And I'm just going to say try to do with this fairly. Let's see what kind of output we are getting. Now this lematizer is super amazing, right? Because it is giving you the good word form, and the meaning of the word is also maintained, right? So here you can see fairly sportingly. Now let me write a post tag, obviously because it was noun, so it may not give you something. So here also with respect to verb also I'm getting the same answer, which is good, right? So this is just to tell you that how good lemmatization is. But one question that I really wanted to ask you, which will take more time, word-led lemmatizer or stemming? The answer is simple, word-led lemmatizer. Why? Because you can see NLTK provides word-led lemmatizer class with a thin wrapper around the word-net corpus. So it is going to compare from there, right? It uses modify function to the word-net corpus reader class to find a lemma. So this will basically take time. Right now I just have some number of words, so it is happening very fast. But if you have a paragraph, if you have a bigger sentence, lemmatization is going to take time, right? So this is the basic difference between stemming and lemmatization. For which use cases you can use this? One simple use case is if I really want to write Q&A, chatbots, right? Chatbots. All this is an amazing examples for all this, right? You can basically use this, right? So let me write it down. Q&A, chatbots, right? Text summarization, right? Q&A. These are some of the examples you can basically consider. Text summarization is also one example, and many companies it is being used. So, right? So you can use basically all these things, and you can basically implement the word lemmatizer over them, because you get the exact good form of the word, that is the root form of the word, which is meaningful, right? So I hope you were able to understand about lemmatization. You were able to find out the differences between stemming and lemmatization. This was it, and I will see you all in the next video. Thank you. Hello guys, so we'll be continuing the discussion with respect to natural language processing. We are still in text pre-processing techniques. We have seen tokenization, we have seen stemming, we have also seen its different types. Along with that, we have seen lemmatization. Now we're going to consider a topic which is called as stopwords. So in this video, I'm going to discuss about stopwords, the importance of stopwords, and again, I'll show you with the help of NLTK. Now, text processing is a very important step in natural language processing, because you really need to clean the data, you need to make the data in the right format. Later on, we'll try to convert all this text data into vectors, and then only we'll be able to train the model. Because model, whenever we say any machine learning model, internally we really need to train with some mathematical equations. So whenever we train something with mathematical equations, there we really need to give the input data in the form of numerical or floating values. So let's go ahead and let's just understand what exactly stopwords is. So I've opened a new notebook file over here. So here I have one amazing speech from Dr. APJ Abdul Kalam. He was the former president of India, and it was an amazing speech. You can probably read out completely over here, and obviously it is given in the materials. Now, what I'm actually going to do is that I'm going to probably talk about stopwords and why it is important that we should try to remove the stopwords. Okay, and just for a definition, what exactly is stopwords? Now, here in this particular speech, you can see that there are a lot of sentences like "I have 3 visions for India. In 3,000 years of our history, people from all over the world have come and invaded us." So this is the entire speech. It is an amazing speech. If you're probably learning it, I would like to just tell you that please read this. You'll be getting a lot of information out of it. Very motivational speech altogether. Now, from this particular speech, you can see that, and I can definitely say this as paragraph or corpus, right? Now, here there are some words like I, the, have, and let's say of, the, to, there, why, right? All these kind of words, right? It will not play a very big role when we are doing tasks like spam classification, or let's say if you're trying to do some kind of task with respect to, like spam or ham classification. I've already told about that. And along with that, to just see that whether this is a positive review or negative review. But some of the words like not can actually play a very important role, not and all. So what we do is that with the help of stopwords, we try to remove this particular words, because with this kind of use cases, where you're specifically focusing on some of the important words to determine the output, these all words like I, the, he, she, of, there is not at all required. So what we can do is that we can basically pass this entire paragraph to that particular stopwords and see that what all words can be basically removed. Okay, and that is the importance of stopwords in short. So let us go ahead. Right now, I'll just go ahead and execute it. Let me make some cells so that it'll be very much easy for you all to understand. And how we can apply stopwords. Along with stopwords, you can also apply stemming. So I'll show you both the combination, which will be super important for everyone. Okay, so let's go ahead and let's try to do that. Okay, now, first of all, I really need to import for stemming. You obviously know what we need to import. So for stemming, I'll write for nltk.stem import porter stemmer. So I can basically write porter stemmer over here, and I'll execute it. Along with this, I obviously need to also import stopwords, because stopwords for English will be different, because you'll be having that entire list of words like the, he, she, and all, right? So what I'm going to do is that I'm going to say that from nltk dot corpus import stopwords. So from this, I will be able to use the stopwords itself. So now I have imported from nltk.corpus import stopwords. Now this stopwords, I have to also download it. So for that, let me do one thing. I'll also import nltk, and I will execute it. And along with that, I'll write nltk.download. And here in this parameter, I'm going to give about the stopwords and the different language stopwords also. And we'll also try to see that. So if I probably write this, here you'll be able to see that downloading package stopwords to this particular location. So the package stopwords is already up to date, and I'm getting 2. So in short, I've downloaded all the different languages stopwords, which is already present in the nltk library. Perfect. Now we have done that. Now let's see that what are the stopwords that are available in English. So in order to do that, I've already imported from nltk.corpus import stopwords. I'll take the stopwords, I'll copy and paste it over here, and I will say .download. Okay, or instead of download, I'll just write .words, and here I just need to give my language, like what language I really want to give it for, like English or something else like German and all. So I'm just going to write this. Let me just write English, and if I execute this, here now you can see the list of all the stopwords that you obviously have, and all the stopwords can actually be removed. Right now you may be thinking, Krish, this may depend on data to data, right? Now here you can see that, guys, this is a list. You can also create your own stopwords in English. Like let's say over here, some of the important words are like aren't, couldn't, right? These all words can actually play a very important role to find out whether a statement is positive or negative. Like not is also there. If you probably search for it, not, you'll also be able to find it not. Okay, so it is always a good way that you create your own stopwords and try to remove all those kind of words from the paragraph. So I hope everybody's able to understand. Now with respect to English, you have this. Now let's see whether we have with respect to different languages. And obviously you can go ahead and check the documentation, but I'll just try to show you with respect to German. So in German also you have the specific stopwords. Along with this, you can also use French. You have this particular stopwords. So with respect to different text or different language of text, you can definitely apply different stopwords with respect to that. Now you may be thinking, is there Hindi or Arabic or some other? I think for Arabic also I think it is there. Let's see whether it is there or not. Yes, for Arabic also it is there, but I did not find it for Hindi, I guess. So again, from the documentation you can check it out. But till Arabic I was able to see it. Again, all the information will be given in the analytic documentation. Now, what I'm actually going to do is that my sentence is already English, right? And I'm going to perform two important tasks. One is I will apply stemming, and before applying stemming, what I'm actually going to do, wherever I find out the stop words, I'm just going to remove the stop words from this particular paragraph so that this entire paragraph will be shortened up, right? So for that, what I'm actually going to do now, see whatever things you have learned from starting, everything I'm actually going to cover up. Okay. So first thing first, I'm just going to say from NLTK dot stem, I'm going to import Porter stemmer, and I'll just execute. I'm just going to execute this, okay? And then what I'm actually going to do is that I'm just going to write stemmer is equal to Porter stemmer. This we really need to initialize it. Now, when we do this task, right? Now, the next step, what I'm actually going to do is that I'm going to perform the tokenization on the entire paragraph. So for that, I can use NLTK dot send tokenize, and here I'm just going to give my paragraph. Now, see this, guys. Here I'm going to get my entire paragraph, entire sentences. Like, see, I have 3 visions for India. That in 3,000 years, this all things I'm able to get, and this is my second sentence, third sentence, fourth sentence. Like this, all the sentences in the form of list I'm able to get just by using send underscore tokenize, right? This is a tokenization process wherein we take a paragraph, divide that into sentences. Okay. Now, let me do one thing is that I'm just going to save this in a variable which is called as sentences, which will later become a list, right? So this is my sentences, and if you probably see the type of sentences, I'm just going to basically see this. It is a list. Now, perfect. Till here, we have done it amazingly well. Right? We have done Porter stemmer on that. Sorry, we have initialized stemmer over here, and we have tokenized it. Now, understand. What we are going to do is that I'm going to traverse through all the sentences. First of all, apply stop words, which all words are not present in the stop words. We are only going to take that and apply stemming. This is what we really want to do. So here, I'm just saying that first of all, apply stop words and filter, and then apply tokenization. Right? Sorry, then apply stemming. So this is the step that I'm actually going to do. Now, see this very simple, very important. So I'll write a for loop saying that for I in range, and here I'm going to basically give the length of the sentences. I can also go with respect to sentences, but there I'll not be getting the indexes. Here I'll be getting the indexes. Okay, so range basically says that whatever length I'm actually giving, that becomes an index, right? 0 to that specific length. Now, what I'm actually going to take, I'm going to take the specific I, and I'm going to write NLTK dot word tokenize, because I'm getting in the form of sentences. I need to get each and every word, right? So I'm getting the word over here, and inside word underscore tokenize, I'll give sentence of I, because this will be an index. Sentences of I. So this will be an index, and here I'll be able to get the word. So here, what I'll do, I'll make a list of words. So in short, I'll be getting the list of words inside the sentences. Perfect. Now till here we have done it. Now after this, we're going to apply one very important thing. That is, first of all, I need to apply stop words for each and every word and see whether it falls in the stop word or not. If it does not fall in the stop word, then only I have to do the stemming. So understand the task step by step. This is super important with respect to all the steps that I'm actually taking up. Okay. So here I will write in list comprehension. I will say stemmer dot stem. Okay. And here I'm going to write dot word. Okay, of the word, because from this particular words, this words is a list of words, and I take each and every word. So here I will write a for loop. Okay. And this is called as list comprehension. So I write for word in words if word not in. See, if the word is not present in the stop words, then only you apply stemming. That is what I'm actually trying to do. Okay, so here you can basically see if the word is not in, I'll use a set. Along with that, I will download all the stop words with respect to English, right? So why I'm using set? Because some of the words may get repeated, so I don't want that. So I'm going to basically write it over here, right? Now through this, what I'm actually going to do, I'll get that specific word that is not present in the stop words, and only stemming will be getting applied to that specific word. Perfect. Now here, what I'm actually going to do is that I'm going to save it in a variable called as words. Perfect. I hope it is very much clear. I'm getting back everything after doing the stemming back in the words itself. And then finally, what I'm actually going to do is that I'm going to take the sentences and I'm going to replace it on the same index with respect to this words. But once we get this words, right, I need to join all these words together. So how do I join? There will obviously be a space dot. I'll just use dot join so that it will join together and it will convert that into sentences. So this exactly is converting all the words into sentences, right? This is very much simple, and we have actually done this. Perfect. So here, what are things we have done? Again, let me repeat. I'm iterating through each and every sentence, and then I'm doing a word tokenize. That basically means from every sentence I'm getting a list of words, and from that list of words I'm iterating. I'm seeing that whether it is present in the stop words. If it is not present, I'm doing the stemming. After stemming, I'm again going back in that same list, and then I'm converting all these words into sentences. I can say converting all the list of words into sentences. Perfect. Now once I execute it, and now if I go and see my sentences, here you'll be able to see now I3 vision India, right? In 3,000 year history, right? So here HISTORY became RI. Okay, people, it became people. World came, invaded us, invaded, became capture, land, conquer, mind, form. You can see all the special words like I, have, everything is gone. See this? I is there, have is gone, right? The, you'll not be able to find out the anywhere, right? So whatever stop words were present over here, that all got removed, and then only we performed the stemming, right? Now you may be saying, Krish, the stemming does not look very good, right? So for that, what you need to do, I've already taught you with respect to snowball stemmer. So I will just import this, okay? And it is very simple. I think you can do the same task again. So snowball stemmer, and then I will try to import this with respect to English. And obviously after this, you'll be able to get a good sentence, right? So let me just remove this one. So snowball stemmer, I've already done it, and I'm going to copy the same thing, okay? And here, I'm just going to say apply snowball stemming, right? And then instead of stemmer, I will just write this word, that is snowball stemmer. That's it. Yeah. And now once I execute it, let me go back to the sentences, because the sentences have got changed now. So where is the sentences? Let's see. Okay, this is the sentences. I've got executed now. Now I'm just going to execute this. Now if I probably go and see my sentences, here you can see that now it is got, right? Now one more important thing that Snowball has done. See over here, I still have capital letters, right? Like there may be some of the sentences which may be in small letter it also. So that becomes a repeated word. But since this is a capital letter, it will be considered as a separate word, right? For the model to understand, right? So what it does is that Snowball, one more advantage is that it is making sure that all the letters becoming small, right? So all the letters becoming small, and for some of the words, it is not even giving a good result. Like poverty has become poverty. But if you try to do this with the help of lemmatization, you can also get a good word. Now let's try it with the help of lemmatization. So I'm just going to do the same thing. Okay, I hope everybody is understood with respect to Snowball stemmer. Now what I'm going to do is that again going to go back to my lemmatization code. So I'm just going to import this NLTK.stem, and it is very simple, guys. I think we are just repeating things so that you also practice in a better way. Okay, so here I've got the word net lematizer. I'm going to initialize it. Perfect. This is done. Now I'm going to go ahead and copy the same code, right? And I will just write it over here. And instead of writing snowball, I'm just going to copy this. I'm going to paste it over here. Perfect. So I've done it, but let me just go ahead and execute the sentence part again, because I need to get the updated sentence. So I think it is somewhere here, paragraph. Okay, and here is the sentence. Okay, perfect. Now let me just go ahead and execute the same thing. And now if you I'm getting it has no stem. Okay, sorry, it should be lematize. Okay, so lematizer.lematize. Now you see some time it took, right? Because it is basically checking from the entire corpus. Now if I probably go and see the sentences, now you have all amazing things with respect to words that are coming up correctly, and all the things are here, right? So with respect to this, you are able to get some good thing. Now one more thing you can do is that after this word, you can also put the post tag. Now if you put the post tag to v, right? Now you see what will be the output. You'll get a better output, I guess. because most of the words it will be basically considering as as an adverb. Oh, sorry, as a verb. So, but anyhow, we will try to understand about post tag again, more moral things, right? So, I3 visions India in 3,000 years history. People come, world come invade us, capture land. So, all the stop words has got deleted. Now we are getting a very good one, at least better than stemming. Okay, and the other one that is snowball stemming, right? So, this was the entire process with respect to text pre-processing, and here we have discussed with stop words and how you should also go ahead and do the text pre-processing. I hope everybody got that idea. Now, in lemmatization also, you can see that it is not lowering it. So, what you can actually do is that you can basically lower all the sentences, right? So, let's say if you write sentences of I is equal to sentences dot of I dot to lower, right? So you can basically give to lower. Let's see whether it will work or not. And let's see whether it will completely work or not. And I'm not sure whether dot to lower will work with respect to list, but I think it should work. I'm just going to execute this again. Go down. Okay, and apply this lemmatizer. Okay, str object has no attribute to lower. Okay, so it's okay, not a problem. What I'm actually going to do, I'm just going to comment this, and before writing here, I'll just say word to lower. Okay, you have to definitely try different things. Okay, and it's all about Google. Just Google it, you'll be able to get it. So again, I'm going to execute this, and now I think it'll execute. I know I'm doing a lot of up and downs, but just try to follow the lecture. String object has no attribute to lower. Why? To underscore lower is there. To lower. Okay, let me just see. str to lower case, right? Python. Let me just see this. It's okay if I don't have any other way to see it, but I think dot lower will definitely work. Let's see. Dot lower. Okay, perfect. It has worked now. Now if I go and see the sentences, it is done. Okay, so I don't have any regrets to search in the Google. You should also do the search in the Google. Now here you can see all the small letters are there along with the lemmatization. So this is the entire text pre-processing. We can also apply some regular expression before this so that we can do the cleaning of the sentence. So I'll remove this word, and I think this will also work if I probably just comment this out with two lower, just lower. Okay, just check it out. It's up to you. So I'll just comment this so that you can try it out. Okay, but in short, we have understood what stop words can actually do and how we can basically apply things. Okay, so yes, this was it from my side. I think you are liking this entire series. We will be learning more things as we go ahead. We have post tags and all. We have entity name recognitions also. Many things are there which is going to come. So yes, keep on learning, keep on practicing. I will see you in the next video. Thank you. Hello guys. So we are going to continue the discussion with respect to NLP, and in this video we are going to discuss about something called as parts of speech tagging. Now I hope you have understood in lemmatization this parts of speech tagging, it plays a very important role, because if we are giving it as a verb or a noun, right, based on that, we are able to get the root form of the specific word, right? And let's see a lot of examples with respect to this. In this video, we'll try to understand that how many different types of parts of speech tagging is there, and with respect to that, we'll also see a practical example. Let's say that if I am actually getting a sentence like this, Taj Mahal is a beautiful monument. How, with the help of NLTK, we are able to understand that, and you'll be seeing that the output of this. Let's say I'm just taking this particular example. The output for this will be that Taj Mahal will be considered as a noun, beautiful may be considered as an adjective, monument can be considered as a verb, right? I'm just giving as an example, but we'll definitely see this particular example, and we'll also see some extensive example altogether. Now, with respect to parts of speech, how many different types of things are there, right? So here you have something called as CC, coordinating conjunction, CD, cardinal digit, DT, determiner, EX, existential there, FW, foreign word, IN, preposition, JJ, adjective, JJR, adjective. So that basically means, suppose if I'm giving a sentence, automatically it will be able to categorize in all the specific different parts of speech automatically with the help of NLTK. And similarly, there are a lot of things over here. You can say personal pronoun, like for the letters like he, she will be put up as PRP, right? It'll be getting a tag called as PRP. If you see over here, small example like RB, adverb, right? Words like very, silently will be put up over here. RBR, it is also adverb, but it will be like a comparative one, right? So example like better. So you have RBS adverb. Like this, you have a lot, right? So what I'm actually going to do is that I'm going to take a very good example, and one assignment you just have to do is that take this particular simple example and try to find out and try to write down the comment in the comment section. Okay. Now over here you'll be able to see that I have this particular speech of Dr. APJ Abdul Kalam, and obviously the same example I've shown you in the stop words example itself, right? So I'm going to take this, very simple, okay? And then let's consider that in this parts of speech tagging, I really wanted to perform stemming, let's say. But I don't want to perform any stemming because I want to see for each and every word, right, what kind of post speech tagging will be there. So no need to import all these things, okay? So I'm just going to remove all these things. Instead, I'll just be focusing on importing NLTK. So I'll write import NLTK. And then here you can see that I'm just writing NLTK.send underscore tokenize. So that basically means I'm actually converting the paragraph into sentences. So let me just execute this. And once I get it, here you'll be able to see all the sentences. So in this example, I'm trying to show you that how for each and every word we'll be able to find out the post tag, okay? So the next thing is that now what I'm actually going to do is that apply the stop words, okay? I don't need to apply the stop words also because we don't want to remove anything. So I'm just going to uncomment all these things, and I'm going to say that we will find out the post tag, okay? Find out the post tag, right? So this is perfect. Till here we're going good, right? Now what I'm actually doing over here is very much clear, very much easy to understand that over here we are able to do that. Like I'm just simply putting a for loop over here with respect to all the sentences, and this sentences here, what I'm doing is that I'm just trying to convert this into words. I'll be getting a list of words, and now no need to do the stemming, so I'll just remove the stemming, okay? And over here I'll just add this word itself. I'll be getting the word, and I'm just saying that if the word is not in, set stop words dot words of English. So let's see that. Okay, I told you that I'll not apply stop words, but let's just remove the stop word because some of the stop words will not be playing an important role. So in order to do that, I'll just import all the libraries with respect to stop word. And obviously over here I had already written that, but let me do Control Z. So here it is stop words with respect to this, and I will also remove this. Okay, so two things, and I will just import the stop words. So I'm writing that from NLTK.cut to import stop words, and now let's apply for this same thing. Whatever we have done in the previous time, the same part we are actually repeating it. So here you can see that for word in words, if word not in this particular stop word with respect to English, I'm going to take all the words, and then I'm just going to comment down this code because I'm not going to join them back into the sentences because I really need to understand what post tag each word will be getting. So I will basically write print. Okay, so here I'm just going to write a simple print statement, and in this particular print statement, before printing this also, what I can do, I can write basically this in the next line. Here I'll be using something called as NLTK.post tag. Okay, so here you'll be able to see post tag. I can also apply it for words, and I can also apply it for sentences. Right now, I'm just going to apply this for the words itself. So this is my entire thing, and here I'll just create a POS underscore tag variable. So this will basically indicate that everything is getting stored over here. And with respect to that, I'm just going to print this. Now, let me revise it again, what all things we did. I'm iterating through each and every sentence, and then I'm converting this particular sentence into words. And for each words, I'm applying stop words. Initially, I thought that I'll not apply, but let's apply the stop words because, see, at the end of the day, they are so small words, like isn't, the, he, she. I don't want this particular words, right? So I'll remove the stop words, and I'll take all the list of words over here. I did not apply stemming because I really need to find out whatever words are present over here. It needs to be, like this NLTK will be able to find out all the different types of parts of speech tagging with respect to that. And then I just apply this particular simple code, that is NLTK.post underscore tag of words, and then finally I'm printing it. So here you can see, I'll just execute it. I'm getting some error. I'm not going to make sure that nothing, I'm not going to, like, if there's an error, I'm not going to edit the video. So here it says NLTK.download average perceptron trigger tagger. So I definitely require this particular tagger to apply post tag. So what I will do is that I'll just go and copy and paste this. You also have to do this because you'll also face this particular error. Now here you can see that it has been downloaded. Now if I probably go ahead and run it, now here you'll be seeing for the first sentence I is basically a PRP. PRP basically means what? So if you probably go over here and see personal pronoun, and I have given the examples like I, he, she, right? Similarly, you'll be able to see the other words like 3 CD, vision, NNS, India, NNP. Let's go ahead and see what is NNP because India has been categorized with NNP. So NNP is nothing but proper noun, singular. It's like a name, place. It can be monuments. It can be different things. Like NNP, S is proper noun, plural, Americans, Indians, like that, right? So all those things are there. And how easily it is being able to simply, just show the post tags, right, with the help of NLTK. This is an amazing thing. And here with respect to all the sentences, you'll be able to see this. Okay, and that is how powerful NLTK is. Let me just show you whatever assignment that I had actually given you, right? So this was a sentence over here. I'm just going to copy this, and I'm just going to take this entirely. Okay, and let's see whether we'll be able to do it. So I'm just going to use NLTK dot post tag sense. Now let's see with respect to sense also if you're able to do this or not. So I'm just going to put this Taj Mahal is a beautiful monument, and I'm going to execute this. Now here you can see T. Okay, now in this particular case, what has happened? Each and every word has been considered over here, right? This should not basically happen. So what I'm actually going to do is that I'm going to basically use post tag. Let's see what is the output with respect to this. So here also the same thing is coming. So the simple way in this particular scenario is that again I'll put a for loop for I in. Okay, I'll say sentence or I in this entire quotes. I'll just put this. I'll go through each and every word over here. Okay, and I can write dot split with respect to this because if I'm just using this dot split, this is my string. Okay. And if I probably use dot split, you'll be able to see that what I'm getting. Taj Mahal is a beautiful monument, right? So for I in this, and here you can see that I'm iterating through each and every thing, right? Each and every word. So I'm just going to print NLTK dot post tag, and I am actually going to use this. So here you can just go ahead and write this specific I, or instead of writing this I, I'll just write words. Okay, for a word in this NLTK dot post tag, I'm just going to use the specific word. Now here, still there's an issue because I am iterating through each and everything. So if I probably get this entire thing with respect to the list, you'll be able to see. Okay, let's see. There's something. Again, I'm not going to delete it. I'm just going to see what is the word over here. So I'm getting this. Okay, and if I take this NLTK dot post tag with respect to this specific word. Okay, this is the problem. Let's see, what did I do over here? I need to provide a list of words. Okay, and then I'll be applying this. Okay, this is the problem. Okay, now all you have to do is that I don't have to give word by word. If it's giving word by word, here you will be able to see for every single character it is giving this, right? I really need to provide a list of words. So if I probably just copy this part and put it over here and remove all these things, now what I've actually done after this error, see, I'm not editing this particular video with respect to this error because you really need to see all these errors. In short, when I give like this, I'll be getting a list of words. So if I execute this here, now you can see that Taj, it is showing NNP, Mahal NNP, is VBZ, ADT, beautiful, JJ, monument NN. Now see, what did I do over here? Post tag basically, whatever parameter we give, we should be giving in the form of list of words. And if you're able to do that, we'll be getting the same answer, right? So guys, I hope you were able to understand parts of speech tagging. I definitely got some errors, but I really wanted to show you all the errors that we're getting. And based on that, how you can solve this, right? That is the main purpose. So the error part, I'm not going to edit it. I'm going to keep it like that. So please make sure that you practice. And yes, this was it. I'll see you all in the next video. Thank you. Hello guys, so we're going to continue the discussion with respect to natural language processing, and in this video we're going to discuss about name entity recognition. This is an amazing topic, so let me open a file over here. So here you can see that. Let's say that we have a lot of sentences, right? Like one example of this particular sentence is over here. The Eiffel Tower was built from 1887 to 1889 by French engineer Gustave Eiffel, whose company specialized in building metal frameworks and structures, right? Now this is a sentence. Now from this particular sentence, we know that what is parts of speech tagging, right? Which is noun, pronoun, and all. But along with that, with the help of NLTK, we will also be able to get something called as name entity tags, right? Now what are some of the examples of name entity tags? So here you can see one of the tags is something called as person. The second tag can be location or place. Third tag can be date, time, right? And here also I've given some examples. So if I probably say Eiffel Tower, it may be coming as a place. It can come as a location, right? Over here you can see that, okay, Gustave Eiffel, this will basically be getting tagged as a name itself, right? Here suppose if this numbers are actually there, it can be something else, right? Suppose if you're giving some money value like $1 million, so let's say this $1 million is present somewhere here, right? And that will be basically tagged as something called as money, right? So it will be given some kind of name entity tags, right? So let's see some examples and let us see that how this name entity recognition will be given with the help of NLTK library. To begin with, what I'm actually going to do, I'm going to take this particular sentence, I'm going to go just execute it over here, okay? And again, we'll be going like how we did in the past videos itself. So let me do one thing over here. Let me create some more cells, okay? Now the first thing, I'll just go ahead and import NLTK. And as you know that with respect to NLTK, also I can use something called as word tokenize. Word tokenize, word underscore tokenize, and here I'm just going to give all the complete sentence itself. So here let's go ahead and give the sentence over here, and once I execute it, here you'll be able to see that the Eiffel Tower was, everything is coming over here. So this is my entire words, the list of words, right? So this is my entire list of words. Now perfect. Now see this. Usually for doing the parts of speech tagging, what do we do? We basically write NLTK dot post underscore tag, and I basically give this entire words to this, and based on this, each and every word will be assigned to some tags. Okay, so let me just write this as my tag elements or tag something. I'm just giving a variable name, which is like tag elements, and this will get stored over here. Okay, now see this. If I really want to provide some name entity recognition, all I have to do is that use this NLTK dot name entity. So there is something called as NE. Okay, so let me just show you NE any chunk. Okay, so any chunk is a function over here. And if I probably see the definition of this particular thing, function, you'll be seeing use NLTK currently recommended name entity chunker to chunk the given list to or given list of tag tokens. Okay, and inside this, I will just pass my all my tag elements. Okay, so this will be my tag elements. I'm just going to give this. Probably we may get an error. The reason is that because we need to download this one, right? So here you can see that NLTK dot download maxnet any chunker, because here we are specifically using some chunker techniques to basically get the named entity, and for that we really need to download it, and that is what is the first requirement. So here you can see that I'm downloading it, and once this downloaded gets once this entire this max and any chunker gets downloaded, we are going to run the specific code. So this may take some amount of time because this may also be a huge it can be a huge library inside it which will need to be downloaded. So now I will just go ahead and execute it. Still I'm getting some error. It also says that okay, you need to download NLTK.download words. Perfect. So what I'm actually going to do, go and make one more cell, and please don't worry whenever you get some errors. I've seen some people who gets worried. First of all, just go ahead and see the error, what exactly it is. It's very much simple, and you just need to execute it. So guys, now once this NLTK.download of words gets downloaded, now all I have to do is that over here you'll be seeing that NLTK.any underscore chunk. I have to give the tag elements, and then I just need to write dot draw. Once I execute this, here you'll be able to see this. What an amazing graph I'm able to get. Now see this. Everybody observe this. I don't know whether you're able to see this properly or not, but just clearly if you will be able to see it, it has given most of the information very much clearly. So here it is very much clear that you this entire sentence, right? The organization is recognized for FL and tower, right? Which is a noun, right? Over here you can see this word was is a VBD, built it is over here. 1887 is something like CD, and here you can see GPE, right? French JJ, right? It is being able to determine as JJ. Here you can see person information is being able to get captured, which is like Gustav NP. So here you can clearly see all this information very nicely, right? So with whichever entity is being able to get recognized, here you'll be able to find that. So person is there, GPE is there, and organization is there. That is what we will be able to find out. This S is the entire sentence over here, but with this graph you'll be able to understand that you're able to get the entire information. So like this, if you probably go and see that what all other entities you can find: person, place, location, date, time, money, and all. So I hope you were able to understand about name entity recognition and how you'll be able to see this and how you'll be able to see the diagrams. So yes, this was it with respect to this particular video, but understand that NLTK provides this amazing feature. You should definitely use it where it is required, right? So this was it from my side for this particular video. I'll see you in the next video. Hello guys. So we're going to continue the discussion with respect to NLP. In our previous videos, we have discussed many topics till now, like stemming, lemmatization, we have seen stop words, we have also done with the help of NLTK and Python. Now let's just go ahead and revise once more. Okay, I'm not revising each and every topic, but if you really want to solve a specific problem statement, so let's consider that over here we have a problem statement called a sentiment analysis. Now in order to solve the sentiment analysis, what all things basically we do and how these topics we have learned till now, where does it fit in the life cycle of an NLP project? Now let's say that this is my text and this is my output, okay? And when I write D1, D2, D3, D4, these are basically documents 1, document 2, or it can also be called a sentence 1, sentence 2, sentence 3, sentence 4. If I combine all these particular sentences, it becomes something called as corpus, right? And if I probably say corpus, another meaning can be paragraph also, right? And over here we'll be also able to see different words. We'll also be able to see unique number of words, which is called as vocabulary. Perfect. Now initially, whenever you are given a problem statement that is with respect to NLP, you definitely will be having a data set. So let me just create a small block diagram over here. So let's say this is a problem statement I really want to solve, that is called as sentiment analysis, just for an example. So initially, what I will be having, I'll be having a specific data set. Now with respect to this particular data set, the first step that I will definitely do is something called as text preprocessing, right? So over here you'll be able to see something called as text preprocessing. So let's say this is my text preprocessing, okay? And I would like to give this as part one, because here, specifically, if I talk with respect to this particular text preprocessing techniques, usually, right, what all things we have learned till now. So first topic is nothing but something called as tokenization, right? And tokenization is a process where we convert a paragraph into sentences or sentences into words and many more things. The second simple thing that we basically do is something called as lowering the use case, right? Lowering the case of the words, right? Now when I say case of the words, that basically means, or I can just say that, right? I'm just lowering all the words itself, right? So here, let me just write this one. I can just write something called as lowercase of the words, okay? Why we require this? Because understand lowercase the words. Let's say I have a capital the and small the, right? Both the words are actually same, right? The can be present in any other sentences, and we really need to treat this as a single word itself, right? So it is important after we perform tokenization, we really need to lower all the specific words. Okay, so that is the reason what we do. Now with respect to text preprocessing part one, we usually do this two simple step, and along with that we can also apply our third thing. Is this with respect to regular expression, and definitely I will try to show you why regular expression can be super important in this particular case. Now over here you'll be able to see regular expression can be removing special characters. It can be removing any characters from that particular word or the entire sentence based on some regular expression, right? So that's what we basically do. And again, this is a cleaning process. When we say text preprocessing, we basically say cleaning process. The next step again, when we further go, and probably we have discussed about all these things, only regular expression is left, which I will probably discuss as we go ahead. Okay? Now, in the second step, what I'm actually going to do, I'm basically going to write something called as text preprocessing part 2. Right? Text preprocessing, and this is part 2. And what are the things we have learned here till now? So some of the topics like stemming, right? Lemmatization. And I hope what is the advantage of stemming, lemmatization we have already discussed, right? And third one, we basically have something called as stop words, which is perfectly going on, right? Now all these things are absolutely fine, right? We are doing all these things, stemming, lemmatization and all. Here also we are focusing on cleaning the text, and our raw text, once it becomes very much clean, we are definitely the next step will basically be to take this particular text and try to convert this into a vectors. Vectors is a numerical representation of a specific text. It can be a sentence, it can be words, right? We try to represent each and every word with some kind of vectors, which will give some meaningful representation of that specific word, so that we will be able to apply any kind of machine learning algorithm like classification, to solve any kind of use cases like sentiment analysis. So we have actually covered till here. The next step, what will happen is that, so here I'm just going to write out all the steps. So this is my step 1, step 2, right? Step 3. Now when I talk about step 4, now this is super important, right? And I'll just give it as another color. So this will basically be my step 4. After completing this step, I will take this entire text, and probably we will try to convert this text into vectors. So what we're going to do, we're going to convert this text into something called as vectors. Vectors is nothing but a numerical representation of the specific text. What are the techniques that is used? That is super important. And you really need to understand these techniques, because as we go ahead, right, later on when you start learning deep learning also, there are concepts like word embedding, word to vec and all, right? And all these techniques that is basically used, and even the advanced techniques like transformer and BERT, they also use this technique of converting the text into vectors. And they have some amazing way. One way is word embeddings, right? That is, they have an amazing way to convert this text into vectors, which will provide meaningful semantic information to the text, right? So just understand for right now, if you're not understanding what is text to vectors, it is just like I have some kind of text. Let's say I have this foot is good. This entire text will be represented by a simple numerical format. Okay? Numerical data in short. Now over here we are going to learn various different techniques. Now first thing is that we are going to see what is called as one hot encoded. Okay, one hot encoded. And probably if you know machine learning, you'll definitely be able to know. And again, one hot encoded is not a very efficient technique with respect to this kind of data. And right now, nobody's using one hot encoding techniques specifically for text data. Yes, for machine learning problem statements there to convert the categorical features into numerical format, we basically use one hot encoded, but not in text. But we'll try to understand the theoretical part of this. And after this, we will be going with something called as bag of words. Okay, super important technique, which we also say it as BOW, right? Very, very super important technique with respect to this. Third technique that we are specifically going to see over here is something called as TF-IDF. TF-IDF. Okay, so TF-IDF is also a very good technique to convert the text into vectors. And as we go ahead and learn different things, right, there will be some disadvantage in that specific technique. So we are using the next technique. The fourth one that we are probably going to see is something called as word-to-vec. Now, this word-to-vec is also an amazing technique. There's a concept in deep learning which is called as word embedding. Word-to-vec is basically used. You can also train your own word-to-vec. You can also train a custom word-to-vec, or you can also use the same weights to train the newer data. I know if it is not making sense, don't worry. I will explain each and everything as we go ahead. Now, the fifth part that we are going to basically see something called as average word-to-vec. Again, a super important topic altogether. And we'll also try to see all these things. Now, why I'm writing all these things because these are all the techniques that we are going to see from the next video itself. First, we'll go with one hot encoded. We'll understand the advantage and disadvantage. Then we'll go and see bag of words. We'll see that how bag of words work, and then we'll see the practical implementation, like how we can do it with the help of NLTK. Right now, after you do this, after we get the vector representation of a text, or numerical information about that specific text, or numerical representation of the text, we take the numerical representation. Let's say that this entire sentence, right? I'll give you an example how it will get converted. Let's say I'm just writing it as 1011, right? Something, okay, some numerical representation. Okay, so this will be my numerical representation for this particular document, that is D1. How I'm getting this? Don't worry. I'll just put some as an example. I'll explain you as we go ahead with the video. With respect to this numerical representation, this will be my output. So what we can do is that we can take these vectors and we can send it to the next stage, wherein I will just write it out as fifth, and this will basically be my model trained, or model getting trained. Okay, and over here you'll be able to see that once I convert my text into vectors, here we will train with machine learning or DL algorithms. Okay, but right now, since we are discussing NLP with machine learning, I'm just going to write machine learning algorithms. Okay, we're going to train this with ML algorithms. Okay. And finally, we'll be able to do the prediction and find out the accuracy. So this is what step by step we are basically going to do it. But you really need to understand all these techniques, right? In machine learning at least, one hot encoded and all. And later on, we're also going to see a library which is called a GenSim library, which will actually help you to do word-to-vec, because it is a huge model. Okay, word-to-vec. It already has many representation of the words. Like it can provide a numerical representation of various words. And again, internally, word-to-vec and average word-to-vec also uses deep learning techniques. Again, we will discuss about it. The overall brief idea, I'll try to give it to you. And then what we'll do is that we'll solve some use cases wherein we'll take this particular data and again we'll follow this entire step. And finally, we'll train our machine learning algorithm. Right? So this is what we're going to do as we go ahead. So I hope you're able to understand what is the flow and how you're going to solve this particular problem. The example of the data set is over here. We'll try to convert this into numerical format and then train with the machine learning algorithms. So yes, I will see you all in the next video. I hope you're able to understand things. I hope you're able to understand each and everything what I'm actually writing. Yes, this was it. I'll see you all in the next video. Thank you. Hello guys, so we are going to continue the discussion with respect to NLP. We have already seen that now what is our next step, after text pre-processing, where we have specifically performed stemming, lemmatization, stop words, and we've cleaned the data, right? Now the main thing is that we really need to convert the text into vectors, and there are multiple ways. The first way that we are going to discuss about is something called as one hot encoding, okay? Now we'll try to understand how with the help of one hot encoding we are converting the words into a vectors itself. So let's take this specific example. So here I have a text and a specific output, right? Our main aim is that first of all we need to take this particular text and we need to convert this into vectors, okay? Now with respect to this, obviously I'm also not going to again lower all the sentences of words, but let me focus on more on like how you can basically implement this one hot encoding and what is the theoretical intuition behind it and how the vectors are actually created. So to begin with, over here, let's say that this is my text. The document one is the food is good, the food is bad, pizza is amazing. Okay, so this is basically pizza is amazing. Okay, now how do you find out how many unique vocabulary is there? Because see, the unique vocabulary will play a very important role, okay, while creating your vectors. Okay, so to begin with, what I'm actually going to do is that we just need to find out how many unique words are there. So let me go ahead and write it down. And obviously, you know that if I combine all these three documents, it becomes a paragraph or corpus. So let me just go ahead and let me just write down all the unique documents. So the is one unique, sorry, not document, vocabulary. The is there, food is there, right? Is there, right? And good is there. So over here you can see good is also there. Then from the second sentence, you can see the food is getting repeated. So I'm just going to write bad. Okay, and if I go probably to the third sentence or the documents, here you'll be able to see pizza is there, which is a unique word or unique vocabulary. Is again getting repeated, and finally we have something called as amazing. So all these words that are probably present over here, these are my unique vocabulary, right? Vocabulary. So these are just nothing but the unique words that are available in this entire paragraph or sentence or in this particular data set. Now, based on these unique words, one hot encoding means what? Okay. Now let's say if I probably consider this particular document one D1. Okay, so let's say this is my D1. Now, what does D1 do is that, like, if we are probably applying one hot encoding, we will convert all the specific words into this vector representation. That basically means, let's say if I'm considering the word, then the vector representation for the word will be 1, 0, 0, 0, 0, 0, 0. Why? Because 1 is present over there. That basically means the is present in this specific word. So this is basically becoming 1. If I consider for the next word, that is food, then how will we be able to represent it? It will be 0, 1, 0, 0, 0, 0, 0. Right? So here clearly you'll be able to see wherever those specific word is, it will be represented by a vector which will be of a dimension v. Okay. Now what is this v? V is nothing but the words that are present over here. So here you'll be able to see 1 word, 2 word, 3 word, 4 word, 5 word, 6 word, 7 word. So the unique vocabulary I have 7. So it is going to be represented by the 7 vectors, where for those specific word it will be represented as 1 and remaining all will be represented as 0. Right? So now if I probably consider how can I represent this D1, that is the food is good, with respect to this particular vectors. Okay. So now understand that in this particular food, there are 4 words, right? 1, 2, 3, 4. So over here with respect to D1, the first word will have a representation of 1, 0, 0, 0, 0. So how many zeros are there? 1, 2, 3, 4, 5, 6. Right? 1, 2, 3, 4, 5, 6. Right? So this will be my first word. Okay. Then coming to the second word. Now the second word over here is food. Right? So here you'll be able to see 0, 1, 0, 0, 0, 0, 0. Right? So this will be my second word. Now if I come to my third word, it is basically is. Right? So is basically represented by 0, 0, 1, 0, 0, 0, 0. So this is my third word. And coming to the fourth word, which is good. So here it will become 0, 0, 0, 1. 0, 0, 0, right? So this is my sentence one hot code representation with respect to this particular text. So this text, if I apply one hot encoding, I'm going to get this kind of representation. So guys, now if I talk about the shape of this D1 sentence, which has 4 words, right? So here you can see the first word representation is this one, the second word representation is this one, vector representation, third word vector representation is this one, and fourth word vector representation is this one. So if I probably see the shape, right, it is basically 4 cross 7. 4 words, 1, 2, 3, 4. Okay, and 7 vocabulary size, right? 1, 2, 3, 4, 5, 6, 7. Okay. Now what we are going to do, we are also going to do the same thing for D2. Okay, so let's go ahead and try with respect to D2. I would suggest just pause the video, try it by yourself, and then probably continue the video. Anyhow, I'll be showing you the entire representation again. Okay, so over here you'll be able to see that, which is my first word. Again, in D2 I have the foot is bad, right? So again, these two are same, these 3 words are same. So I'm going to basically write the same representation. It will be 1, 0, 1, 0, 0, 0. I think there are 6 zeros, 1, 2, 3, 4, 5, 6 zeros. Okay, so this will be my first word. Coming to the second word, this is this one. Okay, I'm just going to write this over here. Okay, so this is my second word. So here I'm going to write 0, 1, 0, 0, 0, 0. I hope the size is 7. 1, 2, 3, 4, 5, 6, 7. Perfect. So coming to the third word now, here you'll be able to see 0, 0, 1, 0, 0, 0, 0. Okay, now here you can see this foot is, it is a similar word like D1 only. So the first 3 is just a replica. Coming to the last word, right? Now if I say last word, over here you can see good, over here you can see bad. Now whenever you have bad, this particular word will become 1, right? So you'll be having 0, 0, 0, 0, 0, 0, 0, 0, 0, and then 1, 0, 0. So I'll just go ahead and write 0, 0, 0, again 0, 1, 0, 0. Perfect. So this is how the D2 is basically represented. And again, over here you'll be able to see the shape will be somewhere around 4 cross 7. Okay. Now, yes, this was the technique, simple technique of one hot encoding, like how we converted a text into a vectors. Over here you can see each and every word is basically represented by a one hot encoded based on the vocabulary size, whatever the vocabulary size is basically present. So here you can see that I have a vocabulary size of 7. So based on that, one hot representation is given for each and every word. Okay. Now, going forward in the next video, we're going to discuss about all the advantages and disadvantages of this. And again, one hot encoding is not getting used for this NLP use cases. We have techniques like bag of word and TF-IDF. We'll also understand what are the advantages and disadvantages. Why should we not use this? And then we'll be trying to understand the bag of words and TF-IDF. Okay. So yes, this was it. I will see you all in the next video. Thank you. Hello guys, so we're going to continue discussion with respect to one hot encoding and NLP, and I hope you have understood that how we can convert words into vectors, and probably the entire process I've actually explained to you over here. In this video, we're going to talk about the advantages and disadvantages of using one hot encoding. So let me go ahead and let me write it down. So here are the advantages, okay, and here are the disadvantages. Okay. Now, first of all, the basic advantage is that it is very easy to implement with Python programming language, right? Easy to implement with Python. Now, why I'm saying you that? Because in sklearn, we have a specific library where we can easily implement this, and it is basically called as one hot encoder. Okay. And in pandas, if you're familiar with pandas library, we have something called as pd.get_dummies, right? So this function will basically help you to create this entire one hot encoding based on the words, right? And again, the second advantage, and obviously we'll see this kind of examples as we go ahead. But again, I'm not going to implement specifically separately as a video in one hot encoding because we don't mostly use this NLP in NLP technique, and I'll tell you why, because there's a lot of disadvantages also. Now let's go ahead and talk about the disadvantage. The first disadvantage over here, you see that over here at the end of the day, if I probably consider, right, the foot is good, right? At the end of the day, I'm getting 1, 0, 0, zeros, and for the next one, I'm getting the 0, 1, 0, zeros, and there's so many number of zeros and ones. In arithmetic, in linear algebra, we basically say this as sparse metric. Okay, so this basically creates a sparse matrix, right? Now, what is sparse matrix exactly? To talk about sparse matrix is that in an array, in a matrix, you have a lot of ones and zeros. Okay, and what is the problem with respect to sparse matrix? I can also say this as, we can also convert this into an array also. So we can also say this as sparse arrays. But understand what is the disadvantage with respect to sparse matrix? Whenever we apply any machine learning algorithm, this specific machine learning algorithm, after we convert the text into vectors, right? In most of the machine learning algorithms, this leads to something called as overfitting, right? Now, what exactly is overfitting? Overfitting is a process wherein you get a very good accuracy with the training data, but with respect to any new data, it will not be able to give you a very good accuracy. So this sparse matrix usually leads to something called as overfitting, right? So this is one of the major disadvantage. Now let me talk about the next disadvantage over here. Okay. Now over here, let's say that I have this words like the food is good, the pizza is the food is good, the food is bad, pizza is amazing, right? Now see one thing over here, right? In any machine learning algorithm, whenever you give the data, right, and in this case also, if I probably say this vocabulary, right, these are all my features. The food is good, bad, pizza amazing, right? Now over here you can see that most of the time my inputs for every word that is getting converted into a vector, the size is 7, right? 1, 2, 3, 4, 5, 6, 7, right? And based on the number of words, here you'll be seeing that I'm having 4 words, so I'm getting 4 cross 7. Here also I'm having 4 words, which I'm actually getting 4 cross 7. But if I consider with respect to the third statement, the third sentence, right? So if I probably consider D3, right? And if I start creating a one hot encoded format for this, so what it will be? See, pizza is there, right? So pizza where it is 1 at this particular instance. So I will probably create something like this 0, 0, 0, 0, 0, 1, 0, right? So this is pizza, right? Is again we have is over here. Is nothing but this will be 1 and remaining all will be 0. So I'll just write 0, 0, 1, 0, 0, 0, 0, right? And the third statement is amazing, which will be the last one as far as I remember from the vocabulary. So this is how my D3 looks, right? In one hot encoded format. But one thing you really need to understand. Over here, the size is 3 cross 7, right? Now in machine learning, you need to understand one thing. Whenever we perform NLP or let's say any machine learning use case, the number of features should be fixed with respect to the length. But here you can see this is 4 cross 7, this is 4 cross 7, this is 3 cross 7. So I cannot train this particular data for a machine learning algorithm because over here we still don't have a fixed text size, right? So this is one of the major disadvantage. Unless and until with the help of one hot encoding, we are not getting a fixed text size, right? Over here I've got 4 cross 7, 4 cross 7. If this was also 4 cross 7, I could have trained it, right? So over here I'll say that for ML algorithm, we need fixed size, fixed size input. Right? And right now it is not there. So this is again a major disadvantage, right? We'll be seeing in the upcoming lectures how with the help of bag of words, TF-IDF will be getting a fixed size of words. Okay. Now the third one that you'll be seeing. Most of the times we are finding zeros and ones, right? Zeros and ones. In zeros and ones, most of the times, if a specific word is there, that will become 1 and remaining all will be 0. But if I talk about the semantic meaning between these two words, like the and food, right? We are not able to exactly calculate how far, how equal it is, or how similar that specific word is. And this process is basically called as semantic. So here I will say that no semantic meaning is getting captured. No semantic meaning is getting captured. Now let me talk about this in a very good example. Okay. Let's say I have something like this. Food, pizza, burger. Okay. Now you know that, let's say that in my vocabulary I have 3 words. So for the food representation, I will basically write as 100. For pizza, let's say I'm going to write it as 010. And for burger, I'm just going to write it as 001. Now understand, these are my vectors. And right now, since there are 3 features, I'm basically having 3 vectors. Now, if you have probably heard of something called as cosine similarity, or if you really want to find out the distance between this vector to this vector and then this vector to this vector, if I probably consider this, let's say I'm just going to draw a 3-dimension. Okay. Let's say this is being determined by something like burger, and this is being determined by something like food, and this is being determined by something like pizza. Now, if I talk about all these things, like let's say in the case of food, it is 100. So in this axis, I will probably getting 1. So this will be represented by 1, 0, 0 in 3 dimension. And if I talk about pizza, 0, 1, 0. So this will be my another point. Let's say I'm just going to denote this by another point, 0, 1, 0. And let's talk about the third point over here. The third point will be somewhere here, burger. It will be in the same distance. So this will be 0, 0, 1. Now, if I probably calculate the distance between all these things, it will always be equal, right? So it is not being able to tell the exact difference between food, pizza, and burger. It is obviously considering that, okay, all these words are in equal distance. So we cannot understand that how this particular word is different from this. Right? This is super important to understand. So in short, what I'm actually trying to say over here is that no semantic meaning is basically getting captured. That basically means in this particular sentence, I'm not able to understand which is the most important word, how this word is related to this word, or how this word is much more similar to this word. So that information is not getting captured because at the end of the day, I'm getting ones and zeros. Okay. So this was the third major disadvantage. I'm talking about the fourth disadvantage, and this is also very super important. And this particular concept is something called as out of vocabulary. Out of vocabulary. And what does this basically mean? OOV. Okay. Now what is this all about? Let's say that. Right now, I have this many vocabularies of words. Let's say after I train my model, now I want to test it for my new data set. So for testing on my new data set, this will be my test data. Let's say I will say burger is bad, and I need to predict this. So this is my test data, and I need to predict this. Now you know that over here, with respect to this particular sentences, okay, burger is nowhere present in this particular vocabulary. So what will be the problem? We will not find out a way. We will not have any way to represent this burger in the form of vectors, right? We'll not be able to form a vectors over here because anyhow we don't have a vocabulary word. So what will happen in this particular case? And obviously we'll not be able to perform this one-hot encoding because in our vocabulary I just have this many number of words. So this will not work when a new word is actually coming, wherein it is not present in the vocabulary with respect to the test data. And obviously this is again a major disadvantage, right? So this technique is basically called as out of vocabulary. So this was in short about the advantages and disadvantages of this. Understand sparse matrix basically means many ones and zeros. It leads to overfitting with respect to various machine learning algorithm. Then for any machine learning algorithm, I definitely require a fixed size input. Right now we are not able to get it. That basically means all my sentences should be of fixed size. It will not work. No semantic meaning is getting captured. I've already told you because if I try to calculate distance, all these words are equidistant. It is not saying that whether pizza is very much similar to food or burger how much similar it is to food, right? That similarity is not there, and based on that, semantic meaning is not getting captured because here either we're getting ones and zeros. So we are not able to provide, right? Over here you can see that much more maximum information, which is the most important word. That information is also not getting captured. So this was in short about the advantage and disadvantage. I hope you have understood this. And again, the next technique with respect to converting word to vectors is something called as bag of words. We'll try to see that how it is fixing some of the disadvantages from here. And yes, one more major disadvantage I'll say that let's say that if you're right now I just have 3 sentences. Let's say I have just 7 vocabulary. Let's say tomorrow I will be having 50k unique vocabulary size. Now what will happen in this particular case? Right? I'll be getting so many number of ones and zeros. So in short, again, this is actually leading it to sparse matrix. But in the real world scenario, I'll just not be having 3 sentences. Right? I'll be having bigger sentences and I'll also be having many sentences as such. So this is also one of the things. In any interview, they ask you, you probably need to talk about or explain like this with respect to advantage and disadvantage. So I hope you have understood this. I will see you all in the next video. And in the next video, I'm going to discuss about bag of words. Thank you. Hello guys, we're going to continue the discussion with respect to NLP. In our previous video, we have already seen that we have discussed how one-hot encoding works, right? And if I probably talk with respect to different types of ways how we can convert a text into a vectors, we had completed already one-hot encoding. Now we are into the second, that is bag of words. Now let's go ahead and understand how bag of words actually work. And this is super important because this is the technique which you can do simple tasks like sentiment classifications or whether basically in short a text classification kind of task easily you'll be able to solve. Okay, some of the applications, famous application like whether a mail is a spam or a ham, everything you'll be able to solve it. Now let's say that I have a data set, okay, and in this particular data set, I'm just saying that this is a positive or negative statements. Now in this particular data set, I have 3 sentences. Let's say he is a good boy, she is a good girl, boy and girl are good. Okay. Now all these are like positive statements. So the output of all this are ones, right? In supervised machine learning, we really need to know the output also. Now let me go step by step and show you that how bag of words are implemented. So this is basically the step 1, right? I have the data set. Now let's go to the step 2. Now what happens in the step 2 is that once I go over here, right? There's multiple steps that actually occur. And initially we should also go with respect to this. The first thing is that if I probably consider 2 things are going to basically happen. First of all, we will lower all the words, and usually all the steps we will even be doing for all the other techniques also. First, we will lower all the words, and then we will probably apply stop words, right? And this also I've already shown you. Now, when I lower all the words, let's say my sentence 1, right? My sentence 1 now becomes, I'm going to take only this text data. I don't have to worry about the output because later on, once we convert this text into vectors, we can apply it to the machine learning algorithm. So in the sentence 1 here, you can see as soon as I lower the words, what will happen? This all will become smaller. Now, why I'm doing this because there may be some repeated words. Now, in this particular case, the capital with capital B, you have boy. Here, small b, you have a boy. So both these words are same, but since it is in uppercase, this will be treated as a separate word. So we really need to lowercase all the words. So I'm just going to write lowercase all the words. Now, in sentence 1, after lowering casing, so what will happen is that this all will become smaller letters. Then once we apply stop words, now what happens in stop words? These all words like he, she, is, a, you know, it will get deleted, right? Because we don't require this particular word for any kind of task like sentiment analysis. Important words like good boy, good girl is basically required. So this all things will go like and, are will also go. Now what will happen with respect to this? The sentence 1 words will become only like this: good boy. Okay, I'm showing you step by step with the help of Python. When we do, with the help of libraries, when we do, it is very much simple. We don't have to worry that much about it. Okay, we just have to use one library. So sentence 2, what it will become once the stop words will get removed, it will become good girl, right? And similarly with sentence 3, I will be having the specific words, that is boy, girl, good. Right? So all these things are there. I have sentence 1, sentence 2, sentence 3. Perfect. Now what we do is that we go ahead and calculate the vocabulary. Now how many words are there in this vocabulary? We have good, boy, girl, boy and girl, and again it is getting repeated. So if I probably consider how many unique words are there in the vocabulary, so I will be able to write it over. The first word is nothing but good. So I'll go ahead and write good. Good is my first word. And one more thing that I will probably write that what is the frequency? of this specific word. Like how many times these words are there in different sentences. And obviously you can see 1, 2, 3. 3 are there, so I'm going to keep the count as 3. Then we have something called as boy. Over here you'll be able to see how many times boy are there. So in sentence 3 also boy is there, in sentence 1 also boy is there. So I'm just going to make the count to 2. And coming to the next one, which is called as girl. So again, girl word is also there in this vocabulary. And again, girl also you'll be able to see 2 times it is there, right? Now, first of all, you need to see that in this frequency with respect to different vocabulary words. Is this in ascending order? And obviously, is this in descending order? So maximum number of frequency will be put up in the first word, right? Then boy is present 2 times and girl is present 2 times. So this can be moved up and down. But just understand what I've done is that based on this descending order, I have just ordered all these words. So it is basically from maximum to minimum. Okay. So this is there. Perfect. Now, before applying bag of words, you already have seen that how many vocabulary size, what is the vocabulary size? The vocabulary size is 3, right? And I can see in a bigger data set, I can have this kind of words a lot. So I will be having all these words like this and frequency will also be there. And one important step is that it's not necessary that you use all the words. This is also there in this bag of words itself. Let's say that over here in the vocabulary, there are 100 unique words. And let's say some of the words are just present once, right? So if some of the words are just present once, we even need not take that. So when we'll be doing the coding with respect to a bag of words, we also have an option that we just select the top 10 features or top 20 features, which of the words are getting repeated more and more. And that is the importance of this particular frequency. Okay. Now, perfect. We have till here. Now the next step will be that it is very simple now. Based on the topmost frequency, what I'm actually going to do, I'm going to keep these words as my feature. So good will come over here, boy will come over here, and girl will come over here. Okay. Now, you already know what is the sentence 1, right? So sentence 1, what will happen is that this sentence 1 has good boy. Now see how this will get converted into a vectors. Wherever good is present, that will become 1. Wherever boy is present, that will become 1. And remaining will become 0. So this entire sentence will be able to see that it is getting converted to 110 as a vector. Okay, so this was the text. Now this is getting converted to 110 as a vector. Now similarly, if I go with respect to sentence 2, wherever there is a word like good, that will become 1. Wherever there is a girl, that will become 1. And remaining all will become 0. I'll talk about the advantages and disadvantages why we are doing this. Previously, in one hot encoded, you saw that for every word we are doing this. For every word we are creating a vector. But here, for the entire sentence, this vector is coming. Okay, and there are a lot of advantages when I talk about this, which I'll discuss. First of all, let's understand what more we'll be having in this. So S3, you'll be able to see the sentence 3. Here I have boy, girl, and good. So wherever boy is there, that will become 1. Girl is there, that will become 1. And good will be there, that will become 1. Okay. Now, this is my entire vectors, and obviously I also have my output variable. The output variable can be 1, zeros, anything as such, right? If you're probably solving the sentiment analysis or something like that. Okay. Now, these are my entire vectors. Okay. And this is the vector for the entire sentence. Okay. Entire sentence.